Hi everybody. Before we understand about Java programming, let's look at why we have to learn Java and what is the importance of Java in the current world. First of all, a very warm welcome to the Core Java course, and we are very excited to teach you about various exciting features of Java which help you to be like very good in Java and you can advance your career from there. So if you look at from various websites which do a survey on these programming languages where they will tell you which programming language is used across the world. If you look at TUB is one of the one where actually they conduct survey across and identify which programming languages are top, and as per them in the 15th consecutive year Java is considered as one of the #1 programming language. Another thing is, if you look at Oracle blocks, approximately 10 million developers and 7 billion devices worldwide uses Java. And as you know, when we say devices, why Java being used on devices? Because it's platform independent. So what exactly is platform independent? So here, platform independent means platform here indicates operating system. That means whether you're working on a Windows operating system or Mac or Unix or any other operating system, it doesn't matter. If you have JVM installed, it will work seamlessly there. That means you go and have a code which is executed on a particular operating system like Windows, and the same code you can, once you compile it, you can take and execute in a Mac operating system also. So that's a part of Java, since it can have this kind of platform independency across multiple operating systems. You can run even on devices as well. Now, Java is like very versatile when we say that it is more of a, I would call it as a, even though it is a platform independent language and adopted mostly on web and mobiles, I would consider it to be like a very versatile. The reason is like it is not fixed to one particular domain. If you look at earlier programming languages like Fortran or Basic or COBOL, they are all focused on one particular domain. Even MATLAB, which you hear now and then, in Coursera, whenever people teach ML and all, those are like actually made to solve one set of problems. Like MATLAB is completely on the scientific and numerical applications, whereas Fortran is similarly on those lines, and COBOL is for business applications. So like these are actually biased towards solving one set of problem. But if you look at Java, it can be used on any set of problems. Like it can be used on web, mobile, desktops, using different operating systems or platforms. It can be used on IoT, and it can be used to have something like an API mechanism. REST APIs you can easily build using Java, and you can have your client calling them. It can also be used in big data. In fact, I'm not sure whether you know the Hadoop, which is one of the powerful component of big data, which actually help you to parallelly process the data. The entire MapReduce of Hadoop is written in Java. And coming to e-commerce, I'm not sure whether you are aware, all the Amazon website which is running is actually written in Java, because Java supports object-oriented programming language, which actually helps it to helps the programmers to maintain their code or to maintain their projects for a longer time in a more modular fashion, scalable and better modular, or to make it more extensible, debuggable. I mean, you can look at like multiple ways, and it actually helps the language to be more reusable also, so that only when somebody builds at the initial time, he might take some time. That's where it actually takes more time, but once it has come to a stage, after that any kind of extension of the language, it can be easily done. So that's the reason why a lot of people build use Java for their projects which are sustainable for years, because Java is made for that. And all these high frequency financial trading platforms, if you look at their backend, it is written in Java. And scientific applications, if you ever look at websites which do a lot of scientific applications, if you look at 100 websites, I'm sure that 20% of the websites backend is written in Java. It is like that. All the scientific I'm talking about, whether you take weather.com, which is a website which gives you weather information, and there are certain websites which talks about scientific related stuff like Fourier transformation and all that. Those are all actually the backend was managed by Java itself. And I've just called a few. If you look at, there are much more like this. Now, Java, like I said earlier, if you remember, I said like it is used on mobiles also, and one of the powerful operating system on mobile is Android, and Java in fact powers Android also. And in fact, your Gmail, the it's actually like most of the Gmail is built in Java, and it is in the Curiosity rover on Mars as well. Now, who are all using? Like I already mentioned, Amazon using it. LinkedIn was most of the LinkedIn stuff is built in Java. eBay, Netflix, Slack, Android, Spotify, Google, Capital One. Here, if you see, a lot of them are mentioned. And in fact, if you look at, there are a lot of other things are startups. Like I was working on a startup called Bloomreach. In fact, most of the system is built in Java. Earlier, they used to write a lot of, this Perl or Python coding. They have migrated a lot of their code into Java and Scala. So these two are basic, one of the powerful object-oriented programming languages. So like you take any particular platform, pick any particular company where it is running for years and years, and look at their backend. I'm very sure that they will be using one of the object-oriented programming languages, and in that, if you count down the number, Java will be the highest being used. And as you know, since the Java is in more demand, uh, the average salary of the professionals who work or who know Java is something around 50 to 100K dollars. And in this course, if you look at, we will learn about core Java. So when I say core Java, if you look at Java, it is actually like there is three parts to it at a high level. If you look at, there is this core Java, advanced Java, and enterprise edition Java. So core Java completely talks about the foundational structure which actually you need so that you can program in Java. Whereas advanced Java talks about even how to do remote method invocation, how to do database connectivity, or how to do something like on the web, how to create web pages using Java and do something like a request server model. All that which is beyond just programming in your system, something connecting to external will come under the advanced Java part. When it comes to enterprise Java, it's more about how you actually build things in an enterprise platforms. All that will come under there. So you will learn a lot of theory here as well as a lot of hands-on demos and quizzes so that you can assess whether your knowledge is up to mark or you need to work on to improve it. And if you're a college fresher or new to this Java developer role, this course will definitely help you to kickstart and start writing programs in Java and start enjoy the exciting features offered by Java. Now, if you look at this entire course is divided into 7 modules, or I would call it as 7 lessons. The first lesson completely talks about what is Java, why we need to learn about it, and what are the different OOPS concept here. And we are talking about Java 11 specifically in this entire course because that's the latest. So that's why it's mentioned as Java 11 introduction. Coming to utility packages and inheritance, we are going to talk about what are the utility packages you can use in Java, and we will give some examples on how to use them, and at the same time we will show them where and all inheritance is used and how it is very powerful when you actually work in Java programs. Now coming to lesson 3, we talk about something called multi-threading. So you might have heard these terms called multi-processing, multi-threading and all. All of these particular things are existing in order to achieve something called parallelism or concurrent execution. That means if you want to execute multiple tasks at the same time, these are your answers. So in Java supports multi-threading. Using that, what we can do is at the same time, you can have multiple functions executing at the same time. So if you ever work on a Windows operating system, you might have opened a browser, you might have played a YouTube, you might have played a movie. How you think that given that you have only one processor in your computer, they are all running parallelly. They are all run with the concepts behind, with the concepts like operating system concepts like multi-processing or multi-threading internally. In fact, your browser runs multiple tabs in your computer by using this multi-threading concept. All that how to implement is what we learn here. Now coming to debugging. Debugging is a very important aspect not only in Java, in every programming language, where whenever you code in your production system where it is running 24/7, how you ensure that it's all runs without any issues, and what if there is a problem, how do you identify that problem, how do you debug it, or when there is a problem, how do you quickly detect it, or how do you alarm on it. All that is going to learn here in the debugging, where actually the recommendation is to write into different log files. When I say log file, it is nothing but a file where every activity of your system will get logged so that you actually go and check what is happening. That is to help to detect the bugs in your system. And not only that, in case if there is anything alarming, when I say alarming, something like your system is getting into a lot of error situations, or your system is getting high latency. That means the request a client is sending, but the response you are getting is, let's say, 2 minutes, 3 minutes, which is huge on a live platform. All that you can detect and alarm on it using these debugging techniques. And one of the debugging technique we are going to learn here is how to do that in Java using log4j. Now coming to the lesson 5, which is called JUnit. JUnit is one of the popular package in Java. It is meant to do some kind of unit testing in Java. So when I say unit test, it's very important that every developer today, earlier was the case that where developer roles and testing roles are separate, but if you look at all the product companies, all product companies encourage developers to write a basic test cases which are called unit test cases. Unit test cases are nothing but for each of the functions you write in your code, you again write the test cases to see whether they are actually performing as expected. If they are not performing, how should we catch it and fix it? It actually helps you to make your code stronger by identifying all the edge cases and make your code more performant enough. And that's the reason every code when you send for any peer review, when I say peer review, reviewing with your colleagues, it is very important that that gets reviewed properly. So that's where this JUnit helps in writing these kind of unit test cases. Now coming to Java cryptographic extensions. So cryptography is more about science where actually you deal with different encryption techniques to convert a plain text into some form which is not easily understandable. And here in Java, we are going to learn about two algorithms called Poly 1305 and Cha-Cha 20. I mean, the name looks funny, but yeah, those are the names and one of the popular algorithms. They actually help you to convert the data in a form where it is not easily understandable. At the same time, the poly algorithm, which is mainly needed to identify if the right user is authenticated or if the right information is properly sent without any intrusion in between. Now finally, the last chapter, design patterns, is one of the powerful concepts. This design patterns is not specific to Java. Even the same concept can be implemented in any programming language. But this concept talks about when you are building a project, what are the different approaches you can take so that you can build your project more better. Like let's say for example, it's not like if I ask you like, can you please develop a system where a small HTML page, a very small website you want to do it, where it just shows a clock in your system, in your computer. Now what you have to do, you have to first of all fetch the clock, or first of all fetch the time in your computer and send it to HTML, and HTML has to generate. So that if it looks simple, there are different ways to doing it. But if you really look at the way to solve it is you have to first divide the code into one for backend, one for front end. If you want, you can have something called a middleware also in between. You might be thinking like, just for simple thing, why I have to do that? Always think big. What I would suggest is, even though it is small here, when you actually have that perception of building things big, you better divide the code now itself. When you start smaller, you can always do the same thing even when you build bigger projects. This might look very funny for small projects, but for big projects, this really makes a lot of sense because you have code properly manageable. And whatever the structure I have said now, that structure is called model view controller, and it is one of the design pattern. So design pattern tells about how you build a bigger projects using some of the approaches so that they are more maintainable, better modular, and at the same time how can you make it more extensible or reusable. That's what it talks about. I'm very excited to start the next session on core Java lessons. I hope you're also on the same page. See you.
Hello everybody, this is Krishna here. So today we will learn about Introduction to Java module. So in this, we are going to learn about basics of Java. We'll understand the object-oriented concepts. Then we will learn about how to install an IDE. IDE stands for Integrated Development Environment. We will learn about how to install one of the favorite developer IDEs called Eclipse. And we will see some shortcuts on how to use it, how to execute a program, all that. Then we will move on to the basic elements of Java, like your variables, constants, literals, Unicode. Then we will also understand about data types, operators, and conditional structures. We'll also discuss about specific Java 11 methods and concepts which are new to Java 11. Then we will discuss about operators, other special operators I would call it as, like null, this, and instance of. We'll also discuss about destructors. Then we will go deeper on garbage collection, how it really happens in Java. We'll also discuss about different string methods Java has. We'll also discuss about different types of arrays we have, both single and multi-dimensional. Then we will close our discussion with command line arguments. So this is going to be our agenda for this Java 11 module. So starting with introduction. So these are the basic features of Java. I would say this actually encompasses the entire thing of what Java is meant about. So here are they. So Java is portable in two ways. When I say portable, portable simply means mobility. So what does it mean by portable? Like let's say you have written a source code, which is nothing but a high level programming language you have picked up and you have written. Now when you have written that code, you will write in English like that is going to be in general, right? So when you have written that code, if you are writing that code in an operating system like Windows and the same source code, if you can copy into a Unix operating system and execute it without any changes, that's called portability. That means the mobility of having a program getting executed in multiple platforms or multiple operating systems without any change. Whereas Java went a step ahead where it said, I can do even more. The next part, what Java has done is once the source code is compiled and generates an intermediate code, or you can call it as byte code, even the byte code also you can copy from one operating system to another operating system and get it executed. And that how that happens, we have a detailed discussion of one slide in that, where it should have a particular JVM related to that OS should be available, so it gets automatically executed. That's how I said Java does two efficient job of portability at two levels. One is at the source code level, another is at the object code level, which is the bytecode. And Java can also be used both for server as well as client-side development programs, where on the server side, on the web server side, it can receive requests and process it. At the same time, you can develop programs which are customer facing and they are like customer web pages which you look at, that also you can develop in Java. Now coming to this one, what is programming paradigm? So each programming language evolves with different styles. Like for example, if you see C, it is a procedural oriented programming. Sometimes people call it a system or programming language as well. Now Java basically supports two high level programming styles. One is procedural programming, another is object oriented programming. So what exactly mean by procedural programming? So when you say procedural programming, it is nothing but given a task, how do you manage it by dividing that task into multiple functions? So in procedural programming, what happens is any task given, your thought process will be how do you divide so that it can be easily managed. So it is more of a divide and conquer model where a project you have given, you will break that code into multiple independent functions and you will make the code talk to each other through interactions. So that is what procedural programming is. So here the procedure term is nothing but a function. That's why there is another name mentioned here, which is called functional programming. Now coming to object-oriented programming, the thought process is a little different here, where rather than focusing on the implementation or the functionality part of it, you focus on the data part first. So you identify what is the data here. Like let's say I want to develop a product catalog. So when I want to develop a product catalog, rather than jumping and writing functions on get product name, get product ID, what I will do is first of all, I identify the product attributes. What is the product ID? What is the product name? What is the product description? All that first I will identify, which is the data part. After identifying, then I will tie that data or bind that data with the functions related to it, like get product ID, get product name, get product description, all to that. So these two bundled together, we will create a structure first, which is called class. Then we will, when we put in memory, that's when you call it as an object. And there will be multiple objects when you program where they can interact, like a product catalog might be talking to a database entity altogether, which might itself be an object. So there is multiple interaction happen between object, and this is called object-oriented programming. Here, philosophically, if you see object-oriented, it's more about a data-focused programming language. And Java has both on the functions part of it as well as the data side of it also. Now, generally when you write a Java program, how actually it executes? Now, first of all, let's say you have written a abc.java code. When you give it to the program called javac, this is your Java compiler, where it compiles your code into a bytecode, abc.class. Now, this is the bytecode we are talking about as platform independent in our previous slide, which means that the same bytecode you can copy into other machine. That means when I say other machine, other operating system altogether, and can get executed. That means, let's say I have written this particular Java code abc.java on Windows. The same abc.java source code I can go and execute in a Unix machine. And the same bytecode which gets compiled after using this program, this also I can get executed in a Unix machine, provided the JVM of that operating system is available. That's why I said Java provides two levels of portability for you, one at source code level, another is at bytecode or object code level. So once this bytecode created, what exactly happens? This is how JVM looks internally. What it does is, once your bytecode comes in, the JVM loads that into class loader, where the job of that guy is to not only execute that class, but also look if there are any other class files do I need to load. After it is done, it will be sent to a bytecode verifier module, where that guy's job is to see whether this bytecode is a best fit to be sent to the interpreter. It is like validating whether this code is sent to the other module I have. That is what it does. After that, it will send to your JIT, which is called just-in-time compiler, where it will convert your bytecode to the native machine code. And the interpreter, after getting converted to the bytecode, it scans and then it's executed on the OS hardware you have. And we also discussed about this platform independent at bytecode level. That is what we have been focusing on, how it really happens. Like I said, in a programming language like C, myprogram.c, you have a software or a program in Unix machine called GCC, which means a GNU C compiler, where when you execute it, it actually produces a machine code. When I say machine code, the exe file which you are looking here, that can get executed only on the OS or hardware you created this particular executable. It cannot be executed anywhere. That's why it is platform dependent. Here, platform means both OS and hardware. Whereas in the case of Java, what really happens is when you execute, or rather than execute, the right term should be when you compile using javac, it provides you an intermediate code. That means before even converting to machine, there is one more additional code gets created, which is the bytecode. And that bytecode you can copy and execute in any other operating system. Like let's say this is executed in a Windows operating system. The same code you can take and copy in a Unix operating system, where that must have a JVM of Unix, and that's it. It can get executed. That is how Java become platform independent in terms of bytecode level also. Now, in the Java modern compiler design, if you look at it, comes with three different types of things. Like, you have a JVM, you have Java runtime environment, then you have JDK. All will help you to program better and develop code faster, performance, lot of things. Now, what exactly is a JVM? So just focus on the term virtual. So here JVM means it's a virtual machine. That means it is not a physical machine that exists. And here, when you say virtual, it is more about talking about the physical CPU. Here we do not have any physical CPU in JVM. It is actually like a logical entity where it executes your code in that particular virtual processor. Now JavaFX in 11, if you look at, as this was removed as part of JDK. Now JavaFX comes as a independent module. So if you want to install it, we have a separate step for it. But before that, if you want to check what is the Java version installed, you can always execute this Java ---- version command, and it will tell you what is the current version available in your computer. Now, like I said, since the JavaFX is coming as separate modules, and if you want to get all that into your code, you can set the path to fx something like this. And after that, you can always compile your code, and while you're compiling, you can give the JavaFX module path like this. And whatever modules related to JavaFX, you can always pass this. And this is your actual source program. That is how you can make use of the JavaFX independent library, which is very powerful. And you can use it even though it is removed from JDK by doing this step. Now, how you run it? Once you added it, like we have seen in the previous slide, All you can do is while running also you have to pass it because it is an independent package, and automatically all the JavaFX controls you want will be available in your code. Now, Java also comes with something called GMC, which is JDK machine control, and it has several things that helps you to do a good amount of data analysis on your code. So how it helps? So it helps you in making your code more performance optimistic. It helps you in making better uses of memory. It comes with a lot of monitoring tools, profiling, all that, so that it does good amount of job on your code to make your programs or applications run faster and use less memory, all that. So that is all taken care by this GMC. And we have seen what does just-in-time compiler do? It actually converts your loaded bytecode into machine code. That's what the main job it will do. And apart from that, it actually does a lot of optimization also so that it gets executed in a native machine efficiently. So like I was saying, apart from just converting to bytecode, it also do something like code optimization. Like for example, it will make something like inline function translation whenever it is required, some constant folding. Wherever you think the optimization is required, it actually does all the job so that when you convert into native, it will have less burden to get executed. So there are a lot of optimization possible. Now, what is object-oriented programming? So these are the object-oriented principles. So you see, we have basic object-oriented principles like abstraction, encapsulation, inheritance, polymorphism. Then we have class and object. We'll look at each one of them. So what is an object? So if you ask me what is an object, object is basically anything which can independently or uniquely identify itself. In fact, we ourselves is an object. We can uniquely identify ourselves maybe using Aadhaar ID, that is for India. In US, maybe social security number. We ourselves use a unique identity, right? And we ourselves have certain attributes. Attributes, the way we look at, the way we actually move our hand or legs, these are all our attributes. The way we eat, the way we behave, those are all attributes. Whereas the kind of operations we can do, like for example, we can walk, we can run, we can jump, we can work, we can program, all these are operations. Like you look at it, object is nothing but anything that can be uniquely identified. If you take an e-commerce word, a product catalog, like I was mentioning earlier, a product ID, product name, product description, these are all the attributes or the data part of it. Whereas the operations possible on it, like get product ID, get product name, get product description, those are all the operations that can be possible on it. So these all together becomes an object, but actually objects simply represents a unique entity. So object is nothing but not just the attributes part, which is the data. It also have some operations bind to it, where that is how you actually ensure whoever is want to talk with your data, whoever want to access your data, you are allowing them through your functions provided in the object. And it's the responsibility of objects to ensure the right access is given to the right clients. It's not like you have the data and you will publicly open it. No. Now, what is a class? Class basically is nothing but a template or structure. When I say structure, let's say, for example, we want to enroll our kids to a school. Now, what is the first thing you see in your mind? They will give you an admission form, and the admission form, only when you fill your child details, that's where it becomes unique to you. Otherwise, up to that point, it is just a structure, and that's the same admission form given to everybody. That admission form in our programming world, particularly object-oriented, is called class. It's a structure where it needs certain details. Only when you fill and put some data into it, that's where it becomes object. So class is nothing but simply a structure that consists of certain attributes. Now, in the programming world, what and all and where and all places we can create these classes and what types of it? We can create class interface. We can create class with blocks. We can have class with constructors. We can have nested classes. We can have class with methods, fields, or variables. So overall, if you see, you can create interfaces. You can create class blocks, constructors and class, nested classes, classes with methods, and classes with fields or variables also. Now, what does it mean by abstraction? So abstraction simply means you will give only the details it is required, and you will not worry about what are the details it is not necessary to you. Like for example, let's say if I want to drive a bike, what is the minimum thing I need? In order to drive a bike, all I need to know is how to kick it, then how to accelerate it, and how to handle the steering. Do I need to know how the engine functions internally? Do I need to know how the circuitry works? That is all hardware I don't care about, right? So this is called abstraction. Abstraction means you refer to the essential characteristics of what is required rather than worrying about how it internally works. So internal details which are not necessary, it will be hidden. And believe me, every human relies on abstraction on everything. There is nothing one thing you can say I know end to end. Everything. Starting from the way you wear the t-shirt, everything we rely on abstraction. Now, what is encapsulation? It is more about binding together this data and functions related to that data together is called encapsulation. And why it is important? It is important so that when some other class want to talk to you, you have a way in object oriented to prevent it by saying, no, I will not let this data accessible to you, or I will control the data so that only the class functions can access, only the functions within it can access, not anybody outside. So it is like tightly packing together or coupling together both the data and functions so that I can give access only to the particular customers I know, only to the particular classes I know. Beyond that, if anybody is there, I don't want to give access to them. All that you can control. Now, like that we talked about, like encapsulation is more about binding together methods and functions. So members are nothing but data here. So when you say members, I would say members means both methods and functions, methods or functions and data also. So here, if you see in this, when you say data members, it is purely about data. Here it is about functions. Now, whenever somebody want to access this data, you have a control through methods where anybody who want to access, they have to talk through these methods. That means you are putting one more guardrail or interface to access your data rather than availing them access to the data directly. That way, more security is ensured. At the same time, you are ensuring that nobody can access your data publicly. Even you can write a code in such a way so that only some of the confidential data can be accessed only by some of the private methods you have written it, not by any public methods it is accessible, when that is also possible. This and all is only available and possible because of the way encapsulation is done. Now coming to inheritance. Inheritance is more about how you acquire features of a superclass to a subclass. Here in this case, if you see, I can take a sandwich with a coffee or a hot coffee or frozen coffee, any one of them. So all this, it's like sandwich is inheriting from coffee, hot coffee, frozen. So it is more about inheriting it. Like simply, besides this example, if you look at, we inherit some of the features from our parents, like our mother or father, and sometimes from our uncles. So that is actually an inheritance. You acquire property from somebody upper or your ancestors. So here in this case, it is sandwich where it is inheriting some of the features. Similarly, if you see ice cream is inheriting from a frozen base class. So something like that. And inheritance helps you. The main advantage of inheritance is reusability. That means if you write one time and you can use the code multiple times. That's what the slogan Java also make. And other than that, let's say any other guy who want the same functionality, rather than rewriting, they can simply extend your class and use it. That's another advantage you have. It's more about the reusability. And automatically all the things like overriding, dynamic binding, overloading, all the things automatically comes with inheritance. Now, what exactly is polymorphism? Polymorphism is nothing but one interface and many forms. Like for example, when I say one interface, like let's say if you consider me, I am a trainer in some X company. I am an employee in other company. I am a father of two daughters. I am a son of a mother. So if you see, I'm playing four roles here. And in each instance, I am the same person. So I am a polymorphic object here, isn't it? Because I'm not changing. I still remain the same, but I have different roles to play together. That is called polymorphism. Polymorphism means one interface, multiple forms. Based on the situation, if a particular function is behaving differently or a particular operator is behaving differently, that's called polymorphism. And Java supports two types of polymorphism. One is compile time, another is runtime. So for compile time polymorphism, one example, or before giving an example, what exactly is compile time polymorphism is any binding or any polymorphic thing happens during compilation time is called compile time polymorphism. Whereas during the execution of the code or while code is running, if there is any polymorphic binding happening, that is called runtime. That means during execution time. So for compile time polymorphism, when you actually overload your code, that means you write some set of overloaded methods, those and all happens during your compile time. Whereas when you actually execute the code during the execution time, if there is something like overriding, so where actually you can customize your code than what you have in the super class, that really happens at runtime or execution time. That comes under runtime polymorphism. Now here we see how we will install and work with Eclipse. Eclipse, by the way, is one of the popular IDE. IDE stands for Integrated Development Environment, and it helps you to develop your code faster. And these guys will help you to get some auto suggestions, improve debugging. You can easily identify errors, easily identify if there are any warnings, if there are any particular packages are missing, or let's say classes are missing, it automatically highlights that. So all this will be easily done. Instead of that, when if you just write in Notepad, unless the code compiles and gives an error, you will not know. So that is where this Eclipse really helps. There are other popular IDEs also apart from this, like IntelliJ and all, but Eclipse stands one of the best IDE as of today. And you can go to this particular URL to download that particular Eclipse, and you have both the open source as well as paid versions also. All we need is just the community supported free Eclipse software, and that is more than enough to work on the things we discuss. So this is how it looks like, and you can just click on this and it will download the 64-bit for your Windows operating system. Good part of this particular website is if you go on a Mac system, it automatically identifies the relevant version for you. You don't need to do much effort, do not spend a lot of time to figure out what is for Mac or what is for Unix and all. It automatically figures it out for you. Now after that, you will get one more download click button. Just do it. It's like a 2-time download click button for you. And after that, it will get you something like this. In Eclipse installer, it will download. In Eclipse installer, you have different things where it says that if you are an enterprise Java developer, C or C++, you have different software for available for each of it. Since we are all going to work on Java, you can install this particular guy and it automatically creates that Eclipse IDE for Java developers. Now, once it is done, it will start installing. Once you click on the installation button, and after that, once you say launch, it will be launched. And this is how it looks like. And all your Eclipse thing by default stored in this Eclipse workspace. In fact, if you want to change the path, you can always change this location. But this is the default one it identifies, Eclipse of F1 workspace. And this is how you create a Java project where you can just click on this Java project and you can do. There are other things also, but this is the basic thing or the common thing most of the time we need it. And these are all Eclipse shortcut. That means once you enter into Eclipse, if you want to do something like, navigate to edit history or do some matching bracket, all the shortcuts are listed here. So there are a lot of shortcuts. And rather than by hearting, I would suggest like over a period of time when you're working on it, maybe you should start getting one by one, because by hearting all that, there are some of them listed, even more than will be there if you look at Eclipse documentation. I would suggest start looking at it now and then and keep understanding one by one so that over a period of time you can easily master all the shortcuts. Now this is the first program we can write, and most of the time the first program will be hello world. Here we started with welcome to my Java tutorial. This is how your basic Java program looks like, and you can see every Java program will have a class like this. This is the welcome class we have created. In that it will have a method with the signature called public static void main, and it will have a string. This is a string array, and it will have a parameter called args. This is the default signature you have to use for any main method which you write in Java. And this is system.out.println, which is the function, or here in this case system.out.println helps you to print something on your stdout. Here in this case it will be your display terminal, but sometimes if you want you can send to file also. That is also possible. Here in this case it tells that Java that just print welcome to my Java tutorials, and after that give a new line. That is what this does. And all your code, if you look at, it is surrounded by flower braces. That means the code starts here and ends here. Whereas this function code starts here and ends here. And in Java, if you want to do a single line comment, you can use double slashes. That is one single line comment. If there are multiple comments, you can use \*, just like the C way, so that you can include multiple line comments. Now, once you click this run, here is the run button. So it shows in your editor console. which is your Eclipse. The output shows up here. So it says print system.out.println, welcome to Java tutorials, and it shows up here. You can also execute this program from command line also. Eclipse hides you a lot of things like Java, C, Java and all. It all takes care by itself. It will not just show you that. It is like kind of abstraction. Whereas if you really want on your Windows or Unix machine, you can do that. One thing you need is Java C, which is a Java compiler, as well as the JVM, which is this Java. These two programs are required. So Java C is to convert your welcome.java program to a class file, which when you do this, Java C welcome.java, it creates a class file called welcome.class. And once the class file, which is nothing but the bytecode, is created, if you want to execute it, that is where you need this JVM program, which is Java welcome, and it executes your bytecode. And the output is welcome to my Java tutorials. Let's discuss about the basic elements of Java. So these are the basic elements in Java, like variables, constants, literals, declarations, conventions, and the Unicode characters. And apart from this, if you see, there are like these parts also comes in basic elements like operators, how the precedence of the operators is when you have multiple operators, which one takes the priority and why. Then we'll also discuss about how they operate, how the data type conversion happens from one data type to another. We'll also discuss about what are the different types of loops and what are the different types of control structures we have, which includes if and while, for loop, all that. Starting with Unicode characters. So first of all, what is Unicode characters? Before that, understand why it is required. So any character which you use in code that has an internal representation, right? So when I say internal representation, every code computer cannot understand A, B, C, nor it will have its own encoding logic. So earlier it used to have something called ASCII, which stands for American Standard Code for Information Interchange, where that will have some 138 characters or 256, something like that. So what really happened was it was not able to hold any other language characters apart from English. So that became a big barrier, because when you say, actually in the real world, when you see, there are a lot of other symbols apart from just English characters, right? So how can all that be included? That is where the thought process of Unicode character schema came in, where they said we can support multiple language character codes also. And Java supports Unicode character coding scheming, where it is a 16-bit character encoding scheme, and it can represent every character of all the known language we are aware. That's what called Unicode. And this is the problem, like I said, same code value represent different letters, large character encoding problem. Like I said, ASCII earlier used to have these problems, and that is what got fixed by this Unicode, where it supports multi-language. It uses a 2-byte schema and uses its lowest value as 0000, which is in hexadecimal, and it can go up to the 4 F characters of hexadecimal. And this \U represents Unicode. Now let's start with variables. So what exactly is a variable? So variable, you can say any particular name which refers to a particular memory location, or any ID or any entity which actually points to a particular memory location is called a variable. So let's say you have created x equal to 10. That x equal to 10, for you it is just a name, whereas internally what happens is this 10 will be stored in a memory location, and that memory location is pointed by this x, and that x is your variable. And in Java, variable declaration is mandatory because it's a compile time language, and you have to declare everything you are using. So only then it knows how you are supposed to use that variable and how the conversion has to happen, all that it will understand. And these variables can be changed during program execution also if required. Now this is how you can see the syntax of a variable is. You will have a data type first, then you will have variable. If you want, you can initialize the value there itself. It is all optional. Similarly, you can have multiple variables like this. So let's see this. Here, if you see, this is the data type, and you have v1, v2, v3, 3 variables you have declared. So here we are saying declared. That means we are telling Java that v1, v2, v3 for this program, they will be of the data type integer. That is what we are trying to say. That's why we said declaring. Then once we declare, The other way you can also do it is, apart from this, if let's say you want to initialize v1 with something, v2 with something, v3 with something, either you can do separately or as part of the declaration you can do like this, where you are saying int v1 equal to 10, comma v2 equal to 10. So you are initializing v1 and v2 at the time of declaration itself. That is also acceptable in Java. Now, when you look at variable, there are different types of variables comes in, and basically there are three types of variables you can identify. One is local variable, instance variable, and static variable. So what exactly is local variable, instance, and static variable? Let's see one by one. So what is exactly a local variable? So local variable is nothing but a variable which is specific to a method. That means beyond that method, nobody knows about that variable at all. Okay, so that means, like, for example, let's say you have written a function saying greet hello. In that you have used a variable called x, and that variable is only known to that function greet hello. Beyond that, even if somebody wants access, it might not be available. So that is called local variable because it is local or bounded to that function only. So the advantage with the local variable is the same variable you can use in other function. That is the biggest advantage. With that, you can easily maintain or avoid the namespace collisions, which generally happens when you use the same name across multiple functions. Here in this case, fortunately, we have the local variable, and that helps in getting all this. And one rule to remember is local variable cannot be defined as static. And another thing is, all this local variable initialization is just mandatory because certain variables in Java are by default initialized. Even we don't initialize it, we will talk about that. Now coming to instance variable. Instance variables are something when you create an object, whatever the object variables as part of the, we are talking about object as data, right? In that there will be some data and all. That data part is called the instance variables. So that instance variables by default gets initialized to 0 if they are integers. If they are strings, they will be initialized to empty string. If they are float, they will be initialized to 0.0. So based on the data type, it will take the closest initial value and do it. By default, we don't need to do it. That's why I said local variables you need to initialize, whereas here instance variables you need not. But it's always a good idea using constructor or some mechanism you initialize the variables. Coming to static variable, static variables are variables which actually you put static before it. So these variables are moreover, I would say, a common variables that is required for multiple, instances of the class. Like let's say you have created a student class, and in the student class you have 40 or 50 students. So each student is an object, and there is one variable called the number of students. That number of students is something you need to count whenever a new student joins into that class, isn't it? That number of students, you can make it as a static variable. That means the same variable will be updated by everybody whenever joins it, and the same variable will be visible to all the objects as it is. So that kind of variable which is common across multiple instances of the same class are called static variables. And you can always create that variable by putting a static keyword before it. And the initialization of static variables is also not mandatory. It will be the default initialized to 0. And if you want to access the static variable, you can always give the class name, and you can say class name dot that variable, and automatically you can access the static variable. Let's see in this program how do we identify it. Like starting with local variables, if you see here in the method, whatever we have written, this n equal to 90, this is your local variable. This no equal to 90, understand that outside this method, nobody knows about it. This is only bound to this method, and this must be initialized. And this cannot be accessed anywhere from outside. That is why it is called local variable. The scope of this variable is limited to this function only, and nobody can see from outside. Whereas if you look at here also, we have a local variable if you closely observe, because main is also a function just like that. We know that it is a standard function by Java, but if you look at theoretically, this is also a function. So this also needs some variable which has to be initialized. And you can see this is also another local variable. Whereas if you see, there is another type of variable we have, which is static int v equal 100. This is a class or static variable which can be seen by multiple instances of the same class var. That means, let's say I have created 5 or 6 objects of this capital VAR, which is var. I can have access to the same v variable across without any changes. That means I just need to say var.v and I can access this 100 automatically. So it acts like a global variable to all the instances of this class var. Now let's understand about data types. So data types generally in any programming language is divided into two types, primitive, non-primitive. When they say primitive, it means mostly the data types which are like the standard ones or something like basic data types. That's what they mean. Non-primitive means based on this primitive, whatever it is built on top of it, those are called non-primitive sometimes or advanced data types. And Java, we have huge number of data types. Like if you see this table, you can easily understand that under primitive, we have Boolean type and numeric type. Again, under numeric type, you have different types altogether, and each data type has its own importance. Now, these are the limits and the default sizes and the range of values they can allow on each data type. For example, if you look at character, the default value will be initialized to a Unicode character, all 4 zeros, and it is a 2 byte, and it can take any value from 0 to 255. Similarly, every data type has its own limit if you observe. Now coming to constants. So what exactly is a constant? Constant is any value which is fixed in nature. That means something which will not change. Something like a pi value. Pi value is 3.14, right? So that will never change. These kind of fixed value, if you want to create in your program, you can use this constant. And how do you create the constant in Java? You can use the static final and whatever data type you want to give, like integer, float, you can give, and you can give the variable name and value, and it automatically create a constant value for you, which can never change. Now, what is the advantage with this constant, for example, is this, for example, if you see this double rate here, it is declared as a constant. That means this 586.78 will remain as a fixed value and nobody can change it. Since you have static final as part of it, the advantage is nobody can change it and everybody can see the same value. Because of final, it is not possible to edit as well. And it has to be initialized as the part of the declaration also. It should not be doing after declaring then initializing. That means you cannot say static final double rate, then you want to initialize rate to something else. That is not possible. You have to do the value initialization while the declaration time itself. Now, apart from this, we are talking about just one constant value. What if you want to create a set of constant values? That's where the enumeration comes in. So the way to create enumeration is like that. So enumeration is nothing but where you can create a set of constant values. So you can see this enum colors of rainbow, there are like multiple constant values. All these are constant values which you can create just by using this keyword enum. And the way to access this is like either you can use this colors of the variable name dot values, which will get you all the constant, and you can put in this enhance for loop and it automatically prints that. But one thing to understand here is if ever you want to access any of the value, you can just say colors of rainbow dot violet, like that you can access all the values. Now what is the literal? Literal is actually more of a fixed value, just that on the source code side of it. Like for example, if you see here, the product equivalent 800, this 800 is the value. Just one difference is like it is a fixed value altogether, but you can change it whenever you want. And these are all assigned mostly to your primitive data types, all the basic standard data types we have. Now, let's talk about convention. So what exactly is convention? Convention means some rules we follow as a best practice. Okay, rather than saying I will do this route, you will follow the route where most of them think or considered as best practice. You will follow that route. Like simply saying, like let's say people have said we have to walk this way, you will all walk in the same thing. We will not walk in a twisted manner because everybody conventionally it is identify that walking straight is the best way. It is not like you walk twisted manner, people will look at it differently. That is a convention. It doesn't mean that you cannot walk in a twisted way, just like snake and all, right? So the convention here is nothing but a set of rules or principles people consider that it is good to have, and if people follow, it has its own benefit. That is what the convention is. Like for example, if you see, everything has a convention in Java. Like for example, starting with class, package, variable, constant, method, everything has set of rules. And if you follow, it has a good amount of benefits. Even if you don't follow, there is nothing wrong in it. But understand, when you are in industry, you are supposed to follow all these good practices so that when you write the code, it will be full of best practices and it will be foolproof and it will not let anybody point out that you haven't followed the best practices and all. So it will make the code more readable. That is what the overall objective is. Now, first rule, every identifier. When I say identifier, it could be a class name, it could be a function name, it could be a method name, it could be a variable name, any variable name or anything like that. It must always begin with a letter. Okay. Or if required, after beginning with the letter, if required, it can have two special characters, either the dollar or underscore. That is the only thing allowed. And after the first character, you can have any number of combinations of letters, digits, or this dollar underscore. That's all. And you cannot have any special character beyond these two. And these all identifiers are case sensitive. When I say case sensitive, there is a difference between small a and capital A. And reserved words, that means reserved words like enum or reserved word like static, they should not be used as identifiers. That is another rule to remember. Now, these are additional set of conventions. All your long names, like for example, let's say I'm writing a code like get product name. So when you say get product name, Java follows this camel casing, which means you can write this get with G small, product name with P capital, and product details D capital. So that means G small get product P capitals and details D capitals. So this is called camel case. This is the convention Java follows. So that is one convention you can follow so that it looks more readable. And all the constants you have to write in uppercase. This is another convention. And if at all the constant is big in nature, you can separate it with underscore. Let's say you have a constant called pi value. You can put everything in uppercase and you can say pi underscore value. And all the object names which you create, like instances of a class, they should be declared in a log class, lower class. And if at all they are big in nature, you can still use the camel casing. You can see the camel casing. The first letter is small and the other words followed of which will have a capital letter. And all the packages must be in lower case. And if they are, the big enough, and if they want to separate it, you can always separate by using dot. Now, let's talk about operators. What exactly is an operator? So operator, I would say, is any symbol that performs certain type of operation. That operation could be arithmetic in nature, it could be binary in nature, doesn't matter, it performs some operation. Okay, and for doing some operation, it actually takes set of values as inputs. That value could be constants or variables. So either of them it could be. So this is called as operands. That means operator is nothing but which act on certain operands, and those operands are your constants or variables. Now, these are the different types of operators we have. Like we have relational, shift operators, arithmetic, unary, bitwise, logical, ternary, and assignment. What does it mean by unary operator? So unary operator means any operator that just works on one operand. It could be a constant, it could be a variable, it doesn't matter. Only one operand it will work. So what are the operands that can work like that? You have plus plus I, that's an unary operator. I plus plus, that plus plus is again unary operator. Let's say you want to say minus 1, that minus is an unary operator. And let's say you want to change the value of a boolean to true to false or false to true, you will negate it. That's again an unary operator. Like here in this case, if you see this a plus plus, this is unary, this is also unary, this is also unary, and this is also unary. So it is, if you observe, the one thing common is they all work on one particular operand. That is the important thing to grab here. And what this program does, it just takes the 50, first prints 50 value, then it increments, then it becomes 51 at this point. Then here you are incrementing it, then using it, that's where it becomes 52. Then after that, you are decrementing it. Before that, you are using the value, so it prints 52. Then you are decrementing it, it becomes 51. And again, before using, you are decrementing it, so it becomes 50. So that is what it is doing. It's a simple program just to manipulate the particular variable by incrementing or decrementing. Now, what are the different arithmetic operators we have? We have basically addition, subtraction, division, modulo, and multiplication. Now, if you see, this is the addition operator where it just adds 20 plus 5. It makes the addition. And this is the subtraction. This is multiplication where it will multiply 20 by 5. And this is your division. So in division, understand that it will give you the quotient part. If you generally do the division, you will get the quotient part, right? That quotient part is what it gives. That means 5, if you divide by 20, I think it goes by 4 times, right? That 4 times is what comes as division. And percentage is nothing but something which gives the remainder. That means 20 percentage 5, the remainder if you look at is 0. That is what it gives. So these are arithmetic operators because they moreover perform some kind of addition, subtraction, multiplication, all arithmetic related operations. Now, what are shift operators? Shift operators are nothing but given a number, if they are able to shift or move the bits of a number to left or right, those are called shift operators. Okay, and Java have less than and greater than operators where it can do the shifting of left or right. So these are the operators available. You have less than left shift, greater than right shift, and you have unsigned right shift as well. So what really happens is, so this 20 will be converted into binary first, and after that the bits are moved, 2 bits are moved from the left hand side. Similarly on the right hand side. Okay, this is what happens, and whatever after moving the bits, whatever the value it comes, binary value, that binary value gets converted into decimal and shows up as yes. So here you see 20 less than 2, it actually moves 2 bits of it, and there will be a binary value coming out. That binary value converted to decimal is what is 80. Similarly, you can try for others, and when you do just a binary calculation, you can get these numbers altogether. Now, what are relational operations? Now, if you look at relational operators, any operator that is used to check if there is a relation between two operands, or if there is a particular checking to say whether there is any relation you can establish between any comparison. Sometimes relation operator is also called as comparison operator. Let's say A greater than B. You are checking is A value greater than B. Or I want to check if the weight of a one person is greater than another person. I want to check if this guy is smarter than another person. All this comparisons comes under relational operators. And we have a bunch of relation operators here, like equal to, not equal to, less than equal to, greater than, and greater than equal to. Everything helps you to just see or compare whether these two operands are equal or not equal, like that. And the result of always these relation operators will be Boolean in nature. When I say Boolean, either it will be true or false. And these will be mostly used in your if conditions, while loops, for loops, all that. Now coming to bitwise operators, like the name says bitwise, that means these operators work at the bit level. So let's take an example. If you take m1 equal to 60 and m2 equal to 13, so the binary value of m1 equal to 60 is this, the binary value of m2 equal to 13 is this. Now when you do ampersand, pipe, or cap, or tilde, these are all the bitwise operators. So what does ampersand do is, ampersand, the way it works is, it will check whether two bits are equal. Equal in the sense, it checks whether two bits are same, and it must be 1. So here understand that both the bits must be 1, then only the result will be 1 in the case of ampersand. Here if you look at 0 ampersand 1 is 0, whereas 0 ampersand 0 is 0 because both the bits must be 1. That is the rule and follows this ampersand. Whereas in this case 1 1 it is 1, 1 1 it is 1. So that's why you see here it is 1 1 and 0 0. So wherever the two bits are both 1, that is where this ampersand gives the answer as 1. Otherwise it will be 0. Whereas in the case of R, it expects at least one of the value to be 1. In this case, if you see 0 1, at least one of the value must be 1. Here in this case it is just 1. So, and the other is 0. So even if 1 is there, even if 1 time 1 is there, it is fine for it. So it just prints 1. Whereas in the case both are zeros, that's why it is giving answer as 0. Whereas in this case both are 1, so it is giving 1. In this case both are 1s, so it is giving 1. So this is how the result of R ampersand will come out. Similarly, this is exclusive R. You have to look at XOR table to figure out how it works. But the same formula will happen where it checks. Whereas in the case of XOR, what really happens is it just checks whether the bits are similar or not. If the bits are same, it will give us 0. If the bits are dissimilar, then it will give us 1. Now coming to logical operators. So logical operators are something which perform some kind of logical operations. So when we say logical operations, if you want to build a bridge of relational expression, like let's say I want to say if A greater than B and A greater than C, how can I bridge these two conditions, A greater than B, A greater than C? That is where this logical operator helps. It can help you to combine multiple relational expressions altogether. So when you use AND, it combines that and checks if both conditions are true, then only the answer will be true. Whereas if you use R, which is 2 pipe, it will result as true only when one of the condition is true. If all the conditions are false, the result is false. Similarly, if you use logical NOT, it is to reverse the logical value of it. That means if the answer is true, it will give false. If the answer is false, it will give true. Now coming to logical and bitwise operators. Here we are doing just a comparison between what is the difference between ampersand ampersand and ampersand. So ampersand ampersand, if you look at the logical ampersand ampersand looks at the second condition only when the first condition is true, because for ampersand all the condition must be true, then only the result is true. So if at all, let's say first condition itself is false, there's no point in looking at other conditions when all of them are true, because for it every condition must be true. That's why the first condition checking it does, and only when it happens and happens to be true, then only it moves to the second condition. Coming to bitwise ampersand, here in this case, if you look at, it checks both it actually converts your number to binary, and it makes the condition value, whatever the value it yields, it will give you that value only when the 2 bits are 1. Otherwise, it will be always 0. So it checks at the bit level whether both the values are true, or you can say 1, then only the answer is 1 or true, or otherwise it is false. Now here is the comparison on how this works. So if you see here, we are combining ampersand ampersand, two relational expression. This is one relational expression, this is another relational expression. And the answer of this or this always will be in terms of true or false. You can see here it is false, false. So the answer will always be like that. So if you look at what we are doing here, 10 less than 5 and 10 less than M3, which is 20. So 10 less than 5, is it correct? 10 less than 5 is wrong. So here itself condition is false. So there's no point in checking. So automatically the entire result is false. That is what it shows up here. Similarly, the same thing, 10 less than 5 is false. So there's no need to go to check other condition. That's what we discussed in the previous slide here, this one. So automatically the result will be false. But here if you look at, one difference is it is ampersand, bitwise ampersand. So in the case of bitwise ampersand, if you use, this one will be checked. And once it convert, this one will be checked, and what is the result of it? It is false. Ampersand, this one will be checked, and if the result is true here, false and true, the answer will be false. Here in this case, since anyway it is false, the entire result will be false. Now ternary operator. So ternary operator sometimes is also called as conditional operator. So what does a ternary operator do? Ternary actually means 3. That means any expression which have 3 operators to do its job is called ternary operator. It is more of a, you can call it as a short form of if else. And this is how syntactically it looks like. It has a condition, and where when the condition is true, this part, whatever you have written expression here will get executed. If it is, this condition is false, the expression you have written after colon will be given importance. And here is how we have used a conditional operator. Here we are trying to identify the minimum value. So what we have done is, we have put 200 less than 500. Since 200 less than 500 is correct, so it will give the m value, which is 200. That means minimum is assigned with 200. Let's say if this is false, the n value, which is 500 in this case, gets assigned. But here in this case, 200 less than 500 is true. It has given this m value, which is 200, and assigned to min. So that's why the answer is 200. Now coming to assignment operator, any operator which assigns a value on its right hand side value to its left hand side is called assignment operator. And the basic assignment operator is equal to, apart from that there are other flavors like plus equal to, minus equal to, star equal to, slash equal to, but the basic one is this equal to. So what does this do? So you can see 30 is getting assigned to M1, 40 is getting assigned to M2. After that, using M1 plus equal to 4, which is nothing but M1 equal to M1 plus 4, it is incrementing or updating the M1 value with 4. That means M1, now it is 30, it becomes 34. Similarly, M2, which is 40, you are decrementing by 4, that means M2 becomes 36. And that is value getting printed here. Now, operations precedence. So why it is important? So operators precedence, why it is important is, let's say if you have multiple operators used, let's say you have used 1 plus 2 into 3 or 1 plus 4 into 5. So there are like plus and star. Now, if you ask somebody which one is it, like multiplication gets evaluated first or plus gets evaluated first, that's where you need to understand how the operators precedence or how the operators are given priority. That's the topic of this operator precedence, where according to Java, this is how the precedence is considered. First, always the postfix operators are considered. then the unary ones, then multiplication, additive, shift, relational. So in our example, 1 plus 2 into 3, the 2 into 3 gets executed first. Then it will calculate the result of that with 1 plus. That is how it happens. So based on this precedence. And you can see how it associates. I mean, how the evaluation happens is also given, whether it's a left to right or right to left based on the operator. Now coming to typecasting or type conversion. Typecasting is nothing but converting a data type from one data type to another type is called typecasting. So you can convert any primitive data type to another provided they are compatible in nature. And there are two types of typecasting possible. One is widening, another is narrowing. Widening is like going from a smaller data type to a bigger data type. Narrowing is going from a bigger data type to a smaller data type. That means widening, let's say, if you are coming from character data type which has 2 bytes to going to integer which has 4 or 8 bytes, then it is widening. Whereas narrowing means if you are coming from integer data type and going to a character data type, which is like narrowing. You are coming from a 4 byte or 8 byte data type to a 2 byte data type. That is narrowing. Let's look at the conversion phase of how the widening happens. So like I said, widening, converting a lower data type to a higher data type. And this automatically happens. This is called implicit casting if something happens automatically. And you can see the byte automatically gets converted to short or int or long or float. This automatically happens based on the compatibility of the values and all. Whereas this is the example where you see whenever I say character equal to f, c equal to f, which is capital F, and when I say v equal to c, actually c is a character. How can I assign to integer? So in this case, it automatically gets the ASCII value of it. ASCII value of capital F is 70. The ASCII value of capital A starts from 65. So from there, if you count, all the capital letter F comes as 70. And that is the number assigned because you are asking about an integer number of this. Since it does not know what is the integer of number of capital F, it gives you the ASCII value and that gets assigned, and that is what getting printed here. This is called widening because you are converting from a lower data type to higher data type, and it is implicit. Automatically happens. You are not saying physically to which data type it has to convert. Now coming to narrowing, this is explicit in nature and we have to tell explicitly that this is what I want you to do. And here every time you have to convert from higher to lower data type, and the way it happens is like this. These are the compatible data types: double to float, float to long, long to int, short to byte. Now you can see this narrow example where here we are getting input from user, we are getting an integer from user, and we want to convert to character. That means a lower data type. So you have to explicitly give this. You can see in parentheses, you explicitly have to mention about this, saying you convert this integer which I have taken to character. That means here in this case, I am giving a number 70. For that, I am asking it to convert a character value. 70, how can it convert it to character value? It actually looks at the ASCII value of it and just stores the ASCII value, which is nothing but capital F here. That is what gets printed here. Let's discuss about conditional statements in Java 11. So what exactly is conditional statements? So when you see conditional statements, they are statements which help you to control other flow of statement based on certain condition. That means you evaluate whether a condition is true or not, and based on that you will say execute this statement or not. That's what exactly mean by conditional statement. And in this we have different types of if statement comes in. Like if you see, there is an if statement, if else, else if ladder, and a nested if statement. All that helps you to control other set of statement based on certain criteria. So you will check, you will have for all this if conditions, you will have certain condition that will help to evaluate whether a condition is satisfying or not. If it is getting satisfied, then only it will let the statements inside it to execute. That's what the whole purpose of these if statements are. Now let's start with the simple if. I'll call it as a simple if because it does not have else, it does not have other types of elifs, or it doesn't have any nested if. So if you look at this, there is if condition and set of statement. This is the syntax. So syntax is nothing but how you write it. That is what called about syntax. Now in this, the condition can be any relational expression or a combination of relational expression with the logical conditions. Okay, so if you see, if this particular condition which we are seeing here, only when this is true, whatever statements you have put it will execute, otherwise not. Like I said earlier, conditional statement means only when the set of condition which you have put, it could be simple relation expression like a greater than 0, or it could be something like a greater than 0 and b greater than 0 and c greater than 0. By using this logical operators like ampersand and using relational expression, you can even build a set of big conditions, and all that only when it is true, then only the set of statements executed. Okay. Now, here you see an example. In this program, if you see, we are initializing the ES variable to 60. And whenever this ES variable is greater than 18, then we are saying your age is greater than 18. So here in this case, this will obviously be telling you your age is greater than 18 because your ES value is 16. Let's say if the ES is 9, in that case, it might not have printed anything. Which if you look at from customer point of view or a user point of view, that's not a great thing to do, right? Because ideally when the age is not greater than 18 or ES is not greater than 18, ideally it has to say that you are lesser than 18 years, but that is missing. And the whole purpose of if condition is to just say, okay, this condition true, just execute the statement. That's it. It will not do any other case like when it is false or you want to check one more condition. No, that is all not possible. Now, how to solve this? That is where our if else comes in. So if else helps you to not only say when this condition is satisfied, what is the statement to execute, but also it will help you to execute other set of statements when a particular condition does not meet a certain criteria. Like let's take an even number, odd number scenario. When a number is even, you can put that here in the condition saying if a number %2 equal to 0, you can say it is an even number. If it is not, then in the else you can write it is an odd number. So else is like a fallback. It is like, whenever the if condition doesn't satisfy, it directly comes to this else and execute whatever statement. So you can always call it as like a fallback statement or an otherwise. Now how we solve this? Even in fact the ES problem which we have seen here, that also could be solved by else here, where what you can do is if ES greater than 18, you can put this as system.out.println your age is greater than 80. And after this flower braces, you can even put else and you can write system.out.print your age is not greater than 80. That also can be done using if else. So we are solving the first problem of simple if with using if else. Now in this case, if you see, this is the same example I have cited earlier. There is this number which we have hard coded here, which is 126, and it's checking whether it is even or not. If it is even, it just prints even number because it checks 136 %2 equal to 0, which is even because it's divisible by 2. So it prints even number. If it is not, let's say I have given 127 or 139, which are not even because they are not divisible by 9. You will have the remainder 1, something like that. So in that case, it will print odd number. So you can think else like a fallback, or otherwise, if this does not happen, what you want me to do, that kind of thing. Now, why we have to go from if to if else? If to if else we understand because if does not have a fallback mechanism. That means whenever a condition is true, it just prints the statement. But what if the condition is not true? It doesn't do anything. That actually solved by this guy called if else. Whereas when we have this, now the other question comes up, like why we need to learn other if statements like this. This is like elif or elif ladder. Now the question revolves around like this. Let's take a scenario. Why the name else if ladder is, you can see a set of else if statements are there just like ladder. Okay, and you have an optional else. If you want, you can write it, otherwise not. The way this guy works is whenever this condition is satisfied, it executes all the statements inside. If this condition is false, then it will give the control to the other else if in the same embedded else if statement. If that is true, it will execute. If let's say that is also false, it will go to this. Let's say that is also false. Whatever else if are there, it will keep on passing it. And let's say nothing is true, none of the conditions meet, it finally gives to else if there is an else available. Otherwise, it will just come out from this if else condition with this particular elif ladder thing. So what you need to understand in the else if is only at any time one of the condition will be true. And even if one condition in between or anywhere is true, it will skip all the other conditions you have written inside else if and come out of it. So it tries to check all the condition, it tries to check one condition after another. Only when the first condition is false, it will passes to other else if. If it is false, it passes to other else if, like that. That is how the flow goes. Now, understand in what scenarios this else if is used. Just remember that whenever you have more than 2 possibilities to check, else if fits very well. So let's understand with an example. Now see this is what I was talking about. So here in this case, if you see, the number is 155. and we want to check whether number positive, negative, 0. If we have just put if else, understand a scenario, if you just put if else, when it is positive, it will say positive, else negative. But even in the case of 0, this might not be true. So 0 also it will say negative, because if else is made only for two possible cases, not beyond than that. Then how to handle it? That's where our if else if or else if ladder comes, where you can clearly see we are checking multiple conditions. Is this number greater than 0? Yes, we will print positive. Is this number less than 0? Yes, then negative. If not, if none of them, either positive, negative, both are not there, then what is the only possibility? 0. That's what gets printed. So you can see that having multiple conditions like that help you to handle multiple use cases. Now, nested if statement. So what is nested if? Nested if is nothing but a set of if statements embedded inside one another. That is called nested if. That's why the name nested. Nested means something embedded inside another or something inside another. So you can have multiple if statements like this. Sometimes these kind of if statements can be written with one if by just putting if condition, ampersand, ampersand, another condition. That also works. But there are some use cases where you have to do like this as well. So this is an example where you see we have picked the input from the user by using the scanner. Then we took the age from the user, and again we took the input as integer. Then we took the weight from the user. We took an integer weight. Then we are checking if age is greater than or equal to 18. If at all age is greater than or equal to 18, then only we are entering into another if condition inside where it checks whether weight is greater than 50. That is how this nested if or embedded if is useful, where only when a particular condition meets, it lets you check another condition. It is like you can say first level condition, second level condition, third level, like you can have as many if conditions inside one another as possible. So you can see it checks age greater than or equal to 80, then only 18, then only it checks if weight is greater than 50, then it says you passed eligibility test and you're eligible to donate the blood. But what if age is not greater than or equal to 18? It will not do anything. Maybe we can add an else here for this if, saying else age is not greater than or equal to 18. So we are not checking any condition. Something like that to make it more useful to the user. Otherwise for user, whenever he enters age less than 18, there's no message comes in. So you can see this is how we pass the input. We ask age 20, we pass the weight, then we confirm it. Whereas whenever he gives less than 80, we will not get any message. So there is still a chance to improve this program by maybe after this flower braces, you can put an else and say that your age is not greater than or equal to 18. So I'm not doing any tests. So before we jump onto the loop, to summarize, understand that this particular if statement is useful only when you have only one possibility. Anywhere you have only one possibilities, you go for if statement. Anywhere you think there are two possibilities for any use case, then go for if else. If there are more than two possibilities are there, then go for if else if. That is how you should look at it. Like this could be just you want to check whether a number is greater than 10. That's it, done. Whereas this could be, let's say you want to check whether number greater than 10. If not, you want to put a message saying number is not greater than 10. Maybe in that case, if else is useful. Maybe in this case, if else if, you have to think like, let's say you want to check number greater than 10, number greater than a number multiple of 5, number multiple of 10. Different conditions are coming and more than 2. If there are more than 2, you should go for if else if. That is how you should remember. Nested if is more about when you have multiple levels of conditions coming in and you have to do multiple level checks, then maybe you can use nested if. But most of the time, these nested if can be optimized by writing single or 2 or 3 ifs rather than having so many nested structure. Because having so many nested structure sometimes make the code readability not very great also. So that also we should keep in mind. So that's more about the conditional statements. So what exactly is a loop? Loop is nothing but any entity that repeats your set of statements again and again. That's what called loop. Now, Java has multiple loops. In fact, Java has 3 different types of loops, and even for loop has multiple varieties anyway. So like I said, loop is nothing but you actually use the looping statements to repeat a set of statement. And why we need it? If we don't do it, we'll end up writing the same statement again and again and again. So loops actually help us to make the program optimized much better than what we have earlier. So you have 3 types of loops: for loop, while, and do while. So what is the difference like between these and where should we use it? So if you see, a for loop is generally used when you know that this many times the loop has to run. That means you should know how many times the loop is going to continue. In fact, I could say as a short form, finite number of times. If you know loop has to run 10 times, 15 times, 16 times, you can go for loop. Okay, that means in this case, you should know how many number of iterations or loops are going to happen. Whereas in the case of while loop, this guy also able to help you to run the code when you know the number of iterations or loops. At the same time, he has one more ability to loop when you don't know how many iterations also there. That means infinite loops. Let's say you want to run the loop, but you don't know how many times to run. So you might be thinking, what kind of use case is this? A simple use case could be your operating system, which runs in your system, is an infinite loop program. You can see that until you shut down, it keeps running it. That's an infinite loop program. And there are certain use cases where people write infinite loop programs, like your 24/7 systems, whatever you're seeing, those are all infinite loop programs. Until something is done, they will keep running it. So all those use cases, the while loop fits perfectly well. The only difference between for loop and while loop is while loop can work even for situations where you want to do infinite loop. Besides, it also helps you to write finite loops. Both are possible. Whereas for loop is only possible when you want to write finite loops. But in Java, for loop also you can make infinite loops. That is also possible. But the recommendation is to use for loop only for finite number of times. While loop, finite as well as infinite. Do while also same. Just that one difference in do while is, in do while you can write finite and infinite, and the same time you can write do while so that at least one time the statements inside that do while gets executed. That is possible because the way do while structure is that the condition checking will not happen at the beginning of or before entering the loop. The condition checking happens after one statement execution happen. That's why it actually ensures that at least one time the set of statements you write will happen. Now this is how the structure looks like for the for loop. There is an initialization part, there is a condition, and there is your step value. Either you want to increment or decrement. Whereas in the case of while loop, you have to write a condition what you want to do. Before that, you want to initialize whatever you have to write before it. And inside this while, you have to write the increment or decrement kind of. Do also, if you want to write initialization, you have to write before. All the terminating conditions you have to write here, and step or decrement value you will write inside the code. Let's understand about for loop here. So what are the different types of for loop we have, and what exactly for loop is helpful is what we are going to discuss in this particular section. So if you look at the advantage of for loop is to iterate off to several parts of your program. That means, let's say you're trying to print 1 to 10 numbers, you want to iterate one after another, for loop is very useful. And here one more advantage is you can make your iterations either fixed or unfixed. When I say fixed or unfixed, if you look at the simple for loop, which is this guy here, using this guy, you can make the for loop both fixed and unfixed. When I say fixed, it is like a finite loop. Unfixed means infinite loop. You can create either of them. Java comes with three types of for loop here. One is the simple for loop, which is more like a C style for loop. And there's a label for loop, and there is for each or enhanced for loop. So we will look at each one of them in detail. Now let's look at this with an example. So this is the first for loop, which is the simple for loop we have discussed. In this case, if you look at, this is how the for loop is, where you have, this is called your initialization part, this is called your condition checking part, this is your increment or decrement. So here, if you look at the same kind of format, it is followed across all of these, right? So let's understand that from beginning. So this is your main program. So once your main program starts in, now what happens? So first of all, this is the label 0, label 1. In label 0, there is a for loop running from a equal to 1. So first a equal to will be 1. And whenever a is 1, this b runs for 3 times. So that's why a becomes 1. And you see here, b starts from 1 to 3. You can see that here. For every value of a, the b also runs up to 3 times. And each time you see b starts from 1 and b iterates up to 3 times. That means b starts with 1 less than or equal to 3. Now 2, it gets incremented to 2. Again, 2 less than or equal to 3. Again, it will increment. 3 less than or equal to 3. That is also true. Then finally, when 4 comes, it will stop. So every time it will run up to 1, 2, 3. Now here in this case, what we are doing is inside this for loop, we are putting a condition saying whenever A is 2 and B is 2, you just break the label 1. So label 1 is what? The inside for loop or nested for loop. This is called as a nested for loop. Nested for loop is nothing but a for loop embedded inside another for loop. So here this for loop is inside this for loop. That's why it is called nested or inner or embedded for loop. So this embedded for loop when A equal to 2 and B equal to 2, you can see that in all these cases, whether it is 3 or 1, this is for B value, by the way, and this is for your A value. B value runs up to 1 to 3, B value runs up to 1 to 3. Both in the case of A is 1 and B is 3. Whereas when A is 2 and B is 1, B worked, but as soon as A equal to 2 and B equal to 2, so you see 2 and 3 is not printing because we are saying when A is equal to 2 and B is equal to 2, that place you just break this label 2. So label 1. That's the reason B after it is printing 1, 2 and 3 didn't happen. So this is how you can use break, which is like a loop control statements, where they can actually take you to the next for loop by just breaking the existing one. So you can do that. And this break and all you have to use inside loops only, not outside. So that's why you see the difference that it prints 2 and B value 1, 2 and 3 skipped because that is the place where A equal to 2 and B equal to 2 matches and it just breaks this loop. In this case, this is the loop gets break. Okay. Now, let's understand this is a simple while loop example. If you see here what we are doing. So this is our static void main. The program starts here and you are reading a variable and your variable is integer and you have set a scanners on system.in. System.in is nothing but your input stream. On that system input stream, the default one is your keyboard. You are reading it and you are saying, I want to read it as an integer after saying enter the number of values. And I, since we have declared as integer, it can take an integer value. So here what is happening? So first of all, let's say I user have given 5 in this case. Now what will happen? N is user is given as 5, or here we have configured it as 5 hard coded. Ideally, we should have put this as an N value and we should have taken this as an input from user as well. But let's consider for this program it is 5. Then I start from 1. 1 less than or equal to 5. It's correct. So it prints 1. You can see it is printing 1 here. Then I increments to 2. Now 2 is also checked whether 2 is less than or equal to 5. Yes. Now 2 gets printed. You can see 2 gets printed. Then 2 gets incremented to 3. 3 checks whether it is less than or equal to 5, which is true. Then 3 gets printed. Similarly 4, 5. And when 5 increments to 6, it will check 6 less than or equal to 5. No, in both cases, it is not correct. So that's where it breaks. So always remember when the while loop breaks, here in this case, the value of I will be always more than the value you have put up here. Whenever you say less than or equal to, the value will be more than that. That means it actually has to reach a point where it breaks the loop. That's why this condition we call sometimes as terminating condition. Okay, this is how the while loop works. Now, if we see the one kind of while loop which we have seen earlier, in this case, one condition is there that this while loop must always be true. When I say always be true, that means, even when it enters into the loop, that means when it starts its journey into the loop, as well as when it is continuing its journey in the loop, it has to be true always. It is not like there will not be any discount that first time, even if it is not true, it's okay. That kind of discounts cannot happen. Why I'm stressing more that on is there are some loops where they have that discount. And in that category, this is the guy who comes. Here in this case, to put it simple, this do while have a discount that first time there is no condition checking. He can enter. After that, the condition checking starts. That means this loop minimum will execute one time, irrespective of whether the condition is false or true. Because there is no condition checking if you see, it is just entering into the loop. Now, let's understand from beginning what is happening in this code. So if you see here, in this do while example, there's a main program which starts. And in this program, you are reading the scanner, which is nothing but your input stream, which is keyboard. And you are reading an integer variable. That's why you have declared an integer variable called s. And you are reading integer variable using the scanner method next int, and it is stored in s. So first time we will print s. What is s here? We have said like we will go up to 5 and s has to be given as 1. Now that 1 gets printed here and 1 actually gets incremented to 2 less than or equal to 5. So the condition is true. So it prints 2, it prints 3, 4, 5, and when keep on it increments the value like 2, 3, 4, 5, and when it reaches the value of 6, 6 less than or equal to 5, the loop you have to read it like this: while s is less than or equal to 5. But at the point of 6, when 5 gets incremented to 6, that's not true. So that's the point it makes a break call and comes out. But if you look at, as soon as user have given a value, which is what here in this case we are just asking what is the first number, please give it, which in this case we will give as 1. You can give it as like 2, 3, doesn't matter, anything less than or equal to 5, okay. But even if you give something greater also, if you look at this loop will still run one time minimum, because the condition checking happening at the end. That's why I said in the earlier case, the simple while loop, there's no discount. Every time the loop condition has to be true. But here, first time the discount is that. That means there's no condition checking. You can do whatever. Even you give 10 here, right? First time it will print the 10, because the condition checking happening after printing the value of s. Now coming to access specifiers. So what exactly is access specifier? So just focus on the name access specifier. See here, what is the access we are talking about? So basically, to just give a high level, access specifiers in Java tells you about the accessibility or scope of a field, a method, you can call it as a function also, a constructor or class. And you can always change the access level of constructors, methods, fields, classes by applying the access modifiers. And basically in Java, there are two types of access modifiers. One is, access modifiers or access specifiers, both are same, and another is non-access modifiers. Our discussion moreover related to access specifiers here. And there are four types of access specifiers by default. One is public, private, protected, and default. These are the ones. So moreover, the names also align with respect to what they sound like when you say public, generally how you take out the meaning, similarly that. Private also similar to that. Protected, you just need to understand a little bit on what exactly mean by protected, and default also similar to that. Now coming to private, private means the accesses of that particular whatever variable or method you write, it is possible only within that class. Beyond the class, you cannot access. That means if you write a program, in that program you have a class, in that you have made certain variables or functions or methods private, that means they cannot be accessed from outside. That's what I mean by access class private. That's what I mean by access specifier private, which means access is only available within the class, not beyond it. Default, when you look at default, means your access level is possible only within that package, and beyond that it will not be available. And one more thing is, if you don't specify any access specifier, by default the access specifier assumed is default. Now coming to protected, one advantage is your access level is similar to default, where the access is possible within the package. At the same time, you can have access to the particular protected data or protected members outside of the package also through its child class. If you cannot have, let's say you don't have a child class created, then you cannot access it outside the package. Public means, like the name says, access is available anywhere. That means within the class, outside the package, within the package, everything it is possible. So we have a good diagram here explaining all of that. The best way I would recommend is just look at private and public. Public means all way it is accessible within class, within package, outside package, by subclass, and outside package also. Whereas if you look at private, like I said, it is accessible only within class. These are all no. Whereas if you see default, you can see it is accessible within class, within package, but outside package by using subclass or outside package, it is not possible. Whereas protected means these all are true, possible. Only outside package it is not possible. Outside package you want to use, the only way is by creating a subclass to it. Now coming about this nest-based access control. So nest-based access control is one of the good feature in Java 11. So what is nest-based access control? So nest-based access control is like you can have a nested classes and interfaces, and these nested classes and interfaces using which you can access their private fields, methods, constructors, everything. And every nested member, they are called as, each of the nested members are called nestmates, and they are able to access each other data. So like I said, they are called nestmates, any members of nested class and all. When you have multiple classes nested in each other, they are called nestmates, and you don't need to write the bridge methods in order for the compiler to do all that. So bridge methods are something like, let's say for example, you want to sort. generally you have your own sorting mechanism. Let's say you want to tell it like this is how you want to sort. What generally you do is you take a class, you extend it as saying something like extends comparator, comparable. Whenever you extend comparable, automatically it will ask you to write a method for that, which is comparator, right? The comparator is a bridge method to tell how to do that job, the sorting job, right? So that kind of things, it's not needed because of this nest-based access control. Now coming to Java 11, what are the good features we have in Java 11? We have single command you can use to run your Java program. There is a better syntax for Lambda parameters, and there is a HTTP client which will support HTTP 1 and 2. And you have a lot of new utilities for string classes. And like I said, the nested access control is there as part of Java 11. And you can read or write string to and from files. That is quite possible in Java 11. And you have this arc64 intrinsic is also improved compared to earlier. And flight recorder is nothing but your code profiler. That is also improved here. Like code profiler in the sense it helps you to do a lot of code analytics on your code and help you to improve your code and help you to analyze your code better. Whereas you have a no-op collector, no-op garbage collector also we have, that's called epsilon. We will talk about why it is called no-op. This is for garbage collection. And these are the new methods as part of your nested access control. So nested access control, if you are using nested access control, these are the methods you can use. You can use get nest host or isNestMate or get nest members, using which you can access the nested members, or you can check whether a particular member is part of the nested class, or you can check whether a particular nest host is part of the class it belongs to, all that. Now let's talk about some of the special operators we have, like null, this, and instance of. So why we actually use null? So one thing you have to understand is this null is case sensitive. It is not like this capital N. The null should be like this. Okay, and by default, if you remember, if you look at earlier discussion, we said instance variables are by default initialized to 0. If it is string, by default to string. Similarly, when you use reference variable, the default value assumed for any reference variable is null. This is the default value for the reference variable. And one more thing to remember is any access to a null reference gives you a null pointer exception, because you're accessing a reference variable that points to null. That means it's not point to anything. So that's not possible. Another thing is you cannot pass a null as a parameter when you call any methods. That is also not possible. So these are the things you should remember about null. Now coming to this. This actually represents the class which it is getting called. Like let's say, for example, you have created an object and you want to refer a member of the object, whether the member could be function, whether the member could be variable, instance variable. You can refer both of them using this. This means simply the current object. So it can help you to refer the current instance variable or the current instance method. All that is possible. And even if you want to refer its current constructor, it is still can be possible with this. And you can always refer using this. You can always pass as an argument by your calling constructors also. That is all possible. Now, what does instance of do? So instance of help you to check. Let's say you have a variable called a and you want to check, is it a part of a data type called integer or is it a part of data type called float? It helps you to check whether that's been the case. So it always gives you result in the form of true or false, but all it does is it checks whether a particular variable or operand you're giving, that could be constant or variable, is it part of the data type you're checking? That's what it verifies. Now here is an example. So you can see here s equal to new simple gm. This is what we are making. We are creating an object and we are saying this is instance of it. So how to check whether this guy, as soon as you create an object, what will happen? This guy is an instance of this. Now that is what I'm checking. Is s instance of simple pgm? So if it is, which in this case is yes, then it will say true. That is what it returns. Let's say if yes is not part of simple pgm, or you have put some other object. Let's say if the object is some xyz, which is not part of, which you haven't created any object like this, then in that case it will yield as false. That is how this particular thing works. So instance of is to verify whether a particular object you have created, is it part of a particular class or not, or is it part of a particular class like what you have created here. That's what it refers. And remember that most of the things which you create object, they all will be child of your object class at a high level. Now, what is destructor? Like the name says, it is something which destructs. You should not be thinking like that. Actually, destructors are something which will help you to deallocate your memory. And Java automatically does all your memory management without our intervention. Java takes care of memory management automatically. Why I'm stressing this point is, if you look at programming language like C and C++, at least earlier days, C does not have any automatic memory management. That means you have to take care of memory management. When I say memory management, it could be creating the memory, it could be cleaning the memory. Once you allocate everything, it's your job. That's why in C you have CLR, CMLR functions and all. Good that all this object-oriented programming language like your Python, Java, everything comes with the automatic memory management. That means they take care of it automatically. So how it happens? Here in this case, there is a destructor function inside your JVM, which will automatically get triggers whenever your object goes out of scope, or you can forcibly also call it. That is also possible. But only thing is you cannot overload it. You cannot particularly make an explicit call, but it gets automatically invoked. There is other way where you can forcibly call similar to destructor, which is called finalize. So if you see here, we cannot call destructor directly, but there is other way called using finalize. When you call it, that guy acts like destructor and help you to clear whatever you want. And one more thing with this finalize is you can write all the whatever cleaning methods, cleaning activities you want, like closing the file or cleaning some database connections or closing certain number of web server connections. All that, whatever you want to do, you can write in finalize. Okay. And one more thing is, this is exactly not a destructor like I said earlier, but it moreover behaves like a destructor kind of functionality. Apart from this, if you want to call other kind of things, other kind of functions, I would say, which does similar job as, either you can call this finalize, that is one thing we already know. Other than that, you can always call this system.run finalizer on exit. That also helps you to do the same job of cleaning that automatically. It's like a moreover, I would say, forcible kind of destruction. Now coming to code refactoring. So what is the code? So whatever you write in English like high level language program, that is your code, right? You will call it as source code. So when I say refactoring, that means you are again trying to do something. That means you're not extending it. See, there's a difference between extending your code or making the code better. Code refactoring is more about making your code better. So you will restructure your code so that the internal structure is more better compared to earlier, and the still whatever behavior earlier it you used to do. Like let's say for example, you have built a software which is for giving a product. Like any product you ask, it will tell you what is the product details. Let's say if that's the software you have designed. When you're doing this code refactoring, you will not change the behavior. For user, it's still same. Nothing gets changed. Just that you will restructure it so that it becomes more. One thing could be, let's say, when you have written initially the code, you haven't modularized. That means you haven't properly divided that into function. Now you are doing all that. That's called code refactoring. And this is always helpful when actually you take a complex project and it helps you to make, using this code refactoring, what you can do is you can make it more better so it can be maintainable and extensible. Now, what is the importance of code refactoring, or I would say what is the benefits? It helps you to make the code cleaner because you have restructured so that it looks better, and it helps you maintain the code for a longer time. Because when you structure the code and ensure that code is better compared to earlier, what really happens is you will keep certain things in mind, that have I made the code so it is extensible compared to earlier? Have I made the code so it runs much performance wise or execution wise better than earlier? Have I made this code so that it is not having that many bugs like earlier? All this you will take into account. And when you code refactor, it is not like you just go and change the code. There is certain steps involved where you have to show the new design of how the entire structure looks like and what are the changes you are going to do and what is the advantage. It's not like you just want to refactor and you do it. That's not how it works. You have to show to your business saying when you refactor the code, what is the savings you have? Is it in terms of money? Is it in terms of time? Is it in terms of bug free? Whatever, all the technical debt, whatever it is, saved, everything you have to show. All that when you show it benefits, that's where they get convinced and let you do the code refactoring. Because it's at the risk of customer, right? Like they cannot in a day, because just you are thinking that it is good to change, they cannot let you do it, right? They have to take the risk. They have to look at what are the advantages, benefits. So all that has to be taken into account. Now, garbage collector. So what exactly is garbage? So garbage, this is how I understand. So garbage is nothing but any value in your memory which is not referenced by any object or any variable or any type of identifier is not referring a particular value. That's called garbage. And it is very important to collect garbage. Otherwise, you will have unlimited number of memory values not referred by anybody and unused. So that's why garbage collection is very important. And here why we are studying? Simple. Java does automatic memory management. So it is very important that we have to understand how this automatically collection of memory, whatever memory we use and just left it, how it gets collected, all that and all. And Java has something called epsilon Java collector, which is part of Java 11. This is also called as a no-ops collector. The reason why it is called as a no-ops is because it just help you to allocate memory, but it doesn't help you in collecting the garbage. That's not possible. So as part of no-ops, that's the name, because it will not do any operations. It will just allocate memory for you. But garbage collection, there are other modules to be taken care. And why it is important? It helps you to simulate your out-of-memory errors, all that. That is how it helps. There are other things also. It actually helps for short-lived objects to clean up for performance optimization and all. Yeah, these are the ones. So performance testing, it is helpful. And not only that, it helps you to improve your latency compared to earlier. And it also helps you to test your memory prints. Now, static code analysis. So what is static code analysis? So code analysis and all, I would consider this as a profiling. So profiling is more about how you ensure the code is good enough in all terms. So static code analysis is more about focuses on, okay, let's say if you take this check style as one of the parameter. So here check style means, are you written the code according to the standard or conventions to be followed? One convention could be, are you giving a tab space, four character tab space after everything? Okay, generally, since we have flower braces in Java, we don't consider it and we write it everything in one line, which is a very bad way of doing it. Now, with static code analysis and with this check style enabled, it will ensure any editor, whether you use Eclipse or IntelliJ, when you enable it, it automatically ensures that your code is having proper indentation, proper spacing, proper syntax, proper naming also. Like for example, you cannot use the variable name, a constant where you say static final and you just make it lowercase. It will not let you do it because it knows that that is not a good idea. So all these check styles will be enforced with this. Like I said, this help your developers to ensure that you are following code norms. It is not like a mandatory, but if you follow, it actually makes your code more better, and that actually helps your code to be more readable to others so that they can maintain their code for a longer time. That's the more advantage you get if you follow all these best practices. Now let's talk about string. So what exactly is a string? So string in Java is nothing but it represents a set of characters, a sequence of characters, I would say. And this is part of the java.lang.string class. And using that, you can create a string. And you can see that here we are creating a Java object. For this string object, we are creating a string variable. This is an object variable of type string where it is referred, and you can easily print it like system.out.println EA. But this is basically a string object. Okay, you might have looked at in other programming languages like C. If you want to create this, you have to create a character array and do that. Here we don't need to do. We can just create a string literal and assign to a variable of type string. That's it. It helps you do it. This is one way. Another way is you can even create a string object by using this java.lang.string class called out here. Using this also you can create a string object and do that. The advantage is when you do it, you will get a set of functions of this string class and you can use it. We have a discussion on that also. We will see what are the string functions possible. Now, this is the string class which we discussed here. In this, like I said, there are certain string functions possible. Let's see some of the string functions possible. So you can see that these are the methods available on the string object when you create it. That means once you create object, there are certain functions automatically comes. So these are those functions like character@, compare to, and all that. So character@ will help you to say what is the character at a specified position. So let's say you have created the string a equal to new string. So you can just say a.character@, and you can ask at that location, you have to give the index location 1. So what is this particular string objects, what is the character at this position index 1? So it will say it is 0, it is 1. So it will say e. So that is how you can use it. Similarly, you can use to compare two string functions. Like for example, it compares, sorry, not string, but string objects. It will help you to compare two strings lexicographically. When I say lexicographically, based on the Unicode ordering and all. Similarly, you can ignore the case. You can concatenate two strings. You can check whether a string is part of another. You can check whether the strings are same or not using this content equals. And not only that, you have other functions where it will help you to check whether a string is ending with a particular prefix or particular suffix, something like it ends with j, x and all. You can check that. You can always check whether the string is equal. This actually is case sensitive, whereas the same thing, both are same, just that this is case insensitive, whereas this is case sensitive. That means it looks at the case. That means here capital A and small a is different, whereas here capital A and small a is same. And it also helps you to format the string based on whatever format specifier you specify. And it will always help you to give the index of a particular character which you are given, and it helps you to give the string representation of a specific value as well. So like that, you see a lot of functions are there, and we do have a demo for discussing all that, so where you clearly understand how to use this function. But like one example I mentioned, if you want to use string, all you need to do is create a string object, and you can try out a string object dot function, and you can try out that. If you use Eclipse, it automatically gives you these functions for you, and you can easily practice. You can see we have functions to convert into lowercase. Similarly, we have a function called dot to uppercase as well. Yeah, this is the one I was talking about. You can see there are a lot of methods apart from this. Let's talk about arrays. What exactly is arrays? It's basically nothing but a collection of similar type of elements. When I say similar type of element, the similar type is the other term to say similar type is homogeneous. There is another kind of data structures also which are called heterogeneous. That means they can have different data type elements, which is more of like a Python list. They are all looks like array, but they can have different data type elements. And one more is, here arrays are dynamically created objects, because if you see when you're creating array also, you will say a new array like that. So it dynamically creates that object. And by default, everything, not only just array, by default, everything will be inherited by object class. And in this case, array implements your serializable as well as clonable interfaces. And as you all know, arrays are in Java are all index based. That means you have to start from index 0 to that particular value. And basically, if you look at not only Java, any data structure, any language which supports data structures, they are all having basically in terms of array two types of arrays. One is single dimensional, another is multi-dimensional. Single dimensional is like, you have just only one index. When you say multi-dimensional, it could be 2-dimensional, 3-dimensional, 4-dimensional, 5-dimensional. Anything more than one dimension is called multi-dimensional. Now, what is the advantages with respect to array and what are the disadvantages? So first advantage of array is it helps you to make your code well optimized, because you can retrieve whichever data you want and you can sort it also whichever way you want. Like, if you want, you can sort the data effectively. And at the same time, you can access the data in a way you want. And one more thing is here, it is random access. Why? Because if you look at, we will not say if I want to fix the 10th location, I don't need to print the first location, second location, third location, fourth location. I can directly say array of 9 and I directly get the 10th location. So it is like a random access for you. So that way it is very helpful so that you can quickly access the elements of the array. Now coming to disadvantages, first disadvantage is size limit. You can store only fixed elements, because when you're creating itself, you have to mention how many elements you're going to store. Even though we say dynamic, it's a dynamic object, it gets created dynamically, but you have to way before declare so that compiler knows how many elements you're going to create. So that's one con, I would say, or disadvantages. And another thing is, because of this reason of having it a fixed set of elements in it, because you have to declare in the beginning, Java has come up with something called collection framework, where using collection framework, you can make these arrays to grow dynamically. I mean, there we will not exactly call it array. You'll say maybe collection arrays or something like that. But we have similar type of structure there where it will help you to grow array dynamically. Now let's look at this example. So if you want to declare an array, how to do it? So this is for a single dimensional array. You can see that, like I said, there is only one square bracket. So if you see here, there is only one square bracket here that indicates it's a single dimensional. The thumb rule to remember whether it's a single dimensional or multi-dimensional is just by looking at how many square brackets they are putting. So each square bracket you can count it as one. This is one. Like that, if there is one more, you can call it as two-dimensional. If there is one more, you can call it as three-dimensional. So there are different alternatives of doing the same declaration. Either you can say first the data type, then square bracket, then array, or you can first tell the data type, then array, then the subscript notation. You can choose either of it. I prefer this way because here itself you're telling, okay, what is the data type and whether it's single dimensional or two dimensional rather than at the later side. So if you see how to create it, so you can see we are creating an array variable by doing new, then data type of size. So when we say it's a dynamically created object, like in the earlier slide, we made a point here. So what does that mean dynamically is this part, because you are creating new and automatically at runtime, that particular memory location address will store here. And when we say it is having fixed elements, that's why we are going to take it collections and all that here, which we said here, fixed elements, and we are going to use the collections. This means that you can see that we have to mention the size. This is what I mean by fixed size. That means during execution, you cannot change it. Once you fix, that's it. So that's what I mean by fixed set of elements. And we have alternative, like using collection, you can make it dynamic. Now you can see that by looking at, you can count how many are there. It is a two-dimensional. This is one, this is two. And there's a different way of denoting it. One, you can say the data type, then these square brackets to indicate whether it's a two-dimensional or three-dimensional. Similarly, you have other way where you first mention data type, then the variable, then the square brackets. Or for me, this is actually confusing, where you can say the data type, then square bracket, then variable, then square bracket. So you can say this way also. Always remember, if you miss this, this will become one-dimensional. That's why I say it is always confusing for me. In this case, this and this is okay because there's a less chance of me missing out the square bracket. Whereas in this case, if I miss out, this becomes a one-dimensional because this is another notation for creating one-dimensional, this one. So that's why that is a little scary. But this one is safest because as soon as you create data type, you can put the square brackets. So you can see in our example also, we are following the same notation. We are saying int and two square brackets. That means it's a two-dimensional array. And we are saying array equal to new int of 2 by 2. That means it will create a 2 by 2 matrix where it will have 2 rows and 2 columns. Okay, so here if you look at it, we just instantiated by using new. It dynamically creates an object and gives you that memory location to this array reference or variable, and this one will contain the memory address of it, and it will create a 2 by 2 memory location for you where it has this data stored in matrix format, 2 rows, 2 columns. Let's talk about arrays. Now, if you want to use arrays, how to do that in Java? Now, first thing, let's talk about one-dimensional. In the case of one-dimensional, you can see here we have set of values, and our task is to identify the minimum. We know what is the minimum to. Now we have to write a program to detect it. Now, first of all, when we say minimum of x, what will happen is this will call our function minimum. Since our main method is static, it can call any other static method. So it called minimum. And this x actually gets passed and assigned to this a. So when we want to take array as a parameter, you have to put a square bracket. Then only it understand that you are passing an array to it. Otherwise, it won't, or it will give an error. So remember that whenever you are using arrays as parameters in the function or method names, you have to do this way. Now, when you pass x, what exactly happens is the first memory address of it will get stored in this a, because as soon as you have the first address internally, you can access the array locations, next consecutive memory locations easily. That's how the internally things happen. Now, once you have x containing the array reference, now what will happen? So here, if you see, we are taking the first value as value, which is this value variable. We are taking the first value of it. What's value? What is it? It is 93. So this we are storing here. So 93 is stored here. Now, once 93 is stored, here we start with m equal to 1. Why? Because we already picked a 0. So we don't need to look at the a of 0 location. We have to directly start with a of 1, which is this. So from here, we start our journey and we go up to a dot length. A dot length is nothing but the one which tells you the total number of elements. And how many elements are there? We have 4 elements. That means this loop will run 4 times. But since we started with 1, it will run for 3 times. So each time it gets incremented and checks. So first it will check if value greater than a of m is 1. So it is checking if a of 0 greater than a of 1. Is it? If a of 0 greater than a of 1? Yes, it is. So if value is greater than a of m, So what will get stored? It actually stores your, it just keeps your 93 here. If x greater than 93 greater than 3, this is the condition checks. Is it true? That's true. So value still kept as 93. Value will be equal to a of m. That means since this condition is true, because your 93 is greater than 3, that means now value will be stored as 3. Now here it will store as 3. Now, before even it's printing 3, okay, system.out.println, it will print the value. Remember that we should have put a flower braces to indicate, but this also works. So what will happen is this part of the for loop will keep continuing, and the system.out.println will not print until this for loop is completed. That means once you take value equal to a of 0, which is 93 in this case, after that, the loop starts with 1 and goes up to the end of the element, which is 2 here. So first it will check if value greater than m is 93 greater than 3. It will check is 93 greater than 3. Then the value will be stored. It is true. Then the value will be stored. The value will be stored as 3. This is your value. Again, now the turn to 9 comes. 9 will be checked. Is 9 greater than 3? Is 3 greater than 9? 3 greater than 9 is not correct, right? 3 greater than 9 is not correct. 3 is less than 9. So it will be skipped. Now 2 comes. Now again it will check, is 3 greater than 2? Correct, 3 is greater than 2. So now what will happen? Whenever it is true, we will change it. Now the value will be changed to 2. Now the value is updated with 2. Now, since the loop is completed, it will come down and print whatever the value is. And what is the value contained? 2. And that's your answer. So that is how it navigates from one element to another to figure out the negative element. Here are few things to do it. Sometimes people actually, instead of putting the first value, they actually put some negative value or 0, which is not a good choice, because you have to go with what are the elements given to you. So always go with the elements given to you. Always keep the first element, which is the best way to do it, because if you are trying to find minimum, let's say you have given only positive integers, then in that case, if you are taking a negative value, maybe it might work. In the case, maybe it might, if you're just considering positive and negative values in the list, in the array, and if you're taking a negative value, maybe it will work because your data also contain negative numbers. But what if think a scenario where you have only positive numbers and you have put a negative value as the default value, something like -1, which is not there in your data. So your program still says -1 is the minimum, even though your data did not contain it. So that's why it is very important that you consider only the one which is actually given to you, not the other ones. Now, let's talk about array class. So similarly, like if you remember, I said like arrays are fixed, arrays do not have, you cannot dynamically grow array and all, but in collections, we can have some arrays which can grow dynamically. This is that guy. So now if you see, this array class actually contains a lot of methods. Not only that, it is a dynamic one. Another advantage with this particular arrays collection is that it helps you to do several other operations like searching arrays, comparing and filling array elements, and also sorting. Now here are some of the methods. There are even some more. Like these all methods, if you look, binary search equals fill sort. Sort it for sorting data. Fill is for filling data with some value. Equal is for comparing whether two arrays are equal or not. Binary search is for doing binary search. So binary search is something like where you actually, it's one of the data structure. If you read computer science, you will know about it. In generally binary search, what happens is you actually takes a list of elements. You first sort it out, then take the middle value. From middle value, what you do is once you get the middle value, you break it up into two parts, and each of these two parts will be again going to the same iteration. Again, middle value, break it, again, middle value. Like that, it keeps on going into that iteration. That's called binary search because it each time breaks the entire data into two parts. So anyway, but this is all taken care. We don't need to worry about it. One thing, interesting thing we have to understand here for arrays classes, all this can take any primitive data type. When you say primitive means basic data types or standard data types. Primitive here means it can be integer, it can be float, it can be long, it can be unsigned long, signed long, all the primitive data types, including character also. All that are possible. So this can be overloaded. When I say overloaded, the same method name can be used for different data types as well. That's the gist of this part. Now, coming to for each loop. So what exactly for each loop? If you remember, we spoke that we actually discussed earlier that, Java has three types of for loops. One is simple for loop, another is enhanced for loop, another is for each loop. So each has a different purpose, right? Now, here we are going to talk about for each. The biggest advantage you get with this kind of loop is you don't need to worry about iteration. It automatically takes care of iteration. When I say iteration, repeating the loop one by one and printing the elements. And you don't need to worry about what is the initial value. You don't need to worry about how to increment. All that is taken care. I would say this is the more comfortable loop where you don't need to worry much. So let me show you how this works. So if you see, by looking at the syntax itself, you can understand. In while loop, always remember in while loop or do while, you should always think about what is my initial value? Where do I start with? And then you have to think about when should I stop my while loop, which is your 10 meeting condition. Again, in while loop, one more thing aspect you have to look at is whether I have to increment or decrement. Three things you must always keep in mind. In the case of for loop, this all headache is not there. Because for loop automatically understand the initial value from the data you have given. That means initial value, you don't need to take it. Another thing is it automatically knows what is the length of your collection or array. It actually takes both array or collection as input. And it automatically understands that should I have to go, how many elements I have to traverse. It knows that because it has a logic where it automatically figures out that. We don't need to worry about 10 meeting condition also. Now coming to increment and decrement also takes care because it remembers the state where it passed. So all this makes people prefer for loop because you don't need to worry about all these three things which you always have to keep in mind when you use while loop or do while loop. But these are all meant for one reason only. These are all meant for looping some set of statements. You can use it for traversing arrays. You can use it for traversing, lines in a file. You can use it for traversing a list of elements in a array or any other collection. All that you can do. And one more good thing about this for loop is since you don't need to worry about iteration, condition termination, or increment or decrement, there's a less chance of you making errors because other things are not need to be worried about. Another thing is it makes your code more readable to understand because it's just simply for variable array or collection. So it takes input as array or collection and it automatically walks through it all of it without any step value or anything like that. And one more thing to put it out here is when we say simple or more readable, it simply means that it makes your code more elegant. You will not write a lot of unnecessary statements which is not related to really repeating the loop. If you look at while and do while, you have to write certain things in order for the loop to work. Like one thing is your terminating condition. Another thing is that step value, increment or decrement, which is not really, if you look at it, they are not really closely related to the what is your purpose in repeating that. They are related to that loop, not to the purpose of it. But here you will not have that. That means the code looks more simpler and more better manageable and readable. So let's look at this with an example. If you see here, the same 13, 14, 15, 46, we need to print it. And you can either print it or sum it. Here in this case, we are summing it. So how does it happen? So here, when we say int x colon a, if you see there's no initial value, just like while loop, it automatically figures out I have to start with 13. So each time what happens is it picks first element 13 from this array a, which is nothing but this, and it puts in x. That means now x is 30. Now, once it do this part, now what happens is now sum equal to sum plus x. Now it sums with this 13 plus 0 because the initial value of sum is 0. Now 13 is, s is your 13. Okay, so s is your 13. Now, once you do that s equal to 13, now similarly you get 14 next time. So it automatically moves to the next element. Now 14 plus sum. What is sum value? 13. 13 plus 14, 27. So it automatically adds and makes it the sum. Similarly, once 27 is done, the other value it picks it, which is 15. And 15 plus 27, it is 42. So that is get added. Now again 42 plus 46, it is 88. Like that, it keep on getting one value and adds it. Here if you see, we are just doing the main purpose of the loop. We are not doing anything like, just adding the incrementing or decrementing or terminating addition, nothing like that, which is not related to this particular use case. In this use case, we just have to sum the value and we have just done it. So this is what we are saying. It makes the code more readable because you're not writing any unnecessary things, right? We are saying here makes more code made readable because you're not writing anything related to the loop. You're just writing to the purpose of it. And there's less chance of errors because you're not worried about step value, terminating condition. Those headaches are not there. So this is more elegant and comfortable loop, I would say. Okay, so that's about this for each loop. And one more thing to remember in for each loop is these guys are very helpful if you know how many times the loop has to run. That means if you say, I don't know how many times the loop will run, it can run endlessly. this guy is not the answer. Then you have to go for do while or while loop. There's no other alternative. Any infinite loop, these guys are not going to work. You have another for loop, by the way, the simple for loop you can use, but this for each loop you can use only for finite use cases. That means you know how many times to repeat, then only you should use it. Otherwise, these are not helpful. But if you see, most of our use cases are finite, I mean percentage wise, so that way this is more useful. Now coming to what do you mean by method overloading? So when we say method overloading, it simply means that, you actually, apart from the behavior of what is that method supposed to do, you're going to make it even more featuristic. When I say featuristic, like let's say if I take add function, I might be adding just two integer numbers. I can overload it or make it more better by adding some more features to it, saying you add two float numbers or you add one float, one integer, like that. All this can be possible in Java by doing this concept of method overloading. It simply says that method overloading is nothing but you can have the methods with same name but distinct parameters. When I say distinct parameters, it simply means that you can have a method name with add and it can have two integer parameters as input, or it can have method with three integer parameters as input, or two integers, or one float, or one integer, one float, one float, one integer, like that, any combination, but the name is same. And the only way method overloading works is only based on the number of parameters you have and the different data type of parameters. It never works based on the return type. Okay, if you just change a function or a method which is add by just changing the return type, it's not going to be overloaded. In order for the method to be overloaded, this is the condition. This is something you have to remember, that by just changing the return type, it won't work. You have to either tweak it to get the method overloaded by having the number of parameters different or making the data type of parameters different. Either of that way only the method overloading will work. And obviously the readability of the program will be more improved because you have just one interface. Method overloading is like you're just giving add interface where that is capable of doing 2 3 number addition, 4 number addition, and 3 number integer addition, 3 number float addition, or 2 integer 1 float addition. Different versions you can produce with the same interface. That's the biggest advantage with the method overloading. Like I said, the rule to remember, if you just remember that rule, that return type, based on the return type you cannot overload any method, then question comes, how do you overload a method? The only two ways to overload a method in Java is, even in fact C++ also is, that by changing the data type of the parameters. That means I can have something like add and it can have something like two integer parameters. Let's say this is integer, this is integer. Similarly, I can have another add method which can take one float, one integer, like this. So this is also possible. Similarly, I have another parameter. I can take something like two float, add with two float, different versions, but all of them have the same name. So that's what I mean by changing the data type. I'm changing the data type of this. Similarly, I can have, based on number of arguments also, I can overload. It means this is two parameters it's taking. I can make it to take three parameters also. This is also possible. That means the number of parameters you increase, that time also the method overloads. The different data type of parameters you take, that time also method overloads. These are the two ways using which you can overload a method in Java. Now coming to first example, like I said, changing number of arguments. That means the number of arguments will be increased. So here if it is 2, you can see here it is 3. So both is returning the same return type if you observe. Just that here this particular version of add can take 2 parameters. This particular version of add can take 3 parameters. Now if you see here, this is our main program where actually the code triggers and sum dot add of 10 comma 21 when you pass. Now what actually, before you execute Java, compiler already aware of which method to trigger. It already created a table understanding that whenever 2 parameters are passed, I have to trigger this guy. So when you say sum dot add of 10 comma 21, it automatically calls this add method and assign x to 10, y to 21, and the result of it, which is nothing but 10 plus 21, 31 gets returned. Now similarly, at the compile time, it automatically realized that when you pass 3 parameters, I have to pick this guy. Now when you say sum dot add of 21 comma 11 comma 11, it actually makes the count as 22 plus 21, which is 43, and returns this back. And that's what gets printed here. So these versions of overloading, method overloading, actually decided the compile time. It automatically knows how to call a particular method because it figured out based on the type of parameters or number of parameters. In this case, it is just based on the number. Here it is 2, here it is 3. But if you see, observe, it is like functional abstraction where you are giving the same name, but inside the way you code it all up to like based on your use case. But if you see, you just made the same function. That means for user, it is just the same interface who is capable of doing multiple things. It is like an all-in-one kind of thing. Different versions of the same interface kind of. Now here in this case, if you see the difference between the earlier one and this is, in this case, if you remember, we said two ways you can overload a method. One by changing number of arguments, which is what we have seen here. Another by changing the data type, which is what we are going to see here. So here in this case, if you see number of arguments is same, it is 2. But if you see the data types are different. So based on that, the compiler automatically detects now. Now when you, in the main program, when you pass sum.add of 2111 and this, so here it knows that both are having the same arguments. Now it comes to a conclusion that how to decide which one. So then it takes the choice of data type. So it will check what is the data type of this and what is the data type of this. Since both are integer, it will try to pick the closest one which matches this. In this case, this is this one. So when you say sum.add of 21, 11, it calls this add function and x gets assigned to 21, y gets assigned to 11. And the addition of this will be 32, which is what returned. Now, when you pass to float value, again, it checks which one is the best match. Since in this case, there are two double parameter receiving add version is there, it picks this one and it does the addition here, 34.9. In this case, it has overloaded method based on the number of arguments. So you see here also the functional abstraction where you are giving just one interface, but you have different versions of the same interface. Now coming to command line arguments. So what exactly is command line? So if you see, have you ever logged into your Windows operating system? There is like in your start bar, your start search bar, you will be typing command and sometimes you are doing this DAR and all those commands, right, in Windows. If it is Linux and all, you will be typing some LLS and all. Those on the command, whatever you're typing, that particular space where you're typing all these commands is called command line. And if you are able to pass the input of your program through that command line, it is called command line arguments. As simple as that. On the command line, you should be able to pass. And there are a lot of applications people build using these command line arguments. All your Unix commands or command line arguments, all your Windows commands which you execute, like DAR, CD, MDKDAR, RMDAR, those are all built using the same concept called command line arguments. In fact, if you know about cloud computing, the famous AWS, they have a CLI called AWS CLI, which is also built around the same concept. Okay, so there are a lot of applications with that. And what does it mean? It just means that you are passing command line, you are passing inputs from the command line. That's what it here. That's what we mentioned here. You can pass number of arguments from the command prompt. And whatever you pass, arguments passed from the console can be received in Java program and can be used. So what does this mean is once you pass it, your Java program can be able to do it. If you look at till now, our main method was never like this. We were just writing just for the namesake. Now, actually, if you look at this guy actually captures all your command line. That's what we are trying to say here, that whatever arguments you pass, we can receive and process and show to you. And all these arguments, when it will pass, when you're running your code, right? Not by compilation. So there are two parts in Java. First, you have to compile it using your Java C. Then you will execute it using your Java interpreter, which is like your Java or JVM. That time is where actually you pass these arguments. Now, if you see, let's look at the example. Assume this is your Windows command prompt. And in this, when you write it, so this Java C grade cle.java will write here. So on the command line, this is your command line. When you write, what happens is your program will be compiled. This is just compilation step. But like you said, if you remember when we said we are going to pass these command arguments at the time of running, that means during execution, which is this part. This part is we are going to pass. So when we pass here Java CLE welcome, in this time, this gets passed and automatically stored in this command line argument, which is part of the main signature which we pass. Main signature, if you see, public static void main string args we write. You can write any name. Args is just a convention people follow. Here we have written A. That means this A is an array, which is a string array, which receive this particular welcome. That means your A of 0 will actually have that welcome stored. Now, when you print this guy, if you see when you are printing A of 0, you get this welcome. Similarly, if you give one more parameter like welcome, hello, welcome, this is Java class, that this Java class will be stored in other elements of the array like A of 1, A of 2, and A of 3. like that it gets stored. So the advantage with command line arguments is it is as simple as your different variety of taking input. Like one variety is by using scanner you can take. There are other ways in Java also, like using buffer reader and all that. Other mechanisms are there. But apart from that, one other mechanism is you can give your input through command line arguments also. This is like another input mechanism, which is really useful if you want to build commands like Unix commands or Windows commands or something you want to work on the cloud interface. All wherever you want to build command environments, this technique of giving inputs is very useful. Now coming to parameter passing techniques. So this is completely related to our methods or functions. Now, how many ways you can pass a value to a function or a method? So there are two ways basically. One is by value and another is by reference. When you say by reference, it simply means memory address. So when you say by value, what really happens is, let's say you have a function called a, and that function receives two arguments, a x comma y. When somebody calls a of 1 comma 2, in the case of call by value, what really happens is your 1 have a, it will create a copy. That means let's say one more copy of 1 will be created, one more copy of 1 2 will be created, and it will be assigned to xy. That means your function is not working on the actual 1 and 2 memory location. It is working on the copy of it. That's why it is called by call by value, because it is just taking the value, not the actual memory address where these values are stored. Whereas in the case of call by reference, what exactly happens is when you pass this add of 1 comma 2, the memory address of that particular 1 and 2 will get stored in xy. That means whenever you are doing anything changes on that xy, it immediately reflects the actual values. So that's the difference between call by reference and call by value. Call by reference is simply that you are directly dealing with the memory address where the values are stored. Whereas call by value means you're just taking a copy of that particular data and dealing with it. Anything you impact on the values which you take by call by value technique will not have a direct impact on the original values. Whereas call by reference, it will have, because you are taking the memory address of them. So types of parameters. Okay. Now coming to formal parameter and actual parameter. So types of parameters. So when you call a function, okay, so for example, when you actually create a function, if you look at here, so actually if you see, these are called your formal parameters and these are your actual parameters, because this is your active value. These are just for placeholder. We are saying I'm expecting 2 integer parameters, but these are not actual values. Actual values are this. Actual are nothing but the actual values you pass. Formal is nothing but which you put it as part of the function signature or function header or function declaration, whatever. It is just a placeholder. You can use A, B, you can use C, D, doesn't matter. But actual values are this. This is called actual parameters and that is called formal parameters. Formal parameters is nothing but variable and its type as they appear in the prototype or function of the method. So what is the prototype for function or method? It is nothing but this prototype or function signature or function declaration, one and the same function header. That is what they are calling. And apart from that, the actual values, the variable or expression corresponding to formal parameter, that means the actual value you pass is actually called the actual parameters. Let's understand how they are passing. Now, this is passed purely by looking at it. I can say how it is passed. This is just by a copy by value. Now, let's look at if that is correct. Now, this is the main program. We have created an object for operation X, which is nothing but this class. Now, in this, we are saying before making change, o.v. What is v? Let's assume this is 500. Then o.v, when you print, this 500 will be correct. Okay. So now when you print 500, this is the one you get. And after that, once you print 500, you're saying o.change of 500. Now you are again passing. Now this v gets assigned with this 500. Now when v is assigned with 500 value, now it is incrementing this 500 inside v plus 100. So it will become, what it will become? V will become 600. Now, when you are again printing it, this particular function call is done, everything is done. Now you are printing it. What is the value you expect? You expect 600. But the surprise is you get 500 only. Why? The reason is simple. Here it uses the technique of call by value. It is not by address. So when you're passing just the value, what will happen is it actually creates a new copy of this 500 and pass to it. And that is the copy it is working on, not the actual memory address of it. If you pass arrays, there it will work by call by reference technique. Only by using some certain data structures use the technique, not everything. If you pass like this, it is always call by value. Okay, so in this case you can see why it didn't affect it, because we know call by value means it just takes a duplicate copy of it and works on it. That's why it didn't work. Now variable arguments. So what does it mean by variable argument? So if you see all these functions, this function receives one argument, or this function receives, yeah, I can change it to receive two argument, three argument and all. But what if I say here, I'm very clear I'm going to pass only one argument. That's why I have put as one argument thing. But what if I say, I don't know how many arguments I'm going to pass, and you should be able to take as many as I give. Like here in this case, it's only one. Until I tell you that I'm going to pass two or three, based on that, you will increase it. You will say int v comma, int the x comma, int y comma, like that. But what if I say I don't know how many I'm going to pass? I can pass 2, 3, 4, 5, or I can pass hundreds of arguments from here. Then question comes how to write that type of function which can receive any number of arguments, because here you can put fixed things, but how to do that type? That is what we are going to discuss about variable arguments. Variable argument is nothing but the function or method which can receive any number of arguments is called variable argument list. And like I said, you can see that that's the same definition. It just accepts zero or multiple arguments. When we say multiple, no need to know how many multiple values you're going to pass. You're free to pass any number of arguments. That's why the name variable arguments. Variable means changing. That means something which is not fixed. Whereas earlier, whatever examples we discussed, those are all arguments are fixed. But when you talk about variable arguments, here it is like arguments are changing. They will not remain the same. Sometimes you might pass one, sometimes you might pass zero, sometimes you might pass three. Anyway, it has to work. That's what called as variable arguments. And it is very useful for language designers when they design it. In fact, your system.out.println or your C programming language printf or your Python sprint, everything is built with the same concept. And here you don't need to provide any overloaded methods, because it automatically takes care of taking different values. Because as soon as I said it can take 2 or 3 arguments, you might get a thought that I can't be overload. But again, remember, in overload also you have to fix the number of arguments. Here the arguments are not fixed. So here no need to provide overload methods. Even for overload also, there's a limit. Unless you know what is the max you get, you can overload methods. But if you don't know what is the max arguments I am going to pass, that's going to be tough. Now, here in this case, there will be only one variable argument. When you write in a method, there can't be multiple. And if you are putting multiple arguments also as part of this variable argument function, remember that your last argument must be a variable argument when you want to use it. It should not be the first one when you have multiple arguments. Now, if you look at here, in your public static void main, you are calling a function, which this display main. So if you see here, look at the signature. This is very important. So to indicate a particular guy as a variable argument, this is the notation, 3 dots. Any variable after the data type, this is the variable values. After the data type, when you put 3 dots, it is indication to Java that this is a variable argument. That means this case should be able to capable of taking 0 to infinite number of arguments. So you see, I never have said I'm going to pass 4. Even I can pass 2, even I can pass 3, even I can pass null like this. It will still work. So first of all, in the main method, when I say display, it makes a call to it. There's no argument passed to it. It is still okay because it's a variable argument. It can take either null or any number of arguments. So it will simply say display method as invoked. Now, in the other case, display my name is Java, this values actually it's assigned with all this value. It actually creates a string array, and in that it will store. But we are not printing here. But actually, if you see, it captures that. Just that we print again display method has been invoked. So the main intent of the program is not to show that this can take this function taking 4 arguments or 5 arguments. The main intent is to say that you are making the function capable of 0 argument, 1 argument, 2 argument, any number of arguments. That is the main intent. In fact, if you look at, just think how does this system.out.println is built, where it never complain you when you give, here in this case, you are just giving one string. You try to give 100 string, it will still print whatever you want. Or you try to give 1 argument, 2 argument, even you don't give, it will still work. Now think about how they have built it. This system.out.println internally, if you look at, it is built using the same variable argument concept. So that's why I said it is very useful for people who want to build these kind of programming languages and they want to work on these kind of functionality. Variable argument is the answer. In the real IT industry, this is not a very picked up use case because it's not readable. Unless people deeply understand about it, people don't prefer to use it. And it creates confusion sometimes because not everybody know about it. So unnecessary confusion will start arising. So that's why people don't prefer it using this technique. But if you really want to work on building programming languages, then this guy you must know. So what is initializer? So where does actually we use initializers, and what exactly is initializer is? Now, if you look at initializer is nothing but something which initialize your data members in your object. So whenever you create an object, all your data variables will be initialized. That means, let's say your class has integer variables. That means whenever you create an object, by default, Python has something called default constructor that actually initializes all your integer variables to 0. If the variables are float, it will initialize to 0.0. If the variables are string, it will initialize to empty string. Like that, it automatically happens. That is all done by default constructor, even though you don't write your own constructor. That happens. That is what one job of it, which is what we mentioned as the first point. Now, when it happens, obviously when you create an object, that's what we mean here. It runs each time an object of the class created. And you can even initialize the instance variable directly also if you want by writing your own, overriding the constructor. And there is something called instant initializer blocks also. Using that, you can even perform extra operations besides just initializing the instance variable to some default value. Let's say you want to do something more, like let's printing or connecting to a database or doing some initialization steps before querying on the database. Let's say you want to pass your username, password, authenticate, all that you want to happen by the time object gets created, all that kind of things you want to do it. You can do even in something called instant initializer blocks. That's also possible. Now, where are the places where generally we can write this instance initializer is 3 places. One is methods, another is constructor, third is block. These are the 3 places you can use these initializers. Now, the rules. What are the rules? The first rule is there is mainly 3 rules for the instance initializer block. The first rule is this instance initializer block automatically created whenever you create an instance of the class. That is the first rule. Second rule is the instance initializer block will get initializer block, which is actually called or invoked after your parent constructor is invoked. That means how your parent class constructor will be invoked using your super method, right? The super method, you can invoke your parent constructor whenever you are doing a subclassing. After this guy will invoke. Okay, only when your instance initializer block is invoked after the parent class constructor is invoked. That means first it has to call the parent class constructor, then only this guy will be invoked. Another thing is this all happens in a sequence. That's what I mean by third point. That means instance initializer block comes in the order in which they appear. Let's say you have written 2-3 instance initializer block. The first one will execute, then the second one, then the third one. They will come in the order. Okay, it just follows the sequence. Okay, so first of all, before even we end this, like first of all, to understand what are the use cases, one use case of using this initializer block is, let's say for example, you want to perform certain operations before assigning a value to a particular data member. You can go for instance initializer block. That's one good use case for it. That means besides assigning a value, because by default your constructor will automatically do the job. Besides the default constructor which I called out, besides that you want to do something extra, that's where you need to prefer this instance initializer block. That is one of the main use case people use it most often.
Hello everybody. I'm opening Eclipse IDE to start doing basic Java programs. So let's create a basic Java program first. So I already have set of modules here. I'm going to create another package called demo. So this is my demo package. Here I'm going to create a new class. So let's say basic Java program. Now this creates a basic Java program. So here we will write our main code. So we'll first write public static void main. And we'll say string args. And this is where we are going to write all our code. So if you want to just to write a hello world, you can just type hello world semicolon. This is the run button in Eclipse. You can see it says run basic Java program. If you run it, always, so it will run, and this is your console or output screen where you also can see the output. Now this is the first program, but behind that, like, instead of that one, let's do some useful program. So I'm going to create two variables, int num equal to 10, num2 equal to 20. These are the two variables I have created. So I'm going to do some kind of arithmetic operations on it, saying arithmetic operations on the two numbers are, and here I'm going to show you some arithmetic operations. So when I say arithmetic operations, it is your addition, subtraction, multiplication, division, percentage, all that. So how to do this? You can just say system.out.println addition of the numbers is, and say num1 plus num2. If you say that, let me show you what will happen. It will still error out because, when you put it, what really happens is this is basically a string. A string can concatenate only with a string. If you just put it like this, this will give you an integer. Since this gives you an integer, it cannot concatenate a string with this. That's why it gives an error. So what you have to do is put this in parentheses so that the system.out.println automatically do typecasting for you. Now if you see, after putting parentheses, this particular thing should disappear. What does it say? String comma int. It still have the same problem. Okay, so here we are using comma. Actually it should be plus. So when you put it plus, now you see this, it is doing it. So what actually happens is, ideally if you see, if you just put num1 plus num2, did you notice the difference? Actually we want addition, but when you put num1 plus num2, what really was happening was, it is actually do a string concatenation. 1020 it is converted to string and doing the string concatenation. 1020 string is like your 1020 like this, and it is converted to string and making it like this. That's why you're getting that. So if we want to perform arithmetic operation, the best way to do it is just put in parentheses and just do this. So when you put it, automatically what happens is, first it will do the addition, which is 10 plus 20, 30, and that 30 result will get converted to string automatically, because by default by default Java do typecasting for anything you put after plus. It does this implicitly, that means automatically. So you can see that now you are getting it. So if you just put plus num1 plus num2, you have seen what happened. Every number it converted to string and trying to attach to it, so which is not the expectation, right? Now let me add some more operations. Subtraction of the numbers is, now I am doing subtraction. You can just say num1 minus num2, and if you run this, this will give you subtraction of these two numbers, which is minus 10. Similarly, I will do multiplication of two numbers. Multiplication of the numbers is, I said arithmetic operation, that's why we are dealing only with arithmetic operation. So now it should give me the multiplication. So there is a star. Did we miss something? So it says, yeah, this is extra parenthesis. So always look out, Eclipse is very useful. It will give you all the errors and it will auto suggest if there is a problem. So it is multiplication of two numbers. Similarly, let's do division of two numbers. System.out.println division of the numbers is press num1 divided by num2 semicolon, click on the run button, and it gives the division of two numbers. 10 divided by 20 will give you 0, right? Because 20 doesn't go in 10, 20 doesn't go in 10, right? You know, you're not asking. So if you reverse this values, num1 to 20 and num2 to 10, now it should give you 2. You can see that now it is giving 2. Similarly, there are other operators you can try out, like system.1.println. You have something called modulo. This one will return you the remainder of two numbers. So what is the remainder? If you divide 20 by 10, it will give you 0. Num1 percentage num2. You can see that it is giving 0. Similarly, you can try for other programs as well. These are just for doing some of the arithmetic operations on the numbers. Like that, you can try relational expressions, you can try for bitwise operators, all that you can try. So if you understand here clearly, one thing is we are actually hard coding the numbers. So when I say hard coding, this is like the input of num1 and num2 numbers is hard coded. So hard coding in the sense, in program itself you have given the input value. So ideally this is not a good example. So what you should do, I mean, since this is the first program, this is okay, but what ideally should do, so if you want to read input from the user, that means in the output it should ask you enter first number, second number, then do it. Then the way to do it is not like this. So I'm just changing this program, or let me put it another program for you, or yeah, let me put another program. I can say new class. I am saying basic Java program v2. So this is your basic Java program v2. I'm just copying everything because that's the same program, right? Just that we want to take the input from user. That's the only change we want to make. Apart from that, everything is same. So why should we rewrite again? So the same program, just that we want to change the input and we don't want to disturb the original program. Now what you have to do is, there is something called scanner. Scanner sc equal to new scanner of system.in. Now you have to import that. I'll explain what is this. Now how the scanner will help is, scanner is a Java package that will help you to read input from the console or your console window. Now what does this scanner we are telling is, read the stream system.in, which is nothing but keyboard. From that keyboard you read the input and you give back to user. That's what we are saying. So what we can do is, after putting the scanner object, like you can say system.out.println, enter first number, then you can say num1 equal to sc dot, as soon as you say sc, the sc is nothing but scanner object. In the scanner object there are different functions to read numbers. Here we are interested in integers, so I am choosing next int. Similarly, I'm saying system.out.println, and I'm asking enter second number. Now here also I want to read the number 2. Again I want to read integers, so I'm choosing this. So you can see Eclipse is very good. It gives you auto suggestions. It saves your time so that like you don't need to type for everything. So I'm just making it num1 comma num2. So this way your program is not hard coded with certain input values which you have given in the code. You can change each time, like I will show you and run it and show it to you. So here is run button. So I ran it, and as soon as I ran it, you know, this window, let me put it down. This one. Okay, no worries. So I enter first number 10, second number 20. Now what is happening is this time the input is not coming from these two, num1 and num2, which was the case earlier. Rather, the input is directly taken from the user. So which is what happening because we have streamed the system.in, and from there you're taking the input. So what is happening? This first one, when we created an object, it actually started getting input from system.in. Here is in this case your system.in is nothing but keyboard. From the keyboard it started streaming the input, and first time it said enter first number, and like I said, the scanner comes with lot of functions or methods where it help you to read integers, float, boolean value, whatnot, strings and all. So here we are saying I want to read a number as integer. I want to read an integer number. So you are choosing sc.nextInt. That means you are chosen, your choice is to read integers. If your choice is to read float, you may have to choose sc.nextDouble or sc.nextFloat, something like that. So you have read the input, which is an integer here. Then you asked for second number. Again, you read it using sc.next. So now what happened? Num1 and num2 is stored with your inputs which you have given for 10, 20. So let's run it again and give some other number, maybe 50, 30. Now you see for any two numbers it will work. The problem with the early any two numbers which will work, it is like a dynamic program. Now the problem with this program is you run it 100 times also, your program input will remain the same. You run it as many times as you want. It's not going to change because that's just one program. Here in this case, the advantage is you can change the input each time. That's the overall point. So you can change and give the input each time. Like this time I want to give 100, 200. You can give that. So every time your input is changing, and based on the input, the values are calculated. Now this time you have given 100 and 200. So those are actually read by using this sc.nextInt and stored in this num1 and num2 variables. The earlier and this program is same, just that hard coding is done in the basic Java program, and this time no hard coding. And in this case, the 100 and 200 is read using nextInt and stored in this particular num1, and the next number is stored in num2. After that, the program is same. It just says arithmetic operation, it does the addition, it does the subtraction, it does the multiplication, it does division, and it does the modulo. So the input is coming dynamically rather than giving anything. So you can run it for different set of inputs and it will automatically work for any number you give. So any number you take, so automatically this will do. So this is how actually you are supposed to write programs where your input has to come from the user rather than you hard code in the program itself, which is actually not a recommended approach. Hope this is helpful. So thank you. Hello everybody, let's open Eclipse IDE so that we can start doing some programs in Java. Okay, so let me open. So this is the project structure I have created earlier. Now I already have a demo package. If you want to create your own package, you can come here and create a package like this. So as the package is created, on that I'm actually creating a new class. Any Java program need to be in a class. So let's name this class as displaying content. This is the displaying content program. So any Java program, as you know, you have to write it in public static void main. So let's write public static void main, then string args, and let's say system. So this is where you write actually your code, because public static void main is the signature, which is part of the JVM, and JVM knows that this is the starting point of any Java program. And here is where you are writing your actual output of what you want to display on the screen. You're saying, hello, this is my second program, and semicolon. Then this is your run button, where when you click on it, the output will be displayed here. This is a very, very basic program to display something on the screen. So instead of that one, let's do something useful rather than just displaying the content. So what we will do is, in this program, we are going to do factorial of a number. Factorial program example. So what is the factorial of a number is, let's say if somebody says 3 factorial, it simply means 1 into 2 into 3. That means from starting with 1, every number keep incrementing until it is equal to the given number. And what is the result? It is 6. Similarly, if you say 5 factorial, it is 1 into 2 into 3 into 4 into 5, which is nothing but 120. So this is how the factorial of a number is collected. The same program we will do using in this session. So first of all, to read input, that is 3 or 5, which is coming from the user, you have to read it, right? So here, if you see in Java, every input is tied to your system standard input streams or standard output streams or standard error streams. These are the streams which actually tied to your input output devices. Now, if you want to do something on output, you have to look at the system.out. On something on error you want to look at, then you have to look at system.error stream. Since we are talking about taking input from the user, which generally comes from the keyboard, you have to look at the system.in stream. So to read it, we have a package in Java called scanner. Since we are going to use it, we need to import it, and that comes as part of a package called util. So util is the package where the scanner comes in. So we can say scanner java.util.scanner. Think it is capital. So this is the package. Once you created the package, now here is where we are going to create a scanner object to it, saying scanner sc equal to new scanner. We want to do on keyboard, right? So which is system.in, that is tied to system.in. So you created a scanner object. Now, after you created scanner object, you have to read the input from user. Now, how to read input? First, let's ask the user to give some number to us. So let's say enter a number. Then now let's read the number. So to read, we use the scanner object sc dot. If you see the scanner when you created on system.in, which is nothing but your keyboard, it comes with set of functions to read input, and all of them will start with next. You have functions to read input as strings, read input as float, read input as integer. Here in this case, we are talking about just integer numbers. So there is a function called next int. If you just type I, you will get this function. So this is the function to read input from the user as integer. Okay, so it shows some error. Did we miss something? What does it say? Create local variable. So we haven't created this n variable, that's what it says. So before using any variable in Java, you have to declare it. So this is where I'm declaring, saying integer, n is an integer. Now once you have done that, now you have to calculate the factorial of number. So I'm writing the logic here. I will explain after writing it. So this is the program. Let's run it first. So it's asking a number. I gave 3, it gave me 6. I gave 5, it gave me 120. You can see that it is matching with the answers which we have earlier discussed. I gave 7, it's working perfectly. Now what is that I have done here? So once I read the input from user as an integer, I'm writing a logic on how to calculate. So how the factorial is calculated, it started with 1 and goes up to the given number. Given number is your 5 or 3. This is your n. So if you see in both the cases, it is going up to the number. So what I have done is I started with 1 and just iterating over up to the given number. So here in this case, if you see in the for loop, it just said I'm initializing the variable I, which one is 1. Then I'm saying 1 less than or equal to 3. Here I'm assuming the input value n is 3. And once 1 less than or equal to 3 is correct, so factvar equal to factvar into I. Factvar is just a variable. Since we have to declare a variable before using it, I have declared this here. Now, first time what factvar will contain? It has to contain a value at the first time also. So that's why I initialize to 1. Since we are doing product, I initialize to 1. If we are doing sum, let's say for example, in that case we are going to initialize by 0. So here we initialize to 1. Now I increments here and it becomes 2. 2 is less than or equal to 3. It's correct. Then it will multiply factvar into 2. What is the previous value of factvar? 1. So factvar into 2 is factvar becomes 2 again, because it multiplies and stores the result in factvar. Now again I increments to 3. 3 is less than equal to 3. 3 is equal to 3. The condition still holds good. So it will again multiply with factvar value into I. I is 3. Factvar is 2. 2 into 3, 6. Now I increments to 4. 4 is less than or equal to 3. Condition is wrong because 4 is neither less than 3, neither equal to 3. So the condition is false. So that's where it comes out and prints the factorial of the number value, which is 3 factorial, which is 6, and 7 factorial 5040. This is how we do it. Now, if you look at program, there are certain things we actually need to follow. When we are declaring variables, all the declaration having it one place is good rather than scattered like this. So let's move it to a proper place so that it looks more clear. Also, commenting in the program is very important. Like we have given an example here. If it is good, if you just say declaring variables here, so that anybody looks at your code will understand what exactly you're doing. It makes your code more readable. Also for scanner also, you can write creating scanner object here. And here what you are doing, I'm not saying for every line you have to write it, but wherever the places you think makes more sense, keep writing it. Comments are a very good way to document your program. Don't think by putting comments it will overload your program and your execution performance will be slow. Comments are ignored by the compiler. That means when your compiler seeing it, it removes all the comment and executes your code. It just skips it. So there is no execution wise, no problem at all. Only thing is when somebody looks at your code or somebody want to add some functionality to code, it is very easy because your code is more readable. So it is more from the user perspective rather than from a system angle. So here I'm saying reading input from the user. And here what we are doing, calculating factorial. Then here, if we want, we can put it, otherwise it's not required. So now if you see, it looks more clear what you are doing here, It is very, very clear, right? So that's why comment helps. Comments are basically used to document your program. And I would encourage you people to use comments where and then possible. And if it is some business logic you're writing, it's must to have comments. It's a good programming practice. Now this code I have written using for loop. The same code I can write using while loop also. So let me comment this code. I'm commenting it. I can use the multi-line comment also. I'm just used to this single line comment, so I've just put it. So if it is while loop, 3 things you need always. One is the initial value, another is condition, then the increment or decrement step. So I'm putting the initial value, which is I equal to 1, because that's where we have to start it. Then the condition part, where we are saying while I less than or equal to n, this is your condition part. And then you have the actual factorial value you need to calculate. By the way, instead of writing this, you can write the shortcut. Instead of factvar equal to factvar into I, you can even write that in a short form. These are called assignment update operators. You can write even like this. This is same as this. The same applies to other arithmetic operations as well, not just this. If you use plus, minus, every arithmetic operation, you can do a shortcut like this. And then you have to increment it. So either you can increment like this. This is same as your I equal to I plus 1. This is just the C style of post prefix operation. So now let's test the program. gave 3, answer is correct. Again, I'm running it. I gave 6, answer is correct. So the factorial is coming correctly. So what is the difference between while and for loop if you clearly observe is, in the case of while, you have to think about 3 things always. One is your initial value, another is your terminating condition, another is your step value. This is always there, but these 3 are must for any while loop. Most of the while loop you need to have this in mind. Okay, so this is must, so that you can put while loop saying this is my initial value, this is the condition to check, and this is the increment or decrement value. Since these are scattered over multiple places and you have to think about it, for loop makes it easier so that you can provide everything in one line. If you see for loop, you can see that this is your initial value, this is your terminating condition, this is your increment or decrement. All that comes in one place, in one line, I would say, so that it is easier to identify where what we are doing, and we can easily tweak also. So maintenance wise, it is easy because everything on one place and all. Whereas in while loop, when the code goes a little bigger, these initial condition, terminating, and the step value scattered. So that way, comparatively, if you see, people prefer for loop because all of that is available in one step. In for loop also, you have different varieties. You have something called iterative for loops where you don't need increment or step initial value and all, so it automatically picks it up. Those kind of for loops are also there in Java, which are called as labeled for loop or enhanced for loop. Mostly comes into that categories. So understand that wherever you have a particular instance where you want to do everything in one place, your for loop works very well. Where you want to have initial value, terminating condition, and step value all together in one place, it is simply you can put in one place and you can easily handle it, because here if you see, compared to this code is more concise. If you see, only the actual computation part you are writing. Apart from that, the initial value and terminating condition, increment and decrement, which the loop has to take care, is in one place. Whereas here it is scattered. This is your initial value, this is your terminating condition or the condition to check, and this is your increment or decrement value. Sometimes we call it as step value. So that's that these 3 things has to be taken care, which is generally related to the loop, but actual computation is on this. Okay, thank you.
Hello everybody, let's do another program which is string functions. Here we will understand about different string functions which we can use in Java. So here we are taking help from the string class, where there are a lot of methods to do certain operations on strings. So let's start with, this is your public class string functions, the main program class, and this is your public static void main where your program get triggered. Now there are 2 variables we have created, string var1 and string var2. String var1 contains string functions program, string var2 contains string functions. And we are putting just an output statement to say string operations are. So when you run it, these are all string operations you get. Now let's go each of the string functions one by one. So now when we say string var1 dot characterit of 2, here this characterit is one of the string function where it tells you that to return a character value at a particular index position. That means, what is the index position of the first character? It is 0, 1, 2, 3, like that. So in this, when you're saying get me the character at index position 2, it is R, 0, 1, 2. So that's why it is showing R here. Okay, so like that you can get it for any position. Let's say you want to get a 6th position character. What is that? 1, 2, 3, 4, 5, 6. So you should get 0, 1, 2, 3, 4, 5. You should get 5 now. Sorry, you should get Z now. Okay, it has gone. We have given 6, right? Since it starts with 0, we should have given 5. So you see, Z is coming. So that is how you can get a particular character at a particular position. Now there is another function called code point8. So here the code point is the Unicode character value at a specific index. So as we know, we can identify a particular index position and get a character in strings. Similarly, you can get the Unicode value. Unicode is the character encoding schema Java uses which supports multiple character codes. Earlier used to be having different encoding schemes like ASCII and EBCDIC, which does not have support for a lot of character set, whereas Java's unicoding helped us to support multiple characters in multiple languages. So that's why encoding is the standard now. So in unicoding, what we are asking is, get me the third character position. What is third character? 0, 1, 2, and 3. That means you are asking, get me the I Unicode position. So I unicoded value is what we are asking here. So what is I unicoded value? It is 105. Similarly, you can ask for any position. So it is giving the character code which is used by computer inside. That's what it is showing you. Similarly, you have something called code point before. So code point before is just the same like this, just that it also gives, when I said same like this, it also gives you the character encoding in Unicode, but it will give the previous character of whatever the index you specified. That means when you're saying before code point before 1, that means you're asking before 1 position, whatever character is there, give me the Unicode value of that character. That means here, what is 1 position we have in string var1? It is T. Before that, what is the character? S. So for S, you are asking to give a unicoded value, which is 115 here. Similarly, we have something called code point count, which is nothing but it tells you the number of unicoded characters between a particular set of indexes. So when you're saying 0, 5, what it says is, what is 0, 5 position? 0, 1, 2, 3, 4, 5. So we are asking in between this position 0 to 5, that means from S to Z, how many unicoded count of characters are there? That's what you are asking. So it's saying that there are 5 unicoded characters between that. It just gives the Unicode characters count between a particular range of index positions you have mentioned. Now coming to string comparison functions, where it is used to compare your strings. Now we are saying, can you compare string var1 with string var2? What is your string var1? It is string functions program. String var2 is just string functions. So when you do the comparison, what does it do is, it compares both strings, and if it is equal, then it says a response, then it gives the response as 0. If it is not equal, at least it tells you the diff. So what is the diff? Here it is diff is 8. That means it is saying you, when I compare this string with string var1, string var2, I see there are 8 characters different between them. So that 8 characters are this, because up to this both are same. What are those 8 characters? This is 7 characters if you count, and this is just the space character. These are the ones different between them. That's why it is saying 8. If you just remove it, just to check, if you just remove this, you can see the difference. I just removed it. Now it should say 0 because both are equal. You see, it is saying 0 because both are equal. So one thing to understand, the comparison function, the compare to actually compares 2 strings, whatever the string you have given and the string you have mentioned in the function, and it will result as 0 if both are equal, and it will result as the difference between the strings if they are not equal. Okay. Now coming to another function called compare to ignore case. This is exactly same as this, just that here in this case it is case sensitive. That means it looks at the case also. Like when I say case, that means let's say all are capitals. In that case, it will say it is not equal. So let me show you that. If you say string functions, we just say string functions. If I run it again, you see it says 32 characters are different, the first function comparative, because all these characters are different than this, right? Because they are uppercase and lowercase. That is what comparative does. Whereas when you say compare to ignore case, it just ignores the case. It makes everything into lower or upper, something like that, and it compares. That's why it is saying 0. That means there is no difference. That's the difference. So the ignore case is what it does is it just ignores case, whether it is capital uppercase letter or lowercase letter, doesn't matter for it. It just looks at the character face value of the character and does the comparison. That's the difference. Okay, I'm changing it back. We have other functions to work on this as well. String functions. Now coming to another function called concat. These are concatenate strings. So concat is nothing but adding 2 strings together. you can add numbers. When you say adding is not a right word, you can say appending, because it is like sticking two strings together. So you are sticking string var1 with string var2. String var1 is string functions program. When you say string var1 dot concat of string var2, it just attaches string var1 with string var2. That's why you are seeing the result as this. Okay, if you run it now, you can see string functions program, string function. So it concatenated it. Similarly, you have a function called contains. So contain functions, what it will do is it will check whether this particular string is contained in string var1. That is what it checks. So whether this particular value is part of it. So it is checking is am a subset of this. That is what it is checking. So it says string var1 dot contains means is string var1 superset of this. So it just check that. If it is yes, it will say true. So you can see that it is saying true because it is correct. Similarly, you have something called ends with. Ends with tells you whether a particular string is ending with a particular letter or particular set of characters. So here you are saying is string var1 ends with gram. If you see string var1 is really ends with gram. So in that case, this guy will return as true. So you see that it says true. So instead of gram, if I put something else, let's say grams, something like that, it should ideally, what it should say? It is saying false because it's not ending with grams. It is ending with gram, program. Okay. Similarly, you have something called string var1 dot equals in var2. This one actually what it does is, so there is compare to we have seen, whereas that guy will return you in the terms of numbers, whether it is equal. When they are equal, compare to will return 0. When they are not equal, they will give the number, which is the difference of the characters between the two strings compared. Whereas equals, what it does is, if it is equal, it will return true, otherwise false. So string var1 equals string var2. Obviously, they are not equal. There is a difference. So that's why it is returning as false. Okay. So if you want to make it true, as we know, just remove this guy. And if you run this guy, you can see there is a true value here. Okay. So that is called string var1 dot equals. So similarly, you have equals ignore case. That means this guy, if you put everything in capitals, just like other time we have done for string var dot compare to ignore case, right? The same thing. I'm just putting a capital case here. String functions. When you do this, you see this is returning as false, whereas this one is returning as true. This is nothing but your ignore case. So it will ignore the case. Sorry, that is comparative. This will ignore the case and does this. So here in this case, if you see, it is ignoring the case and does the comparison, whereas it is not ignoring. This is case sensitive. This is case insensitive. Case insensitive comparison. Okay. Now, similarly, we have other functions called hash code. The way hash code is calculated is like this. So it just calculates by taking the string s of 0, each position it takes, and multiply by 31, power of n minus 1. N is nothing but the number of characters of your string. Like that, it keeps going and generate the hash code. This is the formula for it. So if you want to get a hash code of your string, you can execute this function, and now the hash code of the value of the hash code value of your string var1 is 731540044. That is the hash code generated. Okay, so it changes also, since based on if you modify the string, it changes. Okay, now there is another function called index of. So index of, what it does is, wherever the program is there first, it gets the first occurrence of that program. Say for example, string var1, where is the program? The program word starting from here. So it tells you from what position this particular program is starting. That is what index will tell you. So if you see, it's saying it starts from 17th position. That means in this string var1, we start counting this from 0. This guy is at position 17. That's what it means by. Similarly, there is a function called isEmpty. IsEmpty will tell you whether a particular value or string value is empty or not. Like for example, it will return true when the string is empty. I'm making it empty, and it will return true if it is empty. So let me run it. So you see that this is returning true because these are empty. Whereas if I make it some content here, If I put some value there, if you see, it will return false. Okay. Similarly, we have other functions like last index, length and all. Let's continue our discussion there. So this function, so we have created another string called string var3. This string var3 is assigned with function programs function. Now we want to count the last occurrence here. Where is the functions? If you see, functions repeated twice here, first time, second time. Now last occurrence is nothing but this one, this occurrence, because this is the last occurrence in this entire string, right? That last occurrence index you wanted, then that is the function to use is last index of. So last occurrence position, if you see, it is saying last occurrence of this starts at the index position 18. That's what I mean by last index. Similarly, you want to count the number of characters in a string. That means string var1, how many var1, how many characters are there? It says string var1 has 24 characters inside it. That's what it says. Similarly, you want to replace functions in this with Java. You can use replace function here, where you are saying replace the word functions in this string with Java. So you see this functions, this is the one you want to replace with this. So you see Java program Java. This is how it replaces. So here is one thing to understand. Strings are immutable. When I say immutable, they can't be changed. So even though it shows I have replaced, what it does is it creates a new string object and just showing you the value. But the actual string var3 is never changed. So if you see, I have printed string var3 and it still remains the same. So if you want to change it, you have to reassign back the result of this to the string var3. But otherwise it won't get changed. Just like ends with, we have another function called starts with. Here it checks whether a string is starting with string or not. So we are asking, is string starting with string or not? So if you see, our string functions program starts with string. That's why it returns true. Let's say if I have put something else here saying, is it starting with one string, and run this now, it should say false. See? So that's what it tells you. This is very useful when you work on data, like where you have a lot of log files and you want to process it. There you want to filter out certain log information or certain log information where it is starting with error or warning, that kind of time. Those instances is very useful, where you can just say, if the string starts with only this, then I want to do the processing kind of. Now coming to another string we have created, we just overrated string var1 with hello world. Here we want to convert every character of this uppercase to lowercase. That's what we want to do here. Now for that function is to lowercase. If you do that, see, you can see that it converted everything to lowercase. Similarly, you want to convert everything to uppercase, you have a function called to uppercase. So since it is in uppercase, there will not be any difference. Let me change this var1 to lowercase. Hello, hi, how are you? Something like that. And you put a semicolon there. And if you run it, you can see everything changed to uppercase. Similarly, you have another useful function called trim. This is very useful when you read strings from user as well. Let's say the string has some spaces before and after the string and you want to remove them. Then you can go for trim function, where it automatically removes that. You can see that when I run it, the hello world does not have any spaces before and after. So without this, if I just run it, you see the difference. See, there is a space before. So this trim function helps you to remove the spaces before and after. Here, in fact, here also there are some spaces, just that there is no characters afterward. That's why it is not showing. Okay, that's all on string functions. You can there are a lot of string functions are there, but these are the most commonly used ones. Thank you.
Hello everybody. Let's start opening our Eclipse IDE. This is my Eclipse launcher. Let's close it and launch. So once this is launched, we will write a program where we a quiz program where there will be given a set of options, and from that option user have to choose which is correct. So we already have this package created and we have this demo. In demo, I'm creating a new class. Every program, as you know, we have to quiz program. Every program should be part of a class in Java. So this is where I'm writing public static void main, which is the actual function your JVM looks at when it actually runs your code. So now here we need to, let's say we want to write a quiz program. So quiz, what will happen? Like you can go endlessly, like you can write in different ways. First we will write a normal way where we ask user 4 options. Like for example, if you look at the recent news, one of the popular news is Blue Origin, right? Like, you know, it is scam in Prime or not, Prime also. So who founded the Blue Origin? It is Jeff Bezos. You all knew it. So let's put a quiz program where we put different founders, and one of the option is also Jeff Bezos, and see whether user guesses it correctly. That's what we are going to write. So our agenda is clear. Now start writing something. Start.print.ln. We are going to say, ask the question, who is the founder of Blue Origin? That is our question, a quiz question. And here we are going to give a set of options. Out.println. One, Bill Gates. 2, Tim Cook. 3, Nadella. And 4. So 4 is our correct option. Jeff Bezos. Now when we do this, what will happen? First we will run this. So this is your run button. If you run it, so this is how it shows. Who is the founder of Blue Origin? It gives you 4 options. We didn't give a space here before Jeff Bezos. Let's give a space so that it looks nice. You see that? Now it looks nice. Who is the founder of Blue Origin? Now user have to choose one of the option, 1, 2, 3, 4, one of them. We know 4 is correct answer. So what we'll do is we'll ask the user to give some input. So to read the input, like we know, we have to create a scanner. We have to use the scanner package, which comes with part of, you know, Java. It's part of your util packages, java.util.scanner. So this scanner, we are going to have a scanner object created, scanner sc equal to new, and we need to read from keyboard, right? So which is system.in. So now we created scanner object. Let's put a comment that we have created a scanner object here. Created scanner object. Scanner object here. And here what we are doing, comments are a good way to indicate what you're doing in your code. Displaying the set of quiz options. Now once you display, now you have to read it, right? You already displayed the options for the quiz. Now you have to read it. Now here, the input you can read in different ways. Like since we gave options 1, 2, 3, 4, let's read the input as integers. So here you are saying, I want to read the input. So you're using the sc, which is the scanner object, and you're saying sc dot next. Next are different methods. Scanner had different methods to read input. It has got a scanner object got methods like next string, next line, and all that to read different set of inputs. Like next line will read the entire line, next will read the string, next int will read the integer, next float will read the float value, like that. Here we are interested in just the, you know, only the integer, so we can just say next int, and this is what we need. Okay, and here we need to declare n, that's why this is erroring. So let's say here we put some statement saying declaring variables here, and here we say int is n. So we declared n also. So here is where we are going to read the input from user, the integer 1 or 2 or 4 or 3 or 4 options. Now, once user gives the input, that is not sufficient. Again, you need to check what is that user has given, whether he has given n value 1, 2, 3, 4. As we all know that 4 is the correct answer, we can simply write one for loop where we say this, one if condition where we can simply write something like this, saying if n value is equal to 4, we all knew that that's a correct answer. You can just say if n value equal to 4, system.out.println can say congratulations, you have guessed the correct answer. That's what we are going to tell user. Let's say if user didn't guess the correct answer apart from n equal to 4, that means apart from option 4, every other option is wrong. So you can just put in else, because any other option apart from n equal to 4 is a wrong option. So I can just say system.out.println wrong choice, please try again. That's it. Now let's run the program. I'm running it, and you see it is waiting. Now here is one thing missing. So we are taking input, but we are not asking to ask user to give an input, right? So that statement is missing. So let's write that as well. System.out.println, and we are asking here enter your choice, and choice must be between 1 or 2 or 3 or 4. It shouldn't be any other random value. So we are giving it specifically. The choice must be one of this, semicolon. Now let's run this and see the difference. Before that, let's put proper comments. So this is for reading input from user, and this is for validating user choices. You're validating only, right? So validating user choices. Now when you run it, so now you see it is clearly asking you how to enter a choice between 1 or 2 or 3 or 4. So let's say I choose 1. So it says wrong choice, please try again. Let's run this program again by clicking on the run button. This time I gave 2. It again says wrong choice, please try again. Again I have to run it, and this time I have to give 3. Again it says wrong choice, run again. This time let's say it gave 4. This time I have guessed it correctly. So this is how you can write a normal program. But if you see, there is one problem with this code. The code wise, every time user gives a wrong option, what if you want to, whenever he give wrong option, what if you just ask him to do it again, give a try? I mean, every time I have to click on this run button and then you are giving option. Rather than that, the program itself should keep running unless he press an exit button. So maybe the exit is something like, let's give an exit option also here, like this, exit program, like this. So this option also we will give, and here also we will mention exit. And what we are going to do is we are improvising this program. Okay, let's do one thing. Let's write a separate version of it rather than disturbing this program. Let's test if we haven't modified it. Yep, this is correct. So let me do a good version of another version of this program. I'm creating another class here, quiz program 2. So this is another version of it. So here I'm going to copy everything, but I'm going to make few changes so that the program works in a better way now. Because every time user have to click on the run button, I want to avoid that. I want to give him an option where he can give one number and that will exit from the code. So I missed the public. Okay, so here I'm going to give one more option to him, which is to exit the program. So until he press exit, the program keeps running, and whenever he say I'm done checking the quiz, it will just. So I'm putting one more option because we gave one more option 5. And if he says n equal to 5 or 4, we'll say this, and we can write one more else if, where we say if now, as we say, like this has to run continuously, right? So every time we want to get the options and all need to be repeated. So the same program, if you see, it is nothing, I mean, just displaying the content and taking the input, that's all. So what we want to do is this want to repeat the, if we say n equal to 5 or 4, we will say this, and we can write one more else if, where we say if now, as we say, like this has to run continuously, right? So every time we want to get the options and all need to be repeated. So the same program, if you see, it is nothing, I mean, just displaying the content and taking the input, that's all. So what we want to do is this want to
program in such a way so that until user gives the proper option, it keeps doing it. And whenever user gives the proper answer, that means whenever user gives the right choice, it will exit. Otherwise, for 1, 2, 3, it will keep running the program asking, okay, give me another choice, give me another choice, like that. So let me write it using while loop. While true and making this So let's run this first. So first time you gave an option. You see, whenever there is a wrong choice, earlier program, you need to again click on run button. Now you're not clicking. Whenever there is a wrong option, it says wrong choice, please try again. It is displaying again. 3, it's wrong choice. 3, 4. You see 4, it says congratulations, you have guessed. Now you want to exit from the program, give 5. Now the program is exited properly. Okay. So if you see what we have done compared to earlier program is we have improvised the program in such a way that whenever user gives an input, we are validating whether that is correct. If that is correct, we are saying, do you guess the correct answer, which is what happened in this case. If that is not correct, every time you are displaying the same set of option asking, okay, can you enter another choice? That's what we are doing. And we are given added one more option where we want to exit the program also. Now let's understand how this is being done. Program wise, the same set of whatever we have written here, we have copied here. We have added few things here. Everything we have put in while true. While true means, whilst condition means like, it is an infinite loop here, running infinite loop. So while true means the condition is always true. It will never be false. It is like an infinite loop. In that, we are asking who is founder, then 1, 2, 3, 4 options, and we added one more quiz option. Which is like 5 exit program, and once 5 he presses, it will exit out from the program. That means it will not keep displaying the menu options. Here, since you have to give one more choice, we just added enter your choice as 5. That's why this 5 is appearing, and we are reading the input. So other than this is same where we are saying when n equal to 4, user has guessed a wrong correct choice. Let's say if user have given n equal to 5. We know that n equal to 5 means what? He has to exit from program. That's where we are executing this break. Now this break, what will happen is when this break gets executed, it terminates your while loop, because your while loop is running infinitely. Somebody has to terminate. At what point you want to stop it? You want to stop it when the program doesn't want to continue further, or user doesn't want to continue further. Not program, user. So we are giving extra option to user, saying when user don't want to continue, just terminate from the program. That's where we are executing break, so that when user gives 5, it will execute, it will terminate. That means this infinite loop got terminated and it comes out. Otherwise this keeps running. So you can check that again. Like even when you give correct option also, it will keep running again. So even you can do, if you want to improvise the program, you can even do something whenever user gives the correct choice, also you can execute the program. For that also you can just add a break and it will easily handle that. So I can see that here. So now either I give 4, it will exit from the program is exited, or when I run it again and I press 5, that time also the program gets terminated. So we have two options. And any other option, obviously you want to iterate. So we are iterating and showing the same set of menu options. So if you run it, the other things remain the same. You put 1, you put 2, you put 3. Now it is exited. So like that you can use break to break the infinite loop. Here one more thing, here if you see we are taking integer as input. You can even validate what he is given as the correct choice. Let's say there is a high probability that instead of 1, 2, 3, 4, 5, he might have given 10, he might have given 20, because that's also possible, right? So that case, what is happening? this is really useful when you are actually testing your code. Let's give some other wrong choice. Like if I say 10, is it working? We have handled it correctly because we are saying n equal to 4, it is correct answer. Any other choice, n equal to 4, correct, it is correct choice. N equal to 5, you just break out because this is an exit program. Any other choice, when I say any other choice, given number could be any other thing, you just say this is a wrong choice, please try again. So this applies to any number which we give also. Here in this case it is 10. Let's say if we give 100 also, it applies the same. It applies the same. So that way we validated correctly. Okay, so this is how you can extend your program so that you can handle multiple use cases like this, like where your program will continuously and takes different inputs. That is one way to handle different values altogether. Apart from that, you know, if you want to ever put a lot of menu options and all, you can try this kind of programs. And there are a lot of validation also you can still do. If you want to validate, I would suggest the validation should be part of some functions where you actually do validation. That way, in future, you want to extend the validation or do some more modification on the validation, it is easier. Okay, so that's all. I hope this is helpful. Thank you.
So let's look at this student program where we are going to have certain students with register numbers and student names. We are going to add it in array list. Then finally, we are going to arrange them according to the registration number. That's what the whole motto of this program. So let's start with this. So this is your main class, student main. It has a main method called public static void main. And here we are creating a student array. And here we are saying we are going to have 5 students. That means 5 array locations. In each array location, if you see, we are creating an instance to student class. So from where it is coming. So if you see on top, there is a student class. What does this student class contain? It contains 2 instance variables called registration, 2 class variables called registration number and student name. One is integer. Registration number, it can be string also, but here we are considering integer, and student name is string. Then we have a constructor called student where it takes input as registration number and name. And what it does after it taking it, it actually assigned to the corresponding instance variable. This means the instance variable's registration number and instance variable student name. It assigns those registration number and name read from user. So whenever user creating an object, it will call the constructor, and whatever values he passed, that will get assigned here. Now let's come back here. So each time what we are doing, we are creating a student class, which is this, a student class object, and that object we are passing registration number and student. That means this 12341 and Manish comes here, and it gets assigned 12341 will be here, and it gets assigned to the instance registration number. Here in this case, it is first object instance, which is student, and it is stored in 0. That is what's stored here, and similarly name also stored in that particular instance. The same thing happened for 12342, that comes in stored in that particular object instance, and the name stores in that corresponding object instance. The same happened with other students. Like that, 5 students information will be stored. Now what exactly at the end of this, after doing all that, what does array contains? If you look at, if I run it, you can see it just contains each array location here. Array of 0, 1, 2, 3, 4 contains just the object locations. What are those object locations? These are the object locations, corresponding objects we have created, right? That objects will have information about the registration number and Manish. Now our job is to, using that object instance, we should be able to get the registration number and student of each one of them. Now before that, one more thing I want to say, that here we are using array.length. So array.length actually represents the number of locations in a particular array, or rather the number of elements in that array. So here 5 elements. So until the 5 elements are there, the loop continues. So we don't need to mention 5. We can just say array.length. That is a predefined variable in array. So now let's come to the actual part. So we are saying the same thing. This line and this line, if you observe, it is same. We have started loop with for int I equal to 0. Then saying I less than array.length, I plus plus. So the loop continues up to all the elements of the arrays are done. So we are printing student with registration number. You can see that, and we are able to get registration number and student. But here the interesting thing is how we are getting. So we are saying array of I. So array of I, what does it represents? As I showed you, it represents that particular object instance, each object instance. So when you say array of 0 first time, it will refer to this object. In that object, whatever registration number is stored, which is this, and whatever student name is stored, which is this, will get captured. So first object instance, what it has the student registration number as 12341 and the name as Manish. Similarly, the second one, the second object has 12342 as the registration number and the name as Aravind. Similarly, third object has 1234 as registration number, Satish as the student name. This is how you can put certain student registration number and names and get it using this particular array list, using this arrays using that. So this is how you can arrange a student's information by registration number. So let's summarize what we have learned so far. We have learned about how the JVM architecture really is. When you give a Java program, how actually it gets converted to a Java class, and all those phases we discussed in detail, like how the compiler executes etc. bytecode, what and all thing happen. We also discussed about what is basically an object-oriented language and what are the principles that actually need to be adhered in order to become an object-oriented language, like polymorphism, abstraction, encapsulation, inheritance, object class, and all that. We also discussed about different types of, or I would say primitive elements of a language, like variables, constants, conventions, declarations, initializations, what is the character coding provided by Java, like Unicoding scheme and all that. We also discussed in length about different types of data types we have in Java and where and all how to be used. Then finally, we discussed about different kinds of flow control statement, like conditional statement, where we discussed how to use that when you want to check if those particular variables are greater than or bigger than or less than, like that, using different if statements like if, elif, and else if. And we also discussed about different types of loops. We have for loop, while loop, and do while loop. We also discussed about different variety of for loops we have, like enhanced for loop and labeled for loop, and the C style for loop. Then we discussed about access specifiers, like which we can use to put in before a variable, before a class or a method, in order to restrict the scope of that, like public protected default protected, public private protected default, or the access specifiers we can use. Similarly, we discussed about what is an array, what are different types of arrays that can come in, like single and multi-dimensional, and we discussed in length about how to use that in programs. Then finally, we discussed about something called command line arguments, where how to pass arguments over command line and make use of them. And we also discussed about different types of parameter passing techniques, like call by value, call by reference, where call by value is where you're just passing a value and storing it and processing it, where call by reference is more about you are getting the address directly and processing it. So that's what we have done in this particular chapter. I hope you find this useful. Thank you. Hi everybody, Krishna here. Hi everybody, this is Krishna here. Today we will discuss about utility packages in Java. So agenda of this particular module is you're going to learn about different utility packages Java have, and you also learn about what is inheritance and different types of inheritance we have. Then we will understand about object type casting in Java. We'll also focus on method overriding and writing Lambda expressions in Java. Later, we will discuss about different types of interfaces we have, like set interface, marker interfaces, everything. And then we'll discuss about inner classes in Java, followed which we'll discuss about exception handling, then Java memory management. So packages in Java. So what exactly is a package? So package is basically a group of similar types of classes, interfaces, or sub-packages. These all are, if you want to group it, package is the answer for you. So let's say you want to group a related classes or interfaces, or let's say a sub-packages, you can group all together in a package. And the default package in all of your program is included as java.lang. And the packages helps you program to a good management of your program organization. It helps in easy maintenance, and it provides certain level of access protection as well. So let's move on. So if you see in the packages, when we call utility packages are more about what are the useful packages or the commonly used packages you use on a day-to-day basis. And using these, you can manage different collection of objects. You can ensure there is like certain kind of communication happening, and you can also modify the information within these objects. Now, like I said, package is nothing but a group of related classes or sub-packages or interfaces. And you can create a package just by saying package, a particular name, like let's say package XYZ semicolon, that will create a package for you. And it should be the first statement in your Java code. And when you want to create a package, think like package is more of like a directory in your operating system. Whatever package name you are creating, let's say you have created an XYZ package, with the same name you have to create a directory and put all your related files or related classes under that. And like I said, by default, every program will have java.lang package imported. You don't need to do it explicitly. It is done automatically. And there are certain kind of wrapper classes also are there, which actually help you to convert from a primitive data type to object and object data types into primitive. And you have other types of utility packages like string classes. And generally, the string literals which you use in Java are all instances of your string classes. And in string class, you have a variety of methods to generate new strings or extract or search for strings. And one more thing you have to remember is string by themselves are immutable. When I say immutable, that means they cannot be changed once it is created. Now the question comes how you can change it. The one way to do it is using string buffer classes, where it helps you to modify strings once it is created. And not only that, it provides a lot of methods in addition to what string class have. And there are other kind of utility packages like math. Math actually contains a lot of mathematical related functions, right from absolute function to floor, ceil, all the kind of mathematical functions you can see here. All your trigonometric, everything related to mathematics, whatever you can figure out, you can see in this math package. Apart from that, there is this runtime package also available, which actually helps runtime environment to execute a process to invoke your garbage collection or to get total in memory. Besides that, you have system class packages, which actually help you to access your standard input, output, and error streams. So using that, if you see in earlier modules, we have seen something called system.in. So that system.in is part of a system class, which is used to take input from the user using the scanner, by the way. Now, besides this, like object class, understand that every class is a child of object class, and object class can be considered as a super class of everything. And all your instances which you actually create, they actually come with this runtime state environment automatically because of this object class. And your multi-threading is also supported in Java using the classes like thread and thread group classes and runnable interface. And threading, by the way, multi-threading is used to concurrently run multiple functionalities at a time. That's the whole point of it. So it is like a parallel execution of the program. Let's look at this utility packages example program where we are using date and time. So here, if you see, we are using just java.util.start, which is where we get all the utility packages like calendar and everything. And here we are using the calendar package. So if you look at what we are doing here is we are just getting an instance of the calendar, then trying to print the date and time. And in this calendar class package, if you look at this particular package comes up with a lot of methods. Like you can get the current year calendar, you can get the year of this current calendar, month of the current calendar, date of the current calendar, hour, minute, second, everything you can get. Not only that, you can do some kind of arithmetic also on the calendar data. That means like, let's say you have this particular calendar instance you have created, which is actually gets you the current time and the current year, current month, everything, and including the current hour time and all. In that, if you want to add a minute to it, let's say for a minute you want to add 30 minutes to it, you can even add by saying calendar.minute 30. It automatically adds it. Similarly, you want to get the current time, you can get this current time instance method also, where it will get you the current time information. So you can see that here, that's what we are printing. We are printing the date and time, month, year and all, which we have retrieved in the previous method if you look at. And you can see we are also printing the current time and the date as well, which is what the calendar.getTime is. And this is the individual fields which we got the information. Now coming to access specifier. So what exactly is access specifier? So access specifiers are nothing but, a certain kind of keywords you use in object-oriented programming languages that actually tells you to put some kind of accessibility on classes, methods, or any other members, including constructors, variables, and all that. So there are basically 4 types of access specifiers you can see. One is the default constructor, which will come up when you don't specify any of the keyword access specifiers. Another is private, protected, and public. So private, protected, public, you have to mention it explicitly. Default, you don't need to mention, because if you leave it, it will be considered as a default access specifier. Now coming to inheritance in Java. So inheritance is nothing but acquiring the properties of some previous class to another class. Like that's the first point mentioned here. It's a process where you can have one particular class inherit the properties or behavior of another class. And you can inherit multiple classes, not just one classes from the parent class, which is called hierarchical inheritance, because multiple classes are inheriting from a single parent class. Similarly, with inheritance, the main advantage is reusability. That means why you are inheriting. You are inheriting so that you don't need to add the code which it is already written. So inheriting class, what it will do is whatever features you add, it automatically add new features to it, because the previous classes or the parent classes already has these features. And beyond that, whatever you want to do, that's what you are adding it here. That means, let's say you have a parent class some features and you want to have your own unique feature, you can add it. But the work you have to do in order to write the features which is in parent class, you don't need to do that. That's what the third point which is mentioned here. Now coming to types of inheritance, you have single, multiple, multi-level, hierarchical, and hybrid. So let's look at each of them in detail. So single inheritance looks like this, where you have a base class and derived class. And base class is where you define all the common features required for its subclasses, and derived class is where it just acquires or obtains the features of the base class given and starts from there. That means you don't need to write the code which is base class given to it. That way, the time it takes for developer is improved because you're not rewriting again. So this is an example. If you look at in this parent class, the child class is extending the parent class. So you can see that the child class is extending the parent class, and parent class already have a method called method A. Now when this child class extends, it automatically not only gets the method which is defined inside, it also have access to the methods in the parent class. That means the method A. So that means whoever is inheriting child class, they will have method A and method B also available. So now when you are creating child class object, we might be thinking only method B you can call, but that's not correct. Not only method B, since this guy is inheriting parent class, it will have access to its method A also. That's why in this particular code, if you look at, we are using an object to get the method A call also we are doing, and we are calling method B also. Now coming to multi-level inheritance, where here what we will do is we actually inherit from the different levels. Like there is a class A, class B, class C. So class A you can consider like a super class where it will have some features, and class B actually obtains the features of class A. And when class C is inheriting, so what really happens is here whatever features class B have, they don't have just the class B features, it have the features of class A also. That means class B is just inheriting class A, whereas class C is inheriting both class B plus class A features. That's what it is doing. So let's look at this program as an example. So you can see that there is a parent class which is your super class, and there is this child one who is inheriting from the parent class which has method Y. So when he inherits, as soon as he inherits, understand this method X also is part of this code. Now once this is part of this code, that means child 1 is not only having access to method Y, it has access to method X also because it is inherited. Now when it comes to child 2, it extends child 1, which is nothing but this. Then when it extends it, you might be thinking only you have access to the child 2 method itself within method J, and the child 1 method with this method Y because it is inheriting. It will also have access to method X also because child 1 is inheriting this. That means child 1 will have method Y and method X, which is not visible here because it is virtually obtained. So that's why when you actually create an object to child 2, it is able to call method X, method Y, and method Z. Even though method X and method Y is not defined, since you are inheriting child 1, automatically the method Y and the method X inherited by child 1 is also accessible to child 2 because child 2 is inheriting child 1. Now coming to multiple inheritance. So multiple inheritance means like you have multiple classes, from that one class inherit all of it. That means you have two classes, class A, class B. From both of the classes you are inheriting. Like one example we have given here is, let's say you have a parent class called tea powder, milk, and sugar. Now the class tea powder, milk, and sugar is extended by the class called tea. Okay, that means tea class is a specific class that is extending just tea powder, milk and sugar. It might be the requirement of its own T class, that it might be inheriting its own new features, or it might be just inheriting what and all features given by tea powder, milk and sugar class. And multiple inheritance is actually need to be done by Java through interface, because multiple inheritance is not directly supported in Java. Now coming to class A, class B, class C, class D. In this case, if you see, there is one base class. From there, multiple people are inheriting the features, like class B, class C, class D. These all guys are inheriting from the same class A. Now let's look at this as an example. If you look at here, there's a parent class here where there is one method called message A. In that message A, that particular method, this child class, if you see, he is extending. That means this child class will have access to message A. That means you can think like this is copied here. Similarly, when you extend child to extends parent, this guy also will have access to message A. Similarly, when child 3 extends parent, this guy also will have access to message A, even though those are not defined inside the same class. Now that's the property of hierarchical inheritance, where it gets features of all of it. Now when you create objects to child 1, child 2 and child 3, all these objects are able to call it because they are all inheriting one common class message A, where that has this method called message A, and whatever features written inside that code, it will be accessible. That's called hierarchical inheritance. Now coming to hybrid inheritance. Hybrid inheritance is nothing but mixed inheritance, where you are mixing multiple type of inheritance in one just class. Like in this case, class C is inheriting, if you look at class A to class C and class A to class C, then class C. It is like a multi-level inheritance. Whereas here also it is a multi-level inheritance. Whereas this is here, it is like multiple inheritance. So there is a mixed type of inheritance involved. This type of inheritance is called hybrid inheritance. At any project, these three inheritances are not directly implemented, whether you take single inheritance, multi-level inheritance or hybrid inheritance, because this and all creates a lot of confusion rather than giving advantages. Mostly either people go for like hierarchical inheritance, and at times they mix up with other inheritance concepts, but not this one, because either these are very simple like single inheritance, or they might be causing a lot of issues when you inherit. So that's the reason people don't actually encourage to be used at the project level. Now coming to object type casting. So what exactly is object type casting is? Object type casting is nothing but where actually casting is nothing but conversion from one data type to another. So you are converting from one data type to another. In object type casting, there are two types of object type casting possible. One is primitives, another is references. When I say primitives, primitives are nothing but the standard data types. That standard data types, if you are doing casting or conversion from one data type to another, that will come under the primitives group. Whereas if you are doing this casting using references, which is nothing but object addresses, that comes under this reference type casting. Now let's look at the primitive one. So primitive one, what really happens? Primitive one, what will happen is you have a variable like this, my double equal to 1.1, and that variable contains a value. And whenever you convert that primitive variable, what will happen? This my double equal to 1.1. So this one, when you are converting, this is explicitly you are casting it. If you put parentheses, it is explicitly you're casting it. So this my double 1.1 will get only value as 1, even though it is 1.1, because you are explicitly converting to integer, and that gets stored here in mind. That means what happens is the value of it completely gets changed. The original value will not retain back. That's what we are saying here. Once you convert primitive variable by using casting, the changes are irreversible. That's what we are doing here. So once you get that, you cannot get the 1.1 back because you already casted it. So you can understand that primitive casting, once you do that, it is not possible to recast it back. And reference variable, like I said, it only refers to an object address, but they do not contain the object, they contain the object address. Now casting a reference of variable, it doesn't touch the object, because when you're saying you're not directly storing the variable, but you are actually storing the memory address of that object. So what really happens is it actually stores the pointer to that object rather than its value itself. So that way what would happen is today it is like one memory address it is referring, tomorrow I can change it to some other memory address to refer. Upcasting is nothing but going from a smaller type to upper type. Downcasting is nothing but going from an upper type to smaller type. Now downcasting will actually extend if you look at, because from smaller data type to bigger data type you are increasing. When you say upcasting, it is like small upper data type, higher data type to smaller data type you are moving towards. So in upcasting, you will also see that for this upcasting, when you use in object type casting or reference type casting, it actually reduces the number of methods and properties available because there's not much of support for upcasting at least. Now reference, you can think it is like a reference remote control. The reason being, reference do not actually contains a value. It actually contains the object address, and all objects where are stored, they are actually stored in the heap. Heap is like, you can consider like one section of the main memory where it is dedicated for storing all these objects. And while doing casting, that means type conversion, you can change the type of the object. Whichever object you want to change to, you can automatically change it. And it is simply like remote control. You're just changing one channel to another. Now, when you say upcasting is nothing but from smaller data type, you're going to a bigger data type. Here in this case of context of reference variables, it is nothing but you are casting from a smaller subclass to a higher subclass. That's called upcasting. And upcasting is closely related to inheritance, because you talk about the subclass and superclass funda only when you talk about inheritance. Nothing other than that you will talk about it. And by default, this upcasting is done by the compiler itself, and we don't need to vary about it. And this is implicit in nature. You don't need to explicitly do any type conversions, just like how you have done for primitive variables. And this is very common that you actually use reference variables to specify a particular type in upcasting. Now let's see with an example. If you see here, this animal has a method called eat, and similarly this dog extends animal, which has methods called eat and bark. So whenever it has eat and bark, if you see when it is extending eat and bark, now you might have a confusion that when I create a dog object, will it call eat of this dog class, or will it call eat of this animal class? Let's see that. Now here, when you are actually creating a new dog class object, so now it creates a, it creates an object for this particular dog class. Now after that, how it knows that, automatically I have to call, let's say you want to call the animals eat method. The way to do it is just take this particular dog instance which you have created and assign this to an animal class object. This is animal class object variable. So when you do it, and after that, whenever you say animal equal to animal, so you are doing this explicit casting here. When you do this explicitly casting, what will happen is this dog object, which is extending the animal, automatically able to call its eat method, because by default, if you create a dog instance and call it, you will always able to call only eat of dog class, but not this animal class. So if you want to call it, this is the way to do it. Now coming to method overriding in Java. So what does it mean by method overriding is, when you have a superclass and you have a subclass, in that subclass, if you are redeclaring or rewriting the same method which is there in subclass, that is called method overriding. And why we do it? We do it because we don't like the features which is given by parent class, and we want to write our own implementation. This is the second point which I'm mentioning, that we want to write our own implementation to the method, because whatever provided by parent class is not sufficient for our use cases. Okay, so here in this case, the terminology we use is whatever method in parent class you use to override or to write your own feature because you didn't like whatever provided by the superclass, that is called an overridden method. Whereas the original method in child class which you write is called overriding method. So that means the parent class method, whatever you have rewritten, that is called overridden method. Whereas the method you have written in order to write your unique features in the subclass is called overriding method. These are the terms we use now and then. That's why we not want to understand about it. Now here you see, this is the overriding method. So here if you see, this is a planet class. In that there is an earth method. In that earth method, if you look at, whenever this Pluto extends planet, automatically what happens, this guy by default we say earth also, any method of the particular superclass also will come. Now in this case, what happens, since the methods are same, when you call Pluto object, when you create and call earth, it by default takes care of this particular method only. You will not able to call it. If you want to do it, you have to do upcasting like we showed earlier. This is called overriding, because by default, what this object-oriented programming language, the way they behave is, whenever you rewrite a method which is same as the method written in the parent class, that method you have rewritten, what that happens is, the same method when you have rewritten, the method which you have written in subclass takes the priority, but not the one in the parent. If at all you want to call in the parent, then you have to use upcasting. So here in this case, when you create an object, when you call earth, it will call Pluto is also a planet, not this earth is a planet. Now, what is the advantage of method overriding? First advantage, you can write your own implementation to the inherited method without changing the parent class code. And another advantage is, if child class want to use the same parent class method, it can do it. there are multiple ways. One way it can use by upcasting, another way it can use by using super. These are the different ways it can use. Other than that, what is the other advantages? Like, let's say, for example, if you have other classes that want to have different implementation, irrespective of, they can use the same overriding features to make the changes of their parent class code. That means, like, let's say other classes also have similar requirement. They can use the feature which you have implemented uniquely and reuse it rather than just relying on whatever parent class they have done. That means parent class code, rather than they override and do it, since you already overridden, they can just use the same thing. Now let's talk about lambda expressions in Java. So what is lambda? So basically lambda expressions actually are written to support a one-liner kind of code. It's part of functional programming. So when I say functional programming, this is another name to functional programming called functional interface. So functional programming is nothing but a term we use when actually we want to say that computation of the code can be done in a single line, just like a mathematical function. So lambda expression supports the functional interface, and this particular functional interface has only one abstract method, which is called show. And with lambda expression, like the name says expression, in this you can write the body and type, required type, if required you can consider, otherwise you can leave it. And if you want, you can return a value also. That and all is possible. It just behaves like a function. The only difference is these functions are nameless one. They don't have any name. That's why sometimes these are called anonymous functions also. Like I said, the whole point of functional programming, the lambda which achieves it, is writing in one line without using these curly braces, because curly braces we use to start the code and end the code, right? Without that, if you want to write the one-liners, lambda expression is the answer. And here, if you want to use a return statement, you can use it, but there's no compulsion as such. That's what we are trying to do here. Now, if you see in this code, there is this public interface display. In that, we have written a method called show, and this is the only method, if you remember, that we can override in this lambda expression. Now, what we are doing is, in this particular thing display, this is where we are passing this particular saying, okay, int a. So what does it mean is, whenever somebody passes display is nothing but this interface, whenever somebody calls this particular show method, that what you have to return is, you have to just give them back the same 100 value. That's what it means, because int a is nothing but the same thing. It gets assigned, and you are saying just give the last value. So whatever last value you leave it, that is the value which gets returned. So here you just left a. If you just put a plus 100, you get whatever value plus 100. Here you just left a. That means whatever user passes, it will give it back. So when you say display.show of 100, it will just simply show whatever the code this has been done. That means it will show that display.show return value from lambda expression equal to what we said in the lambda. This is the lambda expression. We just said just give the 100 value back. So it will just show returns from lambda expression equal to 100. Now, with return statement also you can write it. So even though it is optional, in lambda if you want, you can do it. For example, if you want to do more than one line of code in lambda expression while using curly braces, you have to do it. And if you want to return in when you are doing more than one line of statement, also remember that you have to return the statement also. You have to return the value, and the return value must be either an object or variable. It shouldn't be like any other, just a hard-coded value. Now, if you see here, this is where we are writing, and since this is a multi-line code, you are putting multiple lines. This is your lambda expression. You have to enclose this in parentheses. And like I said, you have to return either an object or variable. Here we are returning a variable. So what really happens whenever you say display.show, this show, whenever you create a class to this EAA, this creates an object variable to it. And whenever you pass a value, this lambda expression goes and replaces in the show method. So when you say display.show, this 5 will get assigned to A, and that 5 value gets returned back, which is return 5. And that 5 value will come here. So here also we are doing the same thing. We are not doing additional computation. We are just saying return value from lambda expression equal to 5. Now coming to static variables and methods. So what exactly are static variables? So static variables are nothing but class variables. Generally, when you have multiple classes in a particular, multiple objects in a class, all the objects, if they want to share common data, that's why the static variables are very useful. In fact, methods also can be reused commonly across all of them using this static variables and methods concept. And like I said, static variables and methods all belong to that class. They are not part of any instance. They are unique to the class, but not unique to the instance. For instances or objects, they are all having different copy. And for the entire class, like I said, since it is a global thing, like one class, one static method, one static variable. multiple instances you can have. You can have 100 instances, 100 object variables, but you can have just one static copy. That's why, like I said, there is only one static copy maintained for the entire class. And main method, if you look at public static void main may be right, that is one static method. And that's one thing common for the entire class where you are writing your program. And static methods can be defined as public or private also. You can leave it default also, by the way. And static keyword, where you place it, if you look at public static void main, you will write it just after the access specifier and before the type of the variable's declaration. Now, if you look at, this is another static method. If you see, there is this after access specifiers, you are mentioning this static. Now here we are trying to explain one of the function where the class contains a variable and a class contains a method name. And here, if you look at this particular variable name, this is a static variable and there is a method with taking parameters and it will have some return type. Now, what we are doing is we are just printing class name dot static variable. So static variable, what it will print? So it will print whatever static variables are. And when you say class name dot static method, it will print the static method which is given here. This is just a syntax. So don't just go with the values which is given. Syntactically, this is how it works. You have to refer static variables or methods by using its class name. Now let's look at a program. In this program, if you look at, you can see that there's a public class temp where you have a class. In that class, you have a private variable, you have a static variable. When I say static variable, this variable, if you create this temp class 100 object instances, still one static copy will be maintained, which is max t. Okay, so what we are trying to do is we are trying to create multiple objects to this temp, and each time we will pass a value, and after all is done, we want to find out whether there's a maximum value or not. This can be achieved only when your max t variable is static, because static means maintains only one copy for the class. If you make it object instance variable, each time the value keeps changing. Now let's look at the main program. In this, we are passing temp of 55. It will come to the constructor. It will assign t to 55. Then temp will be t 55. And then it will check if t greater than max t. That means t is nothing but your 55 value. It will check whether it is greater than max t. What is max t? 0. So whenever it is greater, it identifies max t will become 55. Now onwards, the max t will be having 55, not this. This is just the first time value. Similarly, 100 comes. 100 checks whether 100 is greater than max t, and max t will be assigned to 100. Now similarly, 85 comes. Since 85 is not greater than max t, which is 100, it still maintains the max t old value, which is 100. So finally, when you run this program and end it, what actually you get is the final max value, which is nothing but 100. And this concept to implement the maximum values is only possible given that the max t is a static variable, because it maintains the same copy for all its object instances. That's why you create first instance, second instance, third instance. Still, all the instances refer to the same one class variable. Now let's talk about abstract classes. So abstract classes, like the name says, the classes which are abstract in nature. When I say abstract in nature, that means they don't have really any code implementation. And you have to use abstract keyword in order to make an abstract class. Like you have to put something like this in front of a class so that it recognizes it as an abstract class. Similarly, if you want to make a particular method as a class, abstract class, you can do this even. And abstract classes in Java, they cannot be instantiated. If you want, you can extend abstract class and then implement the code. Now let's see this example where if you look at closely, we have put abstract before a class. So to just say this subjects is an abstract class. In that there is a method called hello. We have written this is Java programming, and this particular main class extends the subjects. That means it is extending this abstract class. Now in this, when it is extending, what really happens is here in this case, one more thing to note here is when you talk about abstract class, whoever is extending, it is their responsibility to implement the code. That does not mean abstract class do not have a concrete methods. Concrete methods are nothing but methods with some implementation. So this is a concrete method where it already has some implementation. That's why we are not writing anything. So if you see, we are creating a main method and we are accessing an abstract method, which is object.hello, where when you are calling, you're just making call to it and you're getting this. Okay, whereas this is a concrete method, but if you want to write your own method, you can write and just leave it the implementation, and the guy who is extending it can implement it. And this, in this case, when you call hello, obviously you will get this is Java programming as an answer. Now coming to interface. So interface is another concept where, this is generally used at the design phase, where you will use to both if present interfaces as well as classes. And in interface, you will write all the methods, all the variables which are required. And you can also, all the abstract methods of the parent interface can also be inherited by the child interface as part of the inheritance. Sorry, as part of the interface when you write it. Understand that all the abstract methods in the sense one does not have an implementation, those all can be implemented by its child interface also. That is possible. And one more thing is, using interfaces, you can create a new interface also. Now, all methods, when you say interface, understand that all methods, both from ancestor and child interface, whatever it is defined, whoever is implementing it, when you actually use in the code, whoever is implementing it, they are supposed to write the code for all of it. That means somebody is implementing inherit interface means they have to write the code for it. And by default, all the members of interface are public. That means they are open. They can be accessed within the class, outside the class, within the package, outside the package, everything. And here, if you look at the class hierarchy and interface hierarchies are different. They do not overlap. When I say class hierarchy, it is like one class through inheritance and all. And I say interface hierarchy and interface creating with using that you are creating another interface and all. They are completely different things altogether. They are not one and the same. And one of the main advantage of interfaces, apart from writing the abstract method, you can put the commonly used constants in an interface. That means if there is a commonly used constants in an interface, you want to use it, you can put it. And if a particular class implements that, then the class can simply use that constants without even putting the class name. Generally, when actually you use a class variable, you have to say class name dot that variable name, right? Without that, you can use it when you put in interface. And the name convention generally when you use in interfaces is generally in capital letters. And this is basically one feature which we use commonly, but this is in recent releases, it is not encouraged, it is deprecated. And constants, you use a class, they are more of an implementation, but if you put in an interface, the biggest advantage you get is, because interface, if you remember, by default, whatever you put in there, it becomes public. So even if you put a common constant variable, it by default becomes a public. Whereas in class, that's not the case. Until you make the class public, you cannot do that as a public variable. Whereas in interface, if you put it, it by default becomes public. Now let's look at this example. Like I said, the convention to write interface variables is just put it in a uppercase letters. So these are three interface variables which we are going to share. Now, in this particular program where we are implements game price, there are no methods here. If at all there are implement methods, they have to implement it, but there are no methods, just the variables, so you can directly use it. And there is a constructor called athlete which has int id, no code written there. Apart from that, there is a winner method where medal is set to first prize. Now what really happens here is, if at all this guy here, if you look at, he didn't have this first prize defined, but how he is able to use this, since he is implementing the interface game price, he automatically will have access to the first prize variable, second prize variable, and third prize variable. So when you use it directly, as I said, all the variables in interface are public and they can be used without the class names. So if you see, there's no need to put game price dot first prize. You can directly use it if you implement that interface. Now coming to Java set interface. Java in interfaces, there are multiple types of inheritance possible. The basically Java set interface moreover mimics the mathematical interface. If you remember your mathematical interface, mathematical sets, they are more about union, intersection, difference, all that this guy implements. And this particular interface Java set is nothing but an extension of your collections. And this guy implement all the classes which are required to implement this set features. I mean the mathematical set features. And since set is an interface, when we call anything, not only set as an interface, you cannot create objects, but you can always implement the features in set and write some code in it. This is the high level of it. Like if you want to use the functionality of the set interface, you can use these classes. You can use in sets, there are different flavors again. There is a hash set, linked hash set, enum set, and tree set. And set interface can also be extended if required by these two sub interfaces, which are called sorted set and navigatable set. Sorted set is more about puts your set in a sorted order, because by default set don't sort it, and navigable set is more about for navigation we use it. And you can see this is one of the set we have used. This is called hash set. So hash set we are creating from the actual super interface set called set. That is the main data type, and we are creating a hash set object to it. Now what exactly Java set contains? So interface, as an interface, if you look at it, contains set of methods. Talking about the first method, add, this particular method adds a specific element to the set. Let's say you want to add few elements to it. You can add one by one using this method. But what if you want to add all of them in one shot? Then for this, you have a method called add all. Similarly, remove one element from the set, then you can use this remove to remove that one element. But if you want to remove multiple elements from the set, then you can use this remove all. Now retain all is more about, if you want to retain all the elements on the set that are also present in another set. That means you want to keep them intact and you don't want to delete, but you want to keep whatever there in the other set, then you can use retain all. And iterator is more about a method using which you can move through one element to another in the set sequentially. Now this Java set interface also comes with a lot of methods. If you want to clear all the elements of the set, you have a clear method. It just deletes all the elements and it makes your set empty. And size is the method to just count how many number of elements in the set. And contains, it just help you understand whether a particular element you are looking in the set is that available or not. If it's available, it says true, otherwise false. Contains all, if at all you have given multiple elements, if the set contains multiple elements you have given, and if you want to check whether all these elements are set, then you can go for contains all. To array is more about you actually want to convert all the elements of the set into an array. That's where you go for to array. And hash code is nothing but, like I said, everything. If you remember, all these mapping structures like your hash map and all internally maintains a hash code. That is how the unique references are made. So if you want to get the hash code of this particular Java set, this is the function to do it. That means for that particular object, when you create, it creates a Java set object, right? But what is the hash code for that? You want to get it, then this is the answer. Similarly, you have something called marker interfaces. So what are marker interfaces? Marker interfaces are nothing but interfaces that does not have any methods or no constants inside it. That means they don't have any methods or constant. Now you might be thinking, what is the use of it? They are very, very useful. The reason is, more than us, it is useful to the JVM itself. So all the runtime information about the objects, these are the guys who pass to JVM. That means these guys will tell about all the runtime information about the JVM to the JVM. And that means apart from the objects, we are using additional information, any further information like how much is the memory occupied by that data, what are the things it is doing, all that it will tell you. And this marker interfaces has many built-in marker interfaces such as like serializable, clonable, and remote. Like for example, if you want, you can create your own marker also. The way to do it is, there is a method you have to override as part of this marker interface, which is called accept. What you can do is, this is one of the example like we mentioned. You can, before even somebody want to, delete or write something into the database, you can authorize, saying using this marker interface where they have to override this accept and they have to say whether I want to do it or not. That accept, you can write a logic to allow them to either delete or insert a data into it by doing some method feature overriding into that particular accept method. That means this is like custom, or custom markers are nothing but user defined markers. Now coming to inner class. So what is inner class? Inner class is nothing but a class inside a class, or a class embedded inside another class is called inner class. Now how to refer it? The way to refer it is, you can say that outer class name dot inner class. Then you refer, you automatically get access to all the elements or all the attributes of the inner class. And every static member class which you have defined, like a member class, all the static member class which you define is actually an outer class, and they do not have any special access to the names inside that class. Like for example, let's say you have defined a static class. When you've defined a static class, inside that you can have another static class also, that becomes an inner class. But again, you have to use the static keyword. That's what we are telling here. That static member class is defined like a member class, but with the keyword static. So that we have seen, any static class member you want to define, you have to use the static. Otherwise, it will by default become the normal variable, normal object variable kind of. It will not become a class variable. And if you want a static member class, actually, if you look at, it is nothing but an outer class if you look at. And it all depends whether you want to write an inner class inside it or not. And one more thing is, even though you define a static class as an outer class, it will not have any access to the names inside the containing class. Let's say you have defined a static class, inside that you have defined another static class. This outer static class will not have any special access to the names inside it, but the inner class will have access to it. And static member class, as we know, it can have static fields and methods. And local inner class, like I said, is defined generally within inner class. In a class, whatever, another class if you define, that becomes an inner class. And when we talk about local inner class, that is nothing but something which you are defined as part of a method. If you write a class inside a method, then that becomes a local inner class. And all the local scoping rules apply there. When I say local scoping rules, what is the local scoping? In that method, until it is alive, all the variables will be accessible. The same applies to the inner class you define inside that local method. And since in the local inner class, one more thing to remember is it will not be able to refer to any parameters or non-file and local variables of the method. That means in a method, you have defined another inner class. That guy will not have access to any of the parameters or non-final local variables used in that method. And all the local inner classes which you write, they are only accessible in that method only. So all the access restrictions, you cannot put public, protected, nothing, no default access and all. It's not possible. They will be accessible only inside that. And the use case will be mostly one-time kind of use cases, not beyond than that. Now coming to exception handling. So what exactly is exception handling? So exception is nothing but an error. So whenever there is an error, you want to handle it. Why it is so important? Because we are all living in internet world, where it is very crucial to run the systems without any stoppage. So if at all there is a stoppage, you don't want to stop the system. Rather, you want to, if at all there is a problem, you don't want to stop the system. Rather, you want to capture the failure and take precautionary measures. So exception handling is that part where it can help you to do that, because by default, all programming languages, as soon as they find exception, they will stop it. That's what we have mentioned here. Whenever there is any error condition in the code, by default, not only Java, every language stops the code there itself. It will not let you move it. Like the second point, if you look at when this particular statement is executed, and if there is any method, if exception condition occurs, what really happens? Generally, what happens is, let's say the first part, there's an exception happened and it triggered a division by 0. Let's say there is a 10 by 0 mistake you did and it returns a division by 0. So generally Java, what it will do, it will stop the code and it will pass whatever exception happened in that method. If there is any exception, it will pass to JVM. And your JVM, you have this Java runtime environment, where your JVM interpreter looks at that exception and finds out what is the relevant exception to match. JVM itself have predefined set of exceptions. It will match the one of the predefined exception and give you that error. And all this by default are a subclasses of this Java's the high level exception class. Every exception what you write, they are actually part of the main class called exception. Now, if you want to handle exception, so what are the things to do? So exception handling, why it is very important, we already discussed in 34/7 systems. It is very important so that you are not stopping system, but you're handling the code. And if you want, programmer also can write their own exception handling, that is called custom exceptions. Because by default, Java interpreter stop your exception, whereas using custom exception or user-defined exception, you can modify the code according to your needs. And like I said, Java interpreter provides by default, gives to the default exception handler if you are not handling that exception by yourself. And the default exception handler, the way it works is it will show you the exception name, it will show you the string, and it will show at what point it terminated. That's what it behaves. Now, these are the inbuilt exceptions possible. That means when I say inbuilt, as soon as you download your Java software, whatever exceptions, generic exceptions Java throw to you are this, like unchecked array index out of bounds. Array index out of bounds is more about you actually declared an array for 10 elements and you're trying to access 12th element or 15th element. It will give you this array index out of bounds exception. Null pointer exception, where when you are accessing a null value like that. So these are all inbuilt exceptions. But even though inbuilt exceptions are there, sometimes what happens is these might not be sufficient enough for you, because you might have a specific situation where you need to handle. So you have to write your own exception, which is called user-defined exceptions or custom exceptions. Even that is also possible in Java, where you can write it. Now, the first step towards how to handle error. So before handling error, one thing to understand is you should know what is the error. Or instead of saying we should know what is the error, you should predict what is the error going to happen, or you should anticipate the error that's going to happen. As a developer, it is very important. Every code you write, you must know what is the errors that's going to happen in your code. If you're saying no, that means you're not considered as a proper developer. So any code you write, you must know. So that anticipation part or the prediction part, or when we say what error is going to throw, is what you are going to write here. So in the try block here, you are seeing try. In this, if you see whatever code we write here in the try block is all the code which you think can throw error. And the try block can come with catch or come with finally. We will look at what catch is. So catch is the place where we handle error. Like I said, in try block, that means in this flower basis inside, you write the code which is actually, can throw errors. That means you have already predicted that it can throw error. And when it throws error, you will write what type of error that's going to handle. You will mention here. Like let's say you have written 2 divided by 0. So it raises a divide by 0 error. So that divide by 0 exception you will write here. And in that catch, you will write the code which is going to handle it. Similarly, for file not found, if you think there is an error file not found can happen in this code, you will write this file not found error here. And you will write the code that is relevant to handle that particular exception. Like that, you can have as many exception handlers. I can call it as exception handlers or catch statements for any try block. But the reverse is not true. That means you cannot have one catch with multiple tries. That's not possible. And if you see here, similarly, there is finally. So finally is the place where, irrespective of, like one thing, if you really look at when you anticipate the code, only two possibilities. Either the code can run successfully or either the code can fail. So in the case of run successfully, it is all and good. But in the case of failure, you have a use case of, you have a situation where you are handling using catch. Now, what if you want to write the code where even though there is a success or even though there is a failure in your code, you want some set of things to happen? That is what you write in finally. Something like you want to close the file always, irrespective of whether the program terminated in the middle or the program went into exception or the program successfully executed. That always has to happen, right? The file closing. That kind of things you can write in finally. Not only that, let's say you have, for example, let's say Amazon, if you take, they have opened certain kind of customer requests. And let's say they have gone into an exception state. They still have to close their web server connections. Otherwise, they cannot serve another customer request. So that kind of code probably people will write in this finally block. Okay, like I said, the catch is more about handling exceptions. And let's say it is very difficult that you anticipate all types of errors. So if you don't know certain error, you can always put under this parent exception. This is like, parent of lot of exceptions, and it can handle any error. And there is one more way, like when you write custom exception, this is very important. If you want to raise your own error, or if you want to raise a particular error, you can use this keyword throw to raise it. So here what we are doing is whatever exception being handled in this catch, you are taking it and again throwing it. The exception object is inside E, that you are again throwing. That means you handle the exception and again rethrowing it. Now you can see here, this is what we are doing. So there is a method rethrow x, and there is this function first, and there is this second method which throws the throwable, and there is try block, and there is code, and there is exception and all. So where is our main program? Main program is here. In this, when we are calling our second, it calls, since this guy is, calling the function, and it calls, where is the second function? Second is here. So it calls this function, and second function in turn calls first, which is this. When he is calling this first, what really happens is it actually prints this exception in first method and all, and it further throws an exception. We are intentionally doing using throw keyword. When it throws the exception, since this guy does not have this try catch block, what will happen is it will give to its caller. Who is the caller here? This guy is the caller. That means he will give back to him. That means this call will come to the next line of it. That means it will, since the error happened because of first function, it comes here and it will check whether there is a catch block. Since there is a catch block, it will give to this guy. And in this, we are writing inside second method. Okay, so you can see the flow. First, the exception in first method happened. Then the inside second method happened. Then what happens is, it again throws the same error which has received. Now when it throws it, it again looks back who has called me. Okay, so who has called second now? Second is called by main. So it again looks like whether second is called by main. Do you have a catch where you can catch the exception? And yes, it has. So when it has, it will print this. This is caught in main. That is why it is called. This particular statement is printed. Now here you need to see this is called an exception propagation or exception chain, where exception is traversed from one particular method to another. Okay, here one thing to understand here is, let's say for a while you do not have this try, you do not have this catch in this particular, and you have only the second function. So what really happens in this case is, since the final responsibility of catching the exception comes to second, and since there is no try catch here, it will give to our default exception handler, which is in the JVM, and that guy will terminate our program. That is why it is very important that you have to handle it properly. If at all your calling function is not handling it, it is the responsibility of the caller to do it, which is what happened in this case. Now let's discuss about final keyword. So what exactly is a final? So final keyword actually helps you to restrict the user to actually, for a variable, if you look at, to restrict the user to not change the value of a variable. That's how it is used. Whereas when you use for a method, it will not let them to override that method. Whereas when you use for class, it will not let them to inherit that method. So that is how finally used. So when you say final, it means done. You cannot do much more than this. And like I said, it can be used with class, method, and variable. And you can see here we are, we have a variable called final int b equal to 6. Okay, it can be assigned a value only when it is created. Okay, this is a normal variable, non-final variable. Whereas when you make this variable b equal to 6, you cannot change it this here. When you change it here, because this is b equal to 6, like I said, when you make it final, that means done. You are not supposed to change it. If you are changing, it will throw compile time error, because here we are trying to increment the value of a variable which is final. Final is nothing but a fixed value, and you cannot change it. So when you're changing, you will get that compile time error. Whereas for the non-final variable, you can change it always. The same thing applies when you use for methods. You cannot override it. When you use a final on a class, you cannot extend it. So the basic advantage of final is to stop value changing, or stop method overriding, or stop inheritance. Now coming to memory management. So what exactly is memory management? Memory management is more about allocating memory and deallocating memory. That's what is about memory management. And Java provides automatic memory management. Then when I say automatic memory management, it means that we don't need to jump in and create memory or deallocate memory, which is what happens in language like C, where you have to use CLF and MLF functions to create memory and deallocate memory. Whereas in Java, it is all automatic. Everything is taken care. Okay, and it is all taken care by programs like the JVM, which has this internal garbage collectors, and they will take care of it. Like I said, memory management is all about creating and deleting the objects. That's what we mentioned here. And basically, if you look at the entire memory management structure, it is divided into two parts. One is the JVM memory structure, which is more about it takes care of the heap, and another is how the garbage collector works. And here in the JVM memory heap, the main objective of all this the garbage collector program, which is this guy, is to ensure the heap space is as free as possible, because all your objects live there. If you are not clearing it properly, what would happen is it will fill the memory and you will get into out of memory situation. So that's what the whole goal of this garbage collection is. So let's start understanding some of the utility packages in Java. So there are a lot of utility packages, and it's like a huge list. So we will see some of them. Some of them which I use in daily life is this particular consumer thing, where it works like your for each loop. So let's start looking at it. So here we have created a utility package demo class. Inside that we have a method called public static void main. We have created an array list variable mylist. Then we have created a variable mcons, which is of data type myConsumer. So what exactly is this myConsumer? MyConsumer is nothing but this, where actually it implements a consumer, and this consumer is part of your java.util.functions. That's why we have imported it. So this comes as part of it. And whenever somebody implements it, so they have to override this accept method. Accept method is something you need to override, where you write your own logic. So that means whenever somebody calls it, this automatically methods get triggered. So here in this case, what we are doing is each time we are passing some value to it, and that value gets added with 5, and it results like this. So you can see here we are passing 100, it becomes 105. We are passing 200, it becomes 205. We are passing 300, it becomes 305. Like that, for all of the values, it adds a value 5. So once we create it, you can see that we are creating a array list, mylist, and here we are creating an array list of 5 elements. After creating array list of 5 elements, we are saying we are creating a myConsumer object, which is nothing but this class object, and we are storing in mcons. So after that, what we are doing is on the array list, we are adding different values. So it is 100, 200, 300, 400, 500. That means your array list now contain, if you just print mylist, it now contains this guy contains 5 values. So this is what being done up to this step. Now after this, what we are doing is for each value you have to pass, and this should get triggered. So for that, we are saying my list, which is nothing but the set of all this, and we are saying for each my list dot for each. There is a for each on this, and we are saying on this object memcon. So what will happen is when you say my list dot for each, on each element it will call this particular object. That means this accept method will be called on each element. So that's why you can see working on the number, it is all coming from each number if you observe. So each element, this function gets called, and whatever you have written will get triggered. And when you pass each element, the value gets passed. Here in this case, first time 100 gets passed, then 200, then 300, then 400, then 500. So first time when it passes 100, this is stored in an object. Since it is an object, you need to convert to integer because you want to perform some arithmetic operation like adding 5 here. So that's why I'm doing it typecasting, where I'm converting to integer. So you can see that that is the result of this program. So what we are doing ideally here is, we are actually writing our own logic of what to do with this particular values you pass. So it is like kind of abstraction where you are letting the user just pass whatever he wants, and we have our own logic of dealing things. Okay, so this can be very useful in situations like, let's say you want to connect to multiple databases, and based on the certain database name you pass, you want to do the authentication. I mean, let's say the authentication is different. Like for example, if it is RDS on cloud, there will be a different kind of access. You need a access key and secret key. If it is your on-premise database, the access is different. You need username, password. If it is some other database, maybe the access is different. You need multiple other things like session ID and all that. So all this authentication you can abstract from user, where he just passes some token from here and it automatically authenticates. So those kind of use cases, this is pretty useful, where you are creating an abstraction to the user and just getting things done. Okay, so yeah, so this is a simple demonstration. That's why we are just processing the value, but you can even extend to do even more advanced use cases as well. So let's move on to some other utility library. So here in this case, we want to show one more utility package, which is string tokenizer. The advantage with the string tokenizer library is it helps you to break a string into multiple tokens. Here in this case, the tokens are nothing but words, and after breaking into words, you can do anything. Like here in this case, what I am doing is, after getting each token, I am actually processing word, which is nothing but a token here. Then I'm counting how many vowels are there. That's what I'm doing here. So let me run it and show to you. So if I say hello world, this is utility package demo. So you can see that what it does. So vowel count for each string is just a statement, and each word it is processing, it is counting how many vowels. Hello, how many vowels are there? There is E and O, 2 vowels. Similarly, word, how many vowels are there? Just 1. Similarly, this, how many vowels are there? Just 1. Similarly, E is 1 vowel. Utility, 3 vowels. Because there is U is there, I is there, and I is there. Like that, it does that. Now let's understand how it does. First, we read the string. So for reading the string is what we need scanner. We want to read entire line, not just the string. So when we say string, this part is also becomes string. If you just use a next, so to read a string, we have created a scanner object on system.in. System.in is nothing but your input device, in this case your keyboard. You have created a scanner object on it. Once you created a scanner object, you have to read it, right? So first you said enter any sentence, user have given a sentence. And when you create a scanner object, you have bunch of functions to read the string. One function is next. So rather than next, use next line here, because your string is set of words here and each are separated by space. If you use next, what will happen is, as soon as the space is encountered, it considers that input is done and it will just read up to the space. That means when you give hello world, it will just read hello, because between hello and world there is a space. As soon as it sees space, it just terminates. So rather than that, if you use next line, it understands that until you press the enter key, the string is not done. So this is the safest one to use. Once you read next line, what you are doing, you are creating a object, a string tokenizer, and breaking that object by space, and that is what gets stored here. So if you just print st, it will show you the memory address or object address of where these tokens are stored by breaking into tokens. Okay, now how to get the tokens? You have broken into tokens. Now how to get it? So we are just printing out the output statement. Then how to get it? So since it is string tokenizer, there is a function called has more tokens. Has more tokens is like saying, okay, I got multiple tokens out of string, and out of I will if you want to say until all the tokens are done or until all the words are done, please keep reading. So that is what has more tokens does. So what it says is, in this string tokenizer, which I have built by breaking up into space for a given string, I will give you as many I will give you whatever words are there or tokens are there in this until there are no tokens in it. So this st.hasMore tokens will be true until the tokens are left in it. So understand, tokens are like a set of words in a basket. So each time it will give you one word, and when there are no words left, it will say false. So that's what we are checking in while loop. We are saying while st.hasMore tokens, do you have some more tokens? It will say yes, and then it will enter into the loop. And how to read the token? The function name is next token. So each next token will give you one word. That's why when we are saying processing word, you can see that each time we are getting one word. You can see each time one word is coming. That's what I am printing to show you, that each time we are getting one token at a time. Once you get it, it's up to you. You can do any kind of processing. Here I'm just doing a vowel count program. So what I'm doing in vowel count is I'm initializing vowel count to 0. I'm converting that word to a character array. That means it will build a character array where each location is a character. Each location is one character. So once you get is one character, using for loop, I'm reading one character. I'm converting to lowercase because there could be user can give capital H, capital E, capital L, capital L, capital O. So that time also I should figure out whether it is vowel or not. So it's safe to consider everything to lowercase. And after lowercase, I'm checking whether it is A, E, I, O, U. It is easy for us also. If you don't convert to lowercase, what would happen is you have to check whether user have given capital A, capital E, capital I, capital O, capital U. Instead of that one, better you convert everything to one case, whether it is upper or lower, doesn't matter. Convert to a common case. And once you convert, if you find any of that, then you can do vowel count. That's it. So once this loop is done, you can just print this word has this many vowels. So this is what the output is. So like that, there are other functions also. I would encourage you to practice on other utility packages. So thank you. So let's look at one more program. This is related to how you can use inheritance. So we can simulate a real-time use case. So this is about a bank account situation where you have two types of customer, regular and enterprise, and regular in turn have two types of customer, again domestic and business. And enterprise customer again have two types of customers, like small scale, big scale. So on these customers, what we are going to do is we are going to have different classes, one for regular customer and enterprise customer. Apart from that, we will have one more class. Let me show you the classes: customer, then we have enterprise customer, then we have regular customer. Okay, so then we have one more class called customer, where there are certain attributes are there which are inherited by this. So let's look at each one particular thing. So we have one customer class. This is an abstract class where it will have information about the class variables customer ID, customer name, and customer type. It has its own constructor where it takes customer ID, customer name, and customer type as the arguments, and it initializes them to the object variables like customer ID, customer name, and customer type. This refers to the object instance. And it has there's a method which is implemented, a non-abstract method, where it shows the customer details, where it gives you the customer ID, customer name, and customer type for a particular object. And it has this abstract method get final amount, interest, and year. So this is this particular method is the responsibility of the classes which actually extend this or inherit this. So who is extending it? If you see, enterprise is extending it, this enterprise customer is extending it, and this regular customer is also extending it. That means if you observe, they are implementing the get final amount. So think like a scenario, like each particular type of account, each particular type of customer account will have a different logic of calculating the final amount. Maybe the interest rate calculation might be different. All that is different with respect to the type of customers. So that's why this particular function is left to the user itself, where when they write classes, they have to implement the logic. And here there are certain details which we can reuse, like show customer details we can reuse. So there are two things happening. In customer, we are letting one function to let it get implemented by their individual classes, like here enterprise and here regular customer. That is one thing. Another thing is we are also making use of this particular show customer details in the main program. So there is a reusability happening here, and at the same time we are inheriting from multiple classes. So let's look at the enterprise customer. It extends the customer. So since it extends the customer, it has to write its own logic of how it calculates the get final amount, which is an abstract method here. So it says how it calculates. So it actually takes the interest and year as input, arguments or input, and it gets some amount. It knows about the information of what is the amount he has taken a particular amount. And on that amount, he is calculating interest and multiplying by whatever interest he asked and year. And this is just a simple interest. Once he calculates, he's just adding that interest to the actual amount. That means this is the final amount he has to pay. So for all this, by default, they are giving a discount of 500. Again, if the customer type is small scale, he is giving 100 rupees discount again. If it is big scale, he is not giving anything. So overall, any customer under enterprise customer will get a discount of 500 on the final amount. If it is small scale, they will get additional 100. That means they get 600 rupees discount. For big scale, it is just 500 rupees discount. This is the logic. And here enterprise customer also, if you see, he has its own constructor where it takes customer ID, customer name, customer type, and account as the inputs. And whenever it gets it, it actually calls super, which actually makes call to this constructor here. That means it calls to this constructor, and this constructor will get its value filled by customer ID, customer name, customer type passed to it. Okay, and it also initializes the object variables to this customer ID, customer name, customer type, amount when a particular customer calls it. Similarly, let's look at regular customer. So if you say regular customer also extend customer, he has his own class variables and he has his own constructor where he takes customer ID, customer name, customer type, amount. And he is also calling super to initialize it to the super constructor, which is the customer here, this one. And in the regular customer, he has his own logic of calculating final amount. The interest rate calculation is same, just that once it adding is the same, just that when it is a domestic customer, he is giving a 500 rupees discount. If it is not a domestic customer and a business, he is not giving any discount. It is his kind of logic to calculate the final amount. Now, given that these are there, if you can observe, what we are doing is we are extending the customer class, and when we are implementing our own logic or customizing our own logic of how to calculate get final amount. So we are using inheritance to do that. And not only this, if you look at our main program, which is this bank account.java, this is where we are creating it, and we are making use of show customer details, which is defined here. If you see, this bank account.java does not have any show customer details function. That is part of customer, and that is being used from there. All this regular customer and enterprise customer are instanced to it, so you can easily use it. So there is a reusability as well as there is a overriding, and customization is also happening. So if you run it, this is how the result comes up. So let me move the console to next pane. Okay, so you see I'm getting customer ID, customer details. So what I am doing here, so if you observe, let me put it down. Yeah. So if you observe, what we are doing here is we have created a regular customer with customer ID R123, name Krishna, customer type domestic, and 10,000. Similarly, R345, customer name Satish, business 10,000. Similarly, enterprise customer we are creating with E789 and customer name Madhu, and small scale 10,000. Similarly, E379 customer ID Lahari, big scale 10,000. Once we have created, we are just calling regular customer one.show customer details, and it automatically shows the customer details. If you see, show customer details is part of customer.java, which we are reusing based on inheritance. And we are calculating the final amount, regular customer one.get final amount. So this is your interest and years. That means 5% year, 5% interest, and number of years is 5. Based on that, this will calculate the interest and gives you the final value. So if you see, it says 500 is the discount for domestic customer. So for domestic customer, if you see, after calculating for 5 years, there is a 500 difference. Actually, it should come something around 50,000 something. it should come something around 5 lakh something, but you see 40 lakh, 4 lakhs 9,500 is coming. So that 500 discount is because of domestic. Okay, so you can see that we are using the same function for all the objects, regular customer, enterprise customer, and enterprise customer, and we are calculating the respective final amount as well. So you can even extend this particular program so that it can handle other use cases, like what if the customer is a particular type and you want to do some more, you want to calculate compound interest, or you can extend this particular class like this customer.java to put some more abstract methods, like I have put only final amount. What if you want to give some kind of rewards for the customer? You can put a rewards function, and based on whether it is an enterprise customer or regular customer, you can send some rewards. Or something like, if you see banks these days, they are sending some kind of gift coupons. So you can say that based on a particular customer type, you can add a method, and automatically whenever somebody asks for an enterprise customer or regular customer, you can send a gift coupon to them. So that's like inheritance helps you to implement a lot of it. Like all you need to do is just have a super class where all these methods are there. And if it is common for everything, like show customer details is common for regular customer as well as enterprise customer. So I don't need to again extend it and write the code. But whereas if it is specific, maybe you can put a abstract method like this, and that abstract method, let it get implemented. Like rewards might be different for enterprise customer as well as regular customer. So these kind of things. Okay, thank you. So let's look at some program on using polymorphism. So what is polymorphism? Polymorphism is basically like one interface, multiple forms. That means you're showing only one interface, but that particular entity can do different things based on the situation or context. That's what the whole point. So here what we are doing is we are creating a house architecture program. So what we are doing is, if you see houses, what type of houses you can have? You can have villas, you can have farmhouse, you can have bungalows, you can have apartments, you can have independent houses, multiple things. So here we have considered 3 cases. One is apartments, house, farmhouse, villas. So what we do is we have individual classes for each of it, but using one interface, which is house architecture, we are going to call different methods of each of these classes, which is villas, farmhouse, and apartments, to get certain details. Certain details could be like, what is the average price of villas, or what are the banks who can provide loans, something like that, which we are going to do. So let's start looking at the individual programs. So apartments, if you see, it is a simple apartments. Actually, like it just extends your house architecture program. And how does this house architecture program looks like? This house architecture program is nothing but an abstract class which has 2 abstract methods called get price and get loan back. And whoever is extending this particular class, it is the responsibility of them to implement price and loan bank. That loan bank means the banks who can give loans on that particular type of house architecture. Now let's look at apartments. Apartments extends it. So he has to implement the get price and he has to implement the loan bank. So here what apartments say is the average price of this apartments generally is 80 lakhs. And the banks who can give the loan is, these are the list of banks who can give loans for this particular apartments. That's what it's saying, generally any apartment. Similarly, let's look at villas. And for villas also same set, it is also extending house architecture. So he has to implement his own get price and get loan back. He is saying the average price of villas is 2 crores. The banks who can give loan is ICICI, Axis, and HDFC. Similarly, you have farmhouse. Farmhouse is also extending house architecture. And he's having 2 functions, price and loan. And he is saying the general price, average price of farmhouse is 10 crores. And the banks who can give loan is HDFC. That's all. Now, if you see, each of these classes have an individual values or individual way of calculating or giving the price. I mean, they have their specialized price values and set of banks which are particular to those particular apartments. So each are different. So using polymorphism, what we are going to do is we are going to create just one interface, in this case house architecture variable, and call respective details or call corresponding details of each of them. This particular HA acts like a single interface where it can behave like villas, farmhouse, or apartment objects based on the situation. That is what we are trying to show here. So first what we are doing, we are creating a check polymorphism class, and inside that we are writing a static void, public static void main method, and we are creating a variable HA which is of type house architecture. And house architecture, as I showed you earlier, it is an abstract class. And that house architecture, after creating it, first we are creating an object for villas. Villas class we have seen that has the get price information as well as the banks who can give the loan. And here it is saying what is the average price of the villas. We are just formatting it. It's just a string formatting. Otherwise, since the numbers are big, it will show larger values. So if you see the average price of the villas, it says 2 crores, and the bank you can provide loan is Axis HDFC. So just to format it without any decimal point, we are just formatting it and getting the price. And we are getting the loan, the banks who can avail loan, who can provide loans. Then the same variable HA, house architecture, we are saying this time we want to get the farmhouse details. So we are creating a farmhouse instance and assigning to house architecture again. This time we are getting the details of house architecture for farmhouse. We are getting the price and loan banks, and it says for farmhouse the average price is 1 crore, 10 crores, and the loan, the bank who can provide loan is HDFC. Now we are creating one more instance called apartments, and we are assigning to HA. This time we are going to have the details about apartments. Now we are converting that also to without any decimal point. Then we are getting the price and we are getting the loan back. So if you observe carefully, each time here when I say polymorphism is single interface multiple forms, this particular HA acts like a single interface where based on the situation, here in this case the situation is you have to get the price and loan. So get the price and banks who can avail loan, who can provide loan for villas is what you need to get. Here in this situation it is farmhouse, here in this situation it is apartment. So based on the situation, it behaves like that object and gives you the details. This is called polymorphism. Okay, I hope it is clear. Like that you can implement for certain other features. This is just to show how you can typically get a house architecture elements just by using this polymorphism thing. Maybe you can even add a lot of features to it. Here I put just a price and the bank loan. You can even put a lot of things here, like for example apartments in a particular city. How is it? What is the average price of apartments in particular city? You can even extend it, and you can even put a lot of details like, okay, what is the square feet, average square feet you get for apartments? Is it a 2 BHK, 3 BHK? A lot of things you can do. This is just a demonstration to just a kickstart like how you can use polymorphism. Okay, thank you.
Starting with exception handling, why we need exception handling. So I have written exception handling, but first of all, let's discuss on exception handling. So exception handling is a concept which is really required for any system which want to run 24/7. This is a way to guardrail any kind of issue happening in your system. That means, let's say your system is running 24/7, and if there is an error, it shouldn't be just dying. It should have a mechanism to handle it. It should have a mechanism to fall back to something. All these big companies like Google, Amazon, Flipkart, Microsoft, they do take care of exception handling very much, because their code should not be throwing just an error and falling out. Their code should be robust enough and fault tolerant and all this kind of use cases that could happen. Even though you are a super duper coder, always remember that exception handling is not something which you can ignore. It is very, very important. So starting with this program, which is exception handling, you can see I'm handling sort of exceptions like arithmetic exception, array index, and null pointer. So these are the different exceptions I'm handling, and I have created exceptions intentionally. And if you see here, let me execute. Okay, you can see the output is coming. Now let me explain what is happening here. So if you look at, I'm intentionally doing this str equal to null error. That's what caused the problem. Now let's start with exception handling. So public class exception handling is the main program. Then we have the main code. Then we have our exception handling demo program starts here, which is what the first line in the console output. Then we have something called try, which is where we write the code which you think can throw error. All the code which I have written, that is the code you can predict that can throw an error. And that error I'm catching in this catch blocks. That's the whole concept of it. So you are anticipating the code which can throw error, and you are catching in the relevant blocks like arithmetic exception, array index, null pointer, like that. And finally is the block which always executes. So when I say always execute, this is some block which will execute irrespective of your code has gone into an error state or not. In this place you write code actually where the certain operation must always happen, something like file closing, something like threads closing after the thread operation is done, or some problem. So this is very important. So that's why I have put this block always execute for your information. So this is must, you should know. So just keep in mind, finally, even there is an error in code or not, this block will execute. So you have to write this kind of cleaning code here. So all the cleaning code or free up code you have to write here. That's the main key here. And let's move on to other part of the code. So if you look at this block execute, you can see it is coming in output. Then if you see why we are getting error, so I'm creating a string str with null value, and if you see I have clearly written uncomment to the below value will throw a null pointer, which I uncommented, and that's what caused it, because you cannot calculate length on a null value. That's the main key. That's why it has thrown java.lang.null pointer exception cannot invoke string.length. That's the whole reason. So I have intentionally created an error which actually send the error to that null pointer exception block, which I have handled. So what would happen if I don't handle? It will be handled by your default Java exception handling mechanism. And this exception handling demo program always execute.
So when this null pointer exception happens, you can see that here we are handling saying user is trying to perform operation on null value. And this is the actual error thrown by the Java. So which is this. And after that we are fitting finally, which whatever code you have written, it will always execute. Then we are saying exception handling. That means there is some code after this exception handling snippets, which will execute later. So here, if you look at, one thing to observe is in general real time, what people do is rather than doing system.out.println, they will use logging. Using logging, they log all this, so that how it is helpful is these kind of errors. Anytime any code in production, always remember that they tend to get into error state. You cannot say my code never gets into error state. So all your error cases, whatever you think can occur, you will write using logging to a file, so that later you can put some monitors on it if the errors are going to a threshold or a value where you cannot, where it is not acceptable. That means, let's say in a day you are not expecting thousands of errors to come from your code. If it is, that means there is a big problem. So those kind of situations, you can put some monitors so that they can page you or cut a ticket to you or call you, or you can also do some kind of analytics, or you can do some debugging to understand what is the problem. All these are very much useful. If you're not handling, what will happen is your code just throws an error and stops, and you do not have a clue of what happened. So that's why this piece is very important. So this is on null pointer exception. Similarly, let me demonstrate other errors. So let's do a division by zero error. So this is a division by zero error. So where I ran this code, and you see this, it is saying arithmetic exception, division by zero. So how it is happening? Because I'm trying to divide a number by zero, which is not correct. So when you're trying to do it, one thing to understand is whenever there is an error, the lines after it will not execute. It will immediately raise an error. It will check whether there is any catch block handling it. Here in this case, when it is divide by zero error, it raises an error called arithmetic exception, and this is where it handled. And it says denominator should be zero while dividing number. That's what we are showing up here. And the error name is java.lang.arithmetic exception. The description of that error is division by zero. And as we know, this block always execute, finally executed, and then exception handling demo program ends here. That is on how to handle a division by zero error. Let's try some more errors. So this is on array location. We are creating a particular set of elements in an array. We are creating 6 elements and we are trying to access 10th element. Is it acceptable? No. So what will happen? It will throw an array index out of bounds exception, because you are not supposed to access beyond that boundary. That means after 6 elements, you should not be accessing it, but you are doing it. So then what happens whenever you're doing it, it will throw an error called array index out of bounds exception. Like I said, when it throws error, Java will look at whether you have handled it error. If you haven't handled it, it will give to you so that you can write your code. So you can see that in this case, when it raised it, we handled this, and we are writing this. User is trying to access the location outside array boundary, and we are giving the error Java gives also. So it says index 10 is out of bounds for length 6. So like that, you can try out different errors you get in your code, like syntax error and other things, or typecast exception, all that, and you can handle it. This is Java exception handling is a very powerful feature, and it is must for any code which you are delivering in production, not just for Java. And this is one feature which will be available in every programming language irrespective of Java. So always think about scenario like how to make your program more powerful or more robust. So when I say more robust, it simply means that you're making your code more, more powerful, so that it can handle any kind of errors. You should not let your code just get into an error state and die there. That's not acceptable. Okay, so that's all. Thank you. Let's summarize what we have learned here. So in this module, utility packages module, what we have learned is we learned about how to create a package and what are the different types of utility packages we have. Like we have learned about sets, we learned about hash set and all that. We learned about what are the different functions available there. And we also learned about inheritance, which is more about acquiring properties of its base class. And we also learned about different types of inheritance possible, starting with single, multiple, multi-level, hierarchical, and hybrid inheritance, where we understand how to implement them as well. Then we also looked at an abstract class, where it is more about writing a class without a class of methods without much functionality. Or if you want, you can write some functionality in the code, or you can just leave it blank so that the respective class which extends it can implement the code for it. Then we also discussed about what is exception handling and why it is so important in general object-oriented programming languages. Then we discussed finally at memory management, where we discussed about what are the different types of way we can manage memory, and what is the right way to manage memory by using these garbage collection mechanisms. In fact, I'm not sure whether you are aware, but Java comes with different kinds of parameters also on the command line, where you can put it and it automatically, based on that, the garbage collection happens. That means you can customize the garbage collection parameters also if you go deeper into this subject. So that's what we have done in this particular chapter. I hope you find this useful. Thank you. Hello everybody. Let's discuss about multi-threading concepts today. So in this module, we are going to learn about what exactly is a thread, what are the entire life cycle of a thread, and how you can control threads accessing the shared data. All that we will discuss. And then we will move on to wrapper classes. We'll understand deeply about boxing and unboxing there. Also, we'll discuss about some of the util classes and java.lang. Then we will move on to collection frameworks, followed by which we will discuss about different kinds of classes, which are actually like map, set, and queue. We also discuss about different types of streams we have. When I say streams, stdin, stdout, and stderr, and how those can be accessed in Java. And we also deeply discuss on what are the hierarchy of these character streams, followed by which we will also discuss on byte streams hierarchy. So in serialization, we are going to learn about how do you convert the data so that it can traverse over internet. And JUnit is about how a developer has to write certain type of test cases so that the team or the company is more confident that this code can run without any issues and there won't be any edge cases and all that. And in Logger, which is Logger is nothing but one of the logging framework, and we have multiple things. Like one of the popular logging framework is Log4j, where we are going to understand about how do you log information your system is writing so that you can debug for any issues later, or you can set up some alarms or monitoring on top of it for further analysis. So let's start with our lesson then. So let's start with threads. So before threads, we are going to discuss, let's understand what exactly is multi-threading. So when you call a particular thing as multi-threading. So multi-threading is something where it means that more than one thread is running. So if at all, let's say, if there are programs that can run more than one thread, then it's called as a multi-threaded program. Now, what exactly is thread, and what exactly you might have heard about something called process, and what exactly and why exactly these exist? First of all, let's look at like this. Like you might have heard this term multitasking. If you look into your Windows operating system, you will see multiple programs running. Like you might have opened a YouTube, you might have opened a browser, you might have opened, some file in your system. All these are three different processes which are running, and it creates an illusion for you that it is all running at the same time. Whereas, like I said, it's just an illusion, just shows that something is running parallelly, but actually processor at a time will run only one process at a time. So that's called more about a multitasking, which is done using process. Now, what is multi-threading here? So if you look at deeply, the problem with the multitasking using processes is when you actually divide your task into multiple process, each process actually has its own memory. When I say its own memory, whenever each it is like heavyweight. When I say why I said it is having own memory is because it needs certain kind of memory to run its process. And each of these process, like if you take a browser or a YouTube or any file you open, all of these when they run as a process, which is nothing but a program using some of your computer resources, or you can call it as program in execution. These things have their own memory so that they know where they stand when they execute the program. Because whenever you move from one process to another, like you move from YouTube to browser to file, automatically there is something called context switching happens. That means you switch one process to another, it has to remember where it stopped so it can actually get you back to the same position where you stopped earlier. So that's called context switching, where a lot of things happen. Something like internally at the processor level, it saves the registers values, it saves the program counter register value, where it knows that what point of your program it got stopped, so it can retain back to the same point. Now, the biggest problem with all this multitasking using process, they are all heavy weighted because they contain their own memory. They do not share any memory across. And even to communicate between process also, it is not that easy. So ideally, if you see, it is more memory intensive. Execution wise, it might be good, but comparatively, if you see, it is not as fast as the multi-threading the way it works. Now, when it comes to multi-thread, the concept is simple. Instead of creating multiple processes, why not create multiple sub-process inside a process? So here we are talking about multiple sub-processes inside one single process. Now the advantage there is all of these sub-process share a single memory which is part of that process. They do not have their independent memory of their own, which means even if, let's say, they want to do context switching, is quite easy. And even if, let's say, one thread got stopped, it only affects that thread. The other thread still can run independently. And there is not a lot of context switching required because everything shares the same memory. And execution wise, it is comparatively faster because everything happens inside a process. So that's been the advantage. People started using multi-threading. And this is one of the popular mechanism people use. But again, the whole point of doing all this is parallel processing. And that's why multi-threading is popular, because memory wise, execution wise, and context switching wise, it works much better than the multiprocessing. But whole concept of multi-threading or multitasking using process is nothing but running multiple programs at the same time, or concurrent processing, or you can say parallel processing. That's the main agenda. Okay, so we are going to understand about the threads. So this topic is more about what actually is a thread is, how it is different than from a process, and what are we going to do with these threads? How are they really useful? So starting with threads basically are called as a lightweight process. So the difference between your process and threads, if you compare, process actually is like heavyweight, where whenever you create any process, whenever you run any program inside, there is a process gets created in the operating system which takes care of all of the things you do. And because of this process and all those concepts, you have this illusion of multiple processes executing at the same time. So later what happened was the process further, they have evolved it as a thread where they said instead of multiple process running, why can't we have multiple threads running? The main distinction between process and thread is thread will have a shared memory, whereas process will have individual memories. So threads actually run inside a process and they share all the common memory. That's why the execution wise it is very faster, but it is memory intensive. So when you open a browser, when you open multiple tabs, all the tabs are going to use the same browser memory, everything, the browser cache and all. So you can assume that's like a threading concept. In fact, big systems like Amazon and all, they also use this multi-threading concept so that they can parallelly take the request. So the overall objective of learning multi-threading, and which where the thread is the basic unit, is to understand how to parallelize or how to run things parallelly, or how to run or concurrently execute programs parallelly. That's what the main theme about is. Let's move on. So let's understand about what threads are. So threads, like I said, is basically nothing but a sub process where they actually execute as a separate program. And this is basically used to execute multiple tasks simultaneously. So that's what our first point is. It helps a program to execute as an independent task. So when you take a program and let's say there are 4 or 5 functions written in it, which we can call as tasks also, each of these can be executed simultaneously using this threading concept. That's the whole advantage. Now what happens when you have parallelly executing multiple tasks, the overall execution or the completion of the program will be faster, right? Because you're not executing one after them sequentially. And the other point, reduce the execution time, lightweight process. So when I was talking about the difference between process and threads, you might have realized process is called heavyweight because they have their individual separate memory. And if at all a process want to share with other process, it has to share through different mechanisms like semaphore, messaging, and all that. So whereas in the case of threads, that's not a headache because you have the shared memory. So that's why when they execute and they want to communicate with other process, it is very faster. So that's why we say threads are lightweight process and they reduce the execution time because there is communication between threads happens very fast because all share the same common memory. Now, what are the different ways to create a thread in Java? So there are 2 ways you can create a thread in Java. One is by extending a thread class. Another is by implementing a runnable interface. So these are the 2 mechanisms using which you can create a thread and you can parallelly execute the task in a program. Now, like I said, if you want to implement a thread in Java, you can extend a thread class and you can always override a method of thread class which is run that you can override so that you can write your own code of what has to happen when you trigger a thread. And every invocation internally triggers a start, which in turn invokes this run automatically. And your thread automatically kills itself or dies only when this run method completes. Now, there are 2 ways in Java you can implement this threading, multi-threading. One is you can extend the threads class or you can implement runnable interface. Now, let's look at the first approach, like where you are extending thread class. There you have these types of constructors available where you can just create an instance with this, or if you want, you can give a name. That is what the string is, or you can pass a runnable object. Along with it, there is other constructor where you can pass runnable object and string as well. Now, these are the different types of functions or methods you get when you use a thread class. That means when you extend the thread class, these are the functions available to you. So what this function does? So if you look at start, the start function actually helps in execution of your thread. Whereas if you look at run, this is the guy who actually do the action. That means you can write the code, what it has to happen whenever you start a thread. That's what written here. And your interrupt is the one where it interrupts your thread, or I will say it stops your thread. And then you have something called setDaemon. We will talk more about setDaemon, but understand that setDaemon is a kind of thread which is more of a service provider rather than the guy who actually does the main job. So when I say actually does the main job, it's the threads which you create, or you can call it as user threads. Now coming to join. Join is a method which actually helps for a particular, you can use it to wait for another thread for a particular period of time. That is what mentioned here as millisecond. You can say that this much minute you want to wait and it can help you do that. Similarly, is alive, the test if a particular thread is alive or not. Then we have something called set name, which help you to change a name of thread. Or you can set a name of thread. When you're creating, you want to set some name, you can use this function to do that. Similarly, you can set certain priorities to thread also. We will see what are all the default thread priorities available in the later slides. Now coming to this first example where we are using the first approach of implementing multithreading using the thread class. Like I said, if you want to implement using thread class, you have to extend it. Extending is nothing but inheriting the thread class. And you can see inside that you have to write your own run method, which is what we called out as overriding. So we have overridden that run method, which is part of thread class, and we have written our own string, which is thread is activated. That means our own code. And here, if you see in our main method, we have created an object to this thread sample. And after creating, you can see this is where you're triggering the start. So when you start, automatically what happens is this start will invoke your thread, which is this thread sample one, and internally this run will get triggered. And that's what gives you this activated thread is activated output. Now, like I said, there is other way to implement. This is the second approach where you can implement a runnable interface and there you can write the code for run. This is like a second approach to do multi-threading in Java. So in this approach, if you see, like I said, we are implementing, not extending. In this, we are implementing the runnable class, and there we are overriding the method of run and we are writing the code for it. This part is same as the first approach where we are extending the thread class, where you are creating an object to it. And that object is where you are creating thread and just doing the start fun method, where it automatically invokes the run of this particular thread sample 2, which implements your runnable class. And you can see the output is thread is activated, which is coming from here. Now, what exactly is difference between thread class and runnable interface? Like we understand, these are the two ways where you can create multi-threading. So let's understand deeply on what exactly is the difference between them. Like one thing is, since you are extending a thread class, one thing you need to understand is after extending this thread class, you cannot extend any other classes because Java does not support multiple inheritance. And one reason why it doesn't support, we discussed in earlier classes also, it is because to avoid code ambiguity. And we'll not talk much about multiple inheritance, but we already discussed in module 2 about it. But understand that to avoid code ambiguity, where when you have the same kind of method lying in two different classes, a lot of problems arise, which is what Java strictly says we should not be allowing directly using inheritance, but you have other ways of allowing it through interfaces. So that's because of that reason, when you extend any thread class, you cannot extend any other. And whereas runnable interface, since it is more about implementing a run method in that, so this will help you to extend other classes as well with this approach. Whereas one advantage you get with thread classes, as soon as you extend it, you get all these functions directly available to you, like yield interrupt. We have seen a set of functions like run, start, interrupt, like that. These functions also available to you. Whereas here, those are all not available directly. And in runnable interface, one more advantage is the same object which you have created for a particular thread class, you can share it across multiple threads, whereas that's not possible when you use this approach of extending thread class. Now coming to the thread lifecycle. When I say thread lifecycle, from the time it started to the time it gets killed or died or terminated, what exactly happens? So if you look at this cycle, according to Java documentation, it is just that we have to assume logically that something like this happens. Actually, there are only 4 states. One is new, runnable, and waiting or sleeping, then terminated. So what exactly happens when it is new means like your threads just started. It doesn't mean that your thread is ready to run. It is like just waiting for some attention from your OS. Runnable means now it is ready for schedule. That means it will get its turn to get executed, but not at run. And running is the place where actually thread actually start running. And once everything is good, finally it gets terminated. Whereas during runnable state where it is waiting, sometimes what happens is after going to running or in the runnable state, sometimes it can go to waiting or sleeping state where it might be requiring some kind of IO. That's where it might go, or it might have got some explicit sleep to be inactive or to be there or to be idle for some time there, where if you remember, we can do some kind of sleep functions where you can make the thread sleep for some time. During that time also it will go into that state. So it is more of a state where it is not doing anything and just waiting for some attention to be run by OS. And how it is picked and all, it is all based on, again, different types of operating system algorithms, where based on the particular algorithm, whether it could be preemptive scheduling or round robin scheduling or any kind of scheduling, based on that particular thread or process gets picked. And these are the different process which actually comes into scene whenever we are talking about this entire life cycle, like notify or resume, here wait, sleep, suspend. Those are the things will come into picture when actually we want to implement it as a program. So threads always gets priority with higher the chances of getting that particular thread and attention. So JVM actually decides a priority to each thread by default. But if you want, you can explicitly set the priority of thread as well. And the priority of the thread should be static variable and they should be from the range of 1 to 10. And how you can do it? There is this function called set priority. Using that, you can set the priority of a thread. And let's say the priority is set, or somebody has set the priority of a thread and you want to know it, you can call this method to get that value. So what are the default thread priorities available? So minimum priority means the least priority value you can give, which is 1. And maximum priority is the maximum priority you can give, which is 10. That is, this is the max you can give. And by default, if you don't give any priority, these are the values which is automatically set by JVM to your thread. And now let's look at our example. So here, if you see, we have implemented a class which extends your thread class, our first approach of using multi-threading here. And you are overriding a run method where you said active thread name, thread.currentThread.getName, which actually gets the current thread name. Similarly, we are saying active thread priority where we are getting thread.currentThread.getPriority, which gets the thread priority. If it is not set, like I said, it would be default 5. And in the main program, which is your public static void main, you are creating 2 threads, if you see, for this particular thread class. And for each of them, you are setting minimum priority and maximum priority. The first thread, you have set the minimum priority, which is 1. And second thread, you have set the maximum priority, which is 10. Now, when you start it, these guys will print their names, whatever the names assigned to them by default. At the same time, they will print the priority also. So like you can see, this is the default name given thread 0. And the priority is given as 10. And the second one, it is thread name as thread 1. And the priority is given as 1. So if you remember, we have set one thread to minimum 1, which is this thread 1. And we have given one thread highest value possible, which is the 10, which is thread 0 here. So what exactly is daemon thread? So daemon threads is more about, is more of a service provider thread that actually helps to provide to services to the other user threads. So when I said other user threads, till now, whatever threads we are creating, those are your user threads. And these daemon threads are existing to just provide services to them. And that's one reason why JVM terminates your daemon thread, because they are all purpose in their life is to serve your user threads. And let's say if the user threads are not there, they are not required. That is why JVM kills them automatically when it does not find any user threads. And these always starts with a lower priority, and some of the inbuilt daemon threads available are your garbage collection and finalizer. And let's say you want to see what and all the complete thread information and memory, active class, everything. You have a command. You can do that in command line using this JConsole, where it gives complete information about memory, active classes, and active threads available now. So that's more about daemon thread. Okay, let's discuss about thread scheduling and sleeping. So before that, let's understand what exactly is scheduling. So understand like this: when you have multiple threads running, that means when you have multiple tasks which you have spawned as threads, how you think the JVM should know which one to run first? Okay, so that's all about thread scheduling. When you say thread scheduling, deciding which one to run first and arranging in a way so that it can pick whatever the thread is, or it can do something with that thread. So it's all about how do I identify the next thread to run. That's what about thread scheduling is. And sleeping is more about putting a thread to in a sleep state that you can do in different ways. Like you can put it, you can get the thread ask for an IO, or it can be blocked for some other resource, or it can be put in sleep state also. There are different ways. So like I said, the first point, the thread scheduling is about the JVM plans on which thread to run first. That's the first point. And when I say thread scheduling, if you look at the scheduling, internally the scheduling is nothing but set of programs or algorithms using which the JVM decides which one to pick first. And mainly in JVM, there are two types of techniques or algorithms used in order to decide which thread to next first. That means for thread scheduling, two of the techniques are used. One is called preemptive, another is called time slicing. So when I say preemptive scheduling algorithm used to run the thread, where preemptive simply means that before even thread finishes, it gives that to another thing. So when I say preemptive, again, in preemptive also there are different mechanisms. Like preemptive scheduling, when you say it's a bigger term, there are two types of scheduling, basically preemptive and non-preemptive. And preemptive simply means before the thread completes, it will be the JVM is given to somebody else. Now in the preemptive, here in Java we use something called a time slicing mechanism. So what is the time slicing scheduling is, every thread will be given some time. Let's say 2 seconds for each thread. That up to 2 seconds, JVM will be taking care of that. As soon as 2 seconds finish, JVM will be just storing all the context or information related to that thread, so it can come back to it. All that it will store separately and it will go to the next thread. That's called time slicing, where you're giving different time amounts to each thread so that all of them are fairly scheduled. Now, how to put the thread in sleep state? There are different ways. Either you can let the thread ask for IO. That's where JVM puts that in a sleep state. Or you can make the thread inactive for some time by using methods like this. So this is a method where you can forcibly say, hey, thread, go and sleep for this many milliseconds. And if there is any error, it will give this. If there is any problem, it will throw this interrupted exception, both cases. These are two overloaded methods for the same use case. Just that one will take only the millisecond information, other in turn takes the nanoseconds information as well. So it's more about how to put thread sleeping for some time. The advantage with putting thread in sleep state is so that JVM can be given to somebody else. Let's move on. And what exactly is synchronization? So synchronization is more about, how do you ensure when multiple threads are interacting or when multiple threads are accessing a common resource, or let's say a shared resource, how do you ensure the data is not messed up? When I say messed up, let's take about a bank account where, let's say in your bank account you have 100 rupees, and let's say you have created one program which have two threads where their job is to adding a value or subtracting. One thread is to add a value, another thread is to subtract a value. So if you just run this using threading, what will happen is, ideally, whatever you are expecting, let's say you want to add some value to thread, and then only there should be a decrementation of that account value. Because of you running parallelly, there is no guarantee that first add will happen, then subtraction will happen. It could happen in either ways. And what if they run without any control? You will see your account going into a complete messy state altogether. It is all because these threads has to be properly controlled so that they run according to your need. So that's what more about thread synchronization. Like I said, if you don't control it, you will get into this consistency problem, which is what I am saying, the account will go into a messy state. So the main purpose of this thread synchronization is actually basically one is to prevent the thread interference. That means you won't let other threads to interfere and do something which is not ideally correct. Another thing is to prevent the consistency problem, which I said, like one account going into a messy state because multiple threads try to do something with the data and the data goes into a complete state where you cannot get it back to the right place. Okay, so in thread synchronization, if you see, basically if you look at synchronization, this problem can happen not only for threads, it could happen even for process. But since our concept is moreover related to multi-threading, so we will talk about how we can do the thread synchronization. And there are two ways possible. One is mutually exclusive, another is co-op threads, which is this. And mutually exclusive threads also you can do by using these are three approaches, which is either you can write a synchronize method using synchronize keyword, you can write a synchronize block using synchronize keyword, or you can have a static synchronization. So all three ways are possible. Now let's start with the synchronize method. In synchronize method, you will use the synchronize keyword to actually declare a particular synchronize method. When you do it, what will happen is that particular method, it will not let anybody to access until the job, whatever the execution is supposed to perform, it's completed. Like let's say this is the printing function. Once you make this synchronized, whoever want to access the class or object of it, they cannot access until the main job of whatever the printing is doing. Until it is done, it will not let others to use it. So that's why synchronize help you, so that it is kind of a lock or monitor you can assume, where it ensures no other object is accessing it until the job of whatever printing is doing correctly is completed. Now, in the case of synchronized block, this is really important when you don't want to synchronize the entire code. Rather, you say, let's say you have 100 lines of code in that you want to synchronize maybe 15 lines of code, 13 lines of code, something like that. That's where the synchronized block works really well, where it is more of acting like your synchronized method. Just the difference is you don't want to execute all the lines of code, but you want to execute only few lines out of it. That's where this guy helps. But otherwise, most of it is same. It also lets you control your code so that unless it is finished, it will not give control to others. And coming to static synchronized path, the main static synchronized method, the main difference is rather than controlling the object which you create, which happens in the case of synchronized block as well as synchronized method, here in this case, it will log the class rather than the object. Because, here we use the static keyword also, and static maps to which one? It doesn't map to object, but it rather maps to your class in general. So it actually logs the class rather than an object. And the way to do it is you have to give the same synchronize, just that this additional static keyword is coming, because this is a static synchronized method. This is the other way, inter-thread communication. So what exactly is inter-thread communication? So inter-thread communication, or the other name of this, is called cooperation, which is more of allowing these synchronized threads to communicate each other. Like, why do they need to communicate? And how these are done? These are done using the methods like wait, notify, and notify all. So those are the methods help you, where notify and notify all is all letting other threads know that, okay, I'm ready, come and pick the next task. Okay, so here we will understand about how to interrupt a thread. So when I say interrupting a thread, that means interrupt basically means a trigger to stop doing a particular task. When generally this interrupt is the term used in operating system, it is basically a signal to indicate please stop there. That means the task will not execute, it will just stop there. So here interrupting a thread means you're just stopping that guy in the middle. So now if you see, interrupting a thread in actually when you if you understand from the thread scheduling point of view, the JVM can be given to another thread only when thread goes to sleep state. How thread can go to sleep state? Either you explicitly put a sleep for it, or you can either the thread is going for an IO or it is blocked for some other resource. So let's say that's been the case. When you use this interrupt function on a thread in that sleeping or waiting state, so it breaks out the sleeping or waiting state for sure, and at the same time it throws interrupted exception because it is got interrupted, right? Because it is just waiting for the in a sleep state and suddenly somebody came and just cut it out. So that's what happened when you use interrupt. But let's say if the same interrupt function you use on thread which is not in sleeping or waiting state, this calling on interrupt method just behaves normally. It will not interrupt the thread, but what really happens is it sets an interrupt flag to true. So two things here. You have to think about when the thread is in sleeping or waiting state, what will happen if I call that interrupt function? As you can see, when you call it, it interrupts that thread to come out from the sleeping or waiting state, and at the same time it throws an interrupted exception. Second thing is, if the thread is not in sleeping or waiting state, it could be in ready state, it could be in running state, it could be in any other state, some executionable state if it is in, then if you execute interrupt, it will not throw any exception. Rather, one more thing is, it actually sets the interrupt flag to true. It will not really interrupt, but just set the flag to true. There is an interrupt flag maintained internally that is set to true. Now, how do you know when actually an interrupt flag is set to true for a thread which is interrupted? You should have a mechanism to identify that, right? So for that, you have two functions. One is this interrupted, where using that, if you check, it will tell you whether the thread is really interrupted or not. There is other function called is interrupted that also tell you
whether the thread is interrupted or not. Both will return true or false based on whether the thread is interrupted or not. And the way to interrupt a thread, like we are talking about, if you call this interrupt function, that is this. Using this function, you can stop any thread. Now coming to wrapper classes. So what exactly is wrapper classes? So wrapper classes are nothing but, you have some primitive data types, like you have integer, you have float, you have double and all. What if these are all data types, integer data types? What if you want corresponding object data types on it? Like for example, for integer in Java, you have a corresponding object data type. For float, you have a corresponding object data type. That means these are not really made as objects, but if you want them to be created as objects, the wrapper classes is the answer. Using wrapper classes, you can have a corresponding object data type for each of the standard data types you have. And that's what the whole concept of wrapper classes are. Now, like I said, all of the objects collection stores the object, but not the primitive types. So primitive types, like I said, integer, float and all, wherever you want it, for all of these, this wrapper classes contain corresponding object data types. And like I said, since they are just like, it's like one-to-one mapping kind of thing. Wherever you want the primitive types, let's say there is a requirement, some particular function expects an object, an integer object, but not integer data type. So there you can use it, because primitive types, wherever it is, can be used. Primitive types can be used as objects whenever required. This means that whenever a particular function as isn't a requirement of an integer object, but since primitive data types are not really objects, you can use this wrapper class integer object if it is an integer data type you need there. Okay, one more advantage is, since it is an object, obviously object means you will get not only the data, you get some functions as part of it. So that is another advantage, that not only since it is an object, you get not only just the data part, you also get certain functions also tied to it. And it is also used to be stored in any of the collection. Like if you take any of the collection classes like set or hash set and all, there also you can pass this particular wrapper class as a collection parameter to those methods. That's being another advantage.
This is the same example I was quoting. Like for example, if at all your classes want to be used as objects rather than primitive data types, you can always go for wrapper classes. So like the name says, they are wrapper around your primitive data types. And you can see here, these are all your primitive data types. And you can primitive, or also other name for primitive, by the way, is standard. So these are all the basic data types or standard data types you have. And for each of them, there is a class associated with it. And let's say in future while you're working, for Boolean, you want a particular object in another method or class, you can always use this wrapper class. So you pass these values. Now this is the entire hierarchy of how these are. Like, most of the classes should be part of this. Under superclass object, you have number, Boolean and character subclasses. And inside each of it, you can see this byte, integer, long, double, short, float. These are the ones you have under the wrapper classes. This all comes under number if you notice. And you can see this is our primitive data type character, where you're just assigning one character value to it. And here it just simply declares a character variable named A and initializes with the alphabet single quotes A. Whereas the similar thing, if you want to do using wrapper classes, all you need to do is use this capital integer B, and then you say new integer of 132. It creates an integer object, which is similar to your primitive data type, but just that this is a wrapper object rather than a primitive data type. Now this we spoke about, like conversion of your primitive data type into equivalent object or equivalent wrapper class is called as autoboxing, whereas the vice versa, which is like converting objects into primitive, is called unboxing. Now here we are seeing an example of autoboxing, where you are converting primitives into an object data type. So if you see here, this is a normal primitive data value, which we are converting here by passing x here. You can see here you're passing x value, which is coming from here. And this x value is what we are passing. So here what is happening is, this is called widening also sometimes, where from a smaller data type, you are extending it as an object. Now this 50 gets assigned here. And after that, you have this 120, which is actually a wrapper object. or a object data type, and you're just doing a concatenation here. That's why the value 50120. Concatenation is nothing but merging two strings. So here it is one object, another object, you're just doing a merge. So it automatically merges them as 50120.
Okay, let's look at a program where we use the boxing technique. Sometimes it's called as auto boxing. So here, if you see in this program, unbox integer example. So here, if you see, there is an integer object. It is an integer object. It's not an integer data type. You have created an integer object for the number 540. Once that is done, what you are doing, you are actually converting that particular object, which is an integer object 540, to an integer data type. So that's what you're doing here, and you're printing it. So you can see that this is a wrapper class called integer, using which you have created an object for 540 number, and further you convert it into a primitive integer data type here. Then you are printing the value. So value wise, you will not see any difference. You can even do the reverse, where you are taking an integer data type and then converting into a integer wrapper class. You can even do that. Now, let's understand how method overloading works with auto boxing and widening in Java. Now, let's think about this. What is exactly method overloading? Method overloading is nothing but a function with same name. You will have multiple functions. They all will have the same name, but they might have different data types as parameters, or they might have different number of parameters as data type, but they all will have the same name. That's the whole concept of method overloading. Now, let's say if there is a situation, the first situation, where a signature takes reference type or a primitive type as a formal argument, what will happen? Let's say that's the situation. Now, first what you have to understand is this method overloading happens at compilation time, not at the runtime. So this is the job of compiler to take care. So what compiler will first search is, first it will search, is there a method with the parameters of the same data type? That's what the first objective of any of the compiler is. It just checks, let's say there is an add function and you have given integer, data type integer, not the wrapper class. It will try to check if there is an integer data type function with primitive data type integer is there or not. That's what the first check it will do. That's how it happens. Now, let's say if that's been the case, what it will do is the third point, if that's been the case, it will just resolve that to that particular method. But let's say that's not the case. So what it will do is, let's say if there is a function called add, if there is a function called add, which has an integer data type parameter, and if that is existing when you call it, it will resolve. If not, it will see if there is a wrapper class object used as an actual argument, and compiler does not find a same method. That means the primitive data type it does not find. Then what it will do is it will start searching with the method which has the corresponding primitive data type. Okay, so what does it mean is, here the scenario is like this. So let me repeat the scenario for you again. If the signature contains, when you say here, there are two terms used, formal argument, actual argument. If you see actual argument, formal argument. Formal arguments are the one which are used when you actually define a function. When you write a function add int comma int, that is called formal arguments. Whereas when you say actual arguments are nothing but the values you pass. So here the understanding here is, whenever you have a function header containing a primitive data type as a parameter, and when you call a function with the actual argument where the actual argument is an integer object, compiler tries to check with the integer object first. If it does not find, it will try to resolve a function with the same integer primitive data type, because it does not have the wrapper integer object, right? So it tries to convert whatever integer object you have, it will try to convert to primitive data type, then it will resolve. The conversion automatically happens. That's what the whole point we are explaining here. So now, how to create immutable class in Java? So first of all, what is immutable? Immutable means once you create an object, you cannot change the content. That means when I say cannot change the content, all your standard data types, most of them like integer, boolean, byte, short, and string classes are immutable. So when I say immutable, it means that you have created a string data type with say string a equal to hello world. Now, if you want to update that hello world from one of the hello world character, let's say H is the first character, you want to change to A, you cannot change it. you cannot modify it at all. If you want to create a string like instead of hello world, let's say hi world, then if you want to change it, you have to create a new string for it. That means there is a new memory location for that object has to come in. But directly you cannot just modify one value of that memory object. It's not possible. That is called immutable. Immutable means once the object is created, you cannot edit the contents. It is as it is. And that's the same case for integer, boolean, byte, short as well. And if you want, you can create your own immutable classes also. That's also possible. Now, since we are talking about we can create our own immutable classes, that's what we have mentioned in this particular point, right? So there are certain rules you should remember in order to create an immutable class. So first rule is, if you want to create an immutable class, the class must be declared as final. That's the first rule. And one more rule is the data members. When I say class will have two entities, right? It has data, it has methods. In this case, when you try to create a class as immutable, the class must be declared final. And also the data members, which is the data part entity of the class, must also be declared as private and final. That means when I say final, once they created, they cannot be changed. When I say private, they can be accessed only inside the class. Those also need to be done. And since class can contain the constructors also, and the other rule, the third rule is, if the constructor is parameterized, that means constructor is able to take some parameters, it should initialize all those fields such that it can perform a deep copy. Okay, that's another rule. And one more thing is, if you want to perform a deep copy on these objects, they all should be performed in the getter methods only. Getter methods are something where actually you use to get some value from that particular object. Those are getter methods. So they should be, these deep copy of the object should be performed only on those getter methods. And another rule is, no setters should change the value of the instance variable. That is another rule. These are the 5 rules, is like a mandate you have to remember in order to create an immutable class. So to repeat, first one is like your class must be declared as final. Second one, your data members in the class should be declared as private and final. Third one, your parameters constructor should initialize all the fields in the object, all the fields in the method, so that they will be performing only deep copy. And deep copy of the object should be done only by the getter methods. And no setter method should be there that should be changing the value of your instance variable. These are the rules you must remember.
Now, what is java.util and java.lang classes? These are the classes we use on a day-to-day basis, and they are like very much useful. And util classes is more about utility, or all this most of the utility classes, if you see, like scanner is one of the utility class that will help you to read input, and these kind of commonly used classes comes under util. And java lang classes, which is the default one included in your program without our knowledge, we will see each one of them one by one. Now coming to first utility class, we have something called date. Date is a class which helps you to get the current date and time. And if you want to use that, you can always use import java.util.date. And using date class, you can also format and pass the date strings already present, as well as you can create new date time objects also. Like if you want to initialize date time, this is the constructor you have to use. But if you want to pass your own particular value based on that, if you want to create date, then this is the constructor you have to use. And these are the different methods your date class have. And let's discuss what are they actually do. If you look at after helps you to test if current date is after a particular date which you are given. And before, it actually tests to see if the current date is before a given date. Whereas when it comes to clone, it helps you to give the clone object of the current date. Compare to is more about a comparator, where actually it helps to compare current date with the given date. Whereas equals is another comparison date function, where it helps you to compare current date with the given date to see whether they are equal or not. And get time, it helps you to get the time represented by the date object you have given. And hash code, which gives you the hash code of that particular date object. And set time will help you to change the current date and time to a given time. And toString is to convert your date into a particular string object. Now here is an example where you are converting a date to a string. So if you see, this is how you import your date class into your program. And once you import, you can see in public static void main, we have just created an object to this date class, which is current date. And after you create, we are converting this to a string, and that is the output. So what here gets is simply, it gets the current date for you and it converts that to a string. Now, like I said, these are your state comparison functions, like before, after, equals, compare to, where before is to get the current date before a given date, the after is to get the current date from the given date, like that, and compare to compare whether dates are, whether given current date is equal to the given date, all that, even equals to compare whether two dates are equal. These are different types of comparison functions you have in the date class. Now, this is another class you have, which is called date format. Date format is like a super class, and that has a subclass called simple date format. This is morely required to actually, format and pass the data form, date and time formats in your Java language independent manner. And in this simple date format, you can pass a string based on whatever kind of value you want. Let's say you want to have only the hour and minute coming in, but not seconds, or you want only the month and date coming, but not other things. All that you can do, that kind of passing you can easily do here. So you can see here, so we are using this util package where automatically this simple date format, everything comes in. In that, we have created a date object. Then we are specifying this format where we are saying how actually we want, where we are saying E, Y, Y, Y. So you're saying your year should be 4 digits. Then you are saying your month should be 2 digits. Then you are saying DD, which means your date is 2 digits. And here the E represents this particular Thursday, where it represents your weekday. What is the day in a week you want to represent? And after that, this is just a string. This shows up. And this HHMMSS is what this represents this. So what you are specifying here is in simple date format, you are specifying how your date has to be converted in the format you want. That is what you are specifying here. After that, once you convert, automatically the given date, whatever the date currently it has come here, that current date, which is nothing but, let's say if you run it, it will print the current date. That date you are converting according to the format you want. That is what you have specified in this simple date format. Now coming to calendar class. So calendar class, like the name says, it's actually related to getting all the calendar related information like days, weeks, months, like that. So it's actually an abstract class in Java. And this is basically, since it's an abstract class, you cannot create any instance to it because there will not be any constructor as such. Now the question is how to use this. In order to use this, the only way is, you can use a static method, which is part of this calendar class, which is called getInstance, where you can instantiate using this getInstance and implement the subclass. That is possible. And in this calendar, this guy, like I said, most of the classes extends the superclass object. This guy also does that. And he also implement other classes like serializable, clonable, and comparable. Now, if you see here, like what are the methods possible in calendar class? So calendar had different methods, like you can use this add method to add a particular time to the calendar feed, and you can get what is the time. You can say that from now, let's say after 30 days, what is the time? Or let's say after 30 days, what is the date? All that you can get here. And this one, when you give a calendar field, it will get you the correct value of it. And this one to get what is the maximum you can get. Let's say if you have given a field called week, in that what is the maximum you can get, which might probably end up giving a result as 7. Whereas when you say minimum, what is the minimum value you can get for a week is like 1, because 1 is the 1 day is the minimum and 7 days is the maximum in a week, right? So like that. And you can get a date object also using this function. So these are the functions, some of the functions available in your calendar class. So let's use here. Like you see here, like what we are doing, these are all part of util. So this is not needed. Either you can just do this or do this, because when you are importing java.util star, all the utility packages is automatically available to you. So this is like not really needed, but your JVM automatically optimize it. We don't need to worry. So when you run this, what we are doing here, we are creating an instance to calendar. This getInstance, if you remember, like I said, you cannot directly create an object because that's an abstract class. That's why you have to call this method, which gives you an object of that calendar class. Once you get that, what we are doing, we are getting the current time, or you can say current date. This is what you get. And once you get this one, what you are doing in that date, you are saying -15. From now, what is the 15 days ago time? That is what you are asking. So as soon as you ask and add to this calends, now this calends will a variable will store the 15 days time from now, and that is what this calends.getTime will show you when you run it again. So it says that the current time when we executed this particular program is July 29, 7:47. When we decrease or when we go back to 15 days from here, it shows that it is Wednesday, July 14, 7:47. So this is how you can do multiple date arithmetic also using this calendar class. Now let's talk about another utility package called string class. So string class, first of all, as we know, it is actually immutable. And if you want to create any string, we generally enclose in double quote. And string is basically an object. It's not a non-primitive data type. When I say non-primitive data type, it's not a primitive data type like you have integer, boolean, float, like that. It will not come under that. It's an object by itself. And basically, since it is a final class, you cannot extend it. And this comes under as part of your java.lang.package. This is one reason whenever you use string, you don't need to separately import a package, because this guy automatically gets included in your code whenever JVM runs your program. And this string class implements three interfaces, which is serializable, comparable, and character sequence. We have another thing called string buffer. So string buffer class, if you observe, this guy is a mutable version of your string class. String class is basically immutable, and string buffer creates mutable objects. And not only that, it comes with a lot of functions compared to what we have in string that actually help you to edit strings. Whereas when you deal with string class, once you are created, you can generate new strings, but you cannot update the original ones. Whereas with the string buffer class, you can update the original strings you have created. One more good thing about this guy is he is synchronized in nature. So when I say synchronized, that means there are multiple threads cannot access a string, particularly using this particular string buffer. So sometimes the same terminology people call it as thread safe. That means it will not let multiple threads access the same string object simultaneously. This is less efficient comparatively when you compare with string builder classes. We will look at string builder also later, but understand it is not as efficient as string builder. You have three constructors which help you to create a string buffer object. You can use the default one, or you can pass a string, or you can pass a capacity value to create different types of string buffer classes. Now these are the methods available. We will look at each one of them. So append actually helps you to add a specific string to the given string. Insert actually helps you to insert a specific string at a particular position you have asked, and replace a specified string from a particular start and end position. Whereas delete deletes a string from a specified start and end position. Whereas reverse just reverses the string. And capacity, by default, whenever you create by the default capacity which this string buffer internally maintains is 16. That is like based on how much, whenever your string is going beyond certain characters, it automatically doubles it up. We will see that with as an example. And ensure capacity, that's a function. It ensures that the capacity is at least equal to the given minimum number you have provided.
Okay, let's look at an example of string buffer. So here, if you see, we are creating two string buffer methods. First is SB1, another is SB2, where we have created string buffer with string called welcome. Now, if I do SB2.reverse, what will happen is it will reverse this welcome string. That means it will be EMOCLEW. That's what the answer would be if you really print it. Now, first, when we say SB1.capacity, it will print 16. Because by default, when you create an empty string buffer, the default allocation is 16 bytes given to you. That's what it is showing here. Now, when you append sb1.append, since it is an empty string buffer, it added hello. After that, again, you print sb1.capacity, it still remains 16 because it's no need to increase it. There are only 1, 2, 3, 4, 5 characters. Now, when you say sb1.append, Java is my favorite language, to this empty string, apart from hello, you added one more string. Java is my favorite language. Now, if you try to print SB1, the number of bytes of SB1 will not be the same. It will be even more. Okay, there's a formula to it where what it will do is every time by default it start with 16, and every time based on the content you add to it, it will multiply by 2 and add 2 to it. That's how it will work. So if you see here in sb1.append, once we appended, we are trying to print sb2.capacity. So when we try to print sb2.capacity, as I said, by default, it starts with 16. Since in this case, welcome is like, it is not able to accommodate with those 16 bytes because the string is bigger than hello. So what it did is it doubled. That means what it will do internally is the default 16 it will take and it has to expand. It will do 16 into, it will double up, which is 32, 16 into 2, plus it will add 2 to it, which is 34. That's what the answer you get here. So like that, it automatically does that. So capacity is the function you have to remember. It will tell you how much string buffer is allocating internally in terms of memory. And SB2, as we know, we reversed it. That's why it is coming as EMOCLEW.
Now coming to string builder. Like I said, string builder is much more efficient than compared with the string buffer class. And just like string buffer, it is a mutable string object. That means you can change the strings, whatever you have created. And it is non-synchronized. When I say non-synchronized, that means it is not thread safe, which means multiple threads can access the same object simultaneously, which is a risk, but it has its own controls as well. So these are the three constructors using which you can create a string builder class, where you can use the default one, or you can pass a string, or you can pass certain length as well. And these functions, if you see, they are moreover same as what we discussed in string buffer, where append is to add a specific string to the given string, insert is to insert a string at a particular position, replace is to replace string from a specified start and end position, delete is to delete a string from specified start and end position, reverse is to reverse the string, and capacity is to get the current capacity of the string, which is, like I said, default 16. Ensure capacity is to ensure the capacity at least is equal to the given minimum value. We have another class called string tokenizer. Like the name says, string tokenizer. Tokens means certain parts. If you see a sentence, in that when you ask what is the token, it is nothing but your words. In your words, it could be your characters. So string tokenizer helps you to break a particular string into different tokens. When I say string, it will break that into multiple words by default. But if you want to break based on certain delimiter, that is also possible. So you can see that here, this is the default one, whereas here there's a delimiter in both cases, where you can say that what is the delimiter it should use. And these are the functions available. So what does has more tokens do? So has more tokens function help you to check if there are more tokens available like this. That is what the function is, because once you break the string into different tokens, which are nothing but words in some case, or it could be characters, like I showed in the earlier slide. So whatever it is, it doesn't matter, but whatever the tokens you get, you want to see whether all the tokens are done from the given string, this is the function to use it. And this is generally we use in loops more often. And to get the next token, this is what the function is from the string tokenizer object. And to get the next token based on a delimiter, this is the function you have to use. Observe there is a difference. In this case, it already knew a delimiter, whereas in this case, it doesn't know. That's why you have to pass dynamically while you're running it. And in this case, you are just checking if there are more elements in this. This is more about similar to, I would say, this is similar to this guy has more tokens. Then you have something called next element, that is same as next token. Just one difference is just the return type is object. If you observe, the return type is different. Other than that, these two are same. And count tokens is more about getting the total number of tokens you have.
Okay, let's look at an example of string tokenizer. So you can see, in order to use string tokenizer, it's a utility package. So we have to say import java.util.string tokenizer. Then this is our main program, public class string in token 1. And inside we have a main method. And string tokenizer, new string tokenizer, Java is a programming language. Here we are giving space is your separator. That means what would happen is internally string tokenizer will build a string. You can assume like a array kind of, where it will automatically split this given string by space. So it will be split as Java, then is, then a, then programming, then language, because you have given separator as space. Now how to retrieve it? For that, string tokenizer have function called has more tokens. You can put it in a loop and you can say while st1.has more tokens. So tokens are nothing but whatever the array I said, assume like an array, inside that it is split. Each one of that element will come. So first Java will come, then is, then a, then programming, then language. How to get the each value? It is using this function next token. And you can see the output says the same. So it says Java, first is, then a, then programming, then language. So the advantage with string tokenizer is you can even pass multiple separators also, not just one. Let's say you have a string of semicolon, comma, and space. You can pass all of them and everything will be split and you can easily retrieve using st1.next token. All you need to do is just put that in a loop where it keeps checking whether there are any more tokens to give to you, and that's it. Okay, let's look at the math class. Math class is one of the java.lang package. So what exactly is the math class? Math class basically is all about all the mathematical related functionalities you get here. So you can look at, when I say mathematical functionality, all the logarithmic functions, trigonometric functions, square root, elementary exponential, and even the scientific functions also, which is not listed here, also comes under math class. And how to use it? You can just say, this is the way to use it. You can just use this math class. By default, as you know, it all extends from the object. Object is like a super class, and this is how it defined. If you want to use it, all you need to do is just say import java.lang.math. That's all. And math.star, all the functions will come. If you say math, all the functions methods of that will be available. And not only that, like apart from the functions of that, math class comes with basically multiple constant variables. Some of them could be like this capital E, and another is pi. Pi, the pi value, which is nothing but the ratio of circumference of a circle to its diameter. Generally, it is defined as 3.14, but there are a lot of numbers to it also, right? It's a big value after the floating, after the decimal point. So that also you can retrieve using this pi variable defined in math class. Also the E, which is generally used for exponential for the natural algorithms, like you say 2.1 E plus 10, like that we write, right? That E value, what is it? It is something around 2 power something, if I remember correctly. That also you can retrieve from here, 2 power or 2 point something like that. All those standard math related variables also you can identify from this math class.
And these are a bunch of functions available in this math class where you have starting from absolute, minimum, round, square root, and all. This is self-explanatory where you can see these are all functions you can use to perform different types of mathematical functions using this particular class. Now coming to locale class. So what exactly locale represents? So locale basically represent a particular specific or specific geographic, cultural or political region. And it consists of fields like, language, script, country, variant, and extensions. It is more actually helpful to perform some kind of locale task. I mean, some locale information specific to a user. Like it could be US, it could be India, anything specific to a particular locale if you want. This is the class you need to look at. Now, like I said, you can pass a you can get information about different locales. So here is where you have to pass what is the language you are interested in to get the locale information. In this particular constructor, you can even pass the country code. And like I said, you can pass the variant code also. And this guy also extends your superclass object and it implements your clonable and serializable interfaces. And you have multiple functions here where each of the function, like if you see, mostly they are related to getting the available locales, which actually gives you a list of locales possible. And it gives you the hash code, it gives you the current country of that locale, it gives you the language of that locale. It actually helps you to display the country name of that locale you have set. All that related to that locale you can get from here. Now let's see a small program using this. So you're creating a package, local pack, which is just a user-defined package you're doing. And since you are doing java.util.star, automatically this locale class will be available to you. In this main program, if you see, you are creating an object and you are setting what is your locale, which is en. And this one, India, is nothing but your country code. This one, the second variety of constructor is what you are using here. Now, when it said that, it automatically understands which locale you are asking about. So as soon as you say locale L1, it automatically sets this locale. This is the locale code internally maintained, which is en_India. In the case of US, let's say if this is US, you will have en_US. If it is Indonesia, you will have something like in_en, something like that. But initially it starts with in_. Now here it is getting the current language. What is the current language in this particular locale, which it says English. And if you call this function get display country, it tells you the country name, which is India. and it gets you the hash code of it.
Let's talk about Java Resource Bundle. Basically, this particular package is used to specify locale specific data. So when I say locale specific or country specific data, let's say the currency value in your country is 20 rupees, in my country it is 30 rupees. This is locale specific data. These kind of locale specific data, if you want to do it, to internationalize the Java application, it actually basically the main advantage is to internationalize Java application. In order to do that, you need to have a property file where it talks about if this is US, this is the currency. If this is India, this is the currency. If this is Singapore, this is the currency. So that local specific data you want to mention, we need to have something called a properties file where we can mention that. And like mentioned here, when you mention the properties file, it should follow this convention where the file name must start with file name underscore that language code and then the country code. So this is how you should defining it. The example would be something like this. So where it says that my info, this is my properties file name, where the language code is EN, which stands for English, and the country code is IN. That means this particular properties file specifically talks about the IN related local specific data so that you can localize your data related to that IN. So the advantage is, let's say you have US, IN, and Singapore, you can have local specific data in each of the file, and based on which locale you're dealing with, that particular locale can be picked. So it is basically more about you are making your application a more internationalized by having these kind of resource bundles.
And these are the different kinds of methods we have, like get bundle with locale information, as well as get string to get a particular key value. And resource bundle by default actually have these two, property resource bundle and list resource bundle, are subclasses of this particular abstract class resource bundle. And property resource bundle contains, it's more of a plain text where you actually mention this information. This property resource bundle is nothing but this particular properties file where you mention information about what is the particular resource related or local specific information is there. Whereas list resource locale bundle is more about locale data, where you get the data from your source code.
Let's talk about generic methods. So like the name says generic methods are nothing but the methods which you can generalize so that method can take any type of data type parameter. Understand that it is different than the overloading. Don't mix up with overloading. In overloading, you have to write all the methods earlier, saying this is a method which can take integer, this is a method which can take double and all. Here, that's not the case. So generic method where you just specify the type as generic in nature, so that when somebody calls based on the caller, the data type will get, automatically get resolved. So how to define it? So first of all, if you want to define a generic method, you need to have a type parameter section which should precede the return type of the method, and it should be specified in between less than and greater than. That's the first rule. Another thing is each type parameter section, when you write inside the method also, you will take some parameters as input, right? That parameters type parameter section can contain one or more type parameters if you want. If there are one or more types, you can separate by comma. Another thing is this type parameter is the one which actually generally we write as capital T, by the way, by putting less than capital T and all. This type variable is the one which actually represents the generic type of that particular method. So that is the guy who runs the whole show of this generic method, or the generic nature in order to get that less than, greater than, whatever that capital T you put, that the guy which actually helps to resolve. This is completely different than overloading. In overloading, you are supposed to write all the methods earlier, different types of method flavors you want to take, whereas in generic, it's not required. It all resolves on the fly itself.
If you want to create a generic class, this is how you have to do, where we have said, like, this is how you have to put this particular T, which is nothing but your generic class object. And once you created it, you can see inside the constructor, what we are doing is whenever somebody creates an instance of your generic class, the object, it will call this constructor and it will be set to this. That means the value you are passing while you are passing through constructor will be set here. And after that, once you call this generic thing, it automatically runs it. So one thing you have to observe is this T is nothing but your data type. We generally, when you write normally, you actually specify, maybe in the classes you won't do it, but actually whenever you use a data variable or data member, you actually specify the type where instead of this type, this T is generic. That means it can have any type. It doesn't mean to be only integer or string or anything. It could be anything. So that's why you can see certain places this T is there, where it just indicates it's a generic or generalized data type, where based on what user passes, it automatically puts that particular type. Now, if you see the actual mains method where we are writing actual generics G class where we are writing this main method. So first time we are passing that you are going to deal with integer. That's why you are passing. And this particular integer is what it is set in this capital T. That means this particular thing, this particular generic class which you have written now behave like a class which can take this particular integer wrapper object. That means instead of T, capital T, just substitute everything with capital integer. That means it behaves like an object where it can deal with a wrapper integer. Now that is what happening here. So first time you passed it, and when you pass 15, all that particular this 15 will be set to this object because you are creating it a constructor time, and when you call it, it will be written. But what is the type of it, which is the most important one here? The type of entire this T is nothing but the capital I integer, which is your wrapper data type, wrapper integer data type. Whereas now if you see this second time, what we are doing is rather than integer, we are passing string. Now what will happen is instead of integer, this particular entire thing will evolve as a string data type generic class. That means all this T will get substituted with a string data type. Now this guy behaves like a particular generic class which can deal with strings. Now using that, think about it is not exactly same as your overloading like I called out earlier. It is more about you generalize one particular stuff, and based on that you can write different scenarios which is common across most of them, just that the data types might change. And here you are not writing multiple times multiple versions of the same code, just like how you do in overloading. And what is the output will be? The first one will be 15 because that is what you are returning here. The second one will be this is an example for generics example. As you can see, that is the first output and this is the second output. This is a very basic example, but if you wanted, we can really do something more, like where you can say T object comma T object 2. Two objects you can take, and when they pass integer, you can do addition. When they pass string, you can do string concatenation. Okay, just one thing you need to be very careful is when you are using this generic things, understand that whatever behavior you are writing, that should be common across. When I say common across different data types, integer and string you can do because Java supports plus for doing addition as well as string concatenation. Whereas let's say you use minus for doing subtraction and you are passing strings, it might give an error because minus is not supported across strings, whereas plus is supported both for string concatenation as addition. So you have to use the similar operators, which actually helps in getting a common behavior, getting a common interface but different functionalities. So just keep that in mind. The advantage with type safety is it doesn't allow to store any other object, just one type for that particular situation. And another thing, you don't need typecasting because it automatically takes care. And last thing, it happens at compile time, which is the biggest advantage. That means at runtime, all this doesn't happen. During compile time itself, it knows that how to make use of this. And if there is any problem, it will identify quickly. In fact, one best practice of checking these types is not at runtime, rather than if it does compile time checking. It's very useful because at runtime, you don't need to bother about what kind of these kind of type errors can come, and it will be even more performance wise much faster when these checks happen at compile time.
Let's discuss about collection frameworks in Java. First of all, let's understand what is a collection. Collection basically represents a single unit of objects. So when I say objects, you can consider it like a group, a single group of objects. Now, what exactly these collection framework provide? So collection framework actually provides you an architecture so that you can store and manipulate these group of objects. And with collection framework, if you really look at what you can do multiple operations on data such as searching, sorting, insertion, manipulation, and deletion. Not only that, collection framework provides you multiple interfaces such as set, list, dequeue, queue, and other classes like array list, vector, linked list, priority queue, hash set, link hash set, and tree set. And all these collection frameworks are mostly part of your java.util, which actually contains all these classes and interface of your collection framework. So like I was saying, these are all comes under your collection framework, where you can see starting with this collection, it has set,
list, it has sorted set, abstract set, hash set, tree set, multiple different types of interfaces you have, which help you to do, like I said, help you to manipulate objects or deal with objects and perform different operations on data such as searching, sorting, insertion, and manipulation and deletion. So for doing that, you have multiple interfaces available, like your set and list. Apart from that, you have abstract classes and you have something called concrete classes. So when do you call a particular class as concrete? Since we have got this term, we should understand it. So when you call, you will call a class as concrete when that class has implementation for all of its method. Simply to put, you can say that a class which is not an abstract class can be called as concrete. That means whatever the class you are using, if all of its methods are implemented, then you can call it as a concrete class. So that means all of its methods are already implemented, that you have to just use it. That's what it means here. Now, like I said about Java collection framework, collections is more about, it represents a single unit which consists of multiple objects. And if you take a map, whenever you take a map and actually you try to represent a group, each of these map, actually, if you want to do it, you have to associate with a key. Map you can understand like more of a dictionary, where if you want to search for a particular value, you have to look by key. And how do you add a value to the map? By using the key. And how do you retrieve the value from a map, which is nothing but here object? It is again by a key. Now, in this map, you have again, in the map also you have map itself is an interface and it has got a set of abstract classes as well as concrete classes. We already discussed what is concrete classes. Any class which is not abstract and all of its methods are implemented, that's called a concrete class. And as you know, abstract class is nothing but a class which has its function headers or prototype signature or function signatures are written, but the implementation is left to the class which extends it or inherits it. Now these are the different functions you have in the collection interface. You have add function which takes an object and it adds an element to your collection. You have add all where it will add all the elements of your collection to the collection which you are working with. And there is something called clear which will remove all the elements of a given collection. And there is something called contains which will help you to check if a particular collection contains a particular object you are asking for. Similarly, you have contains all where it checks whether whatever collection you are looking at, does that have all the elements which you are all the elements which are part of this particular collection C, and it returns true if that's the case. And equals, it will just compare the given collection as well as the collection you are referring, are those equal? If it is equal, it will return as true. And hash code, like we are seeing in multiple classes of Java, where it returns the hash code of this collection. Is empty is just to check whether the particular collection does not have any element. That means it is empty. Now similarly, you have something called iterator. You can consider iterator as more of like an object that helps you to retrieve elements from a particular collection one by one. And remove is to remove a particular element from a collection, whereas remove all is to remove all the elements in particular collection you are dealing with based on the elements given here. That means it will remove all the elements in your collection which are listed here in this collection. And retain all, it removes the elements that are both in the collection you are working as well as the collection C which is given. Whereas when you say size, size is more about the count of number of elements in your collection. To array is to convert whatever the elements you have in the collection to an array. And to array here, if you see the difference between these two is it directly converts, whereas here you have a possibility to specify a particular type to be returned after converting to an array. That means it will return you an array of elements but with a specified type you mentioned here. Now has next is more of a that's also an iterator. It just returns true if you still have some more elements to navigate in a list of elements which you are uh, following up through using this particular iterator. It is just to check, do I have some more elements in the collection to process? If it has, it will return true, otherwise it will return false. And to retrieve each element from the collection, you have to use this next, where each next call will get you one element from the collection. And remove just removes the last element, whatever the last element it is there in that collection. From now, we will look at each of the collections. So starting with set interface. So what does set interface does? So set interface, if you first look at it, set interface is more about, it actually
creates a mathematical abstract mathematical set. If you remember in 8th grade or ninth grade, you have this union intersection difference. This particular set interface creates the abstraction of that particular mathematical sets we learned. And like sets actually will not allow any duplicate elements. That means they will have the feasibility or ability to store only unique elements. Even though you try to put multiple elements, they will not store, because if you remember, even the mathematical sets are same. So this set interface also follows the same notion. And one more thing to remember, sets does not guarantee any ordering, which means even though you put elements in a certain order, there's no guarantee that you will get in the same order. So you must remember that, because in the case of arrays or other ordered data structures in Java, you have that particular possibility to get the elements in the same order, whereas for set, there's no guarantee. And set interface with respect to the type parameters, when you use the set interface, it will be something like this, where E is nothing but what are the elements, the type of elements, the data type of elements that is maintained by this particular set you are using. And it has its own super interfaces and sub interfaces. The super interfaces are mostly collection and iterable, whereas the sub interfaces are event set, sorted, and navigable set. Now coming to hash code, like I said, hash code is more about, it's basically help you to retrieve the hash code value for a particular object. It could be a collection or it could be a class object, anything. But basically what is this hash code does? So hash code basically gives you an integer value associated with every object in Java. It actually facilitates something like your hashing in hash tables. So the basic advantage with this hash code is, it actually gives you the hash code, because that's the way it can quickly refer to the elements. And to get hash code value for any object, you can use this hash code function. So, and this method, as it is defined as part of the object class, it is already inherited by your user defined classes. That means whenever you use it, you can directly, if you see normal programs also, you can directly use it, because this guy comes as part of your object class, which is a super class for everything. And it is available to all your basic Java programs you write. This we spoke about, like it is a method which actually a part of your Java integer class, which actually inherits from object. And it actually helps you to give a random unique integer for each object which you call out. And like I said, it's actually an inbuilt Java method, help you to give a hash code for a particular given object, and it is compatible with your integer.hashcode function. Now, what is list exactly? So like the name says, list is basically an ordered data structure. When I say ordered data structure, which means whatever the elements you have put in it, the same elements will be in the same order. It will store the elements, and when you retrieve in the same order, you get it. That means your ordering is preserved and you can get the elements in the same order. This particular data structure also allows you to have the duplicates in it. That means you can have duplicate elements, whereas that's not the case of sets. Those are the differences between your list in collection and set in collection. And this is also called as a sequence. When you call, I mean, ideally you call certain data structures as sequence, but not everything. When you call a data structure as sequence, understand that sequence simply means a data structure where you can navigate elements of it one by one through using some relative positioning, or you can call it as some indexing. And list, if you want to access, that is how it is. In fact, you can call your arrays also as a sequence. So here also, if you want to pass the type parameters, you have E, which mentions about the type of elements in the list. Other than that, you have some super interfaces. This is same like we have for set. It actually uses your collection and iterable as super interfaces. That means these guys base interfaces, base class interfaces. And like I said, since it is a sequence, it allows you to access the element using indexing. That's what been mentioned here, positional or indexed access to list element, because it's a sequence. And just like Java arrays, it also starts its indexing from 0. If you remember, arrays also start with its indexing or subscripting starting from 0, and list also does the same. And with respect to operations, it is proportional to the time you get with respect to the index value for each of the implementation. That means, let's say you are accessing a particular value. When you access the through index value, it will be as equivalent as the time you try to access any element under that. So it's more about a random access, I would say. And here also you have, apart from this particular implement indexing,
You can peek into any value and get any value because it's all through indexing. Let's say I want to get the first position, you can say this particular list of 0, and you want to get 50th position, you can do it. Even though it is sequential in nature, you have a way to get any random location. And this guy also provides you an iterator called list iterator, using which the advantage is once you create a list interface for a particular, once you implement the list interface, after that, if you want to iterate through objects, you can make use of this list iterator and you can traverse from element one by one easily. Like if you remember in the case of collection, we have iterator. Here in this case, the same iterator, just the name as list iterator. So it helps you to get elements from a particular list object one by one. And this allows accessing elements either from both directions, either from left side or right side. Generally, if you see arrays and all this list, you have accessing only from, starting from 0, 1, 2, 3, 4, 5, like that. So it is like left to right. Whereas it is bidirectional. When I say bidirectional, you can access from right to left also. That means on a higher index to lower index also you can move. So like I said, like you have methods also here that actually help you to start this particular iteration. That means iterating to elements of your list one by one, which you can start from any position you require. That is also possible here. And this guy comes with two methods to search for a particular object in a list. And these methods you should be very cautiously using because they are not performance wise good enough. So you should ensure that when you're using, you should be very careful in using it, and you should not be using on higher data sets because that might cause some execution performance slowness because of that. Now, what exactly is a queue? So queue actually it is basically another collection data structure where it helps you to order the elements in a FIFO manner. FIFO stands for first in, first out, where which means that if you enter a first element in a queue, you will when and the last element is, I mean, first element will be removed first and last element will be removed last. It is like a queue order. Like if you go to a movie and you stand for a ticket for a movie theater, the first guy gets the ticket and he will come out, then the next guy, like that. So that's the same arrangement of elements also here. Now if you see here, these particular methods, if you observe in queue, they all have, there are, at a high level, if you look at, there are two types of methods exist in queue. One which when throw an exception if a particular operation fails, whereas there is another set of methods where rather than throwing an exception, they return a special value to you. That value could be sometimes a null value, which is the special value we spoke in module 2, or it could be a simple false also. So some of them, to give you an explanation on it, if you look at methods like insert, remove, or examine, these actually available to you in two flavors in queue. One, either they can throw an exception, the methods to throw an ex or they can throw some special value. So if you want to call about the methods which can throw exception, like for example, insert, for inserting, if you want to insert an element into the queue, there is a method called add. That guy help you to add an element to queue and he will throw an exception whenever certain operation fails. Similarly, there is something called remove, to remove an element. He also will throw an exception if the operation fails. Similarly, there is something called element, to examine a particular element in the queue and he will throw an exception when a particular operation fails. Whereas the other side where I said there are other set of other flavor of functions which will return special value, they are offer for insert. To insert the element, there is something called offer, and using that you can insert the element, but whenever there is any problem, rather than throwing an exception, this guy will return a special value like null or false. Similarly, we have poll for remove and peek for examine. And one more thing to remember is queues do not allow insertion of null values. By default, that's not possible, but some implementation of queues are there, like, linked list and all. They do allow it, but even if the implementation allows it, you should not be using null to insert into a queue, because the reason being these null values are used as special values for some of the functions. Like we have seen some of them, right? Like offer, poll, peek. They they can use the special value null sometimes to return rather than failing, just like other set of functions you have. So that is why it is not recommended to use null to insert the values into a queue, because these are used by other functions as return values. Okay, also one more thing to remember is these guys do not define elements based versions. That means some of the element based versions of queue are there, like
equals and hash code, because these are not defined and these are element based, because equality are not well defined for Q with some elements, but different because of different ordering properties. Because Q do follow some ordering, that's why equality is not clearly defined in the Q data structure. Now coming to comparator. So comparator, what exactly is the comparator? What exactly it does? So if you look at comparator, it is actually used to order the objects of a particular user-defined class. When I say user-defined class, that means in your class, let's say you have, for example, you have, let's say you are going through an admission, you're working for some education company like Edureka or Simply Learn or Intellipath, and you're working as a developer there. And let's say you want to sort a particular set of students based on the rating they gave. Rating when they gave, based on that you want to compare. And how do you compare? Let's say the rating is not in terms of 70, 50, they are not in numbers, but they are something like excellent, very excellent, poor, average, something like that. So based on these, you want to do it. That means you have to teach your Java how to sort it. So for that kind of use cases, this comparator are very useful, where you can write your logic of how to sort it. So you are teaching your Java program using this comparator interface how to sort certain data, which generally cannot be sorted usually with the normal kind of sorting you have in arrays or all these functions. So that's where the comparator really helps. That's where I said it can help you to order the objects based off your user defined class based on some particular logic you have. And not only that, to give you a very simple example, like, the simple example like here mentioning, it's like it could be just like you have student information and you want to sort by roll number. You can still sort the roll number using this. I mean, in this case, even if I want, I can do with arrays also. If the roll number is integer, that's still possible. Whereas the other logic I said, where you have to sort the students information based on the rating they gave, then definitely we have to think about how to implement that in this compare function, which is part of this comparator interface. And it is very useful because it gives you flexibility to write your own algorithm on how to sort it. Case like you see here in this case, it is pretty evident that roll numbers, if it is integer, you can do with sort. But the kind of use case I have said, where you have to sort the ratings based on ratings, that might not be possible with the normal sort functions. And not only this, if you look at comparator, it has other kind of things as well. Like for example, it can, you like I said, this particular comparator can be used to order objects of a particular user defined class. Apart from that, this particular comparator, if you look at this guy, contains two methods. If whenever you want to implement it, one of them is compare, another is equal. So any of these particular methods you can use. If you want to put a logic of comparison, you can do that. If you want to do some kind of equalization, you can use equals. And like I said, it's more about telling it ordering. When I say ordering, it's actually nothing but sorting the data according to your requirement. So it could be ratings, it could be, let's say you are a developer for some flighting system, for some airline system, and you have to sort the data based on the customers the flight class, like economy, passenger, economy, luxury, business. Let's say you want to sort the passengers based on this class status, then also you can use this comparator. There are a lot of real world use cases that can be easily solved using these comparator interfaces. Now starting with DQ, like the name says, DQ simply means double-ended queue. Double-ended queue means you have way to alter the elements in both from both sides. And this actually you can use as a queue also, like first in first out as well as last in first out also. It can be used in any ways, because the idea here is like you can insert the elements either from left to right or right to left. So both ways, since it is possible, you can implement a LIFO or a FIFO easily. That's the best part of it. And it provides two methods for you in order to do these kind of operations. One is remove first occurrence, another is remove last occurrence. And unlike list interface, this guy, if you look at, he does not provide support for indexed access to elements. So when I say, since we are talking about queue, these guys do not have something like indexing. That means you cannot say queue object square root of 0, square root of 1. You cannot access the elements using some subscripting mechanism. That's not possible here. And here also the same statement like what we made earlier with respect to one of the data structure called queue.
where we said that even though queue allows you null values, it is not recommended to do it. The same recommendation here as well, that even though this particular DQ interface allows null insertion, it is not encouraged, like I said, because the reason being some of the functions in this particular queue interfaces uses this particular null value as a return value. So that's why it is not recommended to use it. And at DQ implementation, one more thing to keep in mind is it do not define your equals and hash code just like what it does in the queue method. But if you want, you can always inherit based on the identity based versions. That's still possible. Yeah, this is what I was saying. It do not define the element based versions, but you can always uh, use the identity based version from the class object and make use of them if you require. And all these are part of the Java collection framework. Now coming to map, like I said, it's more about a dictionary. When you say something map, it is more about a key value pair. That means if you see here, that is what mentioned here. There is a key which is pointing to a value. There is a key which is pointing to a value. So internally, the maps and all mostly organized based on some pseudo random indexing. When I say pseudo random indexing, here internally it is all more about like kind of a pointer. Whenever you ask for any particular key reference, it automatically looks at the key and fetches the value. Whereas that's not happens when you use arrays because they are more of a sequential kind of accessing. So mainly the maps are used for situation where you want to quickly get the value and you want to have a zero time for search. That's where they really help. And since we are saying maps and these all keys must be unique. So what would happen if I allow some duplicates? The problem is if you try to add one more key which is already existing, it will overwrite it. So that's why ideally it should not contain any duplicate key. One key should map only to one value. And these guys provide, three types of collection views. There is like tree map, hash map, like that. And all of them, it's more about, you can think like it's a more of a key value pair. And one more thing to remember, just like said, this guy also does not guarantee any ordering. That means once you put the elements in it, you cannot expect the same order. It puts in some pseudo random fashion. So there's no guarantee the ordering is preserved. And this is a small implementation of how the mapping really works. So if you look at the old value we are trying to get using this function, so where we are saying get me the value of this key. If it has value, it will store in this particular old value. And we are also trying to get a new value if at all it exists, where we are saying, okay, remapping function dot apply of key comma old value. So here what we are doing is based on whatever old value obtained, you are setting the key with that old value and you are fetching what is the new value you obtain. It will be mostly in old value. And here you are checking using if condition if that old value is not equal to null and if null new value not equal to null. So you are checking both. Only when this is true, that's where you are putting the key with the new value. Let's say if that is not the true case, let's say if your new value is not equal to null, that means only old value is not equal to null, but new value is equal to null. In that case, it will try to remove the key because your key is set with your old value. So it will try to remove the key. So it is like a fresh key. Now, other case where let's say your old value is equal to null, but your new value is not equal to null. So which means your new value has got something. In that case, you are substituting key with new value. This case, you have to understand that this case where your old value is not equal to null. This case is where your new value not equal to null. That's why you should see the difference that when your old value not equal to null and new value, you are doing some operation. If not, you're just removing it. In this case, when new value not equal to null, either you set the new value with the key or you're just returning the null value. And this is one reason why we said we should not have the null values to be inserted because some functions like this will return the null as a special value. Now coming to sorted map. And here, if you look at whenever you enter any element into sort, it has to implement the comparable interface. That is one thing you have to do it. And all the keys must be mutably comparable. That is another thing. And whenever you use compare to or compare function of comparator, they must not throw class cast exception. That is one thing to remember. And if you try to attempt it, even though this is being told, it will actually cause your offending method. That means the method users or the constructor which is getting invoked but a particular if you are invoking in a constructor from a particular method, that guy will throw this exception if you are not following this rule. Now coming to other types of set we have, like we have hash set, link hash set, and we have array list. These are general kind of, these two are comes under one set flavor, whereas this comes under the list structure. Hash table is more about, just about more of a, a set kind of implementation, and it has this kind of hashing table where it maintains it, whereas linked hash table is, a mix of both hash table structure as well as a linked list kind of implementation. And here also, whenever you try to insert an element, it runs as fast as this, because when you say hash, hash set is more about, you can treat it like a dictionary structure. So it arranges this elements in a form of dictionary structure. The same thing along with the linked, they have added the linked list favor here, which means it will run as faster as this guy. Whereas when you say array list, generally arrays, if you look at, they will not be resizable. When I say resizable, when you say int a of 10, that means only 10 elements you can store at max. Beyond that, you cannot. What if you want to add element? That is difficult. Whereas here, the advantage with array list is it is resizable. That means you can add few more elements to it and it automatically grows altogether. So you don't need to specify it, it automatically grows. So other than that, you have tree set, where it is more of an implementation of a red-black tree. If you know about data structures, red-black tree implementation is done in this tree set. And array DQ is more about your DQ implementation using arrays, where the same DQ which we spoke about, where we can add elements from either side, that is implemented using arrays. And for each method, so for each method is, one of the very interesting one to iterate to your collection. This basically is a function, or you can call it as a method, that provides you a concise and a easy way to iterate over collection. When you want to iterate over multiple ends in a collection, this particular for each is very helpful. Ideally, what these guys do is it helps you to perform action for each element of the iterable. That means it helps you to fetch each elements until all the elements are done. So it will try to fetch one element from your collection, and once it is done, it will throw an exception so that the whatever program you are writing, that gets a trigger that all the elements of this collection is done. Let's understand some differences. We discussed a lot about collections, arrays. You might think like, okay, what exactly is the difference between collection and arrays? So let's talk about it. The first thing, arrays are fixed in size. That means when you say int a square bracket, if you say something like int a square bracket of 10, that means you can add maximum to 10 elements. Beyond that, you cannot add, right? When you say a particular array, I'm just giving an example. Maybe syntax wise, we can do different ways, but just understand that maximum you can create a 10 element array. That is why it said fixed size, because beyond that you cannot increase or decrease. Whereas in the collection, that's not the case. Based on your need, it automatically gets increased or decreased. And in terms of memory also, this is not recommended, because you never know when you're creating array to store elements, you never know how much you're going to store. Maybe you might be putting a random number saying 100 elements. Maybe even though you put 100, you might not be using it altogether, right? You might be wasting some of the memory location. Whereas with collection is not like that. It is dynamic, and it automatically enhances your memory or decreases your memory based on the need. And but if you look at really performance wise, this is good enough, but this one is not as good as arrays comparatively. And arrays, one more thing is, if you look at in the earlier example, it says int of 10. That means in its entire lifetime, this array can store all the elements of only integer type. No other type can be allowed. That's why it is called, the same property is called homogeneous. Homogeneous simply means that all the elements of the data structure should be of the same data type. So that's been the case here. Whereas in the case of collection, it can either hold homogeneous or heterogeneous elements. So heterogeneous means a particular data structure which is able to hold elements of different data type. That means that data structure can have mixed data type. That means one element could be integer, another element could be float, another element could be of some other type, or string or something else. So that is possible. That's called heterogeneous. So collection allows both, whereas arrays hold only one type of data element. That's why it is called homogeneous. And lot of methods, if you see, this guy does not have a lot of method support comparatively. If you look at collections, we have a lot of methods. If you look at, we have seen a lot of methods available, right? That's not the case with arrays. They do have some basic thing, but not ready-made method kind of support. Whereas arrays, it can hold both objects and primitive, but collections basically hold only objective types, but not the primitive data types. When I say primitive data types, your integer, float, and all, those are the basic data type comes in. Now starting with input or output stream. So before we jump on to input or output stream, let's first understand what is exactly input or output and why should we worry about it. So input or output is to process your input and produce some output. That means if you remember, you take some input from user, that's what called your input, and you give some output in the form of displaying hello world or displaying something on the screen. That's called output. Sometimes when you get an error also, that is also on the screen. Even that is also an output stream, just that it comes from your error stream. Okay, so overall, if you understand, it's more about how you deal with input. That means you take input from the user and how you throw back or how you respond back with an output message. Or that message could be on any type of output stream, just that understand this is more about it. And with respect to operating system, this is very, very important because operating system takes a lot of time with respect to input output. Operating system takes less time when actually it deals with the processor kind of operations. That means anything related to processor, all the processing kind of thing, they works pretty fast. And if you remember in the first particular for starting of the module when we are discussing, even multi-threading also, it goes into sleeping or waiting state because of this input output requirement for a program. So just recall that in threads also, whenever there is a request for any input output, your OS puts that into another state because until then it is not need of the processor at all. So now coming to the stream part, what exactly is a stream? So stream simply means flow of data. That means it is nothing but a data flow. Now Java uses the stream concept rather than, if you look at in other languages, the same thing might be called as input output buffer. Here it is called stream. The only reason why Java prefers stream, which is nothing but flow of data, is to make the IO operations faster for you. And another thing is to make the platform independent also. That is another thing comes in. And these are all part of your java.io package. And most of your file handling you can do with IO thing. Like I said, everything related to input or output, you can do it. And one of the output could be writing to file. Another way could be reading from a file also possible. So that is also possible with files. And like I said, stream is more about flow of data. You can call it a data sequence as well. And what exactly is a data sequence it contains? It's more about nothing but a set of bytes. And that's what actually called a sequence because it's just like a flow of water. And basically every program, there are three streams get created automatically without our knowledge. One is standard input, standard output, standard error. And these have relative names in Java. For standard input, we refer here as system.in, and standard output we refer as system.out, and standard error it is system.err. And all these are part of java.io package. And every input stream, if you look at, they have this file, all this java.io file. You have something called a file, array, peripheral device, or sockets available. So this file class particularly is nothing but more about your, I mean, it's just an abstract representation of your file and directory. You can always create this file class object by passing file name. This means this particular thing, that you can create a file object. How you create? By calling that particular file class constructor by passing a certain path. Like the path could be as simple as this, where you just pass a path and it will create a file object to it. And these instances which you get are immutable. That means they cannot be changed once you get the file object. And you can put certain kind of file permissions also if you want to implement. And like I said, the file object, the way to do create a file object looks something like this, where this particular notation comes from this, where you can see that we are just passing a path and it creates a file object and gives back the file object reference to us. After that, there are certain functions using which you can read or write the file, which is this user local program Java. And these are, like we called out, these are different types of constructors you can call, and all these constructors are overloaded constructor. That means you can use anything. Here we use this one particularly. So if you want, you can use the parent path, child path, all that you can give. You can even give the URI also, so that you can read from a particular URI pumping the data to your program. And this is a sample program on how to deal with this particular file of class. And if you look at, we have imported java.io.file so that this particular file class is available to us. After that, we are creating a file object, but before that, if you see, we are using a, so it should be a of square 0. So it means nothing but a command line argument. That means first argument you pass over command line, and where your command line arguments are stored, all are stored when you pass an argument to your main method, isn't it? So the main or the JVM automatically captures the command line and stores in your the parameter of your main method, which is a here. And a of 0 is nothing but the first parameter. And here in this case, when you run as a command line, the first parameter is available in a of square bracket 0, and that is where the file name will be, which we give. And once you read the file name, if you see, we are creating a file object. And once you create a file object, you can get the file name, you can get the file path, you can get the absolute path of the file. Absolute path is something which starts from your root directory up to the file name. And you can get the parent of the file. You can check if the file exists. This is very useful when you want to check if the file exists or not. Rather than this, I would suggest doing this, because there could be certain times what would happen is you want to check, you want to do certain operations on a file only when it exists. In that cases, this is really very useful, because how do you know that file exists or not? If you blindly just start doing this operation, it might give some error because the file doesn't exist. So it is very important to learn that before doing any kind of operation, particularly reading the file or trying to write the file, it's good to check if the file exists. If the file exists, then it is good to do this kind of things. Here we are doing very simple, where we are just checking is the file can be writable or readable, or is it a directory, or what is the length of the file in bytes and all. But it's a good idea whenever you try to read the file, just check if the file exists and do that. That way your program is free of errors. And you can see this is the output where you get the file name, the path of the file name, absolute path. If you see path of the file name, just shows you file name. Whereas when you see absolute path of the file name starting from your root directory, here in this case, for Unix users, it might show you, starting from your just slash. Whereas since it is Windows system where we executed this program, you can see start from the drive where you executed this. And parent of the file, there is no parent, that's why it said null. And is the file exists? Since the file is available, it says true. Is the file writable, readable? Yes, you can write to file, read to file, that's why it said true. And is the file directory? No, it is not a directory, because since it said is a file, it can't be directory, that's why it said false. And what is the size of the file? I mean, the contents in the file, how many bytes are there? There are 20. That means there are 20 characters in your file. And these are different kinds of file operations possible. You have write where it takes byte as a parameter, as well as int. And it throws this IO exception whenever there is any problem writing to a file. That means, let's say you didn't check whether the file exists and start writing it, it might throw this IO exception. Similarly, you have the flush function. Flush function is moreover useful to flush the content into a stream, flush the content left in your stream. Because ideally what happens, if you look at the architecture internally, let's say this is your program, understand that this particular files and all is not part of, is not part of your program. Actually, these are part of your OS. F is nothing but your file, and this is governed by your operating system. Now when you're talking with the file resides, or file is under control of this operating system. It will not dock directly to file. There is in between your streams sit, which we discussed there, right? System.in, system.out, and system.error. These are those streams. Now what happened, these streams will not write the content immediately. It is all for the sake of performance and modularity, all the things. So what these will do is only when they fill completely, that is why they do one flush. It is reduce the IO operations to OS, because like I said, the most consuming operation in the entire operating system, if you look at, is IO. So to reduce the IO, it will not flush the content immediately. It will flush only when it is full. So let's say you have written some content and you are left with only half content but hasn't written. Like let's say there is like this guy, the stream occupies only, just for example, if it can take only 10 KB, only for 10 KB chunks it keep writing the content. Now what really happens is, let's say your file is 22 KB, it first writes 10 KB, then 10 KB, and the 2 KB it is left. If you have to write, it has to be flushed. It happens automatically most of the cases, but sometimes if it don't happen, or sometimes because of some reason you want to flush it, you can use this flush where it will just flush whatever the content left in that particular stream. And close is to close your connection to the OS, because this actually say from your program to OS there will be a logical connection setup when you create a file object. So what you are doing is, when you're closing it, you are cutting this logical connection to your from your program to OS, so that you no longer can deal with the file and it can close and can be used by some other person. Now in file, if you look at, like, there are output stream and input stream functions also. In the output stream, you have different types of output streams available. Something like you have file output stream, byte array, filter output, piped object, and all. And apart from file output stream, you have different varieties here: data output, buffered output, and print stream. Data output is more about a high level platform independent one. Buffered output is like a buffered stream output. Now coming to input stream, like you have for output stream, write, and flush and close. Similarly for reading also you need some functions, right? So to read, you have a function called read, so that you can read the content from the file which you have created using file object. And available is to check whether a particular, how many, I mean the file, how many number of bytes that can be read from the file. That means you have created a file object, you want to know how many number of file objects. It's an estimate basically that can be read from your input stream. If you want to find out, this is the function. And close, I said, like you want to close the connection between your OS and your program. And like output stream also, it has certain different types of classes available, like file, starting with file input stream to byte array stream, filter input stream, piped and object input stream. High level classes like data input stream, buffered input stream, and pushback input stream. Now if you look at low level byte stream, high level bit stream, this is where the difference comes in. When you say low level byte stream, understand that these are all these file input stream and file output stream, like I called out earlier. These guys can read your data only in terms of bytes. Okay, they will not be, even though they read in bytes. Another big problem here is they are machine dependent. Like they are like, when I say low level, it means whatever machine you do, that machine level they will be working. They are not machine independent. Whereas if you want to do machine independent way, that is irrespective of the system, you want to work anywhere, that is where your data input stream and data output stream comes in, where you can read data from an input stream, which is this, or an output stream in a machine independent way. Okay, that means what the way you have written to process bytes and all here, it might work only for your machine. Whereas this way, if you write, it can work for any machine, because these are machine independent way, or you can say platform independent. Now here we are seeing an example using file output stream. So you have imported a file output stream here, and you are creating a file output stream object for a particular file, test file. And the objective here is to write some content to it. So you have created a string which is welcome to learn IO stream, which is what we are going to attempt to write to it. Before that, we just asked how many bytes we have for this particular this thing. So it might come some down to some 20 or 30. I mean, it might close to 30, I guess. After that, what we are doing is we are trying to write to f1.write. F1 is nothing but this file where we created this file output stream object. And when we say write of b1, it automatically writes the number of bytes you have estimated, which is b1. And once it is written, so now what we have written is, system.out.println, so where you're closing it. And once you say f1.write, it writes this welcome to learn IO stream, and that's what it gets. Let's say by mistake, if you observe, we are not checking whether the file exists or not. So if the file does not exist, it will throw an error. In that case, you have to catch it out. Either you can do using here throws, which is not what we are doing, but we are doing the other mechanism where we are putting try and catch. So if there is any exception, it will be caught here and it will be printed. Since there is no exception and this file exists, you get this message like completed from this guy, and welcome to learn IO stream from the message you have written here. Now this one we are talking about the file input stream. So where file input stream, we are reading the content from file rather than writing to it. So first you have created the file input stream, and we have to import it also using java.io.file input stream. Once we have imported and we are starting to read from this file, testfile.txt, we have to read from the file. If you remember, read is the function to do it. The way to do it is something like this, where each time you read one byte from it, and this guy will signal a -1. -1 is nothing but a more of a signal to say the file is reached to end of file. So this -1 internally indicates it's an end of file signal, and that f.read function will throw that but return that particular -1 when there is no content read in the file. That's why we keep on doing it until the value is not equal to -1, where whenever you get a particular value or converting, because here x is integer, so each time it reads the value of that particular character in file as integer, and you're converting back, you're casting it so that you can show what character is inside that file. And this has something like welcome to learn IO stream, which is what gets printed. And if there is an error, this is got caught here. Now byte array output stream, like the name says, this particular array output stream will help you to write a particular a set of bytes to your array output stream. That's the main advantage. Another thing is you can write a similar data into multiple files, and this guy automatically grows or grows dynamically increases based on the data you're putting. You don't need to separately increase it. If you're coming from a C background or C++ background, you know the pain of how to increase the the memory, or using CLK, MLK, you have to dynamically create the memory to write to file and all. That's not required here. It gets automatically done because this guy provides that functionality. Similarly, the byte array input stream, this guy also grows according to whatever data you read, and it reads the data as your input stream. And this will all inherit from input stream, so it moreover behaves like your input stream. And data output stream, it actually helps you to write your primitive data types in a machine independent way. Because if you remember, both the data input stream and data output stream compared with other streams, they help you to deal with your data in a machine independent way. I could say platform independent way. That's why these are pretty much used, because you don't want to write a program that just works on one machine and not other, right? Similarly, like a call dot, these two, data input and data output, both are used to actually stream your content in a machine independent way. Now coming to character stream classes, the biggest problem with the byte stream classes is they actually read the content in 8 bits. So most of the byte, when you say byte, it is 8 bits, right? So these guys overcomes the limitation because all the byte streams can only read in terms of bytes, which means 8 bits only. But if you remember, Java supports unicoding. When I say Java supports unicoding, it can support multiple languages. So whatever character you're reading, that might not be just 8 bits. It might be even more than that. Now, how do you deal with it? That's where this character stream classes helps you in, where they gives you ability to read a 16-bit data also, which is nothing but your Unicode characters, which means it gives you support to read Unicoded data. And this guy comes basically with two classes. One is reader class, another is writer class. And the reader class has this set of functions, like if you have seen buffer reader, character reader, these are the classes you have. And it has got read and reset functions. Read is to read the content from the reader class. I mean, whatever particular, the file you are referring, using that you can read the contents from it. You can mention the how much buffer size you want, location, and number of characters to read using this. You can also reset the file pointer to a particular position you want. You can skip number of characters you want if you want, or you can close the flame. They have different functions we have altogether. And similarly for writing, you have multiple set of functions. You can write particular string, or you can write an integer. You can write a character buffer. You can write buffer from a set of characters from a particular location, and how many characters you want to write, that is also possible. And you can all do a forcible flushing of the stream as well. And you can close the file as well here. Now coming to serialization. So what exactly is serialization? So serialization is more about, let's say not every time you write a code that works just in your system. What if you want to transfer the information from your system to another system which is connected to internet? Now, how do you do that? So that's where this concept of serialization comes in. So serialization is more about writing a state of object into a particular byte stream. So it converts whatever the data, whatever this object you have into a byte stream so that it can be traversed over internet. Okay. And these byte streams are platform independent. Mainly they are used in, in your at least Java. If you see, you might be using this in Hibernate, RMI, JPA, EJB, and JMC technologies. And all this, apart from serialization, you might heard a term called deserialization, which is more about the reverse process of it, which is like once you receive the data on the other end of the network. I mean, like I said, over the internet, if you want to transform, the serialization is the concept to look at. Once you transfer the network information over the internet to the other side, it has to reconvert back, right? So that's where the deserialization comes, where it converts the bytes into object. That's what called deserialization is. And what is the biggest advantage with this serialization and all deserialization? It is mainly used to travel object state on a network, which is called as marshalling also sometimes. The reverse process, converting object state to the bytes, is called marshalling. Converting bytes to objects is called unmarshalling. It is more about, it is nothing but serialization and deserialization again. That's what we spoke about. Objects travel across a network and deserialization is the reverse process. And all your non-static data members are saved via this serialization process, by the way, and it gives you two methods in order to support this serialization as well as deserialization process. Now coming to JUnit, JUnit is actually a particular class you use to do unit testing in your code. When I say unit testing, where actually in the unit test you use certain methods like assert, where to see whether the test result is false or true. If at all even one test case fails, then you will say that there is some problem where your code is not able to take. In fact, if you look at your competitive exams use these kind of assertions in order to figure out whether whatever the program generating values, that means you run a program, and if you remember in the competitive programming platforms, whenever you click on it, it will say this test case failed, this test case failed, this test case failed. All that they have written test cases, and your program is tested against those test cases. So if you assume how they have written, if they have written in Java, they have to use something like this class called JUnit, where they have to write all the test cases and they have to ensure your code is working for all those test cases properly. So this is very useful, and it is must for every developer working in industry where they are supposed to write unit test cases for their program to ensure their program works for all possible use cases. Now coming to Logger, so what exactly is Logger here? And to support these kind of logging, Apache has given these different types of logger frameworks like SL4J and all. In that, Log4j is one of the famous framework given by Apache. So using this framework, you can do this kind of logging. So that's why it says it's a logging framework. And what are the advantages you get? I mean, there are a lot, like here we have mentioned few, but let me call out the advantages like what we get. This is what, first of all, thread safe. And this particular log4j is optimized for speed based on the named logger hierarchy. It supports internalization. It supports multiple outputs using your appenders per logger, and it is not restricted to a predefined set of functionalities. And format for log output can be easily altered by changing your or more extending your layout classes. And not only that, this behavior of logging can be set at runtime by just changing the config file. That's also possible. And if you look at why we need to look at log4j, why not some other logger frameworks? This thing is, first of all, it is open source. That means your code is available, and if you think any bug is there, you can always raise it, and you can always store the full details of your flow details of your automation in file at database. And it works very well with small and big and moderate kind of projects as so. Those are the advantages of why we need to use it, this log4j. Now coming to log4j, there are basically three components, which are logger, appender, and layout. Before this, understand that logger supports two types of objects. One is core objects, another is special objects, or I would say, rather than special, I would say additional objects or support objects. So what does it mean by core objects? Core objects in the sense all the mandatory objects that you require, that you need, or that is must for your logger framework to run. That comes under the core objects. And that core objects is where your loggers, appenders, and layout comes in. Whereas the another set of objects, which I call it as support objects or additional objects, they are just optional in nature, like the name says. If you want, you can use in addition, otherwise not required. Now coming to logger object, what exactly this guy does is, it provides you a logger object. So logger object is the one you need to log some information. When I said you have to log information so that you know everything happening in your system, you have to write somewhere, right? But how do you write it? So you have to create a logger where it will give you a log object, something like logger log equal to new logger, something like that. So it will give you a log. Now coming to appender, what does this guy does? So appender actually is a lower layer which provides a lot of appender objects, and there are a lot of appender objects. I mean, we have at least close to 10. Like some of them could be, file appender, JDBC appenders, console appenders, SMTP, socket, system log, telnet, writer. These are all different types of appender we have. And generally, since we are going to write most of the time into the files, we use the file appender by default. Coming to layout, and this layout, what exactly he does is it actually provides the layout to your object so that you can format the logging info in different styles you want. Like some of these styles is possible, which are possible based on the classes logger framework provides us. simple layout or pattern or HTML or XML layout. So understand layout is about how you want to log the information. The simple layout you just mentioned what is the info, it comes with the default layout of how you want it. In pattern layout, you want to mention that I first want the date, then I want the name, then I want the message, like the format specification. Whereas in the HTML layout, you can log the information in HTML tables and in the form of HTML tables, whereas in XML layout, you log the information in the form of a XML format. So that's why this many layouts you have. And there might be other third-party layouts also available beyond this.
So here is my Eclipse launch bar. So this particular Eclipse IDE will launch whatever the programs are there in my workspace. So I already have written a set of programs. So you can see for each module I have separate programs written. So we'll start with module 3 since module 1 and module 2 is already discussed as part of the previous demos. So with module 1, let's start with the student record.java. This is the program. And what does this program does? Before that, let me execute this. When you execute, you will see the output here in the console. This comes from the console button. So I will explain what is happening here. So the whole agenda of the program is to create a student record, and after creating student record, you need to sort by the registration number, which is this part. So what we are doing here. So first we are importing a set of utility packages which we need, like array list, collection, and list, which we are going to use here. Then we have written a class called student record which implements comparable. I will tell you why comparable is used. Just for now, understand that comparable interface is implemented, and we are going to implement one of the method in comparable called compare to. Now in this particular student record class, we have three variables called name, roll number, address. These are the three instance variable we need. And there is a constructor where it takes name, roll number, address and assigns those values to their corresponding name, roll number and address instance variables. And there is another function called toString. This is just for formatting, so that whenever you do a system.out.println, it automatically uses this format. So where it says that first I want roll number, then there is a space, then name, then address. Now here is where the actual play happens. So this is your public static void main string args, where we are creating a student array list, which is of type list. List is one of the generic data type where it is able to hold a set of elements, and we are creating an array list variable here, just student. And on that student, if you see, we are creating new student record with name Lahari, registration number and city. Now, what is this student record? Student record is this particular class where when you call it, it creates an object to this class. I mean, this class itself, we are creating an object, and when we create an object, as you know, automatically the constructor gets called and the instance variables like name, roll number and address gets assigned with this respective values. Similarly, we are creating student record for another person called Amulya and with registration number and city. Similarly, Madhavi, another registration number Chennai. Like that, we are creating registration number and student for Varhalu, registration number Rajmundry, Sarojini, registration number Rajmundry, Hamsatish, registration number Hyderabad. So like that, we are creating a set of students information and storing in a list by creating how many instances we have created. This is 1, 2, 3, 4, 5, 6, 7. Seven student record instances have been created. Now, the actual job is to sort by registration number. If you see, these registration numbers are, we just added it, but we want the student record to be sorted out. So how we are sorting? So we are saying collections.sort. Collections is one we have imported here as part of the import statement. And we are saying collections.sort stud. The stud is nothing but this list variable which you have created, and we have added student information here. That student information is getting sorted out. Now, when you think like this, when you gave a student list and you're asking it to sort, and that student has different object values stored, and each object has these values, how does it know it has to sort by a particular element? That is what we are going to teach in compare to. So whenever you call collections.sort, it will look at the compare to functions. So this is what we override it, which comes as part of comparable. That's why we implemented comparable, where we are overwriting this compare to say that I will write my own logic. So I am overriding it, where I am saying whenever somebody calls a sort on this particular stud, and whenever each object comes, how to sort it is what I am teaching here. I am saying the way the sort has to happen is, whenever the sort happens, it jumps and comes and looks at here to see what has to be done. And this is of type object, because if you see here, we are creating objects. So that's why it needs to be a type object. So we are saying for each object, this dot roll number. This dot roll number means this particular instance roll number. What is this? The object gets called, right? Whichever object. So in this case, collection.sort of student, it is student's roll number. We are saying this roll number, and student record of O. So O is nothing but this object instance. That object instance we are converting, casting it. We need to be converting, because this is just a superset. This is just saying I am a type of object, but object is a superclass of everything. Here we have to be specific. That's why we are casting it to student record. After that, we are saying roll number, which is nothing but this. So we are saying every time whatever information you pass, pick the current roll number, current instance roll number, and subtract it. And this value, you should take it for sorting. So based on this subtracted value, because you are comparing this roll number, roll number is integer, based on that you are asking it to sort. So these values will be written to collections, and based on the positive negative values, it starts sorting. Now, once it does that, it automatically sorts and put the student list, the entire student list, it automatically arranges it. After that, we are just printing system.out.println after sorting by roll number, and here you can see it is showing in the output. Now, in the loop, we are starting from I equal to 0, and we are saying stud.size. List, if you want to know the length of elements or number of elements in the list, you have to use stud.size, which will tell you how many number of elements are there in the list. So here it says there are 7 elements. This stud.size will give you 7 elements. So until 7 elements, this loop gets repeated. So first time I equal to 0, so it will pick this instance, and each time you have to print that, right? So you can have a function called get, and you say student.get of I, automatically that object's data will come. And how it knows that it has to fetch it, because whenever you call system.println and you do that, this object will be formatted according to what you have overridden here. That's why if you see, first you're having roll number, then there is a space, then name, then city. If you just put a comma here or some other thing, it automatically reflects here as well. You see here, I'm just saving it. You can see the comma is coming. So it is all based on the formatting you have done here. You can put a tab or anything. So I just change it to comma. So whenever you just say system.out.println, this toString will get invoked. In that, we are teaching how it is to be done. So that's how the student, the main part is this sorting on how we are achieving by using this comparative. And this comparative is a method in the comparable, and which is what we are overriding here. Okay. So this is one version of how to arrange the student record number. I'll show you another version of it. That is the first version. This is the second version. So when I say version, this is like one example of how you can sort the student number by roll number. Student details by roll number. The second one is also same, just that here I have put the things in a more organized way. So when I say more organized, if you see this particular program where you have every other thing to sort your student information is just in one class. It is not in different classes. It's all just in student record class and you're manipulating. Here what I have done is I have done little more better, where I have put the details in individual classes, so that it works more better and it is easy to manage. So let's start with this program. I need, if you look at the first line, let me execute this program. So you can see that I'm just printing what is the data before sorting and what is the data after sorting. More than student, here I'm calling student as learner, but the concept is same. So here, if you see, I'm importing all java.util.star. That means all utility packages is available to my program. Once it is available, what I am doing, I am creating a class called student record 2. And after that, I am calling a method called public static void main. And here I am creating array list of learner. So what is this learner? Learner is a class which I have defined here. And what does this learner class contains? Learner class contains roll number, course names, location. So it says, and it has a constructor called roll number, course name, location. And whenever somebody creates an instance like this, it automatically gets that information and stores in its instance data. And there is a string to string also, where it knows how to format it when somebody calls and prints an object on this. Now that is the learner class. So what we are doing here is we are saying this array list will contain elements of type learner, which is nothing but this class. And we are creating an array list. Then on the array list, we are adding multiple elements where each element is nothing but learner objects. And that object contains first one as the registration number, or you can call roll number, and the course they have enrolled, and from which city they are enrolling this course. So it is like a scenario where the setups to multiple students are enrolling for a course, and we are taking their roll number, the course they have enrolled, and the city from which they are enrolling. That's all. Same as that, just that we have put the things into more organized fashion. So here also we added one more registration roll number, and we have put the Java as the course, and they are from India. One more roll number, they are picking course Python for data science, and they are from Australia. Similarly, one more roll number, and they are picking data science using R from the UK. Like that, we are adding multiple things. So how many we have added? It is like 1, 2, 3, 4, 5, 6, 7. Okay. So now once we have added, we are just showing before even you sort it, what is the data will come. So data before sorting, if you see data before sorting, what is that it will be showing up? So each time you are saying array.getAFI, so it automatically fetches you what is there inside, which is whatever you have, whatever the way you have added, the same order it will come. So first Python US, then Java India, then Python for data science, then Python for ML US, then data science using R, then business analytics, then R from R language. This is what happens. Now you have to sort it, because that's the whole point, right? Like you need to sort by student roll number. Now here what we are doing is, here also we are using collection.sort, and we are saying passing array is nothing but this array list, and we are creating an instance to new sort by roll number. This is another class we have written, and this class is implementing your comparator. Comparator is your interface, and it is of this particular learner type. And when we say comparator, that has a compare to method, and here you are using compare actually. So where we are saying how to sort it. So we are saying here we will take two objects, learner A, learner B, and this will return the difference of roll number. So this is where you are teaching how to sort it. So we are saying whenever somebody calls this sort by roll number, it will trigger this compare, where it says that you have to take whatever the two objects learner A and learner B passed, you have to take the difference between two, and that difference will tell you how to sort it. So every time you will get a positive or negative integer from it. And that is what this collections will take as a key to sort it. Now after this part, the data is sorted. Now the same thing, whatever we are doing before sorting, the same thing we are also doing here. So here array.size indicates the length, like we discussed in the earlier first version of this program. So we are saying data after sorting. You can see that that's what the output shows, data after sorting. So we execute again the same thing, data after sorting. And after that, you see the registration numbers are sorted 61, 62, 63, 64, 65, 66, 67. Whereas earlier you see it is 66, 62, 63, 61, 64, 65. It's not sorted. So this sorting happened using this compare function, which we have written in it. And after sorting, you see the result like this. So that is how you can sort. So this program and this program both are one and the same. Just the only difference is here we have clubbed and written everything in one class. You can either do that, but when you want to maintain your program and make the program more extensible and easier to scale, that means when you're really working on development projects, the ideal way to do it is this, because this way you can organize your data more, and a lot of things which we learned like abstraction, inheritance, polymorphism automatically comes out when you properly modularize your program into classes like this. So one class for student record 2, where it will just do the job of processing it. Another class where you have learner information, where it will just create instance. Another class for sorting your data. So this way, if you have written, this is like a proper way to manage things. So would suggest to follow this approach, but output wise, both programs are giving same thing, just that I have passed one type of data in the second example, another type of data in the first example. That's the only difference. But other than that, everything is same. The way the sort occurs, everything is same. So you see, it is same, just the sorting part is same. Other than that, the way organized is different. That's all. Thank you. Let's start discussing some programs on stack, queue, and linked list. So this is my Eclipse launch bar. So once we started, so it loads all my Eclipse programs. Sorry, all the programs which I have written in Eclipse, like all the Java programs. Now, here if you see, these are all part of the package called test. In this, if you want to run, you can always trigger this run student record, whatever. So now we are going to start the stack program first. If I double click it, this will open up. Let me close the other programs. So this is my program, and let me execute it first. I'm using this button. There are different ways to executing. Either you can do execution from here as well. There is run as button here also. You can tell it how you want to run it, and it will run it. Okay, so this is how it runs. So I'll explain how it runs. So what this program does is, I'm clicking this is comfortable. So actual initial stack, this stack contains set of elements, like this is your initial stack. Let me zoom it so that it is more visible. So this is my initial stack, where it contains set of elements like first, second, third, fourth, fifth. And here it is asking me to check something. So I'm just entering third, and it says the given string third exists in the stack because it is there. And it also gets the top element from the stack. In this, the top element is fifth. Stack, as you know, it is like last in first out. That means whichever element is entered last, that will be the first one. If you see, I'll explain this anyway step by step, but if you see this is the last one I have entered. So based on that, this is the last element. So fifth is the last element. And you can pop, as you know, stack has push and pop operation, push for adding an element to the stack and pop for removing element from the stack. So when I pop two elements, it is like removing it. So I popped these two times I popped it. That's why it's case message pop 2 times. And what will be there? First, second, and third. That means third is your top element. After that, one more pop if you do, you are left with first, second, right? Because we popped this one. Now, if you do one more pop, because this is the top element in the stack, you will left with only this. If you pop one more thing, you will left with this. So I'll show you how it is done. So first of all, we have to import this java.util.stack, which is where all the stack operations will be there. And we have imported scanner also because we need to read input from the user. Then I have this stack demo class, which I have created. Then this public static void main method, where the entire program happens. Now this is the scanner object I am creating on system.in. System.in stands for your keyboard input. You can take any input, but here in this case, we are considering keyboard input, where we are reading the input from user. So the point at which we are reading is here, but before that we have created a scanner object on system input. Now after that, we are creating a variable called stack, which is of type stack, and we are saying in this stack I am going to enter string. That's why we are mentioning this. That means the elements will be of type string. That's what we are saying. And how to add elements, like you know, stack to add elements push is the operation. So the stack utility has function called or method called push, where it will add one element to the stack. So first I'm entering push first, then second, then third, then fourth, then fifth. And after you enter, you am printing initial stack. That means after I'll enter all the elements or insert all the elements, this is what your initial stack is, and that's what this initial stack shows up in the output. This console is nothing but your output window, by the way. Now, once it shows the output, I am asking user to enter a string to check. That is why you are getting this in the output.
Now after that, I'm taking input from user. This SC is nothing but the scanner object. Remember, we have created it here. The same scanner object I am using and asking them to read a value from it. So I'm just saying, get me a value. So here it is just a string. So for just string, you can use next. If it is a string spans across multiple words, I mean string contains a set of words in a line, then you have to use maybe next line. Here in this case, just a string. So I'm just entering the string. So this will be captured in user string. Now this user string I can search using one of the function in this particular stack package called search. So that is what I am doing here. If stack.search of user string, that means whatever user have entered, if that is equal, it will say that, okay, it is there. But if it is not equal, it will return -1. So based on that, I am saying when you are searching, am I getting -1? If I am getting -1, that means it does not exist. That's where I print given string exists in stack. When it is not equal to -1, it will produce any number other than -1 when the element exists in stack. If the element does not exist, it will return -1. So if the element does not exist when it returns -1, that time it will fall back to else, where it says that given element does not exist in the stack. If the element exists, it will return a value other than -1. So that's why I'm comparing if this search is not equal to -1. Here in our case, if you see the element exists, that's why it is not equal to -1, and we are getting output as given string third exists in the stack. Now coming to the other part. So here our interest is to get the top element from the stack. To get top element from the stack, either you can use pop or you can use peek. The difference between pop and peek is this is your peek function or method and this is your pop. The difference between pop and peek is peek will just show you what is the top element in the stack. That's it. It will not remove. Whereas pop will show and remove the element also. That's the difference. So when I say stack.peek, if you see when I say stack.peek getting top element from the stack, it just said 5th. But actual initial stack, if you print it, that is still there. So if you just print the stack, and if I run it again, I'm just running again this play button. Enter string to check. Let me enter 4th. If you see, the elements are still there after peeking the element also. That's what I'm saying difference. That peek will just show you what is the top element. It will not remove it. Okay. So here I entered, that is where it is there. Let me end one more time. That is about peek. Now let me show you when the element does not exist, how it behaves. Let me give 6. 6 is not there. Now when 6 is not there, you see given string 6 does not exist in the stack. So that means this condition become true because it might have written a -1 value. Now after this, what I am doing, so given that we are at this step where we have 5 elements, we just peeked to see what is the top element in the stack and it's at 5th. And after that, now what we are doing, we are just popping out elements. Popping is nothing but getting the top element in the stack and removing it. So first time it popped one time, second time it popped. So what is the top element? 5th is the top element. When it popped first time, when it popped this first time, 5th will be removed. Again, when it popped second time, 4th will be removed. So after popping, what are the elements remain? Stack after popping 2 elements. You can see that stack after popping 2 elements, what is that remained is 1st, 2nd and 3rd. So that is what the output is. Now, if you want to remove too many elements, you cannot do stack.pop like this multiple times, right? Like it is very difficult. If let's say you have 100 elements and you want to do the same. So rather than that, what I would recommend is write a loop, something like that is what I am showing, where it will remove the elements stack.pop, if you can see, indefinitely unless the stack is empty. So here is what we are doing. I'm saying while stack is not empty. So I'm saying stack.empty. This will return true when the stack is empty really. If not, it will return false. So I'm saying while stack is not empty, I have put a negation. That means the stack.empty will be true when the stack is empty. It is false when the stack is not empty. So I'm just negating it so that it's true. So this loop will keep running until the stack is empty. And each time what I'm doing, I'm removing one element. And at some point, definitely it will be empty, right? And I'm printing each time after popping one element what happens. So that is what it is showing here. For first time when you pop one element, 3rd is removed and you are left with this. Second time after removing one more element from here, you are left with this. And after removing this, you are left with this. And this is the point where it becomes empty stack, and that is where it gets terminated. This is how the program flow happens here for stack. And one more thing is, like, what if the stack element is there, stack.search, what it will return if you want to see. You can always print this particular stack.search to see the result. So let me show you. Just doing stack.search here so that you can see what will be the return value when the stack element exists and does not exist, because based on that we are writing a condition here, right? So let's say this, and let's give first time when the element is there. So when the element is there, what stack.search returns, you see that's what I'm printing here. This line, it actually returns the position at which it is there. So it says the third which you asked is in first, second and third position. It says it is in third position. That's what it's saying. But let's say when it is not there, I'm just running it again. Just putting something. So you see when the element is not there, it is written -1. That's the reason when the stack search is -1, we are declaring the element is not there. That's why we have put this condition. I hope it is clear now. I'm just commenting it out. So it is just for your information. Okay, I'm just putting a comment to see, uncomment the below line to see what stack.search value returns. Okay, this is on stack. So let's move on to other data structures we have, like queue. So queue, as you know, it is for first in, first out. So we are going to demonstrate the same, how to do that first in, first out using the collection we have. We have something called priority queue. That's what we are going to use here. Now let me execute this program first. I'm executed, and it says that the elements in queue are this, and head of the element is person 1 because this guy entered first, and head of the element, again it is printing. There are multiple ways to get the head. That's why I'm printing 2 times using different functions. You can see element and peak, which are responsible for that. Again, I'm printing elements in QR. This is after entering some more elements, and I'm doing some removal of elements here. And after that, I keep on printing using some iterators. So this is what the whole program is about. So let's start understanding how this output is coming corresponding to this program. So first I have written public class QDemo, so which is like a QDemo main program. In this, it has this public static void main. There's a priority queue object I have created, and we are saying it is a string object. That means each time I'm going to add string. And similar to stack, we have a function called add, which adds multiple values here. So we are adding person 1, person 2, person 3, person 4, person 5. We have added 5 members to this queue, and the first one who entered is person 1. So first one who entered should be the first one to come out. That is the basic principle of queue, right? That's what we are going to simulate. Now how to see what are the elements? So we are just saying elements in the queue are queue. So you can see that that's why we are getting this output statement where it says that elements in the queue are this. Then we want to get the head of it. In queue, what will be the head? This guy, right? To get the head of the queue, or to get the element who entered first into the queue, there are 2 functions. One is queue.element, another is queue.peak. Okay, both will return the first element only. That means person 1. Now what is the difference is, which I have put here. The difference is this function queue.peak will return null if the queue is empty, whereas this guy will not. That's the difference. Okay, but you have 2 ways to do the job. Now coming to what if you want to add one more element to this, then we have a function called offer. So we can say queue.offer of person 6, and it will add that person 6 also to the queue. Now after that, if you want to print, again you can just say elements on the queue are queue. So you can see that after when we are doing it, we have added one more, and you can see the person 6 is here. Now once we have done it, we want to remove an element. Now for removing, there is a function called poll. If you say queue.poll and queue.remove, first let's do queue.poll. So when you do queue.poll, the first element will be removed. What is the first element? Person 1, right? Elements after removing from queue, if you see, this one have removed person 2. That's why this elements after removing from the queue, if you see, the person 1 is not there. So it removed it. Whereas we have another function which also removes an element from the queue, which is called queue.remove.
And after that also we are printing this guy removed person 2. So first instance it removed person 1, second instance it removed person 2. So these are what left now. Now what is the difference? Both are going to remove the top element, remove the first element from the queue. What is the difference is this poll function actually returns null when the queue is empty, whereas this is not. That's the main difference, but both actually helps you to remove the element. Now let's say you want to print all the elements in the queue. Let's say the queue is so big. Now how do you do that? I mean, rather than just printing like this where you're just using the variable to print everything, let's say you want to get one element at a time like this. So for that you can use iterators. That's the reason I have imported iterator also here.
So here if you see, we are using the iterator for queue, and once we use iterator, it automatically creates an iterator object using which you can iterate through each element. So that ITR will have that iterator object. Now the advantage here is you don't need to say from where to start. You can just put in loop while itr.hasNext, and it automatically takes care of if there are any elements, and it will keep moving the elements one by one, keep getting elements one by one, and this will always be true until there is an element, and whenever there is no element it will show as false. And that's how you get each of the elements. So that's the advantage. And to want to get each element from the queue, you can just say itr.next and it will fetch one element at a time for you. So the overall thing is this iterator you can use on anything. We are using on queue. Here in this case, if you see person 3, first it will check whether there is any element, then it will pull person 4, it will print person 4, then it will check if there is any element, then it will pull person 5, it will print person 5, then person 6. So this is how it will print. Okay, so that's the iterator which we have imported by doing import java.util.iterator. Okay, so let's look at linked list demo.java. So this is on program to demonstrate linked list. Here we are using two packages. One is linked list, another is iterator. So first let's run. So you can see in linked list program we are printing all the elements from linked list 1, 2, 3, 4. Then we are printing each element from linked list. Then we are printing elements in reverse order in linked list. Then we are printing elements in linked list. Then we are doing, after removing first element, what is the element? Then we are printing elements in linked list, and after removing last element, what are the elements left? Then we are printing elements in linked list. Then again, after removing first occurrence of element in linked list, what is that? And finally again we are printing, and after removing last occurrence, what are the elements left? Then finally we are clearing the linked list. Let's understand how to do that here. Now first of all, starting with public class linked list demo, that is our main program, main class, and public static void main, which is where our main entire program starts. We have imported two packages, linked list and iterator. Linked list here, if you notice, we are taking string as the data type. That's why we are able to add string elements. Like that you can take integer, float, double, any basic data type you can take. You can see I'm adding only integers, all of that. Oh, I'm adding only strings. Add 1, 2, 3 for all our strings. That's why I have put linked list less than string, like that. If you want to add integer, you can just put linked list less than int. If it is double, you can put less than double. Then I'm printing elements in linked list. You can see that here. Those are the elements I have printed. Now, what I am doing is, if you see, all the elements which I have added, I have printed it. If you just print, all the elements will come in shortly. Rather than that, if you want one element at a time, like the below, 1, 2, 3, 4, what to do? So for that, what I have done is I have used this iterator. Using this iterator, I can get one element at a time from linked list. We have used the same thing in queue also. So you can see I have created iterator on the linked list once I get it. Now here is I'm printing each element from linked list. Then I'm checking while it.hasNext. That means until there are elements in the linked list, please pull one element at a time. So it will keep getting one element to me, and I can print each element by using this system.out.println, and that will print that it.next. Each element, this guy will get me each element from the linked list. You can see first I'm getting 1, then again it will check whether there is one more element, then 2, then 3, then 4, then 5, like that. Then you see the entire it.hasNext, if you see, that will yield always true unless there are elements in it. If there are no elements, it will give false. Okay, that's the whole just part of it. Now let's see the other part. Here I'm printing the elements in reverse order. Now earlier it is all like first left to right. Now it is right to left. Okay, so to print elements in reverse order, what I have to do? I have to use a descending iterator. What it will do is descending left to right. This is left to right. If you want right to left, then you have to use descending iterator, where it will get the elements from right to left for you. So what is the rightmost element? 4, right? From there it will start its journey. So first I am getting the descending iterator object. After getting descending iterator object, what I am doing? I am actually not getting from left to right. This time it is right to left. First I am printing each element from linked list in reverse order. Then first I am getting it.hasNext, same concept, just that it comes from the right side first. First it will pick 4, then each time it will pick one element at a time using it.next, and it will check whether there is any element. Yes, there are elements, so it keeps picking one element at a time like that. First 4 will come, then 4, like that. It will keep getting all the elements for me. Then let's see the other things. Now remove first element from linked list. Now here, if you see, what is the first element? Is it 1? Correct, right? So that ll.remove first, if you do, it will remove that first element. And after removing first element, I'm printing it. If you see, 1 is removed. That is main linked list. And after removing first element, you see the 1 is not there. It starts from 2, isn't it? Okay, so that's why I'm printing, so that we can observe the difference. Then let's start with removing last element. For that, there is a remove last. You can see when you say remove last, what is the last element? There are 3, 4, 4, 2 times. Now you see when you execute remove last, what happened after removing last element? You see only one time 4 is there. Okay, you can see the only one time 4 is there. There's no 2 4s at the end after 3. That's the difference. Now similarly, if you want to remove the first occurrence, if you see elements, the first occurrence, 4 we are removing. The first occurrence of it, not all the occurrences. Now let's see how many times when you print the elements in linked list, how many times they are there? 4 first time, then we have 4 second time, then we have third time. Now when you say first occurrence, this is the guy. This is second guy, third guy. Now when you say elements in first occurrence, that means the element between 3 and 5 will be removed. Now this remove first occurrence of 4 will remove the first element there. So if you see 2, 3, 4 is not there, 5 starts. That means it removed the first occurrence. Okay. You can see that here. First occurrence of 4 is removed. The other occurrences still remain, if you notice, observe closely. Now let's remove the last occurrence. Again, I'm printing the elements in linked list. This time, after printing elements in linked list, if you see here, how many times 4 is there? The last occurrence is 4, right? This time I'm picking 3 here. In this, when you print elements in linked list, 3, when I am remove, last occurrence I am saying, it's not the first occurrence. If it is first occurrence, 2, 5 should come. I'm not touching the first occurrence, last occurrence. So if you see 2, 3, first time, second time, third time, this guy is the one I will remove between 5 and 4. You see after removing, it is not there. So that's what it gets done, like when you want to remove the last one. Now we are doing ll.clear, which will remove all the elements from linked list. You can see it removes all the elements. Now after that, if you print elements, there are no elements because you cleared the entire linked list. Like that, if you see, you can have as many functions as you can write in linked list, and linked lists have a lot of advantages when actually you work in real programming, because you have multiple functions where using which you can perform a lot of operations. So some of them I want to show you. The functions are like, if you see ll dot, there are multiple functions, not just adding one element. You have something like add we have done here. Similarly, you have something called add int index, add all, add first, add last. It takes collection also, if you notice, right? There are a bunch of them which you can use in your code. So it's all about you how to use different functions so that to get a good hands-on on this subject on the linked list in Java. And not only this, there are other functions also available like contains. You have something like clear, clone, get, for each, hash code, get first, get last, and wait. A lot of functions. But what we discussed today is the commonly used functions in linked list, which are more often used in a day-to-day IT life. So keep practicing. I hope this helps.
let's look at some threading programs, some multi-threaded programs in Java. So this is my Eclipse launch bar. So if you click on it, it will start with the default workspace you have. So here is my test package where all the module programs I have put it here. Now we'll go to thread demo. Let me close all the programs. Here you go. So this is my run button. When I click on it, this particular multi-threaded program will start. So here I'm showing a simple demo on how to create multiple threads and run parallelly. So let's start with this. So here I'm creating 2 threads, then later few more threads. So if you see what we are doing, this is a main thread class. As you know, we can implement threading in Java using 2 ways. One is using the runnable interface, another is using the extending the thread class. So here we are implementing the runnable interface. When we are implementing, we need to implement or override certain functions, like run is one here. So that's what we are doing. So what we are doing here is we have created a thread class which implements the runnable interface. And this thread class has 2 variables. One is thread, which is of type thread class. Another is thread name, which indicates what is the name of the thread, which is of type string. And it has its own constructor where it just initializes the thread name with the name passed to it. So here is where it puts a message creating a thread, and you see this is where whenever an object is created, it will put a message like creating thread 1, creating thread 2 and all. Okay, now here is the run method which actually gets triggered when the particular thread start running. If you recall the thread lifecycle, once the thread is started, it will be put in a queue, and when it gets its chance to run, that's where it moves to the run state. And when it goes to the run state, that's where it says running thread and all. So when this particular part is executing, you can assume that the thread is actually in execution. Now, before we talk about run, let me show you how we are doing. This is our main class. This is the class where actually we have defined certain methods, like one is run, another is start method here. Now before that, like what we are doing is we have created a thread demo class where inside we have a public static void main method. In that we have created 2 threads. One is thread t1 equal to new thread class. We are saying thread 1. We can say thread 1 program. We can write anything, doesn't matter. And this is the thread 2. So we have created 2 threads. And after creating thread, we are creating using thread class, and thread class is nothing but this instance, this particular class which we have created an object. And when it calls constructor, it just assigns to the name. And after that we trigger t1.start, which is a method of that thread class. So when you run it using this run button, it says thread 1 program, thread 2 program, thread 1 program, thread 2 program. Or let's say thread 1 instance, that is the right term because your entire file is a program. So rather than saying thread 1 program, you can say thread 1 instance and thread 2 instance. Okay, now after it, you have to start the thread. Here, only when you start the thread will be invoked. When you start the thread, this is an object created on the thread class. When you start it, this is where it says starting thread with thread name. And this is the message which is coming. First one, the starting thread with thread name as soon as you create thread 1 instance, because this name is already set while you created the constructor here. So that's what the message coming. If the thread is null, let's say thread is not created due to some reason, it will be assigned to null. Then in that case, internally we are creating a thread with whatever name we have been assigned, then we are starting it. But if thread is already created, this one will be passed out. Bypassed, because thread will not be null because we are passing something. Now, assume that once it is in start date, it doesn't mean thread is started. It is like you can assume it is in a queue waiting to be executed or waiting to be going to that run state. So it is still in that place, and it is the programming language, this threading engine of your Java will decide when to start it. Now, once we have created first thread, when we say thread 1 instance, it will say creating thread with thread 1 instance, which is the message coming from the constructor. Then after that, when you say t1.start, that is where it says starting thread with thread name, which is this. Once it is coming, the same thing happens with thread 2, where you create the class, it will say creating thread with name, thread 2 instance. And when it starts, it also says starting thread with thread name, thread 2 instance. Now once this part is done, when it goes to run state, it says running thread. Here it is mentioning which thread it is running. So once you start it, automatically your threading engine or threading module in your Java will decide when to run it. As and when it runs it, we are printing the thread name, so we know that which thread is running now. So in this, we are saying this dot thread, which is nothing but thread 1 instance. And what we are doing is, for after starting each thread, like this is for thread 1 instance, what we are doing is inside that we are actually putting a loop where we are running thread name, this dot thread name, and we are just assigning some names to the thread, like 1, 2, 3, 4, 5 and all. That means you have to assume like you are running multiple steps inside each thread. So you can assume like multiple steps, and we are letting this thread to sleep for 50 seconds. The reason 50 milliseconds, the reason for doing it is the threading module will give the processor to some other thread only when a particular thread is going into a sleep state or wait state. When I say wait state, it is like when it is looking for some IO. When it is in sleep state, like what we are doing is like explicitly we are putting into sleep state. That's time. It doesn't need the processor's time, so it can go into a waiting queue or holding queue, where it can get its turn when the processor is free again. So that's why we have explicitly put it. So generally in production, what happens is when a particular thread is going for an IO, that particular instance processor is free and it can be given to other guy. So what we are doing is first we started running thread. Similarly, this run will be run parallelly for other threads. So thread 1, when it started, it picked up this 5 value. We are printing in a decrementing value if you'll observe. So first thread 1 instance 5 is started. Okay, this is a parallel processing kind of stuff. And as soon as the same, by the time thread 1 instance gets the 5 value, there is another thread also started, which is thread 2 instance. And this thread 2 instance, it got the 5 value from here. And after getting it, then it got the 4 value. Because if you remember, the first thread we have put in sleep state after doing the 50 milliseconds, we have asked it to be in idle state. So that guy is still there. That's why thread 1 is not coming. Thread 2 instance is 4, and after that it woke up. That's where it says thread 1 instance and it started running. Again, after thread 1 is done, again it is like again thread 1 instance is 3 now. Now it is like it went to a sleep state. So every instance it went to a sleep state and coming back. So this time it went to a sleep state. So if you see each time now thread 2 instance, thread 2, and again at this point for this 50 millisecond, these thread 1 and thread 1 instance 1 and 2 is running, and thread 2 went to a sleep state. Now it came back and again thread 2 instance started. So it is like we are intentionally putting the thread in sleep. So by that time the processor time is given to other thread. That's why you see these things are not coming in parallel. It is like it is like each time one thread goes into a sleep state, other thread comes out and it takes its turn. Then finally we have, once this is done, if there is any error, this is the cache block where we are handling that error. But since there is no error, it went fine. And if everything thread gets executed and completed its execution, it will say thread with thread name exited. And you can see first time thread 2 exited and thread 1. But actually if you see, we started thread 1 first. So in parallel processing, what happens is there is no guarantee once you start executing which one will take into priority. It all depends on on the way. It all depends on it's on the mercy of the threading engine where it takes it. So you have to use parallel processing only when instances when you see that independently the task can run. It is not like one task depend on another. Then you have to not do directly parallel processing. Maybe you should apply some kind of locking mechanisms so that it has to come in a sequence, or some other methods where you have to use so that it happens in a sequence. But threading is mainly for parallel processing. Okay, thank you. So let's summarize what we discussed in this module. So we discussed about what is a thread, why it is important. And as we know, thread is mostly for executing parallelly or parallel execution. And we also discussed about why we need thread synchronization, the cases where multiple threads actually try to access the same resource. That's where you need to worry about it. We also discussed about what are the different types of streams we have, like input output streams, which generally you will use in your code. We also discussed about byte stream, the low level and high level, which is generally required when you transfer the data over network. Then we had a discussion about the thread lifecycle. That means starting from the thread when it's created to the time it gets terminated, what and all stages it go through. Then we discussed about wrapper classes, which is nothing but a wrapper on your primitive data types. That means if you have an integer, you have a corresponding wrapper object, wrapper class for it. Similarly, we have also discussed about JUnit, which is generally used to write unit test cases for the code you write, which generally is a responsibility of the developer. Then we discussed about serialization, which is an important aspect where you need to understand when you want to transfer the data on network. When you transfer the data, it actually transfers the data into bytes over network, and again bytes to it converts back, which is called deserialization. That's what we understood in this topic. So that's what we have done in this particular chapter. I hope you find this useful. Thank you.
Hello everybody, this is Krishna here. Today we are going to learn about debugging concepts in Java. In this module, we are going to understand these are the topics we are going deeper, and starting with, we'll discuss about what is debugging, why it is important. Then we will move on to tracing and log analysis, and we will discuss about how to set different log levels and perform log analysis. We also discuss about stack trace, then implementing logging using log4j. We also discuss about what are the best practices of using log4j in Java. Then we discuss about how much Eclipse IDE, which is one of the favorite IDE of the developers, supports this debugging. In debugging further, we will see about how to debug the expressions, how to debug the variables, how to debug, by setting breakpoints. So all that we are going to look at. So first of all, before even we start with debugging on this particular module, let's understand what exactly is debugging. So when somebody asks you what is debugging, so what is the first thought it gets in your mind? So debugging, actually, to put out, it is nothing but a process of identifying bugs and fixing it. So it is as simple as saying debugging is debugging, which means detecting bugs. So detecting bugs for what? For fixing it. So that when you're writing, you might find a lot of errors in it. So how do you detect it? How do you ensure it is getting fixed is all covers under part of debugging. So debugging is nothing but a more of a process which helps you in identifying, detecting bugs for you. So it's a term which has coined from earlier. There is a term which has coined saying bug. From there it coined, and DE stands for detecting. And since it is detecting bugs, that's why they named debugging. Or sometimes people put it as shortcut as debugging. Sometimes people also name it as a short form version saying debug. Okay, now let's move on. So why it is important? If you look at as a debugging, right? Like every programmer should have that skill internally, or should actually learn the skill of debugging. It is very important as a programmer because when you actually, it is not just that writing code is your primary task in any industry. It is also very, very important that as a developer, you should learn how to detect bugs in your code. And there are different techniques in identifying it. Maybe you can use log, or you might use some kind of print statements in your code to indicate where exactly the problem is happening. One of the best technique without using any IDEs people prefer is put a lot of print statements in your code whenever you think you're not able to figure out a problem. Wherever you think you're not able to figure out the problem, just put a respective print statements so that you understand what is the value it is coming, and how actually you can fix it. All that you get thoughts of it when you put relevant print statement in your code. And there could be other things also, like this is one part, and other than that, you have these different plugins available for debugging. Not only that, Eclipse also comes with some of the debugging plugins. All that is also possible. So what we are discussing about is, as a programmer, what you can do by yourself. And like I said, IDE, Eclipse IDE, not only Eclipse, like other IDEs like IntelliJ also provides better debugger tools for you. More than that, I would suggest as a programmer, you should have that skill by yourself, so that it's not only that every time you start and jump writing the code, it is also very important that you should possess the skill of automatically understanding how your code behaves, and if there is a problem, how to do by yourself. That is very, very important. So that even if you work on any operating system or any environment where you don't have debugger, you can perform things by yourself without anybody else. That is very, very important. Now, if you see, this is the default Java console. It is used for debugging. So if you see what this particular Java console is, this is, I would say, a bare minimum debugging provided by Java team itself. That means your core Java. So what does it shows is, this is actually shows the Java console for debugging applets and your Java web start application. And if you see, observe clearly, here C stands for clearing the console window, F stands for triggering finalization on your objects in the finalization queue and then displays memory information. It also refers memory related to the current heap used by the GRE. Also, it displays the free memory that is free in your heap and the percentage of it compared to the total size. And G, when you say, it triggers the garbage collection and displays memory information. And H, it displays help if at all you need any help. And I option, this I option, it shows the dump associated class loaded. So which means, what does it mean by dump associated? So actually what I does is, it actually displays a list of all your cached class loader objects in your Java plugin. That means whatever classes are cached to avoid the load time, because whenever it loads in the class loader, every time instead of loading it, it actually caches it. So that particular cache is what this guy shows. And coming to M, displays the heap memory information for you. And O, it stands for displaying the logging information, whichever it is directed, whichever output it's direct from your Java console to the log file. That's what it shows up here. There is an option called P, which actually gives you the reload your proxy configuration, and Q option to just hide your Java console from the screen, and R option to reload your policy configuration, whatever you have done, and S to print your system properties. Mainly it is used for your debugging and all. And then comes T, which actually prints all your thread groups and all that information, existing thread groups and all. X option will destroys all your class loader objects in the cache. And 0 to 5, these are actually called the trace log level options. So what do you mean by trace? These trace levels actually we will look at in the next slides, where you have something from 0 to 5 based on certain deployment trace level properties. You can enable it so that it performs the respective job. We will look at deeper in the next slides. Now coming to tracing and log analysis. So what exactly is tracing? So tracing is basically, a process where you redirect any output in your Java console to a trace file. When I say trace file is nothing more about a file which contains all the traced information. That means, let's say you want to track how your code is doing. Then what you can do is you can write all your output, which is actually on Java console. When I say Java console, your system.out, whatever it is going there on the screen, you are going to send it to a file so that you can trace later to see what is happening. And similar to tracing, one way of doing it is to trace what your code is doing is to write to a file, which you can call it as a trace file. Or using Java logging APIs, you can even write to a log file also. Both are the ways possible. So that's what being discussed. Either you can write to a trace file or you can direct to a log file using Java logging API. And how we do it, there are different log frameworks we have, like SLV4j or log4j and all. We'll discuss about it one by one. Now, what does tracing help? Actually, if you want to trace a particular code, you can trace it for your Java plugin or Java web start by just turning on and setting on the property called deployment.trace.property. That is the attribute, or I would say that is the property. Deployment.trace is what you need to set it to true so that it starts tracing it. Once the property is turned on inside your Java plugin or Java web start, it helps you to give more granular information of what is happening in your code. And in this particular deployment.trace.level property, you can set it to all also, which simply, when you set all, it simply means all complete information of it you need. Like there are different trace levels actually. If you look in next slides,
These are all different trace levels possible. When you said all, it means everything. All you want to get it. That's what you are trying to say. Now we will look at each one of them. So either you can set it to all, or either you can set it to one of the levels mentioned here. Or let's say if you set it all this will be available, or you can set it to any one of them. So let's understand the meaning of each of it. If the basic is like a basic tracing levels is what you get. Let's say for example, so this 0 to 5, this 0 to 5 when you set, based on that you get the trace levels which is mentioned here. So all this are put under a combination of this 0 to 5. So I'll explain when you set it 0 what will happen, when you set it 5 what will happen, when you set it 1 what will happen. Let's say when you set it 0, it means off. That means the trace level is off. When you set it 1, you get the basic trace level features. That's what it means. When you set the trace level as 2, it means you get the network tracing, caching, and the basic thing. And when you set it 3, you will get network, basic, and security. And when you set it to 4, you get network, security, basic, and you get something called extension. EXT stands for extension. And when you set it to 5, it is as simple as setting everything, where you get the live connect, you get the extension, you get the security, network, TEM, basic. It's like DRS. DRS stands for deployment rule set. So all that you get. So it is like 5 is as simple as setting all, 0 is setting it off. And like I said, each level will give you different levels of it. So instead of setting by these names, you actually set it using this 0 to 5 levels. So if you set it to 5, you will get all. If you set it to 1, you will get basic, 2 for network cache and basic, and level 3 for security network basic, and 4 for extension security network and basic, whereas 5 for everything. So that is how you can use this attribute, where in this particular property deployment.trace.level, you will set the values from 0 to 5. You will get the these functionalities associated automatically. And now comes the question of, first of all, why we have to do this log capture. When I say log capture, like I said, one technique could be when you want to trace your code, you can write to a file, whatever it goes to your Java console, you can write to a file, and that file you can call it as a trace file where you can look at later and understand. That is one technique. Another technique could be where instead of writing to a trace file using Java logging API, you can write to a log file and then analyze it later. Now, before even that, let's understand why do we need to really bother about logs? Why it is so important? Is it like, is it that mandatory that we should be doing logging and all? So if we really look at, logging plays a very crucial uh, role in industry. The reason is, now let's take for example Amazon. How do you think Amazon, Flipkart, Google, Facebook, YouTube, every other guy, if you see, they have huge amount of information about logs, where it will contain about how their system is doing. Okay, why I'm saying what their system is doing is, so that they understand why particular what actually caused an issue. Let's say when Google search is happening and suddenly it is down. From logs, they can detect when you are searching Google what exactly happened, what actually caused the system to down. Or when you are searching, let's say instead of giving the right results, it has given some junk values. They even have that information. And let's say when you are searching in the Google search, if it is taking more than some SLA time, let's say their SLA time is something around 2 seconds and it is taking 1 minute, all that information will be logged. And the advantage with logging all this information about their system on how it is doing is, later they can actually put lot of monitors on the logs so that they can assess how their system is performing. That is the main importance of log. Secondly, when they have any problems in their code, they can always look at your log to understand what exactly is happening. From there, it is like a backward tracking. From your log, you figure out what is happening in the code. From there, you go back to your application to understand where exactly it is causing problem and fix the problem. That is how it is. And any 24/7 system, the logging is like must. Okay, this is what we have been discussing. Like every other information you log, it is very important. And certain times, based on how much severe you want, you actually log the information. Certain times it might be just at a high level you log because you don't need to debug to a granular level. But certain times what happens is, when you're not able to reproduce an issue, a live issue, you need to turn logs in a debug mode. When I say debug mode, every smaller information of your system will be logged. Ideally, this debugger mode, people will not turn it on in the live system, because turning on debug mode in live actually produces a lot of logs, and because of that your system might fill up your disk space with a lot of these files, and the servers might not be able to work properly. So debugging very carefully people have to do, and generally in production people will not do, but there have been cases where they have done by mistake, but generally they will turn on in testing so that they reproduce the issue and see what caused the problem. So like I said, it is very, very important to log the information and capture it so that we can use it for analysis later for any code issues. We can use it to detect bugs in your code. We can use it to course correct your code. We can use it to optimize your code, improve the performance of the code. You can use it to understand every aspect of your code. Not only that, you can put a lot of monitoring on your code also. And what is log levels and log analysis? So let's talk about log levels. So log level is nothing but at Java level, it is nothing but a class. There is a class called level class. But actually what log level is, log level consists of some set of levels. Like you might have starting from info, warning, critical, severe, like that, different levels. And each level indicates certain level of information. Let's say if you say info, which means it's an information message. That particular statement you are logging from an application is an information message. Let's say if you logged an information as error, it means that particular information is logged as an error. Let's say if you logged an information as warning, you're saying that particular information is a warning message. Or let's say you logged an information as error, you are indicating that particular information is an error, which you need to look at. So like that, each level you can put it saying, this is what I mean by this statement. When my application is logging this, it means this. Now, the advantage is when you put multiple error statements in your application from application, when you're logging at, let's say, a log level error, multiple lines, you can put thresholds on top of it saying if there are consecutively 3-4 errors happening in my log, raise a ticket or cut a page or send a page to my mail ID so that I can look at and understand what is happening. This all actually, if you look at the foundation of all this, is your logging information. And there are teams like, I mean, apart from the development team, there are this support team, operations team, and all rely on these logs very, very much. So this is like a very, very important piece in order to do anything above. Now, like I said, like all the logging details, you can log at different levels, like starting from, they have basically 7 basic log levels and 2 special ones. And you have different log levels, and it all depends on how granular you want to debug your system. Whether you want to debug at a high level, whether you want to debug at a very closer level or very granular level, that's how the log level differ. And these are the ones we have. So starting with severe is like, pretty critical. When you get a severe, that means something is wrong. So it is like system is not running. So when you look at the severe, it means like things are not working as expected and system cannot function beyond that. And all of these log levels, severe, warning, info, and all, they have certain value, a hard-coded value in Java. It's already defined. So let's understand each one of them, big starting from, in this, if you see, severe has the highest level and finest is the lowest level. So let's start with, there is a one more level called off. That level is used to turn the logging off. And there is one more level called all. That means it can turn on to enable loggings of all these messages, all of these types. So off means turn off the logging. There is one more comes, off means turn on the logging. And there is something called all, which means get all the, I mean, you will get the functionality of all these logging levels. So that's what it mean by two special ones. One is off, another is all. And the 7 which are mentioned are these. Now, if you want to understand each one of that, let's start with understanding. Apart from this logging, if you want additional logging levels, there are third party also available. So let's understand with config first. Config is basically used to message anything related to configuration messages. Like let's say you want to put some configuration messages which is coming from your application, you can always log it as config. That is what the purpose of it. And they are intended actually to provide certain configuration information. Actually, how it helps, if you look at is later, if you want to understand if there is any problem with your configuration, you can look at that. Like things could be like, what is the CPU type you have configured, what is the graphics, or what is the GUI,
or let's say in your database, what is the property set, like username, not username password, but what is the, I mean, database settings you have done, or what is the web server connection settings, all that you can log at the config level. Now coming to fine. So fine, you will log to provide tracing information again, but it is like all of these fine, finer, and finest, all these three are mainly for detailed tracing. When I say detailed tracing, you want to understand code at a very, very granular level. And these and all will differ based on how you use the system. For example, if you use finest, it is like very, very detailed. That's why you see the priority, it is very detailed. It's like a debugging kind of thing. And if let's say if you use finer, it is like comparatively less detailed than this. And when you say fine, it is like, okay, most important messages are better ones, but comparatively lesser than this. So it is like, if you see, it is like this. This is more granular. This is less granular than this. And this is even less granular than this, like that. So find message, actually you will log for things which are like minor errors, something errors which are recoverable. When I say errors which are recoverable, that means something like on retry, that particular request could be processed. But there are some requests which might not have processed. That kind of things you will log at CVR, by the way. When you say finer, it is like I said, it is a detailed tracing information, and anything like all the logs. When you say detailed tracing message, like for example, any exception or you want to log, you can do it this particular thing. And like I said, finest is even high detail. It's more like a debugging stuff. Now coming to info like the name says, all information messages is what you log at info. And you, if you want, you can write to console, but the main idea of logging is to capture in a log file. So all that you will capture in a log file with this statement called info. And this will actually you will use to ensure how the system is doing, but not every other information will be available in info. It is just an info message on how the system is doing, that's all. But if at all you want to set alarms and all, info might not be relevant all the time. Mostly we will look at the severe warning or these finest messages sometimes, not the info ones. And severe, which is the most important and most dangerous, it is message which indicates when you log at this particular severe, it indicates it's a serious failure, something which cannot be, you know, recovered. That means a message which cannot be recovered. Something like your database is down. Let's say you're writing a code and database is down. Unless somebody go and manually do it, you cannot do anything. These kind of messages at severe are logged at severe, and even one severe error is considered as like a big problem. So that's why it is needs immediate attention of the user. Whereas when you say warning, it is like, okay, now it is okay. It's a problem, but for now it is okay. The system can run with it, but it has to be fixed. That kind of issue. If you want to log, then you can put in warning. Now coming to log levels and analysis. So what does it mean by, different log levels we have? So severe is more about the severe information which cannot be recovered. That is what it is being discussed here. When something dreadful has occurred, an application cannot further. So it simply means that something unrecoverable, like database down, your web service is down, and let's say you're trying to talk to another service and that service is down. These kind of messages are logged at severe. And this warning, that means, let's say you are giving me wrong credentials, that is okay. But if user is continuously giving wrong credentials repeatedly, that means it could be hacking your system. So that kind of information, that's why we said this is the information used by administrator and advanced users to analyze if there is any hacking in your happening in your on your system or not. But this is generally okay, that if your system is able to cope up, that's okay. Unless it reaches to a certain threshold, you don't need to page people, so that they will not so that it's not necessary that they have to come and fix it, unless it is acceptable threshold, under some acceptable threshold. Like we discussed, highest rank indicate the more severity. Compared to the severity is the highest rank, and that is the most dangerous one. We discussed about fine, finer, finest, and in that the finest is the most granular one, and fine little less granular than that, and finer gives you detailed tracing. Any configuration thing, that is what talks about this particular thing, which you can log it config. Now coming to logger class. So like if you remember, one, we have put different trace levels 0 to 5. We discussed what are those trace levels. Apart from that, what we discussed is we can even put different log levels, like starting from severe, info, and all. For all this to achieve, like we have one more thing called logger class, and logger class is basically, you know uh,
help us to log our information. So we are saying we will log like this and all, but based on how we will do it. So the way to do it is using this logger class. You will create an instance of it. From there you can start logging. Now how do you log it? So basically this logger class is actually used to log messages related to a particular system or component. And whenever you want to log, what actually you do is you call one of the factory method called getLogger. GetLogger is the method where you call to get the logger object. Once you get the logger object, from there you can mention the log levels which we discussed, info, warning, anything like that. And if you want to access the global logger name is global underscore logger underscore name. And this is very important package for any system who want to log their activity in a particular log file. So that's why the logger is very important in 24/7 systems which run continuously without any fail. Now coming to stack trace. So when we call certain thing as stack trace, so stack trace is nothing but location of the exceptions. If I want to put it in one line, so it is like, let's say your code is running and it breaks. Now what you need in order to when it breaks, you actually need to understand from which point, actually what point broke the code. That means at what point of the code it broke and what actually triggered that. That is called stack. So stack is from the point the code is failed to the point it got called from different methods. All that if you go back, that is how you trace back and understand. That's what called stack trace. And that means from the point it broke to the point what calls have actually called it, triggered it. So if you look at, so we can say stack trace is nothing but just the location of the exceptions. We can say that it actually helps us to track when the exception raised at a point, it is actually caused by what and all sequence of methods which trigger this, you can easily identify. And Java stack trace, if you see, it is nothing but simply an array of stack frames. You can call it as stack backtrace also, both are same. And this helps you to, these stack frames actually represent the movement of an application during execution of the program. It traces the locations where your exception is raised. And believe me, without stack trace, when you get an error, just simply say this caused it, you will not be able to debug. But when you have this stack trace, it is very useful to collect all the information related to your code and understand where exactly the code have actually broken. So like I said, it actually gets information for all the methods which invoked it, the complete chain of it. And this is the job of one of the job of JVM, which produces this stack trace. And these are all comes as part of, our stack trace element. Stack trace element is one of the classes of JVM. From there, these are all comes. These are all comes from your throwable.get stack trace. And if you want to print stack trace from your code, there is a function called print stack trace to print the stack trace on your stdout. And each element represents stack frame. So when I say each element, so for example, let's say there is an error happened here. So when an error happened, so it will start showing you saying, okay, this point line 12, it caused it by method something like method 1. Okay, then it will say it has actually triggered by from line 15, method 2 have called it. That means it's saying method 1 call at line number 12, it failed it. Now it is called by 15, which 15th line number M2. That means M2 called, which is at line number 15 in the code. Then it says, I'm just putting random numbers, don't take it sequentially. Then it takes 17 M3. So it simply tells me that there is an exception which is actually happened at 12th line in the code from M1 method. And that M1 method is called from M2, which is at line number 15. And that particular M2 is called by another method called M3, which is at line number 17. Don't take this in sequence, it might not be correct. Just understand the flow helps you so that you can backtrack from the point the exception occurred. So you can backtrack and see what exactly caused it. This is your stack trace. And here when we are talking about each element represents a stack frame, these are your stack frames. That's what it means. And all stack frames except one at the top represent a method stack invocation. Except the one at the top means the first one is the one which that means the method which gets invoked, and the chain of it actually represent the stack frame. Now we discussed about it. Frame at top of the stack represent the execution point. And if you want to print it, like I said, you can put it. And this is what we discussed. Each stack frame, so what it represents the method name, and these are the line numbers. That is what it shows up, so that you know at what point your code has broken easily. And remember that whenever you do stack tracing, not only stack tracing, whatever logging, you should have sufficient information to debug. If your log does not have sufficient information to debug, it simply means that you haven't written a robust program. So when I say robust program, a program which is tolerable to failures, a program which is stable enough. When this can happen is when you have proper exception handling made in the code and also proper logging made in the code. Only then it is possible, and that is all achievable through exception handling and logging. And why you have to do logging? When we are saying logging using log4j and all, what is important? One, if you see, logging helps you to do quick debugging. That means when you're writing all this log information to a file, it actually helps you to diagnose your problem much faster. Let's say if you don't know anything about what system, which state the system was in when there is a problem, right? So it is very important that when you log it, it actually helps you quick debugging so that you can quickly root cause the problem happened in your application and fix it. Another is problem diagnosis will be very faster. It is as simple as saying quick debugging. Another is easy maintenance. That means when you're logging it, you can easily maintain code for a longer time. Even if you want to extend it, it is easily possible because you have all the logging done. That means whenever you want to add a new feature also, you can easily see whether that is breaking the code or that is improving. Everything you can see from log. And another part, it helps you in your cost and time saving because not every time you have to spend a lot of time to understand what actually happened in the code when you don't have a logging. Since you have logging, it helps you to quickly do it. That means less human effort, and also it saves your time because you have every other information of your system running in your log. Now, logging in Java, you can use either by multiple, multiple frameworks are there. One is SLV4J, and another is log4j. Log4j is one given by Apache. So these are the popular ones. Now in this particular session, we are going to discuss about log4j. Now the question comes when we have SLV4j, you might have a question, why not SLV4j? Why log4j? There are certain reasons to it. First of all, log4j is open source. That means it is free. And if you find any bugs in that particular log4j framework, you can always raise it. And with log4j, you have multiple appenders comes in that actually helps you to easily log code related to that particular thing. That means if you're relating to automation in a file or database, you have the relevant appenders. And Log4j you can use for both for small and big projects also. Whereas there are some particular frameworks which actually might work better for large projects, but not for simple projects. Another thing is Log4j is thread safe. That means even if multiple threads try to access it, it is not possible. They have this lock and monitor concept there so that only one at a time. And it is faster compared to other frameworks. It's a named log hierarchy, like you see, CVR info like that, and it supports internationalization. So we see what internationalization is in one of our modules earlier, and it supports multiple outputs of appenders per logger. So for each logger, if you want multiple appenders, so one appender for let's say pattern layout, another appender maybe like random checker. So all that multiple appenders you can easily integrate. That's one advantage with it. So because of all this, people prefer Log4j. And Log4j is not only for Java. You can use in other programming languages like Python, Perl. There also you can use. That can be ported to any other programming language. Here we are using for Java. And it is pretty easy. Irrespective of any application, you can use it. That's the best part of it. So it is like language independent. And whether you want to log it for database, you want to do it on system console, or you want to do it on a system log or files on disk or a log management server, all that you have relevant appenders available in log4j and you can easily do it. So that's what it means by irrespective of where you are writing or where you want it or for which purpose you want it, you have the relevant appender already available. Now let's understand the best practices. Like we are discussing about log4j and all, but let's understand the best practices of log4j. I mean, when your Java is using log4j, what are the best practices is using it? So one best practices, we have a lot of it, so we'll start with each one of them. So first one is you always have to use the static modifier for your logger object. So you're seeing this logger, this should be a static. I'll tell you why. Whenever you declare any variable in your code, there is always an overhead. Okay, the reason is,
they actually consume a lot of CPU cycles and all. So rather than, because every time you create an instance, if you are making this variable as part of your constructor, each time it has to create an instance, right? Rather than that, when you actually put it as static, so multiple objects also can share the same variable when it is static. So that way it saves your CPU cycle. That's why it is recommended to have one logger object for your class. So that way it is the common one seen across, and it is easy to maintain also. Now coming to how to enable log4j internal debugging. This is another best practice. So the thing is, like, assume a scenario where you facing a problem with a specific debugger or you're having issues with it. Now the advantage with this particular log4j is, if you want, you can use this particular log4j debugging property, which is this. By enabling this, you can even see what is the problem happening in your logging, and you can debug and fix it. That is another advantage you have. Now, another best practice is never send your logs to database table with the JDBC appender. So what does it mean is, like for example, you can always directly persist your log details into database by creating a table and setting JDBC configuration into log4j. Okay, so you have an appender called JDBC appender. So this is the appender. This is the JDBC appender for doing anything on related to database. You can set it in the log4j properties like what we have shown here. And whenever you persist logs into database and try to search, actually, it becomes very difficult if you don't use this JDBC appender and all. And so that's why the one suggestion is, like, instead of sending logs to log management service or write them to a file, it is better that you send instead of directly writing to some other file. It's better to write to a log management service or in a file where you can provide full indexing and more functionality with logs. And the way to do it is by properties. You can see that you can set in database using this JDBC appender, and you can set the JDBC driver, all that. So you have a log4j property where you can set all this information. This is a sample table which we are just showing, but the idea here is to show that you can use a JDBC appender for this, and better to send to a log management service or to a file where it provides it, rather than directly writing to a database, because that will not help you to search faster. Now, never send mails on every exception. This is another problem I see. The problem is, like, for every exception, if you keep sending, like let's say your code is running and there's an application and you configured your code so that it sends an email or page, that's not a good idea. The reason is, what would happen is, let's say you're testing, then also you will mess up sending a lot of emails. Let's say your system is behaving wrongly or some errors you can handle, all that you actually causes a lot of problems. So the idea here is, rather than doing it, instead of sending a lot of emails for all these exceptions, the better way is, maybe you can log some exceptions in your log, let's say error or something. And whenever the error reaches a certain threshold, like for example, let's say your email server won't respond to the first instance when you send an email, it might give you an error. But on second retry, if it gets successful, you don't need to send an email, you don't need to page everybody, or you don't need to cut a ticket to somebody just for first error. Maybe you have to try it one more time, because that is how your server is at times. I'm saying not every time, at temporary times. So that time what you can do is, maybe you retry, and after that, if there are consecutively 5 or 6 errors continuously happening because your server is not responding, that's where you can say, oh, there is a problem with my mail server and it is not happening, so let's trigger a page or let's trigger a ticket that time. So what you're doing is, rather than bursting with lot of email or pages or tickets to your developers, you can only send when it is really required, rather than doing for everything. That's the whole idea of saying, don't send emails on every exception. So if you want to configure, the same thing has been here. If you want to configure, you can use this SMTP appender, and you can say error on mail, and you can see on the mail you are mentioning your SMTP host, all that. And in your code, you can always mention how it has to throw error at what point and all that. Now, how to send alerts for exceptions. Now, this is another thing. Now, here the idea is, like, you can always use this error tracking. Like, let's say for example, there is this anti-event log appender is there. So using which you can do the error tracking when you're, tracking a product, if you are trying to send alerts and all. So sometimes what really happens is, there could be, uh, you know, some kind of false errors, or there could be some deduping errors. So when I say deduping errors, it's like the same error might be coming 2 or 3 times, or the same error might be coming 4 or 5 times. So in those cases, the idea is, rather than doing this in order to avoid this duplication of errors, this generally happens as message queues and all. So in that cases, what is better is you can use this anti-event log appender, where you can say only when the right error comes, and you just avoid the deduplication errors. So those kind of deduplication errors are taken care, so that only you get alerted when it is like the right error, not the repeated errors which happen because of one error get triggered. Now, another thing is send your logs to log management system to VOT across server. The idea here is simple. If you assume that you have 10 servers, and in each server you have your application running. Now, if you write log files in each server itself, now what would happen whenever I want to analyze, I have to go into each individual server and look in and understand what is happening, right? So rather than that, the idea is better you write to a log management system or a server which is particularly for log. Okay, separate server for log, where all the servers ask them to write to that. So that what would happen is when you want to later analyze, it is easier. You can go to that one system where all these servers logging the information, and you can just go and search for that information and see what is happening, rather than going into each individual server and seeing what is happening. This is very advantageous, because if you want to put monitoring and all, you don't need to rely on each individual server. And it is very modular also, because tomorrow if there is a one more server coming in, all you can say is, okay, you start logging into this particular log management server. And this log management server could be separate server you have set up, or this could be an S3, this could be anything like a database like Athena or whatever, which you can use. And the advantage is when you use this S3 and all, or any other thing, you can set up some Elasticsearch cluster that actually helps you to query faster. Why we are talking about Elasticsearch cluster is you have set up the this management log management server. It will not have logs very few, right? Like since it is coming from multiple servers, all these logs, it will be very huge. Now, how you ensure that all the logs you can query faster? That's why we are talking about Elasticsearch, where it can quickly search for you and get the data. Like you can use other things like Splunk and also there to quickly look at it. Now, another thing. Now, let's say, for example, in general, what would happen is you want to suppress certain information in your logs. Well, how to do it? So for that, we have something called filters. So if you see, there is a filter here. If you want to suppress certain logging statement, you can see this filters. So you're saying anything coming from this package org.apache.level match filter, I don't want to get it, or anything which is actually level to match error or accept on match true. If it is happening, don't just filter it. That means in error, you are saying anything from this package and is matching to these conditions, don't log it. You're suppressing those logging statements. Similarly, on info also, you're doing this on level range filter. So using this filter, you can just suppress whatever you are not interested in. That is another advantage you have. Let's understand the best practices. And sometimes, irrespective of these, what would happen is, we have a lot of appenders. Like you see, we have SMTP appender, we have NTV appender, lot of appenders we have, right? Now, let's say these and all are not sufficient for you. You can always write your own appender, or sometimes we call it as user-defined appenders or custom appenders. If we want to write it, for that we have another thing called appender skeleton. That is also available as part of log4j. So using this appender skeleton, as you see, we just need to import. This comes from log4j, and you can write your own appender. You can see this is my appender. I have written it, where I am extending this particular appender skeleton, which is given by log4j, where it helps me to write my own appender so that I can do whatever I want. Okay, so that means instead of the existing appenders which is already available, since they are not satisfying my requirement, I'm writing my own appender. That is also possible. Okay, and if you want to customize your layout, when I say layout, the way the log happens, you can always do with the log4j pattern layouts. So if you see, we are using the log4j pattern layout. So you can mention like how the format should be. So here we are mentioning first I want time, then date, then year and all. I'll explain about these fields, but understand you are mentioning the pattern of how the log file. Like the pattern could be something like first I want year, then I want date, then I want something like log message,
then I want to say whether it is error or not. So this is a log pattern or log format I want to be written. So this kind of formats you can easily specify with this pattern layouts. That's what it mean by customized layout in logs with the log4j pattern layouts. It is very important because your monitoring system which is going to run, they read in certain format. So you have to align with accordingly. Okay, so this is the place where you can set the format and automatically your monitoring system can play on these formatted log files. So if you see each of these particular %5p, %d, %t have certain meanings. So when you say %5p, it simply writes the level in the log. That means, whether it indicates whether it is a severe or it indicates whether it is info, whether it indicates whether it's warning and all that. And you can restrict it to 5 characters. So when you say %5p, you are saying just give it 5 characters. If it is severe, SEVER, that's all. SEVER. There is no E. E will be missing because you constrained it to be 5 characters. Similarly, %d, it is for your date, and you can write date in any format. You can put in different conversion formats like this. And T stands for your method name. If you want to put your method name from which particular method this particular message has come, if you want to do it, then the T is the answer for you. Then similarly, you have C, which C actually implies the absolute class name. When I say absolute class name, it will give the full path starting from this particular thing. So it gives you full path up to this. This is your main project application, but it instead of just giving this, it gives the full path. Whereas if you want just the class name, you can use this capital F, which just gives the class name. That's all. That means it just gives your demo data app. That's all. Whereas if you want to line number in the log, from which line number that particular message is coming, you can do with %l. And the actual log message, you might be logging some message, right? That will come from this %m and %n. Now coming to use diagnostic context to log additional fields. Let's say, for example, you want to log additional fields beyond this. Like you want to log some more information. You can always use this particular diagnostic context to log it. Certain thing could be your %x and %ndc. Using these parameters, we log the additional thing. Like some of them could be, these are all part of your ndc class, by the way. So some of these could be, like if you see there is a %x here, you see this %x, using these fields, whatever you want extra, you can log it. And this %x, so you can log it. And this %x, wherever it is coming, I want to log something which based on my diagnostics and all, I can do from my code. So the code will look something like, so you have to import this ndc in order to do that. So that is on DC stands for diagnostic context. So you are saying, okay, I want to log this, and you're saying ndc.push. So you're saying Aparajita. So you can see that this and all comes from like this. So this is your %x. Okay, that is what coming. So like that, you can put any diagnostic message from your side. Okay, after that, you are doing just log and all, but that particular NDC will help you to put specific things which you want like that in addition to what is being provided to you. And you can always correlate your log request by your web request transaction. I mean, that means like how when a particular log message comes, how you can correlate that with your web request. So one you can do is you can put certain property values there. One thing could be you can put this particular log message when it is written, it is related to this method and all that. So you can even use your toString method if you want, so that you can dynamically see what is happening, to see what exactly is how it is related to that particular web request transaction. So ideally, the idea here is whenever you actually put an object, you can always put, okay, this particular object is called, and from this method, like that also you can put it. That means generally when we write the code, we just put the method name. So here the idea is more than method name, if you put the object that means called, that is also a good idea, so that you correlate. Since the object you cannot put, the thought here is that object you can convert to a string so that it shows up as string value. But the advantage is you know which object gets created at that point. That is the main theme here. Now coming to how to do structured logging, or log an object or properties with a message. You can say anything like that. By default, when you log object and serialize, it comes with your default renders. That is what the general way it works. But if you want to really do the structured logging, then one thing is you have to send to a log management tool. The reason to send log management tool is, the advantage is when you send to log management tool, it is easy to index it. Why you need to index? So that you can perform search easily. If it is not indexed, your search will take a lot of time because it's logs and they will be huge. So that is why it is a good idea to send to your log management system. That could be anything like a third-party tool, or that could be anything like your company have built, or that could be anything like in built house. So it could be anything like that, but indexing is very important. And for this, if you want to do it, you can use this multicolor layout also along with the log4j appender. So that one thing with multicolor, like the name says, multicolor layout is to just give a lot of coloring to your logs, so that when it is error, you can make it red, or when it is warning, you can make it some yellow color, or when it is info, you can make it green color, like that, all that kind of fancy things. So if you see, we are doing this multicolor layout, and if you see, this is the attribute. You are putting color so that the color will come here whenever you are doing the log level. So this color you can change based on error, warning and all. You have to write separate properties for it, but here we have put color for everything. Now coming to make good use of multiple log4j levels and filter by them. So here the advantage here, the idea is, we have different log levels. If you see, we have info, severe, debug, warning and all. The thought here is, rather than putting everything, which is what all is, and rather than putting nothing, which is what off is, based on your requirement, you actually use the relevant log level. So that, let's say if there is a real problem, you have to turn on the debugging only at that mode. It is not like you want to know the logs every time you turn on debugging, because like I said, if you turn on debugging for every other use case, what really happens is it fill up your disk space, because debug logs means every granular information of your system gets logged. If your system has every granular information that gets logged, believe me, your server will be filled only with this log file and they will fill up the disk space, because debug means every minute details will be logged, and your disk easily will get out of memory errors because of the disk gets filled with all these log files. So it is not a good idea. Only the debug is like it's like a trump card for you. You have to use when you are not able to reproduce the problem, you cannot understand what is happening. That's where you have to go. And the idea is not to turn on in production system. Generally in industry, what happens is people take separately one production system for it. Sometimes they call it as one box, and sometimes they call it as a pre-prod system, or you can call it as a testing system, where they exactly have the production version of the application running and mimic it and try to imitate or emulate to see the same problem coming. If the same problem coming in that system, they will turn on, not on the production. So use cautiously all these log levels so that you know what is the problem causing it. Now this is how you can do. You can start from logging everything, which is not a good idea, and debugging is also not good idea because it logs everything. You can have info, which logs your messages at info. Warning, that means, okay, this is the error, you have to take care, but now it's okay to continue. Error, something to be looked at. Fatal, when the error is fatal or severe, it means the system is not recoverable, you have to look at immediately. Only that kind of things you have to log at fatal. So fatal could be situations like where your web server down, your site is down, or your dependent service which you're calling, that application or service or the third party tool is not responding, and that is very important for your application to run. All those things comes under fatal. And off, obviously you don't want to do, because without logging there is no use of your application running. Remember, code without logging is as simple as saying code not ready to run in production. If your code is running without logging, means it's as simple as saying your code is not good enough to fit in production system. Logging is very critical. Now we discussed about a lot of good things about this we have to do, that we have to do and all. Now we learned about Eclipse and all, right? Like, in earlier classes, but we have to see till now what we learned is, as a developer, these are the best practices to follow in log4j and these are the things offered and all. But as an editor, which is your Eclipse, or as an IDE, which provides a lot of support for you, what kind of debugging support it provides? That means all your detecting bug and identifying the issue where it is, what is the support Eclipse provides is what we are going to discuss here. So starting with it, Eclipse can provide you in three ways, like you are seeing here. Like you can debug your variables to see what is the state change, what is the data type of it, what is the value at a particular point, and that is also you can do.
And you can put breakpoints also, saying at this point it is not, you want to break the code up to that point. That means you want the code to execute, but you want to break at that point, and you will not, and you don't want the code to continue later after that. So that and all you can do. You can always look at expressions also. These are the three things you can do. And the way to turn it is, like, you can turn it from different ways. One way to do it is, if you see here, there is like, you can use the debugging mode and you can turn it. As soon as you turn on the debugging mode, you will get this particular right hand side pane, which actually looks like this, variables, breakpoint and all. And you will see this also enabled when you turn it on. Once you enable what, like once you enable, you can always debug on a particular class, and you can put breakpoints also, and you can view variables change also. That means how the variables are changing. Let's say in your code you are running, you don't know, let's say for example this variable is suddenly changing its value, you are not expecting, you can put a breakpoint here to see up to this point what is happening, I mean what exactly it is yielding, and you can see in this variables pane here. Or let's say you want to put a breakpoint here, that means what will happen is the code will start executing up to this and it stops here, it will not continue beyond. Or you can put a breakpoint here. So breakpoint is at until what point the code has to move and stop. That is what breakpoint is. So you can set up all that, and you can look at your variables also to see how they are changing their value, what is their data type when each time they changes, all that you can view. Now let's learn how to set breakpoints. So the way to set breakpoints is, like you can see, you can always come to it, and you just, this one, you can see that in Eclipse, you just click on it and it automatically gives you option to set breakpoints for you. And whatever breakpoint you have set, it will change the color, by the way, something like, yeah, something like this, it will change. So that breakpoint, it automatically shows at what point it is going to cut your code out. That's what it means here. Similarly, you can look at your variable tracing also. So variable tracing in the sense, like for example, here is the code, and in this code, if you see, these are the different multiple lines of code you have written. Let's say you want to see now, let's say what are the variables here. You have object.get calendar and all that. Now you want to see each time how this object date is changing. You can set it up, and you can see from this particular pane in the variable section to see how the variables are changing its value. Is it like same or remaining, or the data type changing? All that you can view. And this is like stepping over. So stepping over is a functionality where it is very useful. So stepping over is like, this one particular, once you set it up, now what advantage is, apart from the variable, what you can do is you can execute your code line by line. That means first you start here, first line, then a second line, then third line, then fourth line. Each time when you move from one code to another, it's like you keep on pressing the step input button. There is a shortcut also, and each time you press it, you will see what is the value of that particular variables, or what is the expressions it is yielding. Like that, you can go line by line interactively with this step function. This is generally useful if you are not able to figure out the problem in your code and you want to go line by line to see. Generally when you execute, you cannot see it, right? Even you put a lot of print statements also, it is very difficult to view it. Whereas with step, the advantage here is you can just use the step, you can just keep clicking on this, or there's a shortcut button also for it. Using that, you can go line by line and see how the values are changing, and you can immediately catch where the problem is. That's the advantage. And step return button, so as soon as you say step return, that means it is closed, it's done. That's what it is. And variable inspection, like I said, variable inspection is more about this part when you're doing step or whatever. So you can look at your variables and see how they're changing the values. Are they, let's say for example, you have taken a variable in your code like x equal to 10, and let's say after 5 or 6 lines it is changing value to 100. What and all happening between that? Is it changing the type or something is happening? Everything you can view in this variable, including its data type. All that you can do in this variable inspection. And one more thing, you can, whatever features we talk about, like the breakpoint, step in, or the expressions, or the other one we spoke about, all this debugging things, you can combine all of them and look at one shot to see what is happening. These are all something which actually work together to make your debugging faster. So object inspector, all of this we spoke about. Let's start with learning how to do logging in Java. We will be using log4j for this exercise. Let me open the Eclipse IDE for this. Okay, so let me close these programs. So for logging, you need certain setup. There are multiple files are involved where you have to tell about the properties of log and you have to tell about the formatting, filtering and all. So I have written some setup programs earlier. These are the 4 ones. In order to create, I'll tell you what you need to do first is, first you have to create a package, something like this, where you have to give a name, something like demo pkj. And in that package, you have to create a class. All these classes I have done the same way, like 1, 2, 3. That's the, okay, the name is not correct, like C1, 2, 3, like that. So the same way how I have created a package and class, the same way I have created a module for package. Inside that I have put these files. I'll explain each one of them so that you are very clear on how to do this. Now first start with logging example. Let me close this. So now if you see here in this logging example, there are file input stream which we have used to read the file, because we have to read the config file, we have to do some kind of file operations, we need this file input stream. Similarly, we have IO exceptions to catch any kind of IO error. That's why we imported this. Similarly, we have all the logging related packages like console handler and file handler to log the data to console. That means your std or in IDE, Eclipse IDE, this is the one. And file handler is to write to the file. And handler is to handle that and do some kind of customizations. Level is to do some kind of log leveling, like for example, info, warning, error, all that kind of log level messages you want to do. This is the one. Log manager is the class which we are going to use the configuration file, and logger is where using which that object we are going to log the messages. That's the whole point of it. So let's start with our main program. This is our logging example program where we have defined a logger line where we are saying my logger object should be defined where it has to read properties from, where it has to log for this application whose name is this. It says logging example dot class dot get name. So logging example class is this, and this name is nothing but logging example. So you're indirectly saying I want to log the data for this particular application whose name is logging example. That's what you are trying to say here. After that, we are creating a main method. Inside main method is where we are saying log manager dot get log manager dot read configuration. This is where we are saying how my log properties should look like. So log configuration, when you say that log configuration properties which I have defined in source my logging dot properties, which is here, this all comes under source, right? And in this is what I have defined. This is the default logging properties provided to us, where we are saying by default my handler is console handler, something which writes on the screen, and the log level I'm using is fine. That means anything log level, let's say you have defined info, anything above than that particular log level, all will automatically come. Similarly, when you say fine, anything above the fine, like you have info, warning, error, anything above the fine will also automatically logged. So you have to give something which is lesser value so that the upper log levels will be logged. And for file, because we are going to do on file as well as console. So for file, you have to tell the format, and the format of logs is like this, where we are saying %h java %u. You're saying the codes to say this log message has to be logged. And you're saying the limit of the log lines that has to happen. So you're saying the limit of the log lines that has to happen is something around 50,000, and you want to write just for one file, not beyond than that. So beyond that, what will happen after the one file is completed, it will keep again overwriting to the same file. And the default formatter you are using is XML formatter. Now finally, for the console, that means on the screen, if you want to write, the default log level you are expecting is info, and the formatter is simple formatter, something which given by the Java log4j. And the log files, the severity is severe for any journal dev files. That's what you are trying to say here. With all that, you are reading it, but it does not mean that you cannot override it. If here we are at certain places we are overriding. When you are overriding in your code, these guys will be taken priority rather than what you are defined in the config properties file. But if you haven't done that, these will be automatically taken effect. And here, if there is any error, it will be either IO error, not able to open the file, or security error because the file has some permission issue and all. In that case, it will fall back to this catch, where this is where it gets handled, and it will print the stack trace of it. Now here what you are saying is, once this is done, let's say this is successfully executed without any issues. Now you are saying logger.set log level level.find.
So you are doing your own logging level besides like what is given in the logging level properties. And you are also saying, okay, I want to add my handler, which is console handler. You have to add two handlers because we are interested in write to file as well as the console. So the first one you are doing is I want to add to console, then I will tell about how to do that on file. So first, once you written on the file, sorry, console, then you said add to the logger. So you have to tell the logger that these are all handlers I want, like it could be file, it could be console. You have taken console into consideration first and you have added that. And here you said my handler. So my handler is nothing but a custom handler I have defined in this class, where if you look at the class here, we are saying how it is like your own handler, like the default handlers provided by log4j is something like stream handlers. So it will do the default logging for you. But beyond that, if you want to define your own handlers where you want to say, okay, I want to write my own logic on how to publish the logs. I want to publish the logs this way or in a certain criteria or based on certain format or based on certain messaging, all this has to come here. Here we are not doing anything. We are just publishing it back, whatever we get it. That's why we are saying super.publish of record. That means whatever log message comes, we are just doing it. We are overriding it, but we are not doing anything. We just want to show that this is the place you can override if you want. Similarly here, if you see flush, we are just flushing out whatever content you received. And here if you see close, once the logging is everything is done and when the logger is getting closed, this will close all the resources allocated. Now once that is done, that the my handler which we have used, whatever the custom handler we defined, then we are saying the file handler. So when we are saying file handler, you need to specify the file where this log has to go. So we are saying here all the logs has to go to a file called logger.log, and it can have maximum of 2 lakh lines and it can create up to five files. That's what we have said. And as soon as the 5 files reach, it will again start from the first file. That's how the work the things goes. Now you are saying the formatter, like what is the format which you want to log the logs. For the formatter, we have defined another class. In this class, what we said is we have to extend the formatter which is given by the log4j, where we have explained clearly how the format of the file looks like. So we have said in the file when you're logging, first I want the class name. Class name is nothing but your logger example.java, and your main method name, which is nothing but your main method in the logger example, and your log level. It will be whatever log level you log, whether it is info, warning, whatever you log, that's what comes here. Then the time duration at which the log logged, then the message which you log. That is the format you explained here. If you don't do it, it defaultly uses the normal one which is provided by log4j. Now the formatting is done. Now coming to the file handler or set filter. So you are saying when I am logging to file, what and all things to be done. So here you are saying I want to create my own filter. That my filter is this guy, where you are saying in my filter, the main agenda of this is you have to use some of the log4j provided package called filter, and you have to extend that guy. Inside that you have to use a method or override a method called isLoggable, where you can say, hey, I don't want to log any messages on file unless it is a config log level. That's what we have given as a statement. So when you do that, what will happen when the log messages are logged? Only when the log level is config, it will get logged. Otherwise it won't. But since I want to show out different types of log level messages, I have put a return true so that everything you can see. But if you remove it in the file, when you see, only the logs which are at config level will get logged, otherwise not. So any kind of filtering you want to do, this is the place you have to take care. Okay, now filtering is done, formatting is done on the file. Now you have to add to our logger, then only the logger will be able to do, because using logger only we are logging the messages if you observe below, right? So now this part is also done. Now the logger is capable of writing to file as well as the console. Now once this is done, this is where in the program actually do the show, where it is running a loop from 0 to 1000. Each time starting from 0, it keeps generating numbers 0, 1, 2, 3, 4. And whenever it reaches something around 7, any divisible by 7, whenever it is divisible, any number divisible by 7 comes, it will log that message as severe and it will say something wrong. Whenever any number divisible by 5 comes, it will log the message as warning and it will say just a warning message. Anything apart from these two, it will just say info, logging message and config. That's what it will do. And if there is, since you are writing to a file or a console, if there is any problem, you will get IO exception or security. IO exception for the case where you are not able to write to file, security exception for the case where you do not have permission to write to the file. In either cases, that is handled here. So the program is good to go. Let's run it. Now if you observe closely, so let me open all this, and if you see here, there is this warning is coming. That means at one point that particular I value is equal to 7. Maybe it is 0% is 7 equal to 0. That's why it has come. And again, if you see just a warning messages, this is all coming from here. And similarly, you will see info messages and you are seeing severe also. That is all coming from here. So certain number, whenever they are divisible by 7 or 5, we are logging here. And you can see certain time at different points you are getting severe info, all that. So this is on console. That means on your screen what you can see is what is getting logged. But generally the good idea is to not to write to the console, because console logs only when you are there in front of the system you can see. What if you are not there in the system and your application is running, or it is a night time? How you know what the system is doing on the screen, what it is logging in the on the screen? You don't know, right? So in order to figure out that, the best way is to write to a file, so that later when you come back to office next day, you can even look at the log file and see what and all issues happen in your system and start debugging. Not only that, in your file you can even go and check and put some kind of alarms or monitors saying whenever the severe warning, severe log level comes, page me or cut a ticket to me, like that, so that it immediately grabs the attention of you. So let me show on the file how it looks like. Let me minimize my screen. Now if I open my terminal, so as I said, it will be on temp. So in temp, if you see, if you observe, there are 5 files created, 0, 1, 2, 3, 4. How it knows is we already mentioned up to 5 files you have to create. And let's see the content of each of these log files. If you see here, the logger.log0, you can see that we already mentioned the format. First we want the class name, then the method name, then the log level, then the date, then the message. You can see that is exactly coming. So the advantage with this approach is never log anything on std out, even though we have shown you, because the main purpose of logging is to debug. So always write to a file like this. So the advantage there is, if you want to put any kind of monitors on this, let's say I want to put monitors on this, you can simply put some small scripts and you can say whenever there is a config error like this, just shoot out me an email, or just send me those messages, or just send to my email, or just page it. Or you want to put certain kind of things on severe log level, user can do something like this. And all severe, even one severe messages means something which is not recoverable, right? So any of the severe messages comes, it can even, you can put some kind of monitor saying if there are more than 10 severe errors, just send me a ticket so that I can wake up and look at what is happening in the system. These kind of things if you do. If there is info messages, you don't need to worry, or even if warning also, you don't need to worry. Just says there is a problem which you can fix later also. Okay, so the best practice of doing logging, as I said, is on the file, not on std out, even though it is not on console, even though it is capable of, because the main intent of logging is to debug the issues. Hope this session helps. Thank you.
So let's summarize about what we discussed in this particular module. So in this module, we understood about what is the different types of debugging techniques you can do using Java console. Then we also discussed about the tracing model, where tracing is kind of a Java plugin you can do and trace the your code and how it is going on. And it actually helps to make your application trace at a better level. It's more granular. And apart from that, you also understood about different types of logging levels, like starting from severe, warning, info, config, fine, finer, and finest. And we have other logging levels like on and off. So these are the different logging levels we have, so that we can log information at different levels and to understand more about the system which we are working on. Then we discussed about one of the popular logging framework called log4j, using which you can write logs either to std out or to a file. Then we also discussed about how to launch a debugger in Eclipse IDE. And the debugger, as you know, it will help you to debug your code and detect if there are any problems. Then we also discussed about how to step through your code by putting certain breakpoints or checkpoints in order to understand the problems in your code. So that's what we have done in this particular chapter. I hope you find this useful. Thank you.
Hello everybody, this is Krishna here. Today we will discuss about JUnit. So before we start about JUnit, first of all, we need to understand what exactly is testing and why we should be so careful about testing and what are the aspects of it. But with respect to the module, we are going to learn about what is unit testing in this, and what is the framework of JUnit test, and what are the components of JUnit test, like your annotations, assertion test suite, and exception test suite. So these are the ones we are going to learn in this particular lesson. Now, before we start with unit testing, I would like to discuss a few things about what exactly is the testing about. So when you say testing, it's actually a process of checking the functionality of an application. And why we need to check the functionality of application? It is to ensure that it runs according to your requirement. Let's say you have given two numbers and you are expecting an integer result, but you are getting a float result as an additional value that is not expected. So that is why testing is needed to check whether when you are writing a code, is it working according to your requirement or not. That is what the main importance of testing. In testing, you have lots and lots of different types of testing, starting from functional testing to non-functional testing, regression testing, unit testing, black box, white box, whatnot. But overall process of testing, if you look at a uber level, it's more to assess whether your code is working as expected. So testing is more about, if you look at, it's more about validation and verification also sometime to see whether it is working as expected. Now in this, JUnit is mainly for doing one of the testing aspect which is very, very important during development, and that's called unit testing. So why unit testing is required before we jump into other things? So unit testing actually happens during the development time. That means as a developer, when you write the code, it is the responsibility of you to write test cases of it. And why we need to write test cases, we will discuss about it, but understand this is not a separate team who is doing the testing for you, but this is yourself as a developer. You have to write certain test cases to ensure that your code is working as expected, to prove that your code is working as expected and you don't see any problems there. And unit testing, as the name says, like you will write for small units, or you can say for each of the function you will write different test cases. Sometimes you will write test cases for different functionalities. It all depends, but unit testing more about says that you test a little, then incrementally you go one by one, like that. Okay, now this actually helps every software developer so that they write proper code and they work as they expected rather than getting surprises from their code. That is very important, and this is the responsibility of not some testing team, it is the responsibility of the developer itself. Now coming to unit testing, so we discussed much about testing. Now, what is exactly unit testing? So first of all, unit testing earlier, before these particular tools like JUnit or TestNG, there are like bunch of frameworks if you look at in the internet, which are available to do these kind of unit testing. And you see a lot of popular ones also, but for Java, you have JUnit, TestNG and all that. So we are discussing about JUnit here. So before that, we should understand what is unit testing. And since we are testing, you might have this question, can't we do this testing manually? Yes, these testing can be done manually. Your unit testing can also be done either manually or automated. Now, with respect to manual versus automation, if you see, definitely there should be a difference. Otherwise, why people have to use these frameworks so that they write the code, right? So what would be the differences when you test it manually rather than doing some automation testing using packages like these JUnit frameworks? Now, with respect to manual testing, if you see, whenever you write different test cases, so when I say test cases, it is nothing but you have written a code to test a particular another function. You can assume like that. So when you write a set of test cases manually without any tool, it takes a lot of time, right? There is a high possibility that it is going to give some mistakes also because you have written it and humans are tend to do errors, and there is a high probability that whatever test you're doing manually, you might not be able to do everything. And it's more about, it's also time consuming. And every time you have to do it, you will get frustrated, the same thing doing again and again. It's like a routine job, right? And one more thing, the more number of test cases are required, you need more number of people. That means huge investment in terms of people here. And one more thing is, if you look at manual testing, reliability wise, that means trust wise, it is not as effective as your automation testing. Another, since you are doing everything by manually, like by using people and all, there is a high dependency on the people. That means somebody who know about the context can only test it. Nobody can execute or nobody can do it without him. It's like a high dependency on him. These are all the problems you get when you do manual testing. Now let's talk about when you do automation testing using some library called this JUnit, what would happen. With automation testing, first thing, it is very clear it is not time consuming because you write once all the test cases required, and that's after that it executes just like anything, right? And it can't be automated where automatically when you write the test case is executed and all. And it's not time consuming because only first time you are going to spend time. After that, it is pretty fast compared to human. Obviously, it is very, very fast. And there is no huge investment on human resources because you will be writing, and after that, anybody can use it. And also, if you look at, you don't need it to be there. After you earlier case in the manual testing, you need some dependency from some other guy who has to write the test cases, and you have to call them and do all this because it's a complete manual, and that guy has the complete knowledge. But here in this case, anybody who has knowledge of executing your programs or writing test cases can look at your code and understand what is happening, and which means there is not much dependency of on a particular user, on a particular developer. That's the right term we should use. And reliability wise, it's much reliable because it's not done by human. There is a less chance of errors, and it's like very fast in execution. And all the test cases can be easily programmed given that we have these kind of programs, frameworks. So these are all the advantages you get when you do automation testing using these kind of frameworks we have. What exactly is unit testing? Like before we jump on this, so this is the same thing we are talking about earlier, but at high level. Now, when you say unit test, what exactly is unit test? Unit test is nothing but a simple part of code, nothing much than that. You can even call a small function, and for that, if you write a test case, you can say that is a unit test for that. So actually, the intent of mainly unit test is to see whether other code or it works as expected or not. It is just to see whether it is working as desired. That's all. If it's working as desired, it might say, yeah, it is good to go. If it is not working, it might give test cases as false, test results as false. And JUnit is one of the popular one which we use in Java to do this kind of automation testing. And like I said, it is the responsibility of the developer rather than the testing team, because this unit testing which we are talking about, developer have to write test cases. That means whenever you develop a code, as apart from writing the code for it, you also have to spend time in writing some test cases, which is nothing but some piece of code to test your functions or code you have written, the parts of the code you have written. And then only you can send for code review so that people can look at your code and assess whether you have done correctly or not. And believe me, in development, writing test cases is very, very important. And like I said, test cases is nothing but just a piece of code that tests another code to see whether it's worked perfectly or not. And there are certain constructs on how to do it. We will discuss in the later slides. And like I said, the whole phenomena of this unit testing is simple. It simply says that we will go step by step. That's what I mean by little, which means you will write one test case. So you will start from a small basic test case to you will test a very, very complex test case. Like first, let's say, for example, if it is like dividing two numbers, you will first test whether I can pass two integers. If I pass two float, what will happen? If I pass two strings, what will happen? These are all different test cases. At the end, you might test what if I pass the denominator as 0. So it is like you will go one step by step and simply write all the test cases so that you check all the possibilities of where the program can go error, and you can let anybody know that, okay, this is the point where it can throw error and this is how I should change the logic. And believe me, writing test cases actually help you to think a lot, because your code should be able to handle all possible use cases which user can give, because you cannot anticipate what user can give. And this unit test cases will make you think, when you write test cases will make you think that, okay, this possibility can be there, so how should I handle it? So your code become more robust in the sense fault tolerant. That means it knows how to handle each edge cases, each corner cases, or all possible cases it can handle well. That's the best part of it. Now we were discussing what is a unit test. Unit test is nothing but just a piece of code you write, just like your function, which helps you to test, another code, or another method you can say. And whenever you write unit test cases, that's like a must requirement, or I would say a mandatory requirement is you should have at least one positive test and one negative test. That means one thing to check whether your code is running correctly, another thing to check whether your code will fail when you pass this, something like that. Like let's say, for example, if you are adding two numbers, one thing could be you will be sending two numbers to it. Another thing could be you will be sending altogether two objects to add to it. So the two objects to adding to it, if you haven't written the proper addition logic in that particular method, it might fail. So you should at least write two methods one for positive and one for negative. This is the recommendation being passed. And what basically is a JUnit? Before we talk about test framework, JUnit is nothing but a test framework where it can help you to automate all the test cases. Now, what exactly is a JUnit? JUnit is basically a unit test framework. That means it helps you to do all this unit testing automatically. It's available in Java. There are other frameworks also available, but this is one of them. And it actually plays a very good amount of, very critical role in doing this test driven development. When I say test driven development, that means you are not just writing the code, you are actually writing the code which actually are tested well, unit tested well, if I want to say. And this comes under the family of, unit testing frameworks called XUnit, by the way. And like I said, if you look at this one, this particular thing checks program little by little. So there is another way of saying it. So JUnit main idea is to promote saying you first test it, then code it. That means every time you write it, first you write some piece of code, test it, write it, then again test it, write it. So that's what I mean by little, which means every time you write some code, incrementally you test it so that over a period of time when your entire code completes, it's more stable and it's more error free. So what is the advantage why we are doing all this kind of things? It actually helps your productivity so that you will not get any surprises when it is in production because you already tested your code very well. That means you will have less surprises and you will have less pages. Let's say something you have deployed in your live production and suddenly one time because you haven't tested properly, there could be some bug and suddenly you get paged in the night. So all this stress will get avoided if you have properly tested, and the time you spent on debugging will be very much reduced because of all this, because you already spent all the debugging time, fault tolerant, you have made all the things like test cases you have written. So that means you have thought well about while developing the code itself, so you will have less strain when actually the code goes into live. JUnit comes under a family of regression testing framework, so we'll discuss about what is regression testing. So what exactly is a regression testing? Regression testing is basically a black box testing. When I say black box, so black box testing is like, a process where it just says that, okay, all you need to know is what is the input to pass and what is the output to expect. That's it. You don't need to aware of how the code works internally, how the code runs internally. That's not your job. That's what I mean by black box testing. So it is like just an interface given to you where you have to pass certain thing and you have to expect the output. And JUnit comes under the same family. Now, when I say regression testing is a black box testing, for example of a black box testing could be like, let's say somebody has given a function to you where they're asking you have to pass two inputs and I will give you a result of subtracting the numbers. So what you know is just passing two numbers, that's all, and the result of getting a subtraction. You don't know how they are doing subtraction, whether they are doing just a subtraction by saying return a minus b by the two numbers you have passed as a, b, or they might be storing in a variable and sending it. That is all immaterial to it, completely immaterial. All you need to worry about is how should I pass the values, what is the value I expect. That is called black box testing. So regression testing is one of the category, it's one of the categories under the black box testing. And how it helps, it actually helps you to verify your code changes in this software to see whether it is not impacting the existing functionality of the product. Why we are saying existing functionality is actually the whole phenomena of this regression testing is, let's say you develop the code, after that whenever you add a new feature, it is not like you have to test only the new feature is working. You also have to ensure the existing code also is working without any fail. That means, uh, let's say for example you have written a program where you're taking care of something like customer's request, and based on customer request you are doing some processing, something like, let's talk about a movie review system, where now in your system you take the movie review and just put in a TV. That's how it is. Now future somebody have asked, okay, take tilde movie reviews you are taking, also ask the user about the feedback comments. So when this comment comes, it's not like only you will test the new feature, which is like taking their comments. You also have to ensure the first part of it, which is taking the reviews, also should work even if you add the new functionality. That's what regression testing ensures, that you have to test as not only the new code, you also have to test the old code which is there. That means incrementally you have to test everything, starting from the old one to the new one. It is not like only the new feature is working and the old one does not work. That means the new feature is breaking the old code, right? So that's not the case. So it is all like that. So remember that the main purpose of regression testing is that. And when we do regression testing, if you look at the use cases, like I said, you can easily guess. Whenever you add a new functionality to your applications, that's where it is needed. Whenever there is a change requirement, that means you want a change in the logic or you want a change in the feature. Just like I said earlier, let's say for example, they are taking movie reviews between 1 to 5. Now they are saying we will take movie reviews like A, B, C, D, E, F. That's like a change in feature. So that kind of things, whenever you do, you need this regression testing. When a defect is fixed, like for example, when there is a bug in your code and you want to fix it, after fixing also you have to do this testing. There's no guarantee that after fixing the bug your code will work the same. And there is a performance issue. Let's say because of performance issue you have done something, like let's say your code is taking too much of memory and suddenly you have optimized it. Now you have to test after optimizing it is working correctly or not. And whenever there is an environment change, let's say for example, till now you are storing all these movie reviews into your database. Now suddenly they ask don't store in database, rather than store in S3, which is a cloud storage. Now you have to check the test cases, are they working correctly even if I change my environment. Environment of your program could be the the program interacting with other components like database or the user interface, anything of that sort. Whenever it changes, you also have to do that. And coming to this particular, we discussed more about regression testing. Now let's talk about what JUnit offers you. JUnit offers you basically 4 types of components, or I would say pillars, which help you to do all this automation testing. They are these annotations, asset, test suite, and exception test. Now let's talk about what is annotation. So annotations is like a kind of metadata, which actually helps your code to make it more readable and simple. So when I say why you want to bother about making your code more simple and readable is, see, when you're writing the code, just don't assume that you are the only one who is going to look at your code. There might be other people also might be extending your code, also might be looking at your code and changing it, maybe later stages. So it should be so easy enough for them to understand. So that's where these all annotation help, so that when you write it, people clearly understand what do you mean by this test. Is it going to be executed after all the methods in the class or before the methods in the class, or is it considered as a test method or not? So all this will clearly will actually let you know when you put these kind of annotations properly. And coming to assertions, so assertions simply means that it's like a testing where you're saying, do you believe this is true or do you believe this is not true? Like sun rises in the east, do you believe this is true? You will say yes, that's a fact, right? But that is like an assertion where you strongly believe yes. So assertion is more about testing these kind of you will get some set of methods in assertion asset part of the JUnit where you will test whether this is true or false, all that. I mean, there are other aspects also, but you have to understand assertion is more about verify this is what I'm expecting, am I getting this? That's how it is. And test suite is nothing but you actually bundle or you actually combine a set of unit test cases and run them together. That's called test suite. It is all like a combination of multiple test cases. You put it together as a bundle and run together. Coming to exception test is actually help you to trace the exception handling part of the code. That means your code can throw errors. But again, are you sure it's going to throw the error which you are expecting? You don't know. Then how can you test it? That's where the exception test comes, where you can write the code, write a test case where you can say that this is the exception I'm expecting. Did it throw that? So that is the part where you can use this exception testing exception test. We'll start with annotations first. So annotations, like I said, it is kind of metadata is what you see, and it's moreover help you to write the code to be more readable and simpler. Now let's look at some of the annotation constructs we have. These are the constructs we have. So you see add test. So add test you will write for before each of the method to indicate that this should be considered as a test case. So if you want to consider a particular method as a test case, just put @test on top of it. That's all. And at before each, in some of the JUnit version, you can even write it as @before. That's all. You don't need to mention each. Just each is mentioned so that it makes it more clear. This is to be executed before each test method. So this particular, whenever you put this particular annotation before any method, it simply means that before any test, that means before any test method, which is this part, where before any test methods gets executed, you want this to be executed. That's what you mean by that. That means this guy will execute before any test method gets executed. Similarly, after each will get executed after any test method is executed. Okay, that is how it is. And after each is equivalent to your @after. It is each is done so that like just to make it more readable enough.
And the at the rate before all, it is to just say, for example, in a class you have written bunch of test method and you want to write a particular and you want to have a test method to be executed before any of the test methods in the class executes. That is where before all helps. It just simply means that before any of the test cases written in this class, I want this to be executed first. That is what before all will do for you. Whereas at the rate after all, it helps you to execute after all the test cases in the class is executed. That means after all the test cases, you have written set of test cases in your class and you want a particular test case to be executed after all of it, then you can use this after all. And by the way, after all, you can use it as at the rate after class, and at the rate before all also can be used as at the rate before class. And at the rate ignore, it simply means that you just want to ignore a particular test case for a temporary period of time. That's all. You just put it before any test. That means you are ignoring for that time. That's all. And there is something called a test of timeout equal to 500 also, or test of timeout equal to some number you can give. It's not just 500, any number. So it just means that you want to see you are setting a timeout for that particular test and you are ensuring that whether it is going to give a response within that time. It is more useful at the rate test. It is more of, this is another flavor of it where you can specify a timeout where you're just saying, am I getting a result within that particular time? Am I getting it or am I not getting? That is to test. That will be very useful when you want to check the response time of a particular method. That's very useful there. And in 24/7 systems, like whatever live system you're seeing, Amazon, Flipkart, Google, it would be very nice function, nice test method annotation to be used. Now let's look at the program. So if you see here, you need to deploy a jar related to JUnits. After you're deploying, you can make use of all these packages which we have mentioned here. Here we are using almost every other annotation we discussed. So here the program is pretty simple. So it is all like we do our program. If you see, these are the two test methods. One is addition, another is multiplication. You see at the rate test wherever it is there before, it simply means that this is one test method. This is another test method. So what this test method does, it just does addition and it checks asset equal. So asset, understand, we are checking is the result of this x plus y. I mean, whatever value we are going to pass, which is this here, x is 5 and y is 10. Is it equal to 15? So we are checking is 15 equal to the z value. If it is equal, it will not fail your test. If it is not equal, it will fail your test. Then we will printing addition value. That's all. Now similarly, we have another test where we are doing 10 into 5, which is 50. And we are checking is the z result, which is 50 here, is it equal to 50? That's what we are checking. If it is equal, if it is really equal, it will say true and it will not fail your test. If it is not, it will fail your test. That is what this asset equals does. So here in this case, if you look at, all we are trying to do is to ensure whether this particular test case is going to be true or not based on a certain value you are giving. You can even give conditions also with assertions. We will look at when we are talking about asset statements later. And if you see, finally we are printing the multiplication value. So wherever at the rate test is written after the method, they are actually the test cases. Now how many test cases we have? We have two test cases. Now before these two test cases, if you want to execute anything, that is where we put at before each or at the rate before. So it simply means that before these two test cases in this program, I want this to be executed. That's what you simply mean. And ignore, you mean you just want to avoid it. That means you just don't want to execute it, at least for this program when you're executing. And after each, like I said, after each is after every test case. If you want to execute some code after this test case and after this test case, that means after every test case, you can use after each. And that means this way we'll print after every test case. Similarly, if you want to do something like you want to ignore the test message, you can just put ignore so that it is temporarily ignored for it. And let's say you want to execute a method after all the tests executed in this class, then you can put after all. Similarly, there is something called before all. So when we run it, what will happen? So first of all, our expectation is we will get this before all the classes message. You see, before all the classes test message has come. So this guy will get executed before any of the test cases because we have written as before all. Now, similarly, the after all is there. That guy should execute at the last. That means all the test cases in the class are executed. You can see this is the last statement you are getting. So it is executing. Now let's look at the other things. You see here, every test case before executing, we said execute this guy. So this before each indicates that execute this particular method before each test method. That means before addition execute, you should see before each test case. Before multiplication execute, you should see that particular
setup method executes. So let's see if that's the case. You see that before each test case, addition value, then before each test case, multiplication value. So you are getting both of it. That means before addition test case and before multiplication test case, you are getting that message. Similarly, if you observe, after each test case also statement is coming, because you have mentioned that after every test case you want to execute this guy. So that is how this helps. So after each to execute, after every test case you have written, before each to execute, after every test case you have written. This is how it looks like when you see in your Eclipse. The code skeleton will look like if at all it executed without any failure. If at all there is any problem, you will not see this kind of thing, whereas you see the failures here. Here in this case, out of runs 2 by 2, it simply means that you have run it 2 times and 2 times it is successful. That's what it simply means. Like I said, asset is more of verifying whether whatever you are expecting, are you getting the result in that way or not. So this is guy is part of your JUnit, and it just provides some set of methods to assert your program logic to see whether it is giving some result to you according to the expectation. All these methods, if you look at, they are most of the methods in assert, actually the return value will be void. That means they don't return any value, but the parameters they can take and they can check for Boolean values, null values, and identical values. Like you can see, these are the list of them. If you see, one common pattern is all of them written white. You should not be expecting any written value from them, because they are meant here to check something, and if the test is passed, they will fail your test cases. That's all. Now what this guy does, he just checks whether given two Boolean values expected, the actual, are they true or not? That is what he checked. Similarly, asset true. So here you can give a condition saying maybe something like a greater than 15, a less than 15, like that. So you are checking whatever condition you have given, is that giving true value? That's what you're checking. Similarly, you can give another condition, something like x greater than 10, and you're checking whether that condition is yielding as false value or evaluating as false value. That is what you're checking. And here asset not null, so you're checking if the object value is not null using this assertion statement. Similarly, this asset null you are checking for a given object, is it evaluating to a null value? If it is evaluating to null value, that means the answer is as expected, so you will not fail the test. Similarly, here you are checking if the two object references are pointing to the same object by using this asset same. So you are simply verifying whether they are pointing to the same reference. Similarly, here you are checking whether they are not referring to the same reference. That's what you are doing. And similarly, here you are checking whether these two arrays are equal or not. It is just same as asset equals, just that it will check on your primitives or objectives, whereas this guy will check on your arrays. So if you see, the names are self-explanatory. Now let's look at a program on this. If you look at, we have imported our assertions because all the assertions are part of this API of JUnit. And once we imported, you can see we have written a test. That means this is a test case. Now, when you have written it, you can see we have created two variables, val1, val2, 5 and 6, and you have written two strings. One is str1, str2, and there is an str3 null, str4 welcome, str5 welcome. These two are string objects. Observe the difference. These two are string objects. These two are string returns. There is a difference. Now, there is an array, expected array 1, 2, 3, and there is another array, result array 1, 2, 3. So now our objective is to test all the assertions on this. First one, we are checking assert equals str1 comma str2. So what we are checking is str1 is equal to str2. What is str1? It's an object. This is also an object. Are they equal? If you see, both are equal and they're both pointing to the same reference. So this will give us answer as true. So there will not be any errors. All you can see is the failures are 0. It's all without any failure. Similarly, you are checking a Boolean condition. If you remember asset true, we said it takes a Boolean condition, and that's what we are verifying here. So is value 1 less than value 2? Let's see. 5 less than 6. Value 1 is 5, value 2 is 6. So 5 less than 6 correct, right? So when it is 5 less than 6 correct, then obviously this guy will say, yes, it is correct. It will yield true. So obviously we are checking for true value. So this condition is true. We are checking value 1 greater than value 2. So value 1 greater than value 2 is 5 greater than 6. That is what we are checking. Is 5 greater than 6 is false. So we are checking asset true or false. We are checking asset false, which is correct. Value 1 is not greater than value 2. So it will give the value. This will result as false. So since we are checking for false value, it will not fail. But if we are checking for true here, it will, this particular test will fail. Similarly, asset not null, str1. So what we are checking is str1 not null? If you look at str1 is not null, str3 is null. So since str1 is not null, this guy will say yes, str1 is not null. So it is correct. So it is helpful to check whether your objects contain null values or not. Similarly, you are checking set null of str3. So it is just to ensure, is str3 containing null value? Yes, it is containing null value. That means there is a problem with it. But if you same asset null, if you used on str1, it might be giving a different, it might fail the test because str1 is not equal to null. Similarly, asset not null, if you used on str3, it might also fail because str3 is equal to null. Now you are saying str4 comma asset str5, you are checking are they same? Str4 comma 5, yes, they are same. So it will say yes, correct. So no problem. Again, you are checking asset not same. The same asset not same, I would suggest you to try on str4 comma str5 and you will see the test results failing. So since in this case we are using str1 comma str3, obviously they are not equal because this guy is equal to null and this guy is a string object. So it will not be equal. And the values are also different if you notice. One is null value, another is welcome. So that will fail. Now coming to asset array equals, like I said, it is same as equals, just that it help you to check two arrays. Now result array is 1, 2, 3, and this guy expected array is 1, 2, 3. So here checking, you are checking here whether these two string arrays are they equal. If you see they are equal, so answer will be true. That means the test case will not fail. And see the result here. Observe this failures. It is 0. If any of the test fails, it will be 1 or 2. How many failures happened? It will be listed there. Now, what I would suggest is rather than using the positive things scenarios here, I would suggest you to just flip the values, something like make asset true, value 1 greater than value 2. Like that, if you do it, you can clearly see how the tests are failing and you understand how the flow is working there. Now coming to test suite. So test suite, like I said, it is like a bundle where actually it integrates multiple unit test cases and run them together. That's what the main part of test suite is. So test suite is more about, a combination of multiple unit test cases where you want to run together. And if you want to do this test suite, you actually need help of these two annotations called run with and suite to run this test suite. Basically the run with comes with a suite dot class. What you are supposed to do is first you have to create a test suite. Let's say one test case you have create, and in that the class object of a whatever the class it is, that is what you need to give here so that it run that. And similarly suite classes, you can pass multiple test classes like this. Let's see the program with that. So you can see we are making this guy as a test case. So addition is a test case here where it just adds the value. Similarly, these are two separate programs. This is test suite 1 and this is test suite 2. This is for multiplication program. We have made this guy as a test case, and this is for addition program. We have made this guy as a test case. Now you have two programs. Now two programs, after you run it, you have written one more program where in that program you have used run with and suite, which is what we discussed to necessary for making a test suite. And in that you said run with suite.class, and you said in that you clearly said suite.suite classes, suite test1.class, suite test2.class. So what is that suite test1.class and suite test2.class? If you see, suite test1 is this and suite test2 is this. So you are saying here, I want to, using this construct, you are saying I want to integrate this class and this class. So you are bundling them. Now, given that you have bundled in this program, now what is that you are going to do? In this particular thing, this is where actually you trigger so that it runs. So this program, you just integrated those two test cases, those two programs which has different test cases written. Now after that you integrated them. This is another program. Then what you have done is you have written the actual program where your main method is there, where you are saying junit core.run classes. So you said run all the classes from this junit test.class. And what is your junit test.class? Your junit test.class is this program where you have integrated them. And this guy, what they have integrated, he integrated two other programs which have some test cases. Now when you run it, you are looking, are there any failures you're getting? And each time you are just converting and converting them as a string. Now you just calling the functions, and as soon as you start triggering, what will happen is it automatically trigger this multiplication as well as these values, and whatever the result comes to it, it automatically converts to string. So you can see the result is addition value equal to 20, multiplication value 100. So these are all coming from those two programs where it is triggered from here, this part, and it gets converted to string. So if you observe, what we have done actually here is you have integrated or combined 2-3 test cases into one by writing a separate program. And again, you triggered all of them from a separate class where your main program is written. Rather than putting everything into one bunch, what you are doing is you're writing set of test cases separately. So that, let's say, for example, this will be useful when you want to, you know, run a set of test cases in bunch of programs. Like, let's say you have one program for taking requests, another program for processing it. You can integrate both of them and put in one thing, and you can see whether they are throwing any error in one shot. That is one thing. And also to bring the modularity structure in your code. And you can see this is what how the structure is when you're creating the suit test 1 and suit test 2. This is how the structure looks like in your Eclipse. So what is exceptions test? So exceptions test, if you remember, this is the last component of your JUnit test framework, and this guy will just test to see whether whatever exception you are expecting from that code is it returning that, or it is giving some other error. Like, let's say for example, whenever I missed a semicolon, maybe Java might be giving a syntax error, but is it giving that syntax error or is it giving some other error? I don't know. But I can always, using a test case, using this exceptions test, I can always check whether that's been the scenario or not, because that helped me to properly make my code more stable, where I can say that, oh, these are the errors you can get when you do that. I can create an error table and give it to you saying, okay, when you do this, this is the error going to happen, like that. So it is all to check whether a particular code, even if behaves as expected, if it fails also, what kind of error it can come. That's what actually help you to test using this particular exception test. Now for this exception test, if you want to do it, you can use our @test annotation, just that it needs a parameter where you are saying what is the exception. So what is the exception you are expecting is what you write here. So let's say syntax error, you will write syntax error dot class, something like that. And here you're just mentioning it. And if you want to test for multiple errors, you can always write your code where you say @test expected equal to this and all. So now you see this program we have written. If you see here, this is inside message, then we have a equal to 0, 1 by 0. 1 by 0, what it will do? Division by 0 error it will give. But in Java, what is the error it will give for division by 0 error? Some arithmetic exception, right? So that arithmetic exception, is it giving or not, is what we are going to observe by writing a test case for it. So if you look at here, we have written, this is this is your first program where you have written a test message. This is another program where actually you have said, you have written a method where it just says this and just calls your test message.print. Your test message is this particular class. In that you are calling this print. But before print, one thing you should notice is you have @test expected equal to arithmetic. So you know that that program is going to throw error. And again, you are saying what kind of error you are expecting. You are saying I'm expecting arithmetic exception. Is that returning it? So that is what you are verifying. So rather than verifying whether a test actually going to return a particular value, or the test going to be whether a test is going to check whether two values are equal, here you are checking whether if that particular test case fails, is it returning the error I'm expecting? That's what you are doing here. So if you see, obviously it will fail with an error. So that's what we are checking. So let's see the output. So if you see, when it calls, it has given inside test message first, from where it is coming. So inside test message, it is coming from here. This is where you triggered it. And when you call test message.print, what really happens? It will print inside message. So after inside test message, you can see inside test message is coming. Then you are calling your test message.print. This is where you are invoking. When it invokes, you get inside message, then 0, 1 by 0. This is where the error gets triggered. So that's why if you notice, after system.outprint and dividend value is not coming, because at this point itself, there is an error raised, which comes under this category of arithmetic exception. And that error is returned back. And that is where we see whether it is this. So since it returns this, it says yes, it is true. That's what it says here. So when it says true, that means it is indicating to us that whatever error you are expecting, that's what being written by this guy, and the program is correct. Okay, but let's say instead of arithmetic exception, let's say that is not the case. It might be array index out of bounds exception. Let's say you have used a program where you created an array and you are accessing an index which is outside the array boundaries. That means you are creating an array of 10 elements and you are accessing a 15th element. Then what would happen? It will raise array index out of bounds exception. But the same program, if you check for arithmetic exception, it will say false because the error is not arithmetic exception, it is array index out of bounds exception. So it is all to verify whether your code is giving a desirable exception or not. That's what it does. So let's start writing some JUnit test cases, and after that, let's see if we can generate some report out of it. So the objective of this particular exercise is to generate a JUnit test report using Java, and either we can take an existing program or we can write our own test cases. So let's start first. I'm opening my Eclipse IDE. So once I open, so in order to generate a test report in a HTML format, something like that, what you actually need is you need some build system. That could be Ant, it could be Maven, anything. Here in this case, I'm using Ant. I'm using Maven. So there's no restriction that we have to use this. You can use anything. There's no hard code restriction that we have to use this since Eclipse actually have this Maven already set up. So I'm just making use of it. Now, what should we do in order to just get a test report? So first of all, let's have the build system coming in. First open new project. Then in the new project, you see this Maven. In that Maven project, you just click on it. It will open. Just say create a simple project and then do next. And here is where you have to give the group ID and all. So what will be the group ID? So group ID is something, here you can arbitrarily give some group ID and all. So I'm just mentioning it as com.junit.testing, and this artifact ID is what it is going to create as a project for you. So I'm saying JUnit test reports. That's what going my artifact to be. What is the name of it? JUnit test report program or JUnit test program demo, and how to generate test reports in HTML using JUnit. That is what our main objective is. That's it. Once you click finish, observe it has already created this. This creates a project for you, JUnit test reports, and you can see you will have this structure. This is where you will write your test files, and this is where you will put your main code. So if you are following my previous demo sessions, we already have done some testing program, student mark testing program. I will be using that. So this is my test student mark program. I can use that, or if you want, we can write our own code also. It doesn't matter. You can write our own thing or you can use the existing one. First, let's use something we have. So I'm just going to copy this and I'm going to put in this source test Java. I'm going to say new class and let's say test student mark, and here it created, and here I'm going to put this program. Don't worry about these errors. As soon as we created the JUnit, it will work. Then we have the student main, not this one, student mark, this one, and this is where our main program is, which we need to copy in this source main Java, and here student mark, and here is where we are going to keep this program. So this and all is good. Save. This is our student main. This is not needed. So these two are copied, student mark, and I think this is the old one. Save. Now this is in the main program where we have written student mark, and this is the test student mark program. Now if you see, as soon as it created, don't worry about the errors, it will get fixed. As soon as you create it, there is this form.xml. This also gets created. And this XML is what it tells you that, what all the build system to use to test your code, all that. So here we need to add certain dependency to say that this is what I need in order for that to happen. So I'm going to add those lines here. So I'm saying dependencies, and in dependencies, overall, I'm going to say the first dependency is this is my first dependency, where I'm going to write about what is my first dependency. I have the group ID as JUnit, and I have the artifact ID as, I'm just trying to say, get me the JUnit artifact. And here I'm saying version. What is the version we need to install? I'm just giving some random version, 4.12. And this is my first dependency. What does it say here? Dependency group ID, artifact ID. So once it is done, now, so this is about, you are saying as part of this is a Maven build file. So as part of the pom.xml, you are saying, so all your information is given here, whatever you created, artifact ID and all. This artifact ID is different than this group ID is different than this, by the way. So here you are saying which JUnit you want to install, what is the artifact ID of it, what is the version of it. Okay, so you are saying, you are telling your Maven, which is your build system here, that this is what I want to download. Then you have something called properties, where you want to say, why this guy, okay, properties, okay, this is not needed. In properties, you're mentioning the Maven compiler source. We're talking about which Maven to use here. Maven compiler source. And here you're saying I want to use 1.8. And similarly, you want to say what is your Maven compiler target. Again, you're saying 1.8. That's it. That is your properties. What does it say? Malformed pom.xml unrecognized tag properties. Properties unrecognized tag. Properties tag seems to be good. Why does it say it is unrecognized? Let's write it again. Okay, we'll see that anyway. We'll come back. Then we have to say, since we want in HTML, we have to say reporting. And in reporting, you have to say that Maven actually comes with, lot of plugins. So this is Maven plugins. If you see, this is the official Maven build system. And this has got a lot of plugins, not just this. I'm opening just one plugin. If you want to look at what are the other plugins available, there is this plugin tab also available on your, you see the plugin tools. You can check from here. Here I'm interested in this Surefire report because that is the plugin which we use to generate HTML for us. That means whatever test report we get, we are going to get a HTML report out of that. And in this, if you see, so this is what we are going to use, surefire test report. And in that, there should be properties also here. Okay, these are its own parameters. Anyway, let's maximize this guy. And here in reports, like I said, we want plugins. So you can say plugins, and under plugins, you have to mention which plugin you need. You can say plugin, the plugin name you have to mention. The plugin name is, and the plugin again you have to mention the group ID, everything. The group ID. Group ID is org.apache.maven.plugins. These are part of the website itself. Since we are using on a day-to-day, it is like we can easily remember. Artifact ID, and the artifact ID is maven-surefire report-plugin. So this is where we are mentioning I want this particular thing, and this is where I'm mentioning the version of it, where I'm saying the version of it is, if you look at it, this one, the recent version is 3.0.m5, and this Maven Surefire Reporter plugin is what we are using. So that's the recent one we are going to use. We're going to say 3.0.0-m5. You can just get this from here, 3.0.0-m5. That is the version. Now let's come back to this guy to see why he is giving an error. We are part of project. These are part of dependencies. This is very important because Maven looks at this particular file, and based on that it will do its job. So here in this case, this particular properties tells you that which particular Maven is a build system. So you have to tell it which particular compiler version it has to use, what is the target it has to build. And again in the plugins, this is comes under reporting section. You have to say which plugin I want to use. Since we are talking about just a HTML test report, we need just this show report plugin. If you want some more, you can put it in this plugins tag. Multiple plugins you can add. Now coming to our properties, why this guy is giving error is what we need to investigate. Did we miss anything here? This looks to be good. Why this properties? Multiple annotations found on the line. Dependency, unrecognized tag, properties, position start tag. It says it has multiple properties field. That's what the properties problem it says. This shouldn't give any error. Let's put less than. Eclipse sometimes. Let's check. I'm just checking what is the properties in Apache Maven. So POM reference, you see a POM reference is there, and properties seem to be like the same way we have used. I don't see a difference. So there is this sample reference they have given, and they were talking about the same properties. You see, I was telling multiple plugins you can add, right? So you can see that how many plugins they have added. We just need the, the report one. That's why we just use that. Properties seems to be correct. Let me copy this there. Okay, let's say this is also done. Now the next part is when you say run configurations. Here is where you need to, since our code is already there, and this Maven build you have to come, and this is the older one, and this JUnit report. So this is the command you have to use. I mean, you can use a Maven CLI also, and here what we are using is the Maven clean install testfire surefire report. This one will actually install Maven for you, test and generate the report using this plugin. And you can use, this is our workspace, so I'm just mentioning the workspace name, and if you say apply, then run, let's see what it says. The builder did not read the project. Yeah, this malformed, so POM itself malformed is what it says. POM should not be malformed. I think I got it, the problem. The dependencies should not be here. Ideally the dependencies are here, so it has to end here. Yeah, that's the problem. So as part of the dependency, we have added dependency, but dependencies contain the properties also, which is not expected. That's why it was giving error. So this one we have added earlier here. That's why the problem is, ideally after you add dependency, the properties and all should come. That we missed. Anyway, okay, now coming back, just run, and it says run configurations. Run it, and here you have to give this clean install test surefire report : report. And since it's already, let's see where it is configured. It has to be in Maven build JUnit reports, and see whether it is choosing your correct workspace. Yes, this is correct, JUnit test reports. Then give this command where it will clean your whatever files earlier created, install the Maven again, test it, and after testing it will put all the reports in this particular surefire. Using that plugin it will put it. Now when you run it, so this is the place where it reads your this pom.xml file and it does the job. So it is finished. What actually it is doing is it downloads JUnit for you, it runs using Maven, and it also gets this plugin for you and do that. First time it will take more time, and after that it is easy. You can see that earlier there were a lot of errors, right? Now you see all that is gone. It is automatically resolved. Okay, now what really happens is, now given that it is created, now you can see the test reports. So what you need to do is go to your terminal. These are all created in my system in users class Java. This is where my entire Eclipse workspace is. You can see that this Eclipse workspace contains my other files. This test package is there as part of it, and JUnit test reports is another project. JUnit test reports, if you come, JUnit test reports, JUnit test reports, okay, cd JUnit, okay, go to Java, JUnit test reports, and this is where my target file is, the same target file. It is not showing up here, but it will show up in your environment. So you see some set of files is there. In this, go to site, target, go to site. This is the place your HTML file is there. So this file I am copying and I am asking it to put in my desktop. I have put in my desktop. Now once I put in my desktop, I could see my desktop here. In this desktop, do you see this surefire-report HTML? We click on it, this will open and this will show all your JUnit test report. You can see that it says there are 8 tests run, no errors, no failures, 100% success rate, time taken this. It is run using from this package. This is the time taken, the success rate, and this particular class test student mark is used for testing, because if you see, that's what we have used to test all the code, right? And it says that it took total 0.02, and it tells you about each function you have written inside it. Like if you see, we have written multiple functions, get total marks, get students and all, and this particular test program is testing the student mark.java. So it is telling all the test results are going good, and this is the one which took more time, 0.002 seconds. And you can click on test cases, summary, it will take you to that page, package list. I mean, this will help you to navigate easily to anything. So this is how you can create a test package. And if you want to write your own test case, you can do that even. So this is on how to make use of, one thing where you want to do some test cases and do it. So now this is use case where you already have something and you want to test based on that. Apart from that, let's say just for, I mean, like people will not write, but just for that, like you want to write your own test case, you can even do that. Like in that case, I'm saying here it is proper testing where you're testing a particular program student mark and put a test use case, and that test use case you have generated a report and showing up. Now apart from that, let's say you just want to play with it, you can just simply write a test case. You don't need this main program and you can test that event. That is also possible. Let's do a small program using that. I'll just remove it. These two I am removing it. We can even put it that way. What would happen is this will consolidate. So this one as of now saying test to student mark, ideally should consolidate. Let's put one more test case. So in the same test Java, I'm just putting a test case, just a random one. So random one is test demo. I'll just put random test cases here. And in this random test cases, I'm going to have something like, a simple test case could be a test public void instance of, that's the test name, instance of test, and I'm saying asset that, there is asset that also is there, new array list, comma, instance of this dot class. So here I'm seeking a simple thing. So let me get the relevant one, import array list, then what we have, import test, then it will ask us to import few more, import, we have imported array list, we have to import list also, java.util.list, we need asset also, instance of. So this one actually are part of these test libraries. They are import static org.hamcrest. These are all related to your unit tests, core matches. This there is an instance of. Now import instance of, it still shows some error. It says add static for this as well. Now we have added. Now I think we are good. We have added asset that. So this is for getting this. These are all basically a test unit jar files which is needed. All that is already part of my system. If you look at in your JRE system library, these will already be downloaded by Maven. If you want to check it, like you can check that the Maven should be part of your Maven dependencies already. You see Hamcrest core and JUnit jar. This Hamcrest is coming from there. JUnit is also coming from there. That's it. So now if you run it, again, I'm just running it. Now if you run it, and here same, we are going to run in the same thing. So now if you run it, oh, it is running. The Maven build is running. It says test pass, build success. Now the same thing again here. Come and see what is there in this site file. So if you see, go to site file and you copy this to desktop, and this desktop, if you click now, this report, you see there are two classes has come. One earlier one is just one package. Now I have put a dummy test to just show you that you don't need to have the main program, but generally your main program will be there. Based on that only you will write test. But if you want to play with it, you can just have a dummy test example also, just to see whether it is working or not. So I have put a very simple thing just to ask it, is array list is an instance of this list or not? That is what I was asking it. And if it is saying true, that means your test is passed. If it is saying false, that means your test is false. It is like that. So for this use case, when I put it, now what it understand is, it understand that you want to put everything in single HTML page. So it has put it everything. So you can see now two classes. Earlier it was only one class. Now the other dummy class also has coming. Now if you click on it, that dummy class test it is showing. It is just test instance of. If you want to see these guys test cases, it will show these guys test cases. So that is how you can put, and you see this is taking 0.011 time. That's what it shows up. Okay, this is how you can generate a test report of your existing program, or you want it, or you want to do just want to play with some test cases, you can write it. You can even write a lot of test cases also based on this, not just this one. Here if you see, let's write one more test case, just one more. That is to just say asset true, very basic one. So I'll say something like at test, say public void, and we are saying asset true, just say asset test, and in that we are saying asset true means, is it true? Generally true means in Java what it will return, it is going to return this, right? True value only. In other language it is capital T. Here we are asking, when you say asset true, what is it returning? Is it true returning or not? So this needs an import, asset true. Okay, this is done. Again come here, run configurations, and this is already there. Let's check one more time. Yes, this is already there. Now run it. Now once this guy runs, it is running your build. After this runs, again the same thing. Come here, see site, go to site, there should be a file, show file, and copy to your desktop, and go to your desktop, and if you open this now, you see in test demo there should be two test cases, instance of asset test. So like that you can add as many test cases as possible. Now what we have done is just added one more test case. Ideally the expectation is when you generate this surefire report, you can have like one HTML report for each of your test cases. You can do even that. Here in this case, what we have done is we have clubbed multiple test cases, multiple test programs into one particular HTML page. So it will show consolidated everything. And even though we consolidated, there's not a lot of confusion, because if you see, it clearly says this is from test demo and this is from test student. So that way it is still good. Okay, I hope this helps. I would suggest you to practice few more examples by using the existing programs, like some programs you have written. And if you want to just play with it, you can just have the test. Ensure that you are always putting in the source test Java, your test file, and in main Java, you have to put your main program, whatever you're doing. Then just ensure the pom.xml. Like you see, if you just miss one tag, it will be corrupted and it will not work. Like you understand, like, we have seen, right? Like how much we have to check and all that. That problem will not be there. That's all. I hope this helps. Thank you. afternoon. So today we will do some programs related to JUnit. So the program, we're going to open Eclipse. Let me close this all again. Now let me open my Eclipse IDE. Now we are going to take a student marks project, a small program, where for that we will write test cases and see how we can test in using JUnit. Now this is my project, and in that I already have set of packages created. In that we will pick the demo one where we will write our code. So first of all, let's create a class. The class name is student mark. So this is the class we are going to create, and in this I need java.util.scanner so that I read the input from the user. The input will be mostly, their marks, and we are writing the public static void main string args. So this is where we are going to read the this is where our program is going to run. So I'm saying declaring and initializing variables here. So first one, I want to declare a scanner object. The scanner object is for reading the keyboard input from keyboard. So I created a scanner object. Once I created a scanner object, I'm taking physics, chemistry, and maths, only 3 ones. Physics marks, chemistry marks, and maths marks. These are the 3 subjects we are going to ask user to give as inputs. Now let's ask the user the input. System.out.println, enter physics marks out of 100. And here we are going to say physics marks equal to se dot. We need to read a float value. So for float, there is a function called double, se dot next double. Now we can even put, you can either use float also, float and double. Here in this case, marks, since we are talking about just within 100, float should be enough. If you want, you can use double also. Then I'm going to read the marks for enter chemistry marks out of 100. Se dot next float. Then I'm going to say system.out.println, enter max marks out of 100. So now you can put a comment saying here we are reading marks from the user. The marks is read. Now we need to calculate the total marks and all that stuff. So for calculating total marks, I'm going to have a method which does that job. Get total marks. I'm going to pass your physics mark, chemistry marks, and max marks. And since that function is not defined, it is asking us to define it. And this is where we are going to write the code for it. Now that code should be doing the marks addition. Say method to calculate total marks. Now here is what we are going to write it, saying floater total marks equal to physics marks plus chemistry marks plus max marks. Now once we have written it, and here we are going to return total marks, just a simple function. You don't need written there. So now this one will get you the total marks. Just making the variable different. You can even keep the same also, doesn't matter. Now once we have done total marks, now you want to calculate the percentage. Before that, let's print the marks to user. System.out.println total marks of the student out of 300, 100 each based on that is to put total marks. Now total marks is done. Now we want to calculate the percentage. Percentage marks equal to get percent physics marks plus chemistry marks max marks. Now this function is also not defined, so let's write for this also. So you will say method to calculate percentage of marks, and here we will write our code. We'll say float marks total equal to physics marks plus chemistry marks plus max marks, then float percentage equal to total score divided by 300 into 100. Now this one is your percentage answer. Okay, this is marks total. Okay, so this is percentage is done. Let's display the percentage marks also for the user. You can say system.out.println percentage of marks obtained is, we are saying here percentage marks. There are two R's here. This is also a mistake. Now percentage marks is calculated. Now when you get the percentage marks, we'll see anyway later, then we want to get the grade. Grade equal to get grade based on percentage marks. Again, this method we need to implement, and method to calculate grade, and here we'll write the logic. So logic would be like, how you rated grade. So I'm just considering few of them. So I'm just saying we'll take as percentage. We'll say if percentage greater than or equal to 80, I'm going to consider it as A++, and else if percentage greater than or equal to 60 and percentage less than or equal to 79, if user is in that range, I'll say return A grade, and else if percentage greater than or equal to 50 and percent or y percentage percent less than or equal to 59, then I will give this as B grade. Anything other than that, we can say let's give C grade. There's still some errors. Oh, this is percentage. Okay, if percentage, so it is still showing some errors here. Where is the problem? Create local variable percentage. So this looks good now. So we have a way to calculate the grade also. Now once the grade is calculated, we have to print the grade also, right? Like let's print the grade. Dot out dot println grade of the student is going to say grade. That's it. So this completes our program. Now let's execute this. Okay, still there are errors in the code. Okay, what does it say? Oh, I used comma, it should be plus. Now if you run it, it is asking how many marks he's obtained. 80, let's give 90, let's give 89. So it say total marks of the student is 259, percentage of marks obtained is 86.336 and A plus. Similarly, let's run one more time. So this time how many marks he has obtained? Let's say 90, and this is 40, and this is 30. And percentage of marks obtained is 53. So if you want to truncate and make it to 2 decimals, the percentage of marks obtained, even you can do that also. If you remember, we have the string.format. Using that, you can format the output in a way so that you can just say this is what I need. So let's do that. So let's say string.format and say percentage. After that, I want 2 decimal digits, and for which one you want? Percentage marks, and percentage marks, and this one we can delete. So this one, now the same thing, if we enter, it should give a 2 decimal value. $80, $90. So you can see the 2 decimal point value is coming. And if I enter 50, 50, 50, it is giving it. So if you see, there's no validation here whether the marks entered is 505 and all. That and all we have to catch during testing. So it's coming properly. Okay. Now, if you look at here, there are certain things. From it, think like a tester. When you think like a tester, what and all things can cause a problem? Like one thing you observe is like I am able to freely enter any value. It's not stopping me. You can say I can put some if conditions, whatever and all. That is also fine. But the question is, as a tester, when you think, you have to write certain test cases that catch these kind of problems. So how to write that test cases is what actually our main discussion. The main discussion of the program is not this. So let's write some test cases which catches these problems. So let's create one more class that is like purely a test class, and that testing we will do using JUnit. So let's say test student mark, which is going to test this guy. And here is where we are going to write those test cases. So our first test case, first we will write all the positive one. Any test case you want to have a method to be executed as a test case, you have to put this annotation @test. So first test, we'll write a positive test first, then we'll slowly put a negative test altogether. So test for, I'm just putting a name, test for what? Get total marks. We have one test for it. And what does this do? And this one will say asset equals is one of the JUnit method. Before asset equals, if you see, as soon as I use test, it is saying you need to import arg.junit.test, otherwise I won't work. So let's import it. And similarly, when you use assert equal, that is also not known. So if you want to use, so ideally what you'd be doing is, if you just import this guy, import static arg.junit.assert. So this has lot of functions related to assert. So all this will be useful. So the asset is coming from this particular thing, and these annotations are coming from this package. Now we are saying asset equals 300.0 student mark dot the student mark dot, this is not visible. So whatever student mark we have created, get total marks and all, if you see, we have made it private. So when you made it private, nobody outside know you about it, right? So you have to make those as public, then only those will be visible from outside. So that's one thing we need to remember. I'm making them public because if you observe, those are not visible. If you want them to be visible outside of the class, you have to make it as public. Now after you made it, now if you see this student mark dot, now you see it has started coming. Now here is where we are going to pass get total marks test. So first test is get total marks. We'll pass 100, 100, 100, 100. Now once we do that, we'll say this asset equals student mark. Now let's, what is that it is saying? Asset. Okay, that's not a problem at all. Okay, so now we are going to run this guy. The way to run it is, you can just say run as, and there should be, where is our test student? Okay, this one. And when you say run as, it should say JUnit test. So when you run it, this is how the test results will show up. So here it is saying I have run 1 out of 1 and the failure I got is 1. So if you see here, this is your actual code and it is saying I am failing at this point, and this is the error I got. That is what it says, right? So this one failed one time. So why it failed? It says I am failed at get total test student mark dot java 9th line. I failed, but actually it is coming from this particular guy. If you click on it, you will get. So it's a expected actual delta to compare float numbers. Okay. So one thing with this float is when you are comparing using asset equals, when you are comparing, you need to give a delta value also to float, because you are comparing float values, not integer. If it is integer, it's not required, but you have to say when you are comparing float values, you have to give a delta value also according to the syntax. If you just say asset equals, you can see it will clearly show that function syntax. Like when you put it, that asset equals itself, if you see there is this delta, that is the delta it is asking about when you use for float. So that's what we missed. That's why it is saying that. So you can see this is same thing, delta to compare float number. So I am saying delta is 0.0f. That means the difference between this and this should be 0 only. That's the difference I am saying. Now let's run again. Now since one time it is run, you can run it again from here. Now you see this time there is no errors, failures are 0, and it has run one time. And there is no error. If there is error, it might have come here. Okay, this is how you tested the first one, just the positive one you tested. Like that, you can write lot of test cases. So what we will do is, we'll write one more test case here. And to indicate any method as test case, just put at test. It's like an annotation. Now another test case we are going to do is test get total marks above. Okay, so here I'm going to say student mark dot get. Again we are testing on get total marks. This time we do the negative test. This is like a negative test. Negative test is the test where it will let your code fail. So I'm giving all 3000. If you see, our code has this problem that it can take any value, isn't it? So the same thing we are going to write here. Student marks dot get total. we just call it with all 1000. Our code actually accepts it. Okay, so to see whether it really works, just run it and see how many test cases both are passed. But if you see, really it should pass. When you're passing these two values, should it pass? Ideally not, right? So ideally it should not pass. Okay, ideally it should throw an error. This is what you have caught, saying ideally it should not work, but in your case, since you are giving it, it is doing because you haven't put any validation. So this is an input to the developer. Since I said we have to assume ourselves as a tester, this is an input to developer saying, hey, when you're entering higher values also, your program is able to take. Similarly, we can do one more test. One more test is something like public void, where the user is going to give less marks. So as a tester, your aim is to crack the code or fail the code. I mean, like, you should see all the points where the code can fail. That is what your main objective should be. You should never expect the code to be working fine. You should see whatever possible cases the code can fail, and you have to attack all that. This could also be possible, right? See, this is also running fine. That means the code is full buggy. You do not have a validation when you enter negative values. You do not have a validation when you enter more than 100 marks for each of the subject. Now, this is the problem with the code where they are not handling. Now, what ideally they have to do is, whenever you are taking this get total marks, they should not be blindly doing it. They should raise an exception, or they should flag out saying, hey, this is not expected because you are entering marks more than 1000, more than 100. So let's add that exception. So if we say, let's do something like, now what we will do is, if we are adding here, if physics marks, any of the marks can be entered more than 100, greater than 100, or chemistry marks greater than 100, or max marks greater than 100. Any of that greater than 100 means, that means it's a wrong input from user. Then what you have to do, you have to throw an exception, throw new arithmetic exception, and we are saying invalid marks error. Now, since we have written this guy, this get total marks, so we are saying this should throw this error. Now let's see what happens when we run this program. Now, if I run this, now, so it stopped here, because this one, what we did, we said whenever the marks, any of the marks is above greater than 100, you just give an error. And here the expectation is this should run fine, but it will not run fine because you have put an error. So ideally it has to verify whether an exception is coming or something is coming when it is some validation is coming and all. So it is just doing it and it is working fine. Now what we will do is, for test cases, for these test cases, we have one more way where we can say that I'm expecting some output. So something like this. You can say expected equal to, because that's what we are returning, right? Arithmetic exception dot class. So when you do that, here this test case it is saying, whenever you enter more than 100 any of the marks, I will be expecting this arithmetic exception. Now run it. Now it is successful because you are actually returning arithmetic exception when you are entering more than 100 for any of the subjects. So that means it is correct. So this is how we are testing whether we are doing properly. So if you see all these test cases, test marks above is good. It doesn't have any errors. Now coming to this is still not solved because we are not handling it. So let's fix that one as well. So not only this, we'll put something like else if physics marks less than 0 or chemistry marks less than 0 or maths marks less than 0, what you should be doing, again same thing, throw new arithmetic exception. You can say invalid, either you can put generic or invalid marks invalid. Let's put the same thing. Anyway, invalid, right? What is the point in saying you are entering above marks or below marks and all? If you want to be descriptive, you can do even that. So now I'm saying even if you enter less than 0, you can still raise an error. Now you again run it. Now this guy again stopped. Now where it stopped, test marks below, because this point it is raising that error. Now here also you put it saying expected equal to arithmetic exception dot class. So what does it mean is whenever you run this class and if there is a failure, it is this test case is expecting arithmetic exception. So this is how you identified a problem in the code and fixed it. Okay, so this is what you have done. Now test few more things. So you can see we have written 2 negative cases. This is positive case. This is 2 negative cases. In 2 negative cases, we are successfully able to figure out a bug in the code and told the developer and they fixed it. Now this code at least is bug free. Now let's look at some more use cases. Like let's write a test. And this time what we will do is we will check whether, whether arithmetic on while passing argument is happening or not. Let me show you what does I mean. What does I mean by that? Get total marks arithmetic check. So I'm just going to do some arithmetic check here. So arithmetic check I mean is something like this, where I'm going to enter student mark dot get total marks. Here I'm going to do 10 plus 20 plus 30. I need to verify if user gives something like this, is it going to work or not? 30 plus 20, comma 40 plus 20 plus 10. So this is what I mean by arithmetic. So that means on the parenthesis itself when they do it, what is this? When they do like this, is it working? Ideally it will work because that is something the Java itself takes care. We don't need to worry about it, but still we want to check. Okay, that is also working. See, get total arithmetic check, that is successful. There's no errors. If there is any error, you should have able to find it here. So that is also good. Now let's write few more edge cases. Like, before edge cases, let's test the other functions also. We are just bombarding the same function. Let's go to maybe other function like grade. Test get grade, and here on the get grade we'll say this is a positive case for the grades. So we are checking, am I getting A plus when the marks are student mark dot get grade and the marks are something like 90. That's what I'm checking. So I'm saying, am I getting answer as A plus? So asset equal to, what it does is, if you look at multiple places we have used asset equal to, it just says that is this value coming when you pass this input to the functions you have written as part of the code. Similarly, you are saying, is this value A plus gets returned when I call this function? That's what you're checking. Okay, now see this, it says correct. So you see get grade, no errors. But let's put A++. Some schools give A++ and all. Let's see this. Again the failure. That means the test is not, the use case is not like that. They only written A++. So that's one thing. Similarly, let's test one more positive case for, public void percentage. Why we have to leave that guy? Only one other function. We will do test for that as well. And again we say asset. There are a lot of asset functions available like this, but this is the one most popularly used across. So we are using the same. Student mark dot get percentage 100 100 100, and here we have to give the diff because it's a float value 0.0f. This is not 0, this is O. Now test this one also. Here we are testing the percentage. So still it says some error. It shouldn't be part of this. It should be outside of this. And this should be like this. Again you run it and you see all these are passed. Now what else can be the problems? We have tested multiple things. What else can be the problem? We tested the total marks is like when it is more than 100, it is not validating. So we caught in the code and gave the input to the developer and they fixed it. Similarly, we gave input to the developer when he is entering less than marks. That also we gave. Now here also percentage also can get into this trap, right? What if the percentage directly the value entered is more than 100? The percentage should be, when you say get percentage, all the marks here also there is a chance that user can give any input. You should block that also, right? So in the percentage also, we were talking about the negative test case. So what we are going to do is one more test case we are going to write, where we are going to say get percent test get percent invalid marks. I'm testing the invalid marks use case. The invalid marks use case test is, we'll do the same thing. Now here I will be, here when I'm asking percentages, I will again do the same thing like what I did earlier. 1000, 1000, 1000, and the total should be 3000. Okay, if I just leave this, so no, I think let's do this way. Just call the function. Now you're calling function, we are calling percentage of the marks by passing more than 100 for each subject. Again, this is not valid. So if you see, we are trying to catch the code wherever there is a problem and fix it then and there. That's what we are doing. So if you see again, it is getting passed. So that means our guys have written a very bad program where they are not handling the percentage. Again, here also you have to fix. Now what they have to do is, before adding them blindly, they should have this check. These two checks should be there as well. Or I would suggest, rather than doing this, I would suggest, since we are validating marks every time, maybe we can write a one function that do the validation also. So every time you just pass the valid, and if it is valid, it will return true, otherwise it will return false. That also you can do. Since we already have spent time in writing it, I'm just reusing the same stuff. So I'm saying if physics marks are anything or less than that, you just throw this error here also. Okay, now if you run this guy will fail because he will be returning an error, right? So you see that he will be returning this error. He is returning this error. That's what it says. Okay, so let me show you that. If you click on this, you see it says I'm returning this invalid marks error. Who is returning it? This guy is returning it, which is good because you should not be entering beyond than that. Now again, like what we did here, the same thing you can put so that you can say properly it is validated. Now you see that now you run it, it's properly running because you're expecting the marks, and whenever the marks is above 100, you are handling it. That is one case. Now let's think what else we can do. So we put boundaries for percentage also, we put boundaries for total marks also. Is there any other place it can go wrong? That's what we need to check as a tester. So percentage, when you're saying it shouldn't be greater than 100, right? That is another thing. When you're passing grade also, when you're calling grade also, the percentage value should not be 100 because anything greater than or equal to 80 is A plus. That's all. You can enter even 200 also. So let's test that first. So where in the student test marks, I will return this as 900. Let's see 9000. Okay, anything. Ideally, it should give me some error, but what it is doing, getGrade is happily taking it because we don't have any validation, right? This is another wrong kind of coding. Again, here you have to check before even doing all this validation. As a developer, it is our responsibility to make the code more, properly working. So again, you have to do check saying if percentage greater than 100 or percentage less than 0, then first itself you should not let the code run it. Throw arithmetic exception. I'm saying invalid percentage error. That's what I'm doing. The beginning itself, throwing the error if percentage is above 100 or below 0. Okay, now this is done. Now let's run this guy again. If you run this guy again, he will fail. Where is failing? Test grade. And which point? The same point. Why? If you come here and you check, it says invalid percentage error. Okay, so you should check that here. So the same thing, test grade, and here you can put expected and arithmetic exception dot class. Now if you run it, it should pass. You see, that means it is returning arithmetic exception when you are entering invalid one. If you have entered proper one, you get the answer. Okay, we should have written separate function for it because this is written specifically for the invalid use case. Let's keep one for test get grade. Let's name it as, let's copy this test grade. This is a positive case, and this is like test get grade invalid marks. This is for invalid marks. Now if you run it, all of them is passed. Okay, still there is a problem. Oh, okay, here. So you see, now it runs perfectly. You have all your test cases passed. Now you can see that when you're, as a developer, when you're writing the code, you have to check all this. And even though I said like you should assume yourself like a tester for some time, but when you're writing, you should always keep in mind, as a developer, you're supposed to write these unit test cases. Don't think that you're a programmer means you will just end up writing only code. You could write, these unit test cases also will be part of your job when you work as a programmer or developer in a company. So it's very important. Sometimes we have to context switch and think like a tester to figure out these problems. If you see just with this exercise, when we have written it, the program is not, properly guardrailed or secure. I will not say secured, properly not guardrailed. All the bugs are not handled. Now, if you see, the program is like, moreover, we handle all the problems, like when a marks can enter more than 100 or less than 0. Similarly, here also we put some guardrails so that invalid marks are captured. And here also grade can be any value. It will simply say A+ for anything above than 100. That also we handle. So like this, every other function you can easily catch if you properly write unit test cases. So when you're sending your code for review, it is very, very important that you write these kind of unit test cases so that it gives the confidence to the, whoever is validating your code, saying, okay, this is where these are all cases are already handled, and it will help them easily to understand how you are doing it. I mean, have you tested your code? It gives more confidence and trust to the peers so that they can say this code is written properly. And just writing code is not just the the only thing. You have to write proper test cases also, and this is part of every developer. It is, even though I said you have to assume like a tester for some time, but this is also one of your job. So like this, any kind of thing you want, you can keep assuming. Let's see if we have missed any other test cases. I'm just seeing if we have missed anything. Okay, let's say physics marks, chemistry marks. If it is greater than 100, less than 0, that is one possibility, any of the subject. And we have handled that. And in fact, this we don't need here. In fact, this, let's calculate this only when it is correct. Why? Otherwise, why we have to evaluate? You can see that what is the difference? There is a difference. This expression need to be, I mean, why you want to give that button to computer unless it is very clear that this is good to go. This is just giving a signal. If it is coming here without matching any of the if condition, it is just giving a signal that the code is good to go. So it's better to write it rather than above. There's no difference with terms of performance, but it is like you're just saving some time for the computer, because only when there is exception also this guy gets evaluated when you put above. Now you're putting down, so that only when these cases are not matching, then only you will do the proper evaluation or expression calculation and all. Otherwise you won't. Here also it looks good. Then we have, what else we have? We have that also here, guardrail. I think we are good. Hope this helps. Ensure that every program you write, ensure you are writing proper test cases, and this one is more than enough to test any bug in your code. Thank you.
Let's summarize what we have learned in this module. So in this module, we learned about JUnit framework, and we learned about what basically is unit testing, which is about a developer's responsibility where he has to write small test cases for his code. Then we understood about what is regression testing framework and what are the different aspects in it, like starting with assert, exception test, test suite, and annotations. And we discussed in length about each one of them. We also discussed about what is a test suite. Basically, it is like bundling multiple test cases together. And we finally discussed about exceptions test, which is where you can handle any exceptions arising from the code and you can match whether the expected error is occurring or not. Then we discussed about assert class, which is basically different types of assert methods you can find from or.junit.assert, where you can figure out whether a particular test fails or not, and you can apply on relation expressions. You can apply this assert on a particular string value comparison, or whether to check whether string is null or not, all that. So that's what we have done in this particular chapter. I hope you find this useful. Thank you.